You're watching the part 1 of the Blender Master course, and before starting, I should tell you that this entire video of over 11 hours comprises of the first 40 chapters of the Blender Master course. The first 40 chapters will cover the basics of Blender, the modeling tools, techniques, modifiers, materials, textures and shaders, the node system, and we'll even begin with the chapters related to geometry nodes. Then in the part 2 of this course, whose link will be added in the description once it is uploaded, we'll cover the remaining chapters of the geometry nodes. Then we'll understand about animation, compositing, shape keys, add-ons, particle systems, all types of physics and simulations, and then we'll also model a 3D character. Then we learn about character rigging and even character animation. So there's nothing to wait for, and let's start with the journey of this Blender Master course. In this chapter, we'll be understanding that why we're choosing Blender for 3D animation and about some basic features of Blender which you must know before using this application. Also, we will be installing the latest version of Blender, and we'll also check if our system specification matches with that of Blender's minimum and recommended system requirements or not. So to begin with, the first question that may come in the mind of a beginner in 3D is, why Blender? And the answer to this is that with Blender you can make almost everything, from a simple model to motion graphics and even complex characters. Also, Blender releases many new versions from time to time, fixing bugs and sometimes bringing new features as well. Now we should check the basic and recommended system or hardware requirements for Blender. And for this, I should move to my PC screen now. First of all, open any browser, search for blender.org. This will take us to the official page of Blender. Now we click on the download button here. Before downloading this software, we look at the requirements for running Blender. For Windows users, it says that you need to have at least Windows 8.1 installed, and the recommended is Windows 10 or Windows 11. At least 8 GB of RAM is required to run Blender, and to avoid any lags or crashes in Blender, you need to have 32 GB of RAM. GPU of at least 2 GB of VRAM is required, and 8 GB of VRAM is for a faster and smoother experience in Blender. For macOS users, you can check the minimum and recommended requirements here. For Linux users, it's mentioned here. So now we'll download Blender on our PC. So if you are using Windows, then you can download Blender directly by clicking on this button, download Blender 4.1.1. But if you're using Mac or Linux, then you can download it from here. So basically the latest version of Blender right now is Blender 4.1. But if you're watching this video a few weeks after uploading, then obviously the Blender must have released a new version, so you can download that. So I'll download 4.1 version right now, and it will download in a few seconds. But till then, I'll answer another question that comes in mind of many beginners, and that question is that should you use a laptop? So basically, yes, you can use a laptop, but just make sure that you have connected a basic 3-button mouse with it. Although Blender can run with just a trackpad and without using a laptop, without using a mouse, but you will feel the need to buy one if you decide to use Blender in the long run. Now coming back to downloading part, it will download in a few seconds, and it's not a very heavy software, it's just 327 MB. Now that it's downloaded, we'll click on open file here. Now it will install Blender on our PC. We'll click on next, accepting all the agreement terms and conditions, and click on install button. So it will take a few seconds to install Blender on our PC. So it's installed on our system. Now we'll search for Blender 4.1, and this is the screen that appears the first time you open Blender on your PC. So this is the splash screen of Blender, and from here you can change the theme of Blender dark to Blender light or deep gray, but most of the people use Blender dark, so we'll set it on Blender dark here, and spacebar should be set to play, and these are the settings that must be there in Blender before running the software. So now that we have installed Blender and even opened it on our system, so this was all in the chapter number 1 of this course. In this lecture, we learn about basic interface of Blender, how to open and use different things in Blender, and by the end, we'll also be having our first rendered image. So as discussed in the previous chapter, this was the splash screen of Blender, which appears the first time you download and open Blender, and this allows us to set the theme of Blender and make some very basic settings. And if you click anywhere else on this screen, this splash screen will disappear, and this screen arrangement appears, which has multiple panels in it, and this is called the graphical user interface of Blender. Now there are different windows in Blender where you will be working, and these are called the panels, or basically the editors of Blender. The major area is covered by this 3D viewport, where you will be spending maximum amount of your time, as it basically contains all the objects that you will animate and make different things in Blender. Then this is the outliner editor, and it contains the names of all the objects that you are working on. Now this is the property panel, in which you will basically edit all the properties of the objects that are present in a particular file in Blender. And this is the timeline editor, which will be used while we animate different stuff in Blender. Now this is the default cube of Blender which always appears whenever you open a new file, and along with this a lamp and a camera also appear. Now you can select any of these using the left mouse button click. Now here the lamp is selected, and using the left mouse button click the camera is selected. So this was about the default things that appears whenever you open a new file, and this is the tool panel of Blender which basically covers the very basic operations like moving, rotating, scaling, etc. And we will learn these in our future chapters. Now you can toggle the object properties panel using the N key. And this is basically used to edit the basic properties of different objects in viewport very quickly. So it's time to analyze the tool panel by using the move tool, rotate tool and the scale tool. And for this you need to click on this cube here, which will be the object that we are going to move, and you need to click here in the tools panel the move button. Now as you click the move button, these arrows will appear on the object which are known as gizmos in Blender, and if you left click on these arrows and drag it, then object will also move along with it, and if you leave the left click button, then the objects get relocated at that place. So these are the axes in Blender, and these also represent the X, Y and Z axis. This red one is the X axis, this green one is the Y axis, and this blue one represents the Z axis in Blender. Now if you want to rotate any object, then you need to click here in the tools panel, and then you can drag it as per the direction which you need to rotate the object. For example, if you want to rotate it in X direction, then you need to drag this X one, the red one here, and for example if you want to rotate it this much, then leave it here. So this is the rotated object in the X direction. Similarly, if you want to rotate it in Y direction or in Z direction, then you can do so using the particular gizmos. Now it's rotated in the Z direction as well as in X direction. Now scaling any object is also very similar to rotating and moving it. You need to click here on the scale option. Then if you need to scale it in Z direction, then you need to drag the blue one. So it is scaled up now. And if you want to scale it down, then you need to move it like this, then drag it like this. Now it is scaled down, and similarly for other axes, for example for X axis you can scale it down in X axis as well, and this one is for Y axis. But with usage of Blender, you might observe that using gizmos for moving, rotating and scaling is not convenient every time. So Blender also gives you the option to use shortcuts for moving, rotating and scaling. So for moving you can use the G key and move it anywhere you want in the 3D viewport. If you want to set a position, then you need to click left click button on the mouse and it gets set in that position. Now if you want to rotate this in a particular direction, then you need to click R button and move your cursor, and it gets rotated in that particular direction. Now to set it on a particular rotation, you need to left click, and this is the new rotation of your default cube. Similarly, to scale it, the shortcut key is S key. So if you press S and then move your cursor, then the object will scale up and scale down. Now to set it, you need to left click like this, and this is the scaled object now. Now the next thing is zooming in and into the 3D viewport and rotating it. So for that, if you want to zoom in and out, then you can do that by your scroll wheel. If you rotate your scroll wheel, then you can zoom in and zoom out of your 3D viewport. And to rotate it or move around the viewport, you can do it by pressing the scroll wheel button and moving it. This will allow you to rotate the viewport or basically pan in. Now if you want to go up, down, left and right in the 3D viewport, then you can do that by pressing the shift key, and along with that press the middle mouse button or the scroll wheel button, and if you move your cursor or basically the mouse, then you can go up, down, left and right in the 3D viewport like this. And if you leave any of the two buttons, then the position will get set. Now if you're just a beginner or you're just starting out in Blender, then you might think that it's too much, it's too hard, or there is too much to memorize, but with time these things will become a habit of yours and you will find it very easy and interesting to do. The next thing is that now since everything cannot be made with just a default cube in Blender, so Blender gives us the option to make different objects and add different objects in the 3D viewport. And for this, first we need to delete this default cube, and we can do it by using the X key. If you press the X key and press delete, the object will get deleted. And to set up a new object, add a new object, you need to click Shift plus A. This will give you a list of different objects that can be added in Blender. For example, if we want to add a UV sphere, then we'll click on Mesh and then UV sphere, and UV sphere will get added here. But one question that might strike your mind is that why is it appearing at the center or basically at the intersection of these two axes? The reason is this 3D cursor that you can see here. If I turn off the gizmos, then this is the 3D cursor that you can see here. Whenever you add any new object in Blender, it gets added at the location where the 3D cursor is present. And to move this 3D cursor anywhere in your 3D viewport, then you can do it by pressing the Shift key plus right click mouse button, and the 3D cursor will get relocated. But if you want to get this 3D cursor back at the original position, then you can do it by Shift plus C, and the 3D cursor will get back at the center of the 3D world. Now many people find these gizmos very boring to work with, and therefore Blender gives you the option to use shortcut keys for moving, rotating, scaling in a particular direction as well. So if you want to rotate it in a particular direction for say x-axis, then you can press R, then instantly press X also, and the object will rotate only in the x-axis now. Similarly, if you want to scale it in a particular direction, say y-axis, then you can press S and then Y, and it will get scaled up only in the y direction. Similarly, for moving, if you press G and say you want to move it in Z direction, then you can press Z and left click, then it gets relocated in the Z direction. The next thing that we are going to explore are the modes in Blender, and for this I'll delete this object and add a new cube here. Now the different modes of Blender allow you to do different operations. For example, if you want to edit the vertices or the edges of a particular object, then you can do it only in the edit mode and not in the object mode or any other mode. Similarly, if you want to do weight painting of an object, then you can do it only in the weight paint mode and not in the object or edit mode. So for different objects, there are different modes in Blender, and you can discover them here where it's written object mode. So the cube has the option of object mode, edit mode, sculpt mode, and weight paint mode, texture paint, and vertex paint mode. But the most important ones are the object mode and the edit mode, as you would spend most of your time working in these two modes only. Now to enter into the edit mode, you can click edit mode here, or you can also use the tab key to toggle in between object and edit mode like this. As we enter the edit mode, you can select the vertices of your object using the left click mouse button like this, and right now we are in the vertices selection mode only, and to change it to edge selection or face selection, you can do it from here. If you click on the second option, then you can select the edges of your object like this, and if you want to select the faces, then you can go here and select the face mode, and now you can select the faces of your object. You can also do it using the shortcut keys, and the shortcut keys for selecting the vertices or the edge or the face selection mode are the 1, 2 and 3 keys, but these keys are not from the numpad but from here in the keyboard. Now if you click 2, the edge selection mode will appear, and if you click 3, the face selection mode will appear. 1 is for the vertex selection, 2 is for the edge selection, and 3 is for face selection mode. Now to come out of the edit mode, you can do it using the tab key. Now we are into the object mode again. For people who have just started out working on Blender and they feel that it's too boring to learn so many new things altogether, you need not worry, since the best way to deal with this problem is practically making something in Blender. And so we will start our first practical session in this chapter right now, in which we'll basically make this simple looking Rubik's Cube. In this way, we'll also understand about adding basic colors or materials in our scene. Now before starting this practical session, there's one more important thing that I must tell you, and it's basically about saving your file. I have personally experienced it many times that I'm making something on Blender and due to some crash or maybe some power failure, Blender closes, and if I had not saved that work manually, there is no backup and all the time gets wasted, all my energy gets wasted. That's because Blender doesn't auto save anything. So before beginning this practical session, we'll first save our file. For this you need to click Ctrl plus S and we'll save a file on our desktop. I've made a new folder, Blender MasterCourse, and we'll name our file as chapter 2. So now our file is saved and we can begin our first practical session of making this Rubik's Cube. A Rubik's Cube's shape and structure is nothing but a cube only, so we do not need to change the shape of this default cube very much, and we'll begin by adding colors or materials to it. To do this, we need to click here in the properties editor. Make sure that the cube is selected and is highlighted. From here you can change the material properties like the base color, its metallic strength, etc. We'll be exploring all these in detail in the upcoming chapters, but for now we'll look at the base color option only. Suppose we want to change its color to red. Now if we select red here, we observe that there's no change in the object's color in the 3D viewport. The reason behind this is that we are currently in the solid mode, and in Blender there are 4 modes of viewport shading which you can change from here in the upper right corner. The first one is the wireframe mode, where you can only see the edges of the object in a wired form. Second one is the solid mode, in which we are working till now. The third one is the material preview, and in this mode we can see the colors that we have assigned to our object. And the last one is the render preview mode, And in this mode you can see how your output would look like when it's ready as per the lighting and other effects. You can also switch between these modes using a shortcut key, that is Z. Now you can enter any mode like this. Now we are in the material preview mode. We have one problem here, and that is we did not want to color the entire cube as red. To assign different colors to different faces, we need to enter into the edit mode using the tab key. And now we'll select this upper face by pressing 3 for face mode, and now selecting this face. Now we'll assign it another color by adding a new material, and for this we have to click at the plus button here. Then we'll click at new and assign here. Now it has changed its color to the default white. We'll change it to something like blue. Blue looks good on it. Similarly, we will assign different colors to the different faces of this cube. For this face, we'll assign yellow color like this, and for this face we'll assign some other color. Let's assign green for this face. Now we have 4 faces ready. For this face we'll assign white color, and for the last face let's assign a new color. Let's assign it purple. Now although this cube has different colors on its faces, but still it does not look that good. That's because we need to assign more colors like in this one. For this we need to increase the number of vertices so that there are more faces where we can assign more colors in the cube. For this purpose we'll use the subdivide option. First select all the faces of this cube. For that you can use the shortcut key A to select all. Now right click and select subdivide. Click here and increase the number of cuts to 2. Now it looks fine, and now we'll change the color of these smaller cube faces. Now we'll assign blue color to these 3 faces. For this we'll select the 3 of them. To select them together we will press shift key and then select them like this, or else you can also do one more thing, that is to press the left click button and then drag it like this. The 3 faces will be selected. Now we'll click at the blue material and click assign. The 3 faces will now get assigned blue color. Similarly, we will change the color of these 3 faces. We'll change it to white, and for these 3 white faces we'll change them to pink color. Now these 3 faces will be selected and we'll assign them yellow color. So that's basic structure of a cube ready. Now we'll press tab to enter the object mode. To get the final render, we will get it from the view as per the camera sees it. So to enter into the camera view, press 0 on your numpad. So this is our camera view, and to make it look better we'll rotate this cube in the Z direction. Press R then Z, and you can rotate it like this. And if you rotate it in X direction, then it looks something like this. In Y direction you can rotate it like this. You can finalize any rotation which suits to you and looks good to you. Let's finalize this one. I know it's not looking like realistic cube, and that's because we are yet to cover a lot in Blender. We have tried to create something on our first practical session with less than 1% knowledge about Blender. But as you continue to learn and understand all the concepts, you will be able to make realistic looking animations as well. But yes, to make it look a bit more interesting, we can try one more thing. We will enter into the edit mode, click A to select all, and now we'll use a new tool called bevel. Basically it will make the edges look a bit rounded or curved. We will be understanding this tool as well in much detail in the upcoming chapters. To use it right now, we'll press Ctrl plus B and move your cursor slightly to see its effect, and then release it using the left mouse button click. Now to fix this mismatch in colors in these edge loops, we'll change their colors by selecting all of them and assigning them a different color. To select the entire edge loop, we'll first enter the face mode by pressing 3. To select the entire edge loop, we'll press Alt and then select by left click like this. And to select multiple edge loop at once, we'll press Shift and Alt simultaneously and select the edge loop. Now this edge loop is also selected. Similarly, we will select all these edge loops now. Now one thing to note is that selecting them will take some time, and you have to judge on your own on which face to click to select the correct edge loop. So try practicing it after this chapter ends, and in upcoming practical sessions also we will be doing this again in order to master it. Now we'll assign these edge loops black color so that they look interesting. So we'll create a new material here And to get black color here, we will bring this down like this. And now we'll click the assign button. Coming back to the object mode, we observe that there are still some faces left that should be colored black. So we'll select those particular faces in the edit mode and assign them black color. For example, this face that is red colored, this should be black so that it matches with the edge loops. So we'll go to black material and click assign. Similarly, this one. Now our cube is finally ready, and we'll return back to the object mode and click 0 for camera view. So now it looks more realistic than before, and so we'll render it now, which means that we will ask our software Blender to give us the output as an image form. To check the lighting in this scene and that how the final output would look like, we'll press Z and enter into the rendered viewport. Now this one face is a bit dark because of the lighting, since our lamp is located here, so the light does not fall on this face, and as a result it appears to be darker. But for today we will render it as it is, since we are going to have a complete chapter on lighting as per its strength, position, etc. And also for our first practical session it looks simple and decent enough to render. In order to render this image, we'll click here on the render button, then click render image, and based on the PC specification it will take the required time to render, and this is our final output. Do tell me in the comments about how good your cube looks, and if possible also share the link of its image if you manage to render it. Now to save this image, we'll click on image here and click save, and save it at your desired location. And that's all in our chapter number 2. In the previous chapter we tried to understand the interface of Blender by moving or basically changing different things, and we ended up making this simple looking cube in our first practical session. And now let's start a new chapter. Our first topic for today will be understanding editors in Blender. So as we even discussed in our previous chapter, editors are basically individual windows or the panels which together make up this Blender interface, and they basically contain the controls to edit different types of data in Blender. Now the default screen arrangement, that is the arrangement which appears as default whenever you open a new file, it comprises of these 4 panels or editors, namely the 3D viewport editor, outliner editor, properties editor, and timeline editor. But these are not the only 4 editors available, and to access more you can click this icon. This is called the 3D view editor icon. It's available in all the editors with different images, but it's the first icon of your editor, and if you left click on this icon, it displays a list of all the editors which you can access. For example, if I select this image editor, it will open up here, and here you can open images while working on your Blender file. This helps you when you are working on some Blender project and you need to see some reference images. By clicking on image and then open, you can open your required file. Since it's gonna be a long but a complete master course, all of these editors that you can see here, these will be covered in detail in our upcoming chapters. The next thing is resizing editors. So sometimes you might feel that you need to change the size of your editor. So for that, just place your mouse cursor on the editor or the panel border and it will change to a double-headed arrow like this. Now click left mouse button and drag it to resize accordingly. So editors can be changed from here or here depending upon the editor that you want to change, and also they can be divided or basically be splitted. Now to split an editor, place your mouse cursor in the corner of any editor panel and it changes to a white cross like this. Now click right mouse button and you can split it in 2 ways, vertical split and horizontal split. If you select vertical split, you can drag this line as per the area you need for the new editor and click left mouse button to finalize. It will duplicate the same editor panel, and then you can change the editor type from here and adjust the size accordingly like this. Now for horizontal split, you can place your mouse cursor here and click horizontal split and drag the line as per the area required for the new editor, and this will create a new editor here. It will duplicate the same and you can change it from here to like timeline. Now the timeline that was here initially will appear here as well, and you can resize it to see it completely like this. Now to close an editor panel, you basically have to join 2 editor panels together and make them into a single one. So for this, place your mouse cursor in between any of the 2 editors and then right click and select join areas. Then you have to drag this arrow into the editor that you want to close and click left mouse button to finalize. Now the 2 editors are joined into a single one and the other editor is closed now. And now we'll try to do the same thing with this one as well. Right click and select join areas, then drag the arrow to the one you want to close and it will close. Same with this one, and then we'll resize it And now in order to make this similar to the default arrangement in Blender, we'll try to add outliner editor up here, and for that we'll click horizontal split here, and we'll split it like this and change this to outliner editor, and now we'll resize it so that it looks similar to the default arrangement in Blender. So this was all about editors. Now Blender also gives you the option of hiding some objects in your 3D viewport, and this will be beneficial when you work on projects like this where you basically have a lot of objects in your 3D viewport, and if all of them are shown together it might create some confusion for you. To hide any object you need to select that object, and then in the outliner editor click this eye-shaped icon against its name, and this will hide the object, and clicking it again will show the object in the 3D viewport. There's also a shortcut available to hide objects, and that is to press H in your keyboard, and this will hide the object, and to unhide or show it again then you have to click Alt plus H. Now the next thing to explore is user perspective and orthographic view. So by default Blender opens in this user perspective view. That means that there is no visible end of this 3D viewport. Even if you see it from different angles, it seems as if this viewport is infinitely large, and so it's a perspective view. And to switch to another view, that is the orthographic view, press 5 on your numpad. Now this is the orthographic view in which the viewport visibly ends here, and it seems to make a right angle with the face. So this was the difference in the perspective view and orthographic view. For most of our time we'll be working in perspective view only, so let's return back to the perspective view by pressing 5 on a numpad again. Now one way to navigate or move around the viewport in Blender is to press the middle mouse button and to navigate like this. But there's one more way in which the navigation is similar to the walk style navigation in games such as GTA. So if you play GTA with a keyboard, you will use the WASD keys to move your character. Similarly in Blender, there's a special mode in which you can use the WASD keys to move around the 3D viewport, and it is known as walk navigation. To access it, click on the view menu here and then go to navigation and select walk navigation from here. Now you can use your WASD keys to move around the 3D viewport. W is for moving forward, A is for moving towards left, S is for backward movement, and D is for moving towards right. And in order to increase the speed of your movement, you can press Shift key simultaneously along with WASD keys. Shift W will move it forward in a quick way. Similarly, Shift S, Shift A, Shift D. And the view will be finalized with the left mouse button click. And always remember that when you have to cancel your navigation, like you are navigating like this, then before finalizing, press the right mouse button click and it will return back to the position where you were before navigating. All these things will get in your mind when you actually practice Blender over time. So if possible, do try to practice all these shortcuts and modes and try to explore them after this chapter ends. Also, I can assure you that following this MasterCourse series will brush up your skills, and at the end of this course, you will be in a position to make everything that your mind can think of in Blender. Now coming back to our chapter, the next topic is workspace. So workspaces are basically the screen arrangements of editors for working at specific tasks. Like there's a separate workspace for modeling things, a separate one for sculpting, shading, animation, etc. And these can be accessed from here in the upper screen header, where you can see layout, modeling, sculpting. These are the workspaces in Blender. The default one is the layout workspace. If we click on modeling or sculpting, we observe that the workspace layout changes, and since right now we haven't done modeling, sculpting, shading, etc., so we won't be discussing each one right now, but whenever the upcoming chapters will be released, we would be understanding about all these different tools as well. Now we'll return back to our default workspace. Now we'll see these tools which are known as the widget panel in Blender. If you click here and move around your cursor, then you will navigate in the 3D viewport. So this is another way to navigate the 3D viewport. And this one is for zooming in and out in the 3D viewport, which you can also do using your scroll wheel. Then this one is to move around the view like this. And as discussed earlier, you can also do this using the Shift plus middle mouse button. Now this camera icon is for toggling the camera view. And the shortcut for this, as discussed earlier, was the 0. You can toggle the camera view using the 0 key in the numpad. Now this one is for switching between the perspective and orthographic view. If you click this, the view changes from perspective to orthographic, and if you click it again, it returns to the perspective view again, and the shortcut for this is 5 in the numpad. The next thing is the preference editor, which is basically like the settings menu for Blender. To open it, click edit from here and select preferences. And here you can basically change the settings in things such as interface, themes, viewport, navigation, input, saving different files, and installing add-ons. There will be a separate chapter in this course which will make you understand what exactly the add-ons are and which ones are the best for Blender. Also, it is advisable not to change any preference settings on your own. unless and until you know the exact consequences of that change. Whenever it is required to change anything, I will share that with you in the upcoming chapters. But yes, for today's chapter, we'll be exploring the themes in the preference settings. We will try to change the color of this 3D viewport background. For this, with the theme selected here, we'll go to 3D view here, 3D viewport, and scroll down and select theme space and scroll down again and select gradient colors here. Now click the gradient high off option here to display this color picker circle. Now to increase the brightness, you can use this brightness slider here, and this will increase the brightness of the colors. Now you can select any of the colors, like if we move it to green, the color of the 3D viewport editor will also change. You may set any color that you like, and you can adjust the brightness from here. Now you can also change the cosmetic appearance of your interface, that is the theme of your interface, as per your preference. To do that, in the same themes preference, scroll up and select this presets drop down menu. You may select any of these themes that you would love to see while working on your Blender file or Blender project. And the default one in Blender is the Blender Dark theme. Also, Blender gives you the option to download themes from some external websites, and to install them you can click this install button and select the file. But for most of the people it's not required because Blender already gives you a good range of themes to choose from. So choose the theme that suits you the best. And now we will close these preference settings, and this brings us to the end of this chapter. Now coming back to the topic, today we are going to start navigating and saving in Blender. So first of all, Blender files are saved in your PC with the file extension of .blend. And as we even discussed this earlier, in order to save your files in Blender, you have to press Ctrl+S, and then it will ask you to choose your desired location. It's suggested to make a separate folder in your PC for Blender files. Like I have created this Blender MasterCourse folder where I save the files that I have created during this MasterCourse series. Similarly, you can also create a folder in your PC. So now I will rename this file as chapter 4, and then I click enter, and it automatically adds the file extension. And now I click save Blender file, and the file is now saved in our folder. Now one of the most important things while working in Blender is to frequently save your work, and the reason is that Blender doesn't have any autosave feature as of now, and so if your software crashes or if there is some power failure, you will lose all your unsaved work. Similarly, if you want to open a Blender file, then just press Ctrl+O, and then by navigating through your folders from here, you can choose your desired file which you want to open. Suppose I want to open chapter number 2 file, so I click here and press open, and the file is now open. So this was the file in which we made the cube, and this was the chapter number 2 file. And now I'll close it and open the chapter number 4 file like this. So till now in this chapter we have learned how to open and save files in Blender. But what does it exactly mean to save a file in Blender? Just like a text file contains the data of words and letters, or an image file contains the data which displays an image, similarly a Blender file contains a combination of data organized into separate parts or elements. So whenever you save a file in Blender, you are basically saving the elements of that file. And to understand this in a practical way, click on File here and press Append. And now I'll click on the chapter number 2 file and press Append. So it displays a list of the different folders, and these are the folders which contain the data of a particular file in Blender. For example, the materials folder here contains the data of all the materials or the colors that you have used in your project. And if you go back and select the object folder, then it contains all the objects that are present in your 3D viewport of that particular file. Now you may be thinking what this append option was when I clicked it earlier. So basically you can insert elements from one Blender file to another using the append option or the link command. The difference between the two is that append will take the data from a file and will add it to the other file, whereas link allows you to use the data from an existing file to your current file, but the data will still remain in the existing file. At this stage it might be difficult to understand these, but in our upcoming chapters when we will use these tools and commands practically, then your concept will get more clear about them. And also we will try one example of append right now. So suppose we want to add this cube that we created in our previous chapter into this file. So to do that, we have to go to file and press append here. Then you need to select the file where it was saved. For example, I click chapter number 2 and append, and now I will click on collection since it contains basically all the objects that were in your 3D viewport, and it will add this cube here in the 3D viewport of this new file. The reason why it's appearing like this is that there are duplicate cubes here. The previous cube that was in the default file is also there, and the added cube is also here, and the lamps are also two, the cameras are also two, which you can see in the collection here. So we'll delete one light from here, and we'll also delete one camera from here, and now I will also delete this default cube. And now if I go to the material preview mode here, then we see that the cube we made in chapter number 2 file is now in our chapter number 4 file as well. And now our final topic for this chapter is importing objects. So basically there are many file types or formats which can store a 3D model, and Blender has the ability to accept most of them. Now there are many websites from where you can get such 3D models for your projects, such as sketchfab.com. Here you can find a number of free and paid 3D models which you can use in your Blender projects. We will be discovering this in detail in one of our upcoming chapters. But for now we will see an example of importing an object from this website into our Blender file. So let's search for a 3D model of an apple on this website, and for this I'll go here and search for apple, and I'll check this downloadable option, and this one looks good. So I'll go here and scroll down. Let's look at this first, and it looks fine. So I'll scroll down, click on download 3D model, and we'll choose this USDZ format to download it, and it will download in a few seconds. Now let's go back to Blender, and I'll first delete all these objects from a 3D viewport, or maybe I'll keep this cube and delete the rest of them. So I'll click on this, and along with shift I'll select this camera, press X to delete, and I'm thinking of hiding this object instead of deleting, so I'll press H to hide this cube. Now to import that 3D model of apple in this file, we'll go to file, then import, and from here we'll select universal scene description USD format. Now I will go to my downloads page and select this apple.usdz, then click on import, and now I'll scroll back and press S to scale this down like this. Similarly, you can also try this with other 3D models online. And that's all in the chapter number 4. Now the most important thing in our 3D view editor is this 3D cursor here. So while working in the 3D viewport, there are two cursors, the mouse cursor which I am moving right now, and the 3D cursor which is by default located at the center of the scene. And before understanding the usage of this 3D cursor, it's important to understand selecting, deselecting and adding objects in your 3D view editor or your file. So in this default Blender scene, the cube is selected as it's shown by this orange outline or this yellow outline here. And to deselect it, click left mouse button anywhere in the empty space, and to select it again, click left mouse button on the cube. And as discussed earlier also, the shortcut key for selecting all the objects in your 3D view editor is to press A, and all the objects would get selected. An alternative selection method is the box selection method, and for this I'll first deselect these objects, and now I'll press B on my keyboard. Now left click and drag it like this, and to finalize the selection I will release the left mouse button click, and now only the cube is selected since it lies within the box area. Now whenever you open Blender, then by default this select box tool here is activated in the tools panel. So basically this tool is similar to what we learned in box selection method. With this selected, you can click left mouse button and then drag it like this, and if you release it, then this will select all the objects that lie in the particular box area. And if you keep your cursor on this tool and keep holding your left mouse button, then you will see a list of 4 options. If we select the tweak option here, then it basically allows you to select only by clicking on a particular object using your left mouse button. For example, if I click on this camera here, then this camera will get selected. If I click on this cube, the cube will get selected. Now the next option available here is the select box tool, which we have already discussed, and it basically allows you to make a box and any object within the box area will get selected. Now the next one is the select circle method, and in this case the mouse cursor turns to a selection circle, and in order to select an object using this, for example this camera, make sure that the entire object is within this circle area, and for this I will scroll my middle mouse button to make sure that the camera lies within the circle area, and then I'll click my left mouse button to finalize the selection, and the camera will get selected. And the last one is the select lasso tool, and it basically allows you to create a lasso area like this, and any object that lies within the area will get selected. If I try to select this lamp will get selected, and if I try to select this cube, then this cube will get selected. Now our next topic for today is adding objects in Blender. So by default, Blender scene contains 3 objects, a cube, a camera and a light. And the camera and the light are the special objects which perform their functions but when you actually render your image, they do not appear because camera takes the image and the light adds 3D lighting effect to your scene. Now if you want to add a new object in Blender, press Shift plus A and select the mesh list. Then you can see a list of 10 mesh objects which are called primitives in Blender because they allow you to basically create any model out of them by resizing them, by scaling them and doing other operations. Suppose I select this cylinder here. Now this cylinder will get added where my 3D cursor is within the scene. And if you want to change the location of your 3D cursor, you basically have two options. First one is to select this tool which is known as the cursor tool from here. And now if you click your left mouse button anywhere, then the cursor will get relocated. And another way is to hold shift and click right mouse button anywhere to position the 3D cursor on your viewport. Also there is one more way to change the location of your 3D cursor. If you press shift plus S, then this cursor pie menu appears and it basically allows you to snap your 3D cursor to some particular locations. We will be using all these in the upcoming chapters while modeling things practically. But for now, I'll take an example by taking my cursor back to the world origin. And for this, I'll click on this cursor to world origin option and my cursor gets relocated back to the world origin. Also, Blender gives you the option to duplicate objects. Suppose I want to create a duplicate of this cylinder. So the shortcut key is Shift plus D, and then by dragging my cursor around, I can move the duplicate object. Now, if you want to move it in a particular direction, let's say X axis, then I'll press X on my keyboard and its movement will get restricted to the X axis. And suppose I type a number like 5 in my keyboard, then it will move exactly by 5 meters in the X axis. And to finalize, you can click either enter or another option is to click left mouse button. Both of them work. In order to move an object, let's say this cube in our scene, then one way, as we discussed in our previous chapters, was to press G on our keyboard and then move around the cube. But there's another way as well, and that is by using the object properties panel here. So you can change the location of your selected object by entering different values here. Suppose I type 1.5 meters in Z direction, then it will move in the required location. Similarly, if I type 3 in Y direction, then it will move by 3 meters in the Y direction. And instead of entering the values here, you can also click left mouse button and then drag like this, and the object will relocate as per the values. And to finalize it, you need to release your left mouse button. Similarly, you can also rotate or scale your object from here in a particular direction. Also, there are many people who are not comfortable with the metric system and they follow the imperial system more. So for such people, you can go to scene properties here and then click on units, and you can change from metric to imperial from here. And I'm choosing the metric system since I'm more comfortable with that. Now you might have noticed that when you press Shift A, then apart from mesh, there were many more object types here. So we'll be understanding almost all of them in our future chapters whenever they are required to be used. Now coming back to the topic, these objects in our scene have different names assigned to them which you can check from here in the outline editor. For example, the selected object is named cube, and this cylinder, this is named as cylinder in the outline editor. And since this one was the duplicate of this cylinder, so it's named as cylinder.001. Similarly, if I create another duplicate out of it, then that duplicate will be named as cylinder.002. Also, you can rename any of these objects by double clicking here and then typing the name, for example cylinder duplicate, and then press enter to confirm the name. Similarly, let's change the name of this cube and let's name it box. And now I'll delete all these objects, and now I'll add a special object in Blender, that is the Suzanne or the monkey model. The reason why Blender has this complex model in a list of all simple looking models is that most 3D softwares have a generic semi-complex primitive that they use for testing renders and other things in their software, and they can't do this with a simple cube or a simple sphere. So they need something more complex, and that's why Blender added this Suzanne or this monkey model in this software. The next thing that we will see is joining two or more objects together, and for that let's add a cube here. Let's move it in X direction. And we'll also add a UV sphere and let's move it in X direction like this. Now suppose I want to join all these together as a single object. So for that, I'll select all these by pressing A and then press Ctrl plus J to join them. Now they will appear as a single object here in the outliner editor. And if you wish to undo the action, then you have to press Ctrl plus Z and this will undo your last action. And if you want to redo any action in Blender, then you have to press Ctrl plus Shift plus Z. Now I'll delete this and we'll add a UV sphere. We can notice that its surface is not smooth and is made up of rectangular flat surfaces. If you want its surface to be smooth, then you can do this by clicking right mouse button and selecting Shade Smooth. This produces a smooth spherical surface which looks better than the previous one. Also, if you want the surface to be flat, then you can do this by clicking right mouse button and going for the Shade Flat option. And now the last and the most interesting topic of this chapter is meta shapes. So first I'll delete this UV sphere and press Shift plus A. And in the meta ball section, I'll select the ball. So meta shapes are described as clay-like forms having a rounded shape, and the reason why they are special is that they show some strange behavior when they get close to one another. So first I'll move it in X direction like this, And now I'll add another meta ball. And if I try to move it closer to the other one, then they try to pull and flow together like liquid droplets. And to finalize the structure, you have to click left mouse button. Also similar is the case with other metaball objects such as the metaball cube. If we add it and scale this down and move it in Z direction, and if you bring it close to any of the metaballs, then it will also behave in a similar way. So with the help of these meta shapes, we can create some very good effects by animating and texturing them, but that would be covered in our future chapters. So now we have learnt and understood lots of tools in the 3D view editor and different types of objects, and so it's time for a practical session in order to apply our knowledge practically. In the first practical session of chapter number 2 of this series, we made this Rubik's Cube, and in today's session we will be making this simple scene of a table. So to begin with, I'll first add a cube and we'll scale it down in the Z direction like this. I'll move it in the Z direction. Now we'll scale it up in X and a little bit in Y as well. So it looks like this, and it looks good as a tabletop. Now for the next part, I'll place my 3D cursor over here by pressing Shift plus right mouse button. And now I'll add a cube here. To make it look like a table leg, I'll first scale it up in Z direction. And now we need to scale this down in both X and Y directions simultaneously. And the shortcut key to scale it in two directions, say X and Y simultaneously, is to press S, then Shift plus the other direction, that is Z. So by using this shortcut, we can scale this down in two directions simultaneously. And to finalize the scaling, we have to click left mouse button. Now we'll also scale this down in the Z direction, like this. And we'll move it down in Z direction also. So it looks fine now. And instead of making all the legs separately, we will duplicate this leg by pressing Shift plus D, and now I'll move it in Y direction and we should place it here. Similarly, we will select both these legs and we'll duplicate them and we'll place them here on the other side of the table. So this looks good, and now I'll move this table down like this, and I'll make it into a single object by joining it. So I'll press Ctrl plus J, and now this is converted into a single object, and I'll change its name from here. I'll rename it as table. Now I think that we should place the Suzanne model on this table so that it doesn't look empty. And so I'll first place my 3D cursor here on the tabletop so that the object gets added here. And now I'll press Shift plus A and select Mesh, then Monkey or the Suzanne model. And now I'll resize it and place it on the tabletop. And it's also not mandatory to copy the exact location or the rotation that I am doing. You can do it on your own as per your preferences. And it looks complete now. And it's time to render it, but before that I have to add a camera in my scene. So I'll press Shift plus A and I'll press camera here. Now if I press 0 on my numpad for the camera view, we notice that we don't see the table. That's because the camera is located where the 3D cursor was. And the best way to fix this is to select view here and then click on lock camera to view. It basically allows you to view navigation within the camera view, meaning that if you scroll down, then you will zoom out in the camera view as well. And similarly, if you press your middle mouse button and navigate, then your camera will also move. But if this option is disabled, then if you try to navigate, then the camera would remain still. So it's important to turn this on if you want to navigate with your camera view. And now I'll scroll down so that the entire table is visible, like this. Before rendering, let's assign the table and the Suzanne model some colors. So I click on the table and I'll go to the materials tab. I'll click on new and I'll change the color, but first I'll go to the material preview mode. And now I'll change the color to something like brown. I'll decrease this brightness slider. And I'll change the color of this Suzanne model to yellow. Now I'll go to the render preview mode. And I see that there is no lighting, so I need to add lights also. I'll press Shift plus A and select light, then point. And here the light will get added at the 3D cursor. I'll move it up in Z direction. And I'll switch this off, the lock camera to view option, so that I can navigate properly. Then I'll select this light and move it in Y direction and down in Z direction. I'll increase its power from here. Let's set it to 50 watt. And I'll also increase the brightness or the power of the light. Also I'll add one more light by duplicating it, Shift D, and I'll move it in Y direction. Now I'll return to the camera view. And if I zoom in, although this looks very simple, but with the amount of knowledge we are having right now, it looks decent enough to render. So now we'll click on render, then render image. And so this is the final rendered image. If you also tried making it, then do tell me in the comment section how it was. And that's all for this chapter. So whenever you open Blender, then by default you are in the object mode with this default cube selected. And if you want to edit an object, then you have to enter the edit mode. And as discussed in the previous chapters, the shortcut to do that is to press tab, and now we are in the edit mode. So the difference between the two modes is that in edit mode you basically work with the individual vertices to model your shape, whereas in the object mode you basically change the properties of this cube as a whole to model something. Now by default, the edit mode comes in the vertex select mode, in which you can select the vertices by using a left mouse button click. And to switch to the edge select mode, press 2 on your keyboard, but not from the numpad. And now you can select the edges of your object by left mouse button click. Similarly, you can also enter the face select mode by pressing 3 on your keyboard. And now you can select the faces using the left mouse button click. Now Blender even has an X-ray mode which you can toggle from here, and it allows you to select the hidden vertices, edges and faces. And there's a shortcut available for the X-ray mode also, and that is to press Alt plus Z to toggle it. And this one is also available in the object mode. You can enter the object mode and then press Alt plus Z to enter the X-ray mode. Now let's come back to the edit mode. So in the edit mode, we can apply move, rotate and scale to the vertices, edges and faces as well. Suppose I select this vertex and press G to move it around, and then I can left click to finalize the movement. Similarly, if I go to the edge selection mode by pressing 2, and if I select this edge and I try to rotate it by pressing R like this, so the object is now transformed. And similarly, I can also go to the face select mode, select this face, and if I try to scale it down, and now if I go to the object mode, the object is now transformed. Now I'll return to the edit mode. So there may be some occasions where you need more vertices in your object for creating details, and for this Blender has subdivision. So suppose I've selected this face, and to subdivide this face I will click right mouse button and then select subdivide from here. Now this face is subdivided into 4 parts, and you can also change the number of cuts from here by increasing the number of cuts or decreasing it. And if you want to delete any vertex edge of face, suppose I want to delete this face, so I'll select it and press X and now select face, and the face will get deleted. Similarly, if I want to delete any edge, so I first have to enter the edge select mode by pressing 2, then I'll select the edge, and now I'll press X to delete, and I'll select edges, and the edge will get deleted. And the reason why the upper face is also deleted is that the edge of that face was connected with the edge that I deleted, so since the shape of that face could not be completed, so it also got deleted. Now I'll return to the object mode and I'll delete this cube, and now I'll add a new cube in its place. And let's also add a UV sphere. Let's move it in Y direction. Now in the object mode, you can easily select any object by simply clicking on it with the left mouse button click. But suppose I select this cube here, and if I enter the edit mode, and now if I try to select this UV sphere, I can't do that. And that's because edit mode is only for the object that I've selected before entering into the edit mode. Now the question arises, how do I edit both the objects together in edit mode? And to do this, we have to come in the object mode. Then with the box select tool, I'll select both of these. And now if I enter the edit mode, then I can edit both of these objects together. Now let's come back to the object mode, and if you notice, then every object in your scene has a dot in the center, and this is the object's origin or its pivot point. To understand it, let's try to rotate this cube. We observe that the cube rotates about its center point or the pivot point, and that's the use of the object's origin. And you can also change the position of this pivot point, and to do this, first place your 3D cursor at the point where you want your object's origin to be located. So let's place our 3D cursor over here using shift plus right mouse button click. Now to change the position of your object's origin from the center to where the 3D cursor is located, you have to click your right mouse button while selecting this cube, and then go for set origin and select origin to 3D cursor. Now your pivot point or the origin point of this cube is shifted here where the 3D cursor is located. And now if you try to rotate it, then it rotates like this due to the position of your pivot point. And you would be using your object's pivot point in a number of different situations based on what your project is. Now the next topic for this chapter is proportional editing. So first let's remove all this, and let's bring the 3D cursor back to the center of the world origin by pressing shift plus C. And now we'll add a new object from mesh, and the object we are going to add is the plane. Now press tab to enter the edit mode, and let's suppose we want to make a mountain using this plane. So for that, first we need to have more vertices on this plane, and so we'll subdivide it. And let's increase the number of cuts. Let's keep it to 10. Now to make the peak of the mountain, the first thing that comes in our mind is to select one of these vertices and then move it up in the Z direction like this. But as we can see, it doesn't actually look like a mountain. The smoothness or the flow is somewhere missing in it. And here comes one of the most important editing tools in Blender, proportional vertex editing. So proportional vertex editing is basically used to create a flow in the shape while you are editing your vertices. And to enable it, you have to click here in the 3D view editor header, and now the proportional vertex editing tool is enabled. Also the shortcut key to toggle proportional vertex editing is to press O in your keyboard. So now let's undo this editing by pressing Ctrl plus Z. And now with the proportional editing enabled, if I try to move this vertex upward, then you can see that it's forming a much better shape, and that's because it's influencing all the vertices around the selected vertex. And the circle that you are seeing is the circle of influence, and all the vertices within this circle will get influenced by the change. And you can use your scroll wheel to change the size of the circle. And now let's finalize this by clicking left mouse button. So that was about the proportional editing, and now is the time for the last and the simplest topic of this chapter, parenting of objects. So first let's delete it, and now let's add two different objects. Let's say one is a cube, and let's add another object. Let's say it's a cylinder. Now let's move it in y direction like this. So suppose you want two or more objects in your scene to act as a single object, meaning that if I move this cube, then the cylinder also moves with it. Then we use parenting. Now some of you might say that we can join them by pressing Ctrl plus J, and now if I move them, they move together. So yes, it will work, but what if I want it to be like, if I move the cube, then cylinder should move with it, but if I try to move the cylinder, then the cube should not move. And here I will have to use parenting. Now let's understand this with the help of an example. First I'll unjoin them by pressing Ctrl plus Z, and then I'll deselect them, and now let's select this cylinder, and then by pressing shift I'll select this cube with a left mouse button click. Now we have to press Ctrl plus P for parenting, and we'll select object, and now the cube is the parent object of this cylinder, which means that moving the cube will move the cylinder with it, but if I try to move the cylinder, then the cube won't move. So basically you have to remember that the object that you selected first while parenting, that is this cylinder, becomes the child, and the object that is selected later, that is this cube, it becomes the parent object. And to summarize the various concepts that we have covered till now in this series, let's start a practical session for this chapter. In the last two practical sessions, we made these two objects, and in today's session, we'll be making this scene. So let's begin with it. I've deleted all the objects in my scene, and we'll start with making the computer screen and its upper body. So let's first add a cube. Let's scale it down in the x-axis, and let's scale it up in the y-axis a bit, like this. And we should scale it down in x-axis a little bit more. Now to make it stand, we will place a 3D cursor over here, but before that there's one more important thing. Suppose you want to view the object from a particular viewpoint, like from the top or the front. So for this there are certain shortcuts assigned. For the front view you have to press 1 in your numpad. It's appearing like this because the rotation of our object is not right, so let's press R, then Z and 90. And so for the front view you have to press 1 in your numpad. For the back view you have to press Ctrl plus 1. Similarly for the right view, press 3 in your numpad. For left view, you have to press Ctrl plus 3. Similarly, if you want to see the top view, then you have to press 7 in your numpad. And for the bottom view, it's Ctrl plus 7. I have typed all these navigation shortcuts here. If you want, you can take a screenshot of this. Now let's come back to the front view by pressing 1. And we'll place a 3D cursor here by pressing shift plus right mouse button click. I place my 3D cursor over here so that I can make the stand for the computer. Now let's add a cylinder here. Let's scale this down. And let's scale it up in the z-axis like this. And now I'll navigate, and I see that the position is not correct. So by pressing 3 on my numpad, I'll go to the right view. Now I'll press G and Y to move it in Y direction, and I'll place it here. Now if I come back and see, it looks fine. Now let's return to the front view, and now I'll add a cube at the bottom of the cylinder so that the stand is complete. So I'll first place the 3D cursor over here by pressing shift plus right mouse button, and I'll add a cube. Now I'll scale it down in the z-axis. And it looks slightly bigger in size, so I'll scale it down in the y-axis and also in the x-axis. Now even if the basic structure of a computer is ready, but still it looks very simple. So for this, let's select this PC screen and let's tab into the edit mode. And now with all the vertices selected, I'll use the bevel option, and bevel basically makes the edges of your object look smooth, so let's use it to understand it. So I'll press Ctrl plus B and slightly move my cursor away, and to finalize I'll press left mouse button click. And now if I come out of the edit mode, the edges now look something like this. Now I'll join this entire computer with its stand as a single object, and for that I'll press A to select all and press Ctrl plus J to join them, and I'll change its name from cube to computer. Now if you remember, we made this table with the Suzanne model in the chapter number 5, and I think that we should add this table in this chapter number 6 project, and in this way we'll also revise the concept of appending. So to append that table, we'll first go to File, then Append, and now we have to locate our file and click on the file name. Then we'll go to collection and press on the collection, and now the table along with the Suzanne model and the lighting setup will get added. And now I'll go to the front view by pressing 1. Now I'll select this computer, press G and Z to move it in Z direction, and I'll place it on the tabletop. Now I'll select the Suzanne model and hide it, and now it looks good. So let's enter the camera view by pressing 0 on our numpad, and to adjust it, we'll click on the view here, then lock camera to view. And now if I scroll back, then the whole computer along with the table will come in our view. And now let's enter the material preview mode and let's change the color of our computer. So we'll go to the materials properties here, then click on new and let's change its color to light blue like this, but its screen should be black. So I'll go to the edit mode. Then if I go to face select mode and select this face only and then click on the plus button here and click on assign, then this particular face of the object will have a different color what I'll assign now. So I clicked on new and choose the base color from here. To turn it into black, I'll have to decrease the brightness slider. And now if I go to object mode, it appears something like this. Now one thing that you might have noticed is that it appears very simple, and the reason for that is that we have currently learned only editing objects in Blender, but to make it realistic and complex, we'll have to learn the editing tools in Blender, and that we are going to cover in chapter number 7 of this series. Now let's go to the render mode to see how it will look when we finally render it, and it looks ready to be rendered, but we have done one mistake here that we'll get to know after we click on the render button. So let's render it. And this is the rendered image. We see that the Suzanne model is appearing here, which means that even if we hide the Suzanne model while working on our 3D viewport, it would still appear in the rendered image. Now suppose you want to hide the Suzanne model in your 3D viewport as well as the rendered image, so you can do this by clicking on the camera button here. So if I click this camera button, then it will be disabled in the render also. And now if I click on render image, then this image is rendered in which Suzanne model does not appear. And so that's all in this chapter. So the first tool that we will use today is the extrude tool. For this we will go to the edit mode of this cube, and to enable the extrude tool, press on this extrude region icon, and now this yellow gizmo appears, which is normal or perpendicular to the face of this cube. So first I'll go to the face select mode and select the upper face. Now if I left click and drag this gizmo or the manipulator, we will notice that it duplicates the face and moves it along the normal axis. If I release the left mouse button, it finalizes it, but these edges still remain here and thus stay connected to the extruded face. And we can also left click and move around the viewport to move the extrusion along the viewing plane. Also you can do this with vertices and edges and also with multiple faces together. And the shortcut to enable extrusion is to press E key in your keyboard and the face will extrude along the normal, and left click to finalize it. Now let's return to the object mode and press X to delete it. Now I'll add another cube here and we'll enter the edit mode and I'll disable the extrude region option. Now suppose I select this face and press E to extrude, but instead of left clicking I press the right mouse button. So you might think that the face did not get extruded as I can't see it here, but in reality the face is extruded, but it does not have any height. And to confirm this, with the face selected, we'll press G and then Z to move this face along the Z direction, and we see that the face gets extruded. Now let's undo this by pressing Ctrl plus Z twice. And suppose I want to make a stack of cubes, so for this I'll press E to extrude, then I'll right click to cancel it, and I'll scale this down like this, and I'll again press E to extrude and move it upwards like this. And I can do this multiple times. Press E and then right click, then S and extrude it again. So in this way it can be used to form a stack of cubes. Now the extrude tool has 5 modes. If you click on this tool for 2 seconds, then it will display the list of the 5 modes. The first one is the normal extrude region tool, which we have already used. So if I press E, then it will get extruded like this. And the next one is the extrude manifold. If I drag this gizmo upwards, we notice that the edges that were here will get dissolved. When we previously used the normal extrude region tool, the edges did not disappear, but with this mode, that is extrude manifold mode, the edges will get disappeared or get dissolved, and only that's the difference between the two modes. Now the next one is the extrude along normal, and this one is used when you are extruding multiple faces together. To understand its importance, let's first try to extrude 2 faces in the normal mode, that is extrude region mode. So let's select these 2 faces. To select the other face together, you have to press shift key along with left mouse button click. And now with both the faces selected, if I extrude them, then we observe that it is basically extruding in the direction which is average of normals of both the faces. But now let's select the other 2 faces and let's switch to the extrude along normals mode. And if I extrude it now, we observe that both the faces are extruded along the individual normals. This is the difference between extrude along normals and the normal extrude region mode. In the normal extrude region mode, the extrusion will take place in the direction which is average of both normals, and in extrude along normals mode, the extrusion will take place in the direction of the individual normals of the faces. And the next one is extrude individual tool. This one is really very helpful in making certain faces extend out independently from its neighboring faces. Basically, to understand it, let's select these 2 faces and choose the extrude individual option from here. Now if I try to extrude it, we notice that extrusion takes place in such a way as if both the faces were being extruded individually. That is, both the faces got extruded along with their individual normals. And for anyone who has any confusion in these methods, I am going to summarize them for you. See, the extrude region tool basically extrudes your face along the normal, and if you try it with multiple faces, then it will calculate the average of the normal of the faces and it will extrude it in that particular direction. The second one, that is extrude manifold, is used when you want to dissolve the edges while extruding. And the third one, extrude along normal, means to extrude at right angle to the selected face. You will be using this mainly in case of extruding multiple faces together. And the next one is the extrude individual tool, in which the extrusion take place in such a way as if multiple faces were being extruded individually along their own normals. And now let's explore the last one, that is extrude to cursor. So first let's delete this and add a new cube in its place. Let's go to the edit mode and select this face. Let's go to the extrude menu and select extrude to cursor. Now if I simply left click anywhere in the viewport, then the selected face will be extruded to wherever I click using the mouse cursor. And now the most important thing is that in most of the cases, like more than 90% of the cases, you will be using the normal extrude region tool only to extrude your faces or vertices. So even if currently you can't learn all different extrude modes, you do not need to worry, because these things will get in your mind only when you practically make something in Blender. And our next chapter is gonna be completely on modeling of different objects only, so we'll be using all these tools there also. And now let's come to the next tool, that is inset faces. So inset faces is used to create new faces inside a selected geometry. To understand this, first I'll delete this and add a new cube in its place. Now let's go to the edit mode and I'll deactivate the extrude mode, and now I'll select this face. So to insert this face, press I on your keyboard and move your cursor and left click to finalize. So by using this tool, we basically created a smaller face on the face that we selected, and it can be used to make many cool things, like if I press E to extrude it and left click, and now if I press I again to insert this face, press E to extrude and again I to insert, and I can also extrude this face inwards, like if I press E and take it backwards, then the face will get extruded inwards. And if I want the face to be outwards, then I'll press G to move it and in Y direction, and it will come outwards like this. Now the next tool is the bevel tool. So this tool basically helps to make the edges look curved or rounded. Let's try this with the help of an example. So I'll switch to the edge select mode by pressing 2 and I'll select these two edges. Now to apply the bevel tool, press Ctrl plus B and slightly move your cursor away, and now use your scroll wheel of the mouse to scroll up, and this will increase the number of segments. Now left click to finalize, and we observe that these edges now look much curved and rounded, and so that's what the bevel tool does. And now the next thing is the vertex or the edge loop selection. So let's come out of the edit mode and delete this, and I'll add a cylinder. Let's tab into the edit mode. Now I'll deselect all these edges, and suppose I want to select all the edges at the top now. So one way to do this is to select one of them and then press shift and select each one individually. But this one is too much time consuming, and so the shortcut to do that is to press Alt and select any one of them, and the entire edge loop will get selected. Now the next tool to explore is the loop cut tool. So suppose I want to add more edge loops in this cylinder. To do this, I'll press Ctrl plus R, and now I'll move my cursor towards the cylinder. Now I can use my scroll wheel to increase the number of cuts or to decrease them, and to finalize the selection I have to press left mouse button, and now I can move them based on the location that I want. If I want them to be at the center, then I have to press right mouse button. Similarly, if I want to add one more edge loop here, I'll press Ctrl plus R, and now I'll left click, and if I drag it upwards and then left click again, then this position will get finalized instead of the center one. And now the last tool is the rip region tool. For this, first I'll delete this cylinder and I'll add a cube in its place. Now let's tab into the edit mode and select the vertex mode by pressing 1 on your keyboard. Now you can see that these three edges here are connected to each other with this single vertex, and to rip it apart we use the rip region tool. So to activate this tool, we have to press here rip region tool, then I'll select this vertex and I'll drag it away in a way that it rips apart. Similarly, I can try it for this one also. So it basically opens up the cube by disconnecting the vertices that were joined together. And now we have explored all the basic tools in Blender. Before ending this, I want you to analyze yourself. If you understood over 60% of all the concepts explained today, then it's definitely very good, because the remaining 40% would be cleared when we will model various objects in our next chapter. But if you feel that you couldn't even understand 60%, then I would request you to either rewatch the video and only understand what I'm showing and telling you, or else you can also watch the selected part again where you feel that your confidence was a bit low. And so that's all for this chapter. Now in this chapter, we'll be modeling these three objects in Blender, and in this way we'll revise the concepts that we have learnt in this course till now. So let's first start with this model of chair. So let's begin with it. First I'll delete this default cube by pressing X. Now I'll go to the add object menu by pressing Shift plus A, and whenever you're modeling something, the first thought that should come to your mind is that which mesh type or object should be edited so that we can model our required object. For example, if you were to make a model of a planet or sun, you would be using a UV sphere because its shape resembles and it can be easily edited to make the required object or the model. Now for this chair, the best object that can be edited is cube only, so I'll add this in my 3D viewport. Now I'll tab into the edit mode. With all the vertices selected, I'll scale this down in the Z direction. This will become the seat of the chair, so we need many more vertices in order to edit this. For this, we'll add some loop cuts by pressing Ctrl plus R, then left click and right click to finalize it. and then go here where it's written loop cut and slide, and you can increase the number of cuts from here. Let's set it to 6. Now again I'll apply a loop cut in this direction, left click and then right click so that it takes the default center position, and increase the number of cuts to 6. Now I want you to understand two basic things. First is why I applied loop cuts. So for editing any object you need multiple vertices, and to create more vertices you have to add loop cuts. Also always remember that better or more detailed the object you want to create, the more number of vertices are required. The second thing is that always edit your objects in edit mode only. Even if you can do basic stuff like scaling in object mode, but it's always advisable to edit only in the edit mode. Now let's make the legs of this chair. For this we'll switch to the face select mode by pressing 3, and we'll select these 4 faces. So with the shift key hold it, select this face, this one, and this one. And now we'll extrude these faces by pressing E and dragging them, and left click to finalize. And now we'll press S to set them a little apart from each other, and in this way we'll also scale up the bottom faces. And now to make the back of the chair we'll select these 7 faces. For this I'll select this face and keep pressing Ctrl and select this face. This will basically select all the faces that lie between these two faces by picking the shortest path in between them. And this tool is called the pick shortest path tool. Let's practice it once again. So I'll deselect these faces. Now let's select this face and keep holding Ctrl button and then select the last face. So that's how the pick shortest path tool works. Now to make the back we have to extrude these faces in the Z direction, and to make them look a bit more comfortable we'll press G to move them, and let's move them back by a few centimeters in the X direction, and left click to finalize. Now we'll delete these middle faces at the back of the chair so that it looks like this. For this press 3 on your numpad to see the front view of the chair. Now if I'll try to delete these faces by the regular method, then we won't get the desired results. But still let's try to do it using this regular method only so that we can understand where it goes wrong. So enter the X-ray mode by pressing Alt plus Z and select these faces here. Press X and select faces to delete them. Now turn on the X-ray mode by pressing Alt plus Z. And now we observe that there are these empty spaces in between that were basically created because the cube was empty from inside in terms of volume. And to avoid this we'll use a new tool that is known as Bridge Edge Loop tool. But first let's undo this using Ctrl plus Z. And to access this tool you have to go to Edge here and select Bridge Edge Loops. And now you can observe that the faces got deleted without leaving any open edge loops or empty spaces in between. So the tool that we use, that is the Bridge Edge Loops, it basically works to join a series of adjacent edge loops, and it is an advanced tool which is used for modeling objects. And the condition for using this is that the edge loops should have same number of vertices. For example, in this case the front face had 4 edges and the back face also had 4 edges. So when I selected both the faces and applied Bridge Edge Loop tool, it worked and joined the two selected edge loops. Now let's do the same for other faces as well. So let's select this face, and with shift key hold it I'll select this face. Now go to edge and select Bridge Edge Loops. Then I'll go for this face, and with shift key hold it let's select this face. Then go for edge and Bridge Edge Loops, and now it looks fine. Now to make it look better let's select these faces from here and press Ctrl key and select this face, and we'll extrude these faces by pressing E and left click to finalize. And also let's scale them up a little bit. Now let's switch to the edge select mode by pressing 2, and we have to select all the edges except the top ones. And the best way to do this is to enter the X-ray mode by pressing Alt plus Z, select all these vertices that we didn't want. And now to invert the selection we have a tool called Invert Selection tool, and to use this tool we have to press Ctrl plus I. So basically it will select all the edges that were not selected and will deselect the ones that we selected, and that's what the invert tool does. Now we'll apply the bevel tool on all the selected edges so that they look more rounded, curved and a bit natural. For this I will press Ctrl plus B and slightly move my cursor away and left click to finalize. Let's increase the number of segments from 1 to 3 and click anywhere else to deselect. And let's switch off the X-ray mode by pressing Alt plus Z. So now it looks like a real chair. So let's tab into the object mode, press right click and shade smooth. Now we can also render this image, but before that let's apply some colors to it. So I'll go to material preview and go to this material tab here, press new, and let's choose the base color from here. We'll decrease the brightness to get some brown color. So let's adjust it. Now it looks good enough to render. So I'll press 0 for camera view. Now to lock the preview to the camera mode, we need to toggle the sidebar. So let's press N to toggle it and go to view and click on lock camera to view. Now if I scroll down, the chair is completely visible in the camera view. So first let's go to the rendered preview mode, and it looks like there should be more lighting. So I'll select this light and I'll increase the power of this light to around 5000. And also let's create a duplicate of it by pressing Shift plus D, and let's move it in Y direction and left click to finalize the location. Also we should add one more light at the back. So I'll press Shift plus D again and right click. Now I'll press G and move it in X and Y direction simultaneously by pressing Shift plus Z, and now I'll move it at the back. Let's move it down in the Z direction. Now I'll press G and X to move it in X direction. Now I'll move it in Y direction. So you basically have to adjust the lighting according to what suits you or what looks the best to you. And also one of our upcoming chapters will be completely based on lighting, so we'll understand everything about the lighting, its types and other things in that particular chapter. So it looks good now, and let's render it by clicking on render, then render image, and that's the final rendered output. It looks decent, and I hope your rendered image would also have been perfect. So now it's time to create the second object on our list, the treasure chest. So I've created this new file, and I'll tab into the edit mode with the cube selected, press 3 for face select mode, and I'll select the top face, and let's bring this face down by pressing G and Z and left click to finalize. And now I'll press A to select all the faces, and let's scale them down in the Y direction, left click to finalize. But I think that we need to scale it up in the Z direction, so with all the faces selected I'll press S and Z and let's scale them up. Now I'll select the top face and scale it up a little bit more and left click to finalize. Now to make the top part of the chest, we'll extrude this face and left click, and let's scale it down and left click again. Now let's bring this face a little bit down by pressing G and Z, and this much looks good. And if you're doing this along with me on your PC, then it's not mandatory to copy each and every step of mine. You can change the basic dimensions like scaling and other things according to what you think will look the best for your model, and you might end up making something more beautiful than what I'm making. Now we'll select 4 faces, this one, with the shift key holded, this one, also this one, and the last one is this. Now what we're gonna do is to press I to insert, but we'll press I one more time to insert each face individually and press left click to finalize. Now to make this look like a treasure chest, we'll extrude these faces inwards. So the shortcut to get the menu of 5 extrude tools is to press Alt E, and we'll select the extrude faces along normals. Now slightly bring down the cursor till the extrusion looks good and left click to finalize. Now it looks like this. And now I'll switch to the edge select mode by pressing 2. I'll select this edge, and with shift key holded I'll select this edge. Now I'll use the bevel tool by pressing Ctrl plus B, and we'll increase the number of segments by using the scroll wheel and left click to finalize. And now to work on these faces here, I'll press 3 for face select mode. I'll select this face, and with the shift key holded I'll select this face. Now press I to insert and left click. Now we are again gonna extrude these faces inwards, and for that I'll press Alt E, select extrude faces along normals and bring down your cursor a little bit. Left click to finalize the extrusion, and it looks like this. Now we'll tab into the object mode and apply shade smooth by clicking right mouse button and click shade smooth. But we observe that the smoothness is too high, and Blender gives you the option of adjusting the smoothness. So first let's undo it, and now click right mouse button and go for shade smooth by angle, and you can adjust the angle from here. Now higher the angle of smoothness, more is the smoothness applied, and I think around 60° would work in our case. Since it looks very simple, we should apply some colors to it. So let's go to the material preview mode and click on the material properties panel. Now we'll change its color to dark brown. And to make it look better, we'll also change the color of these faces that are extruded inwards. So let's tab into the edit mode. Now we'll select this face, add a new material and click on assign. Now change the color from here. We'll change its color to dark green. So let's take it to green, and to make it dark, let's decrease this brightness slider. Let's tab into the object mode, and the color looks fine. So I'll apply this color to all the other extruded faces also. For this face, I'll select the green material and click on assign. Similarly for this face and for this face. And now we'll change the color of the top faces. So I'll select alternative faces, I'll select this one, then with the shift key holded I'll select this and this one and also this one, and I'll create a new material and let's change it color to gray. So I'll decrease the brightness from here and I'll increase its metallic nature to around 0.4. So let's take a look at it in the object mode. So it looks like this. Let's also change the color of these faces here. So I'll tab into the edit mode, select this face, create a new material, and we'll change its color to red, and I'll bring down the brightness slider. Let's tab into the object mode and it looks like this. Let's increase the brightness slider a little bit. Now we'll assign the same material to the other side. And now to make it look a bit more realistic, we'll tab into the edit mode and press 2 for edge select mode, and to select all the edges I'll press A, and then I'll apply bevel by pressing Ctrl plus B and slightly moving my cursor away and click left mouse button to finalize. Now I'll tab into the object mode and it looks like this now. So it looks a bit more realistic than before. I'll add the before and after images and you can compare the difference between the two. And now we need to model a lock to place at the center of the chest. For that I'll hide this object, but first let's change its name to treasure chest. And now press H to hide it, press Shift plus A to add a new object, and we'll add a cube to make the lock, press S to scale it down. Now for the front view you need to press 1 in the numpad. Now we'll zoom in, let's scale it a bit more. Now to model the top part of the lock, I'll place my 3D cursor over here by clicking Shift and right click. Now I'll add another cube here, let's scale it down and let's scale it up in the Z direction. Now let's get to the side view by pressing 3. Select this cube and let's scale it down in the Y direction. Now we'll select this cube and let's place it here. So it looks like this. Now let's again go to the front view by pressing 1. Let's tab into the edit mode with this object selected and let's apply a loop cut. Let's take it above and press 3 for the face select mode. Now I'll select this face so that I can extrude it and complete the remaining portion. Let's go back to the front view and press E to extrude and left click mouse button to finalize. Let's add another loop cut and I'll select this face here by pressing 3 and selecting this, and we'll extrude this face. And now the basic structure of our lock is ready. Now we'll return back to the object mode and we'll select both of them and press Ctrl plus J to join them together, and we'll rename them as lock. And now let's zoom out and let's bring it ahead in the Y direction so that we can unhide the treasure chest. Now go to the front view and let's scale this down a bit. Let's place it here. Now go to the side view by pressing 3. Now let's move it in the Y direction and we'll also rotate it a bit, and now it looks like this. And let's change its color by clicking on new and let's set the color to blue. Now we'll tab into the edit mode and let's zoom in. Now select this edge, this one by holding shift key, and this one and also this one, and now we'll apply bevel tool on them by pressing Ctrl plus B and increase the number of segments using your scroll wheel and left click to finalize. Similarly we'll do the same with this. We'll select this edge and this one by pressing shift key and press Ctrl plus B for bevel and left click to finalize. Let's come back to the object mode and it looks like this now. And now I think that we should render it. So let's go to the rendered preview mode and switch to the camera view by pressing 0 on numpad. Now we need more lights in our scene, so we'll select this light here and we'll duplicate it and let's place it here. Let's add another light by duplicating and let's place it here. By pressing on this light we can also change its power, or basically the strength of brightness. I think around 800 should be fine. And to lock the camera to view we need to open the sidebar, so press N and go to view and select lock camera to view. Now we can adjust the camera and we'll zoom in, and this looks decent enough to render, so I'll click on render button. And this is the final rendered output of a simple treasure chest. And some of you might think that it looks very basic or very cartoonish, but that's only because we haven't studied materials textures yet. And since this is gonna be a very long course, so I have divided it into such a way that we first understand the basics by creating the basic objects around us, and then we will slowly go to the advanced level. And so now is the time to create the third and the last model for this class, that is this grenade. So I've created a new file and we'll delete this cube. Now I'll add a UV sphere. The reason for adding this UV sphere is that its shape resembles the most with that of a grenade, and there's a small menu here which says add UV sphere, so we'll click it, and from here we can reduce the number of segments or the number of rings, and we can also change the radius from here. So we'll change the number of segments to 16 and the number of rings will also be 16, and let's change the radius to 1. Now let's tab into the edit mode and press 1 for the front view. Then I'll zoom in and let's scale it up in the Z direction. Now we'll delete some of the lower faces, but if I select it like this, then the faces at the back would not be selected. And the solution for this is to enter the X-ray mode while selecting. So I'll select these faces again, and also I'll select the faces at the top by holding the shift key while selecting them. And now I'll tell you one more shortcut to select more vertices if you want. If you want to select more edge loops, then you can do this by holding Ctrl and press the plus button in the numpad, and this will increase the number of edge loops selected. Similarly, if I click minus instead of plus, then the edge loops will decrease. Now we'll press X to delete them and select vertices. Now we'll select this edge loop by holding Alt and pressing left mouse button, and I'll turn on proportional editing by pressing O, and now I'll scale it down. Similarly, I also select this edge loop and scale it down. Also I'll select this edge loop and scale it down. Now let's switch to the face select mode by pressing 3. Select all the faces, and now we'll extrude all these faces to form a shape like this. For this I'll press Alt E, and in this extrude menu we'll select extrude individual faces and slowly move your cursor up so that the faces are extruded, and press left click to finalize. Now it looks like this. Let's switch off the X-ray mode, and this is how our grenade would look like. And now let's apply the bevel tool here by pressing Ctrl plus B and slightly moving away our cursor. Let's increase the number of segments using our scroll wheel and left click to finalize, and so it looks like this now. Now it looks a bit more realistic than before, and now we'll close the edge loops here. So press 2 for edge select mode and press Alt and select the edge loop. Now we'll use a tool called fill tool to fill the space in between, and to access this tool we have to press F, and the space will be filled using the fill tool. Similarly, we'll also go above, select this entire edge loop by pressing Alt and selecting it, press F to fill. Now to make the top of this grenade, we'll extrude this face and let's scale it down a bit. Let's extrude again and again scale it down. And now to make this handle above, or whatever it is called, we'll add a cube here by pressing Shift plus A and select cube, scale this down, press G and Z to bring it up. Let's scale it down in the Z direction more. Now we'll go to the front view. Let's bring it down in Z direction. Let's go to side view by pressing 3 and it looks perfect from here. Let's also scale it down in the Y direction. Now we'll go to face select mode by pressing 3 and select this face. Now we'll extrude this face and rotate it in the Y direction. Now extrude it again and we'll rotate it one more time in the Y direction. And now one more time we'll extrude it. So the basic structure of our grenade is now ready, but let's also scale up this handle from the bottom. Now it looks better. Now suppose you want to select only the handle in this object, but if you press A, then the entire grenade would get selected. So the trick to select the handle only is to press L in your keyboard. This is the select link tool and it helps to select only the object which has the vertices or the edges connected to it. Similarly, if I deselect everything and I take my cursor close to the grenade and then I press L, then only the grenade part would get selected, that is the main body. And if I deselect and hover my cursor over the handle and then press L, then the handle of the grenade would get selected. And now let's apply the bevel tool by pressing Ctrl plus B and take the cursor away a little bit, left click to finalize, and let's come back to the object mode so it appears like this. Now we'll change the colors. So first let's go to the material preview mode. Now let's go to the material panel, add a new color. Let's change the base color to dark green. Now to change the color of the handle, let's go to the edit mode and press L to select the handle completely. Now I'll add a new material and assign the handle this new material. I'll click on new and we'll change the color to gray. And I'll increase the metallic strength of this handle. So let's change the metallic nature to around 0.5. Let's go back to the object mode. And this is how the basic structure would look like. Let's tab into the edit mode again and change the color of this part also. So let's deselect, and now to select the entire face loop, I'll press Alt and then select one of the faces. Similarly, I'll also select this face loop by holding Shift and Alt simultaneously and selecting one of the faces. And now I'll add a new material and I'll click on Assign. And let's change this color to yellow. Let's decrease the brightness from here and let's tab into the object mode. So it looks like this now. Let's apply Shade Smooth by Angle and let's change the angle to around 20. So it looks like this now, and I think it looks decent enough to render it now. And I'll switch to the camera view by pressing 0 on my numpad. We need to increase some brightness, so I'll select the lamp here and Shift D to duplicate, and let's place it here. I'll add another duplicate lamp and let's place it here. Now to lock the camera to the view, we'll press N for the sidebar, then go to view and lock camera to view. Now we can navigate using the camera, and let's set our camera here. We'll zoom in a bit and this position looks good. So now I'll click on render and select render image to render it, and this is our final output. So that's all in this chapter, but before ending this chapter, I would like to give you a task. Try to model the basic things such as cupboard or a refrigerator or any other similar basic object which you can render using your knowledge in Blender that you're having right now. And so let's end this chapter here. So the first advanced tool that we'll explore in today's chapter is the knife tool. But before starting that, there is one more important thing, and that is you would be using these advanced tools in not more than 5% of the cases. In majority of the cases, we would be using the tools which are the basic tools that we have already covered in the previous chapter and in all the other chapters that we have covered so far in this course. So you might think, why to learn them? And the answer to this is simple. See, if you're learning a software, the best thing is to master it completely so that you would be efficient in everything or basically every feature of that particular software. Now let's come back to the knife tool. So the knife tool allows you to create custom edges in any direction on any particular face of your object. And to access this tool with the cube selected, we'll go to the edit mode, and here is the icon for the knife tool, and if I click on it, my cursor changes to a knife. Now to make a cut using this tool, you need to click any of the edges with the left mouse button click, and a green square is created which is basically the vertex. And now we'll click on the other edge, click left mouse button, and we see that a cut is created. We'll also do the same with this edge, press left mouse button and a second cut is created. And to finalize the cuts, you have to press enter. And now if you go to the face select mode by pressing 3, let's turn off the knife tool first. We can select these faces individually now, and also we can edit these faces separately. For example, if I select this face and press E to extrude, then this particular face that we created with the help of a knife tool will get extruded and not the other faces. But always make sure that you start with an edge and end on an edge while using the knife tool. To understand this, let's enable this knife tool again, and I'll create some random cuts from here, and I left click here, here and here. So I made some random cuts on this face, but if I have to finalize my cutting, then I can't leave it here. I have to end it on one of the edges, like this can be an edge, this is an edge. So I'll click left mouse button to finalize, and to exit it I have to press enter. Now I'll disable the knife tool So always remember that while using the knife tool, you have to start with an edge and end on an edge. Now, the knife tool has 4 options which are pretty helpful in modeling complex bodies. But to use these options, we must enable the knife tool with its shortcut key only. And so the shortcut key for enabling the knife tool is to press K on your keyboard, and the tool is now activated. And suppose you want to come out of the knife tool before selecting anything here, then you can do this with the right mouse button click. Now, the first option in the knife tool is the midpoint snap. For this, press K to enable the knife tool. So to use the midpoint snap option, you have to hold the shift key, and now if I hover over any of the edges, then it will automatically snap to the center of the edge. So if I left click here and with the shift key holded, I take my cursor to this edge, then it will snap to the middle of the edge here. And if I left click, then it will create a cut here. And to finalize the cut, I'll release the shift key and press enter. So basically it will help you when you need to work more precisely, and the cut has to be exactly in the middle. So that's the use of the midpoint snap option in the knife tool. Now the second option is the ignore snap option. For this, press K on the keyboard for knife tool. Now suppose I want to create a cut not from the edge but somewhere very near to it, like from here, but it would automatically snap the cut to the nearest edge if I try to create a cut very near to that edge, which I don't want to happen. So here we will use the ignore snap option so that it does not automatically snap to this edge. And to enable this option, hold Control, and now if I try to create a cut very near to this edge, it won't snap to the nearest edge and the cut is created. To finalize, release the Control button and press enter. But as I already told you, this tool must start from an edge and end on an edge, so it would automatically connect my cut to the nearest vertices. So this was the ignore snap option, using which you can create a cut which is very near to the edge and it won't snap automatically to the edge which is near to it. Now the next option is the angle constraint. First, let's come out to the object mode, press X to delete this and add a new cube in its place. We'll tab into the edit mode. Now let's go to the front view by pressing 1 on the numpad. And now to understand the angle constraint option, press K to enable the knife tool, and for the angle constraint, press A. Now if I left click anywhere and drag my cursor, then this straight line would appear, and if I move my cursor away, then this line would rotate at angles of 30 degrees, and that's what the angle constraint tool does. It allows you to create precise cuts by giving you the option to cut at specified angles. Now suppose you don't want the angle to be 30 degree but to be like 10 degrees or 45 degrees or anything else. For that, you can type that specified number. For example, if I want it at 10 degrees, then I can type 10, and now if I move it, then it will move at angles of 10 degrees. Now suppose I want to create a cut from this point to this point, so I left click on this point here, and now I'll move my cursor there at that point. Now I'll left click here also, so this would create this precise cut, and now I'll press enter to escape the knife tool mode. So the angle constraint option allows you to create a cut at any specified angle. You just have to type in the angle after pressing the A button, which is for the angle constraint option. And the last one is the cut through option, and for this we'll press K for the knife tool, then press C to enable the cut through, then press left click from here to here, and again click left mouse button, and now we can see that it has created a complete cut even on the faces that I couldn't see from that angle before. And now I'll press enter to exit the knife tool mode. So that's what the cut through tool does, and now we have completed all the options in the knife tool. And now the second tool for this chapter is the bisect tool, but before that I'll tab into the object mode and press X to delete it, and I'll add a UV sphere in its place. Now for the bisect tool option, you have to tab into the edit mode, then click here for around 2 seconds, and you will see a menu where it's written knife and bisect. So we'll go for the bisect tool, and to see what it does, we'll left click here and drag a mouse cursor like this and release the left mouse button click. So it has basically made a loop cut around the UV sphere, and you may also notice this gizmo that is here, and if I left click and move it, then it would allow me to move this loop cut. Or else you can also click on bisect that is written here, and from here you can change the location and even the rotation of your loop cut. And if you click on the clear inner option here, then you will get rid of the mesh that was opposite to the direction pointed by this gizmo. And if I turn it off, and if I click on the clear outer option, then we'll get rid of the mesh which was in the direction where this little gizmo is pointing. And with one of these two options, that is clear inner or clear outer selected, if I click on fill, then it will create a face along the loop that was used to bisect the object. And now it's time for the third and a very simple tool in Blender, the spin tool. For this, I'll delete this UV sphere and we'll add a cylinder here. Let's rotate it in X axis by 90 degrees and press 3 in the numpad for the side view. Now we'll tab into the edit mode. Let's scale it up in Y direction. Now suppose you want to make a pipe out of it that goes from here and like this. In that case, we have to use the spin tool, and to access the spin tool you have to click here. Now we'll select the vertices on this side, and here you can see a little gizmo which basically tells you about the direction in which the spin tool will work. And also we notice that all the vertices are not selected, so let's select all of these vertices. And to change the direction of this spin tool, we can click on here X or Y or Z, but for our purpose we would need it in X direction. Now we'll go to the side view again by pressing 3. Now before using the spin tool, we have to place a cursor over the pivot point as per the direction in which the spin tool is required to work. So we'll place our 3D cursor over here by pressing shift and right mouse button. And now if I click on any of these plus symbols and drag it like this, then the spin tool will begin to work, and if I release it and press E to extrude the face, then we see that it has made this pipe-like structure. So that's how the spin tool works in Blender. And now the fourth tool on our list is Edge Slide and Vertex Slide tool. For this we'll tab into the object mode and we'll delete this pipe object. Let's bring back cursor to the world origin by pressing Shift plus C. Now we'll add a cube here. Let's tab into the edit mode and press 2 for the edge selection mode, and we'll select this edge. Now suppose I press G and try to move this edge, then it will move like this. But it might be possible in certain cases that I do not want to move it like this, but I only wanted to slide it along the faces, and that's where the edge slide mode comes into play. For this, double press G, and now if you try to move the edge, then you will notice that it is not moving away and it is only sliding or basically moving along the faces, and that's how the edge slide tool works. It basically restricts the movement of a particular selected edge by sliding it along the faces of the particular object which are adjacent to it. And to finalize, we left click, and the same is available for the vertex also. So press 1 for the vertex mode. We'll select this vertex. Let's zoom in a bit, and if I press double G, then instead of freely moving it, it will basically slide it only along the adjacent edges, and this is the vertex slide tool, and you have to press left click to finalize. And now the last tool on our list is the shrink flatten tool. So let's come out of the edit mode, press X to delete this. So to understand this, the object that we are going to add is the monkey or the Suzanne model. Now let's tab into the edit mode and press 3 for face select mode. Now select some of the faces from the top. Let's select these two faces, and to enable the shrink and flatten tool, you have to click here. So I'll press on this icon. Now if I drag this gizmo upwards, we observe that the two faces get expanded or flattened up. Similarly, if I left click and bring this down, then we observe that the faces will get shrink, and that's what the shrink flatten tool does. Moving this gizmo upwards will flatten or expand it, and moving this downwards would shrinken it. And this brings us to the end of all the advanced tools in Blender. I hope you like this chapter. Now let's come back to Blender, and our topic for today to understand is what exactly are the modifiers and what can you do with them. See, theoretically modifiers are some sort of codes that apply some algorithm or process to an object, and thus the properties and looks of the object changes. But practically speaking, modifiers are simply some editing tools which allow you to do things in seconds which might otherwise take you several minutes, and also in a much better way. Now to access the modifiers, you have to click on this tools icon here, and this is the modifier properties editor. And by clicking on the add modifier option, you can add any modifier from the lists here. So as you can see, there are these 4 categories of modifiers. The first one is the edit modifier, second is generate modifier, then deform modifiers, and the fourth is physics modifiers. As for the first group, the edit modifiers, it basically includes some advanced modifiers which do not affect the shape of your object but rather other data such as vertex groups. But we won't be discussing about them right now at this point because understanding them would require some more concepts to be covered in this course. So we'll be discussing these in some future chapter of this course. And the next two are the main and the most important modifiers in Blender, that is the generate and the deform modifiers. The generate modifiers contain a list of these 18 modifiers, and we'll be discussing all these in detail in the very next chapter, that is chapter number 11. And next, the deform modifiers have this list of 16 modifiers which we will be covering completely in the chapter number 12 of this course. So the upcoming 2 chapters would be covering a total of 34 modifiers in complete detail. And now the last one is the physics modifiers, which include simulations like fluid, clothing, etc. And each one of these topics is so complicated that every modifier has to be covered individually in detail. So we'll be covering all these one by one in our future chapters of this course. But before ending this chapter, let's try to understand what modifiers actually do with the help of an example. So we'll be taking the example of array modifier. For this, go to add modifier, then generate, and then array. Or else you can also click on the search menu here, then type array. Although we haven't understood what this array modifier is, but we are just gonna use it to see what happens when applying a modifier. So no worries, as this modifier as well as all the other modifiers will be covered in complete detail in the next chapters. So let's click on this generate array modifier, and we see that a duplicate of this cube is created, and that's what this particular modifier does. It allows us to create duplicates of an object in any number, which you can change from the count option here. Like if I increase the number of duplicates of this object will increase, and to make some gap in between the duplicates, we can increase this X factor from here, and in this way the distance between the duplicates will increase. So with this you can understand how modifiers actually work. While you could have just selected the individual object and duplicated it using the Shift plus D shortcut, the much better or a quicker way to do this is to use array modifier. Similarly, all the other modifiers also do operations which help us to save time and edit the object in a very efficient way. And so that's all in this chapter. So in the previous chapter, we understood the fundamentals of modifiers and an overview of their categories. And in this chapter, we will be discussing about these 18 modifiers in the generate modifier category. We will be understanding the working of each one in detail. So let's begin with it. Now the first modifier to start with is array modifier. For this, let's first delete this cube by pressing X, and now we'll add a monkey or Suzanne model. So to add the array modifier, with the Suzanne model selected, go to the modify properties editor, click on add modifier, and in the generate category select array modifiers. So basically what this array modifier does is that it creates copies of the object by placing the copies in an array with each copy offset from the other. To increase the number of duplicates or the copies of the object created, we can do it using the count button here. So we can increase the number of duplicates from the count option here. Now by default, this relative offset option is turned on in the array modifier, and the relative offset means that it uses the overall size of the object as a reference for determining the distance of the displacement between the arrayed items, which means that if I increase the x factor, then the offset, or basically the distance between the duplicates or the copies of the object, will increase like this. Similarly, if I increase the y factor, then they move in y direction like this. Similarly, decreasing them also would move them in y direction like this. Now suppose I want to move it upwards in z direction, then I can change the z factor from here, and I will increase it like this. Now if I go to the side view by pressing 3 on numpad, or maybe Ctrl plus 3, and if I zoom in, here we can see that each one of these is separated by an equal distance from each other. Similarly, if I press 1 for the front view, then from this perspective also, the distance between each of the copies is same, and that's how the array modifier works. Now let's change the z factor to 0 and also the y factor to 0. Now there is one very interesting option in array modifier, and that is object offset. So basically in this option you can add any other object as a reference, and whatever we do with that particular object like rotating or scaling will also apply to these arrayed items. For this, let's turn off the relative offset option and turn on the object offset. Now click on this little arrow here. Here we need to add an object which would act as a reference. For this, let's add a UV sphere here, and let's place it in X direction. Let's deselect the Suzanne model, and you can select this UV sphere as the object by clicking on this eyedropper and then selecting the UV sphere. Now to see the results, we have to select the UV sphere, and now if I rotate it like this, then the arrayed items would also begin to rotate. But one thing to notice is that the original object, that is this one, would not show any transformations, but all the other duplicate objects would show it. For example, if I scale it, then all the arrayed items would also scale up, but you will observe that this one scales the most in comparison to this one. Similarly, this one will scale up more in comparison to this one, and the same for others. So the original one would not show any effect, and then the effect keeps on increasing. And so that's all in the array modifier. Now the next modifier on our list is the bevel modifier, but before that, let's clear it all by pressing A and press X to delete. And now let's add a cube by pressing Shift plus A and select cube. To see how the bevel modifier works, let's apply the bevel modifier to this cube. For this, we'll go to add modifier, then generate and select bevel. We see that the edges of this cube have been beveled. It's the same bevel that we also apply using the Ctrl plus B shortcut when we are in the edit mode, but it's mostly better to apply it using this modifier. And the reason for this is that suppose you would have edited this cube and applied bevel, and if you're working on a big project, then undoing that bevel is not possible. But in case you have applied this modifier to apply the bevel, you can easily remove this bevel effect by clicking on this crosshair. This would remove the bevel modifier, and it also works with all other modifiers, and that is the biggest advantage of modifiers. Normally in edit mode, whatever changes you make cannot be undo after a particular point of time, but modifiers always give you the option to remove them unless and until you apply them by clicking on this arrow and clicking apply. But in most of the cases you won't apply them, because even without applying it would show you the results. Similarly, you can also apply bevel to the vertices by clicking here, and now you can increase the amount from here, and you will notice that the vertices are now beveled, and you can even change the number of segments from here. So let's increase the number of segments. So now our cube appears something like this, like a dice. So these are the two options available in bevel, the vertices and the edges. So you can apply any of these based on the shape that is required by you. And now the third modifier on our list is the Boolean modifier. So the Boolean modifiers are used to create shapes by adding or subtracting one object from the other. For this, first let's delete this cube and add a new cube in its place, and let's also add a UV sphere and move it up in the Z direction like this. Now with this cube selected, click on add modifier and select Boolean. Now this has three options: intersect, union and difference. And by default the difference one is selected. In the object, we'll click on the eyedropper and select this sphere. In this operation, the part of the Boolean object overlapping with this selected object will form an empty space in it, or basically that area would get removed from the selected object. To see what it does, we have to apply it first. So we'll click on this arrow and click apply, or else you can also click Ctrl plus A to apply it. Now if I select this UV sphere and move it in Y direction, then we see that this UV sphere has created an empty space in the cube, that is the area which was overlapping between the cube and the UV sphere led to the formation of this hollow space. And the reason why this effect was shown only in the cube and not in the sphere is that we applied the modifier to the cube and not the sphere. The object that is selected while adding the modifier is the object on which the modifier actually performs its operations. Now let's undo it by pressing Ctrl+Z to see what the other operations do. Now let's try the Boolean intersect option. So what this Boolean intersect did was, the part of the cube which was intersected by the Boolean object has been separated as a new object. In simple words, the area which was common in between the cube and the UV sphere got separated as a new object. And now let's try the union operation in Boolean, and what this does is that it basically joins the two objects. To see this, let's go to the wireframe mode by pressing Z and sliding towards wireframe. Now if I deselect them and then if I try to select the cube, then the UV sphere will also get selected along with it because they have been joined together. And to select only the UV sphere, you have to click at the common area, that is the intersecting part, and then you can select the sphere. Here selecting the cube will select both of them, or basically the union area of both, and to select the sphere you have to click on the intersecting part. Let's come out of the wireframe mode, and this is how the Boolean modifier works. Just to revise, if you apply difference and click on apply, and then we move this UV sphere in the y direction, then we see that a hollow space is created, that is the intersecting area got subtracted. Whereas if I undo it and use the intersect option, then only the intersecting part of the cube will remain and the rest of the cube will get deleted or subtracted, and in the union operation both of the objects will get joined together. Now the three modifiers that we have discussed till now, that is the array modifier, bevel modifier and the Boolean modifier, these are the most important three modifiers that you would be using in the most of the cases. So if you still have any doubts, then you can either rewatch that section or you can write the doubts in the comment section. Now let's move to the fourth modifier, that is the build modifier. So let's delete this first by pressing X, and this one also, and now we'll add a cube here. First, let's understand what does build modifier do. So the build modifier creates the effect of something building linearly over a period of time. Although any object can have a build modifier, but to see a nice effect, a high vertex count is required. That is, your object should have a high number of vertices. For this, let's tab into the edit mode. Let's scale it up in Y direction, and let's subdivide it by right mouse button and click subdivide. And to increase the number of divisions, click here where it's written subdivide and increase the number of cuts from here. Let's change it to 8. And now to see the functioning of the build modifier, let's tab into the object mode, click on add modifier and select build. We see that our object disappeared. Now to see what has happened, click on this play button here, which plays the animation for you. And you will observe that the object is getting reconstructed, and that's what the build modifier do. It creates an animation effect of the object building over time. By default, it starts from frame 1 and ends on frame 100. Now, although we have not covered animation yet, but you can understand it in this way that by default, 24 frames together comprise 1 second of animation, and this animation started from frame 1 and the length was 100. So it ended after 100 frames. So the animation was around 4 seconds. You might understand it better when we learn animation properly, but you can try this effect with different types of objects. You just need to select an object, apply the build modifier and press the play animation button to see the animation effect. Now the next modifier on our list is the decimate modifier. To understand the decimate modifier, first we have to delete this and let's add a Suzanne or the monkey model here. Now let's tab into the edit mode and let's subdivide so that we can increase the number of vertices in it. Let's set the number of cuts to 2. Now we can see that there are a lot of vertices in our Suzanne model. Now if I tab into the object mode and suppose I want to decrease the number of vertices or the faces in this model, so this can be done by using the decimate modifier. So let's go to add modifier. In the generate section, go to decimate. Now this ratio bar here represents the vertices or the faces in your model. If it's set to 1, then it means that it has the original number of vertices or the faces in it. But suppose I reduce it to like 0.02, then we observe that the number of vertices or the number of faces in this model has decreased drastically. To see its effect in the edit mode, we have to apply this modifier. Now if I tab into the edit mode, we observe that the faces have been triangulated. That is, the number of vertices forming the faces is just 3. So it triangulated the faces and reduced the number of vertices and the faces of our model. And that's what the decimate modifier do. Although in most of the cases you won't require the use of this modifier. However, if you are modeling something and in between you feel that the number of vertices or the number of faces should be reduced, then you can use the decimate modifier. And now the next modifier on our list is the edge split modifier, which basically allows you to split an object apart by selecting vertices, edges or faces. To see how it works, let's delete this and add a cube in its place. Now go to add modifier and in the generate modifiers, select edge split. Now we have to apply this modifier. For this you can either click on this drop arrow and then select apply, or else you can also use the shortcut Ctrl+A to apply this modifier. Now to see its effect we have to tab into the edit mode. Now if I select any one of the vertices and try to move it, we observe that it basically got ripped apart, or in other words, selecting the vertex will allow the corner to be lifted or moved. Now it's very similar to the rip region tool that we explored in our previous chapter. Now suppose I select this vertex and press G to move, then the same will happen to this also. Similarly, all the other vertices will also show the same effect. Now if we undo by pressing Ctrl+Z and press 2 for edge select, now if I select this edge and press G and try to move it, then we observe that this edge also got ripped apart. And so this is what the edge split modifier do. You can see here that selecting the edge would basically open this face like we open the lid of a box. Similarly, if I press 3 for face select mode and select this face and try to move it, then we observe that it basically got separated from the remaining object. However, this face still remains the part of the object even though it is separated. So this was all about the edge split modifier. Let's tab into the object mode now. And now the next modifier that we'll explore is the mask modifier. First let's delete it by pressing X and let's add a UV sphere. Now the mask modifier allows you to limit what part of a mesh displays in 3D view editor or what part renders, and the part of the mesh is defined by a vertex group. Let's understand this with the help of example of this UV sphere. For this, first tab into the edit mode, press 1 for vertex select, and now we need to create a vertex group. Now you might think, what exactly is a vertex group? So vertex group is simply a group of some vertices. Suppose I select some random vertices here, then click on this triangle icon which represents the object data properties, and here you can find the option of vertex group. If I click this plus icon, then it will create a new vertex group, and if I want these vertices to be a part of this group, I'll click on assign, and now if I deselect these vertices and suppose I want to select the same vertices again, so with this vertex group selected, I'll click on select and those particular vertices will get selected. So basically this group consists of all these vertices. Now let's apply the mask modifier. So we'll go to the modifier properties editor, click on add modifier, and in the generate select mask. Now in the vertex group option here, we'll add these vertices. So click here and select the group. This group represents the group of these vertices. And if we now go to the object mode, we will see only that part of the sphere which was defined by the vertex group. And if you want to reverse the selection, then you can click on this double-headed arrow, and now we'll see the part of the sphere which was not defined by the vertex group, which means that the part of the sphere that was defined by the vertex groups is not being displayed, and we can see the remaining portion of the sphere. And this is what the mask modifier do. It allows you to limit the part of the mesh which it would display in the 3D view editor or the part of the mesh which will be rendered. So that's all in this modifier, and the next modifier in our list is the mirror modifier. For this, let's first delete this, and now let's add a UV sphere in its place. Now the mirror modifier allows the construction or the deformation of a mesh on one side of a center point to be duplicated or mirrored on the opposite side. To understand what it really means, tab into the edit mode and let's go to the top view by pressing 7 on numpad. Now we are going to delete half of the vertices of this UV sphere. For this, let's turn on the X-ray mode by pressing Alt+Z. So let's select these half vertices. Now press X to delete and select vertices. Now this is the half UV sphere. So if we go to the object mode and let's turn off the X-ray mode, and now if I ask you how can you complete this UV sphere, so the best way to do this is to use the mirror modifier. So let's click on add modifier, then go to generate and select mirror. Now our UV sphere is completed. So basically what it does is that it duplicates one side of the mesh to the other side based on the axis that we have selected here. In this case we have selected the X axis. So it created a duplicate along the X axis of our viewport. So you can select your axis from here based on your particular requirement. Now suppose I go to the edit mode, and if I select some of these vertices and try to edit them, like if I press G and move them, then we observe that the vertices on this side also show the exact transformations that we did on the vertices of this side. Basically it creates a symmetry on both the sides. So whenever you are making something which requires exact same symmetry on both the sides of your object, then you must use the mirror modifier. So now let's tab into the object mode, and the next modifier in our list is the multi-resolution modifier. Now the multi-resolution modifier can only be understood after we have learned sculpting in Blender. So we won't be covering it right now in this session. Now the next one is the remesh modifier. For this, let's delete this UV sphere. So to understand remesh modifier, we have to make a structure like this in our scene, and so we'll add a cube, and to make a hole like this in our cube, we'll add a cylinder in our scene and then apply the Boolean difference modifier. So let's scale it down in the X and Y direction by pressing S and then Shift+Z. Now we'll select this cube and go to add modifier. Then in the generate section, we'll first select Boolean, and in the object we'll search for cylinder, and we'll apply this by pressing Ctrl+A. Now if I select the cylinder and if I delete it, then our cube with the hole is ready now. Now let's go to the edit mode, And now we'll see how the remesh modifier works. For this, go to add modifier, then generate and select remesh. Now if you're making something which requires detailed modeling, then you can't work with such low number of vertices. Now some of you might think that you can apply the subdivide to increase the vertices. So if we right click and apply subdivide, then you will notice that the vertices are not properly added in our object. For example, in this area at the top of the face, there are no vertices added. And that's why we use the remesh modifier. So for this, we'll change the mode from voxel to sharp. And now if I go to the object mode and then apply this by pressing Ctrl plus A, and now if I go to the edit mode again, we see that the number of vertices have increased significantly. Now the reason why I went to the object mode before applying the modifier is that you can only apply a modifier to an object when it's in the object mode and not in the edit mode. So now you must have understood that the remesh modifier increases the number of vertices in your object for detailed modeling and evenly distributes them in your mesh. And if I undo it by pressing Ctrl plus Z 2 to 3 times, then you will observe that there are some options here. And the most important one for our use is the octree depth. The higher the octree depth, more will be the number of vertices. But do not increase it to something like 7 or 8 if your PC cannot handle it. So it's always advisable to keep the number to around 4 or 5 for best results, especially if you have a moderate PC. Now let's go to the object mode again and press Ctrl plus A to apply it, and then go to the edit mode again, and the number of vertices are increased. Now the next tool to discover is the screw modifier. For this, let's go to the object mode and delete this. Now we'll add a circle by going to mesh and selecting circle. Now let's tab into the edit mode and press G to move it in Y direction. Now you might observe that this pivot point or the center point of this circle is still at the 3D cursor and has not moved. That's because we moved this circle in the edit mode and not in the object mode. And the reason for doing this is that it will act as the center of the screw that we will make by using the screw modifier. Now we'll add the screw modifier to this circle. So let's go to add modifier, then generate and select screw. And you can also change the axis from here where it's written X, Y, Z. By default, it sets in the Z direction, but you can change it by clicking on Y or maybe X. In X direction, it looks something like this, like a donut, but we'll keep it in Z axis. And you can also change the orientation of the screw by rotating the circle. So if I press R, then Y to rotate it in Y direction, and press 90 degrees so that it rotates by 90 degrees, and press enter, then it looks like this. And we can even scale down the circle and press left click to finalize. Now this looks good to form a screw. Now the screw modifier has many options here. The angle option will change the angle of revolution, so let's set it to around 300, and the screw option will change the offset along its axis, or basically the length of the screw, and iteration means the number of times this would repeat itself. For example, I've kept the iteration to 22 so that it would keep on repeating itself 22 times. But suppose I keep it to around 10, then it would repeat itself 10 times. And if I reduce its length by decreasing the screw value, then now it looks like a screw. So basically this modifier generates a spiral shape by revolving a profile or an object around an axis. And now we'll tab into the object mode, and here we have this option of axis object. To understand this, we have to add another object in this scene. So we'll add a cube, select the screw again, and to add this cube as the axis object, we'll press this eyedropper and select this cube. Now this cube has become the axis object for our screw, which means that this cube will now define the screw axis. For example, if I press G to move it, then you can see how the screw axis is changing itself. Basically the radius and the position of the screw is changing by moving this cube. This is because this screw is taking this axis object, that is this cube, as its reference. Similarly, if I rotate this cube like this, then the screw also rotates with it. And that's all in the screw modifier. And the next modifier on our list is the skin modifier. So let's delete all of them by pressing A and then X. And let's add a plane, and let's tab into the edit mode. Now the skin modifier works the best with stick-like structures. To understand this, let's delete one of these vertices by pressing X on our keyboard. And now you can see that there's no face but 3 vertices here. These 3 vertices are forming 2 edges, but without forming any face because they're not connected to each other. Now let's select this vertex, and we'll extrude this vertex by pressing E and then Y to move it in Y direction, and left click to finalize, and let's move it in X direction also. Now it is a system of 4 vertices that are joined with each other but are not forming any faces, and the skin modifier will create a 3D shape out of them. To understand it better, let's tab into the object mode and apply the skin modifier. For this, I'll go to add modifier, then in the generate we'll select skin modifier. So the skin modifier uses the vertices and the edges to create a skinned surface which helps to define the shape of the object in a better way. As you even saw in this case that we just had 4 vertices in the edit mode, but after applying the skin modifier, it turned it into a complete mesh object. And now suppose I add a cube, and let's move it upwards in the Z direction, and if I apply skin modifier in this cube, then let's see what will happen. So I'll go to add modifier, and in the generate we'll click on skin. So as I already told you that the skin modifier works only on the stick-like structures, so it considered only the edges of this cube, and so it formed this cage-like structure. Now here is this option of branch smoothing, and if I increase it, then it will smoothen the geometry of the object, and that's all in the skin modifier. And now is the time for the 13th modifier of this chapter, the solidify modifier. First, let's delete all this by pressing A and then X. Now to understand how the solidify modifier works, let's add a cylinder in our viewport, and now we'll tab into the edit mode and press 3 for face select. Now let's select this face and press X to delete the face. Now what I'm trying to do is to make a cup from this cylinder, but if I tab into the object mode, you observe that this cylinder is very thin. It requires some thickness to be added to it, and that's where the solidify modifier helps us. So let's go to the modifier tab and let's add a modifier. We'll go to generate and select solidify. Now to increase the thickness of this cylinder, go to the thickness option here and you can increase it, and now you can see that our cylinder has gained some thickness. So basically what the solidify modifier does is that it converts thin walled objects into solid objects. Like earlier it looked like this. That is very thin shape, but after applying this modifier it looks like this. Now it has gained some visible thickness. So whenever your object is very thin and you need to add some thickness to it, you must use the solidify modifier for that. Now the next modifier on our list is a very important one, and it is the subdivision surface modifier. So we'll use the same cup object to see how the subdivision modifier works. For this, let's add the modifier. In the generate section we'll go to subdivision surface, and here you can see that our object looks like this. But one thing to notice is that on this cylinder object there are two modifiers applied. Although we have not finally applied them, but you can still see them in the modify properties editor. And one more thing to notice is that the subdivision modifier is appearing below the solidify modifier in our modifier stack. Basically the modifier at the top takes precedence over the modifier that is below it. So in this case the solidify modifier will take precedence over the subdivision modifier. And if you want to change the order or the precedence, then you can click here and left click and then you can drag it, and in this way you can change the order of your modifiers. So we'll place it below the solidify. Now let's come back to the subdivision modifier. So the subdivision surface modifier basically subdivides the surface of an object by adding vertices, edges and faces, and it helps to give the surface of the object a smoother and a rounded appearance. And all these things are important while you are editing a very detailed object. But you might see here that the cup is not perfectly rounded, and to improve this you have to change the levels viewport number from here. Let's set it to 3 or 4, and now you can see that the cup is much more rounded than before. Similarly, if I increase it to 4, then its shape is improved much more than before. Now this levels viewport means the number of subdivisions it will show in our viewport. However, if you will render this, then you won't get the same results because the render number is not the same as the levels viewport number. So before rendering, you must also increase the render number to around 4 so that you can get the same results. Viewport means the display that you are seeing right now, and render means the final image that is obtained after you click on render and then render image. So now the next modifier is the triangulate modifier, and to understand it we have to delete this cup and let's add a Suzanne or a monkey model. Now right now you can see that each face of this model is made up of 4 vertices here. But suppose you are in a situation where you want each face of your model to have just 3 vertices. And for this you can use the triangulate modifier. So let's go to add modifier, and in the generate section we'll select the triangulate. And now you can see that each face of your model has 3 vertices now. So basically what the triangulate modifier does is that it reduces the number of vertices of each face in your model to a lower number. Now you will be using this modifier in very rare circumstances only, or basically after you have applied subdivision on your mesh model and there is some fine detailing in your model and you want to keep it consistent while you're exporting it or rendering it, then you will require this modifier, but in most of the cases you won't require it. So now let's move on to the next one, which is the volume to mesh modifier. So to understand it, let's delete this and let's add a torus object in our 3D viewport. So a torus object looks something like a ring. Now in simple words, the volume to mesh modifier means that it turns volume to mesh. So at the first place, we need to have a volume in our scene. But as you can see that this torus is just a mesh object and not a volume. To add some volume to this mesh, press Shift plus A and go to the volume and select empty. We will use this empty volume to add some volume to the torus object, and to do this with the empty volume selected, go to add modifier, and in the generate go to mesh to volume. Now the mesh to volume means that it will give some volume to a particular mesh that we will select here. So in the object, click on this eyedropper and select the torus object. Now to see if our torus object has gained some volume or not, we'll hide the torus object, and this camera button here indicates that even if we have hidden this, but it will still appear in our final render. So for now I'll turn off the render display also. Now you can see that even after I turned off the display for torus, you can still see a slight volume of the torus object, and we can increase the density of this volume from here. So if I increase it to 4, then it looks better now, and in this way our torus object has gained some volume. And now to give it some texture, I'll click on add modifier, and in the deform we'll select volume displace to give it some texture, and then click on new, and now you can see that it has some texture. It now has a cloudy texture on it. Now to understand what the volume to mesh modifier does, let's add another object by pressing Shift plus A, and let's add a UV sphere. It's not mandatory to add a UV sphere, you can add any other object. Now with this UV sphere selected, go to add modifier, and now we'll add the volume to mesh modifier. We see that our sphere has disappeared. And now in the object, if I click on the eyedropper and select this volume, then you can see that the new mesh, that is the UV sphere, takes the shape of a volume. And this is what the volume to mesh modifier do. The object on which this modifier is applied will take the shape of a particular volume. But again, you won't be using this modifier very often, but it's always better to understand the fundamentals of these modifiers that you won't be using much often. And so now let's move to the next modifier of this chapter, that is the weld modifier. For this, I'll delete this and let's unhide the torus object and press A and X to delete them. Now everything in our scene is cleared. So let's press Shift plus A to add a cube in our scene. Now tab into the edit mode, press 1 for the vertex select mode and right click to subdivide it, and we'll increase the number of cuts to 3. And now let's tab 1 for the front view. Now what I'm going to do is to basically cut this cube into 2 parts. For this, I'll turn on the X-ray mode by pressing Alt plus Z and I'll select the vertices on the second half. Always remember that whenever you are doing this thing, never select the vertices in the middle, because deleting them would leave you with less than half of the mesh and you don't want that to happen. You need exact half mesh, and so for this, always select only the second half of the mesh. Now I'll press X to delete vertices, and now we have half of this cube. Press A to select all, and let's make a copy of it by pressing Shift plus D and right click, and let's rotate it in Z direction by 180 degrees and move it in X direction. Now suppose I want you to merge the vertices at the center with each other. So how do you do this? So one way to do this is to select this vertex and with Shift key hold it, select the other vertex and then merge them by using a particular tool known as the merge tool. And to use this tool, you have to press M on your keyboard and this will open a merge menu. From here, select merge at center and this will merge the two vertices at the center point, and this can be used to merge all these vertices together one by one, but merging them individually would take a lot of time, and here you can use the weld modifier. So let's turn off the X-ray mode and let's undo this merging by pressing Ctrl plus Z and go to add modifier, and in the generate section select weld. Now what this modifier will do is that it will merge all the vertices that are falling within this distance from each other. So if we slowly increase the distance, then at one point you will notice that our mesh will get completed as the vertices have been merged. And now let's tab into the object mode and we see that our cube is completed. So as its name suggests, the weld modifier basically does the welding of the vertices of a particular mesh. And now the last modifier for this chapter is the wireframe modifier, and it's a pretty cool modifier and a simple one. So we'll delete this cube and let's add a new cube. To see what the wireframe mode does, go to add modifier and in the generate section select wireframe. So basically the wireframe modifier converts a solid display as seen in the solid viewport shading to stick or wireframe display. Or to increase the thickness of these sticks, you can go to this thickness option here and increase it, and now it looks like this. So it's an interesting modifier that you can use if you want to make stick-like structures from your mesh. And so this brings us to the end of this chapter, since we have covered all the modifiers in the generate modifier section. So do tell me in the comments if you like this chapter or not. So in the previous chapter, that is chapter number 11, we discussed about all the 18 generate modifiers, and in this chapter we'll be discussing about these 16 modifiers of the deform modifier category. We'll be understanding the working of each one, so let's begin with it. So deform modifiers basically help us to change the shape of an object without adding any new geometry to it. And the first modifier, after clicking on modify properties editor and then going to add modifier and selecting deform, is the armature modifier. And armatures are used when you're modeling your character and rigging it. Therefore, we will explore this armature modifier in a future chapter of this course when we understand about character creation. And the next one on our list is the cast modifier. But before applying the cast modifier, let's tab into the edit mode of this cube and let's add some vertices to it by subdividing it. So I'll click on subdivide and let's go to the subdivide menu and increase the number of cuts to around 4. Now tab into the object mode. The reason why I did this was that the cast modifier works better when your object has a high number of vertices. So let's go back in the object mode and go to add modifier, and in the deform section select cast. Is now looking somewhat like a sphere, even though it's not perfectly spherical, but it still looks like a sphere. And that's what this cast modifier do. It basically deforms the primitive object such as the cube that we selected here and changes its shape to the shape that is mentioned here. Since here the shape selected is a sphere, so the cube in our scene is deformed to turn into a sphere. And to make it into a perfect sphere, you have to increase the factor from here, and if I click on it and enter 1, then you can see that our object looks like a perfect sphere now. But if you increase the factor beyond 1, then you can see that our object is forming a very odd shape which we don't want. So we'll change the factor to 1 and it will perfectly change its shape to sphere. Similarly, there are also other shapes available here. If I select cylinder here, then it will change to a cylinder. Now let's try to create a simple animation using this cast modifier. To do this, I'll delete this and let's add a Suzanne or the monkey model in our scene. Now go to add modifier and in deform select cast modifier. Now let's change this factor to 0, and at 0 you can see that our model has the original appearance, and you might notice that after this factor value there's a small dot here, and this dot is used for animating stuff. So if I click on this small dot, it will basically add a keyframe at the frame number 1 here, and if I drag this to increase the space of the timeline and take this timeline cursor to around 100, and now if I change the factor value to 1 and if I again click here, then basically what it does is that it will assign the frame 100 this factor value of 1. So if I go on frame 0, then this frame will have a factor value of 0, and if I drag it, then you can see that the factor value is increasing, and at frame 100 the factor value is 1. So if I go to frame 0 and press space to play the animation, then you can see that our Suzanne model is transforming into a shape like a sphere. So you can use this cast modifier to make a simple animation that shows your object deforming into a shape like a sphere or a cylinder or a cuboid, and that's all in this cast modifier. And the next modifier on our list is the curve modifier, but before that let's delete it by pressing X and add a cube in our scene. Now for understanding the curve modifier properly, you need to have a knowledge of the curves also. But currently in this course we have not covered curves, but still we'll try to understand the basics of the curve modifier in this chapter. So press Shift plus A and click on the curve section here and select this Bezier curve from the list. Now we can't see it in our scene, so press G and Y to move it in Y direction. Now it appears like this. Now we'll select our cube and tab into the edit mode. Let's reduce its size in the Z direction and scale it up in the X direction, and right click and select subdivide, and we'll increase the number of cuts to around 9 or 10, and let's tab back into the object mode. Now select this curve, and to increase its size press S on your keyboard. Now select this cube, click on add modifier, and in deform select curve modifier. Now in the curve object here you have to add this curve, so click on the eyedropper and select this curve. Now you can see that our cube object is deformed, and if I now select this curve and tab into the edit mode, and if I deselect, you can see that this curve has two vertices, and if I select one of it and if I press R to rotate it, then you will notice that there are same transformations being applied on this cube also, and this is what the curve modifier do. Basically, this curve modifier uses the shape of your curve to deform your mesh object, and you will understand this in a better way when we'll cover the curves in Blender in the upcoming chapters. So now let's tab back into the object mode, and now the next modifier to explore is the displace modifier. So press A and X to delete all, and now let's add a plane in our scene by pressing Shift plus A, and in mesh select plane. Let's tab into the edit mode and let's subdivide it and increase the number of cuts to 8 or maybe 16. Now what I'm gonna do is that I'll select some of these vertices, some random vertices, and make a vertex group. Now we studied about creating a vertex group in our previous chapter, so click on this icon which will open the data properties editor, and in the vertex group section click on this plus icon to add a new vertex group and click on assign. This would create a group of all these vertices in this vertex group. Now if I go to the object mode and if I click on the add modifier, and after that if I go to deform and select displace, we see that the entire plane object is displaced upwards, and you can control this with the strength option here. But this is not the real use of this modifier, because you can use it to displace your vertices in a vertex group as per a particular texture. To see what it really means, click on this vertex group option and select this group. So basically what it did is that it displaced the group of vertices that we created, and with the strength tool you can change the displacement of these vertices. Now suppose I go to this texture tab here, and if I create a new texture and let's change its type to noise. Now you might be thinking that we have not covered textures yet, we don't know what texture is. So you don't need to worry about that, because we'll be covering textures completely in our upcoming chapters. But for now let's just see what happens on applying a texture. And so now let's go to the modify properties editor, and if I now try to change the strength, then you will notice that the vertices are getting displaced as per the texture we have applied. Let's set this mid-level to 0, and now you can try testing this strength option. For those of you who are new to this Blender software and have not worked with textures yet, it might be difficult to understand this displace modifier, but later on when we will cover textures completely in this course, then you will completely understand every concept of this displace modifier properly. And now is the time for our next modifier, that is hook modifier. And this one is a simple modifier. So let's press X to delete this, and let's add a new cube in our scene. Now tab into the edit mode, and to understand what a hook modifier is, we have to select one of these vertices, and to apply this hook modifier there is a special shortcut available. Press Ctrl plus H, and from this menu select hook to new object. Now if we go back to the object mode, we notice that apart from this cube there is this empty object also created. Now this empty object does not have any volume, it just exists in our scene, and if I select this cube then you can see that this hook modifier has been applied to it. And to see what it does, select this empty object, and if I try to move it, then we notice that the vertex that we selected will also start displacing with it. And all this is happening in the object mode. And if I left click, then my object will get deformed. And that's the use of the hook modifier. The hook modifier allows you to manipulate or animate selected vertices of a mesh while in the object mode. The vertex with which this empty object was hooked will also move when you press G and try to move it. And that is the complete use of hook modifier. And the next one on our list is the Laplacian deform modifier. So press A and X to delete all. Now this Laplacian modifier is a very interesting and a very useful modifier. So let's understand it by adding a cube in our scene. Tab into the edit mode and right click to apply subdivide, and let's increase the number of cuts to 3, or maybe let's increase it to something like 8. And now to see how the Laplacian modifier works, we need to connect hook to this corner vertex. For this, with this corner vertex selected, I'll press Ctrl plus H for the hook menu and I'll select hook to new object. Now this vertex has a hook attached to it. Similarly, I'll do the same with this one also. Press Ctrl plus H and select hook to new object. And with this one also, Ctrl plus H and select hook to new object. So I've done it with 3 of my corner vertices of this face. Now if you want to select any individual hook, then you have to press Ctrl plus H and go to select hook and select that particular hook. For example, if I select this hook, then this one got selected. Similarly, I press Ctrl plus H again and I'll select the second hook, and Ctrl plus H for the third hook also. And here you can see the modify section that there are 3 hook modifiers applied for the 3 individual vertices. And now we'll create a group of these 3 hooks by pressing Ctrl plus G and then click on assign to new group. And now if I go to the modify section and click on add modifier, and in deform I'll select Laplacian deform. Now I'll scroll down and in the anchor weights we'll select that group of hooks. Let's tab into the object mode and now we'll click on bind. So let's see what it does. If I select this hook and press G to move it, then I observe that the object is also getting transformed. And similarly, if I select this hook and try to move it, then it also does the same thing. That is, the object is getting transformed here also. And this is the use of the Laplacian deform modifier. So in this way, you can use these hooks to deform the cube or any other object that you want to animate. And that's all in the Laplacian deform modifier. And now the next one that we'll see is the lattice modifier. By using the lattice modifier, you can easily deform your object, especially if it has a large number of vertices. So press A and X to delete this setup, and let's add a sphere in our scene by pressing Shift plus A and select UV sphere. Let's move it in X direction like this. The reason for choosing this UV sphere is that this UV sphere has a high number of vertices, which is a basic requirement of using the lattice modifier. Now to use this lattice modifier, we need to add a lattice in our scene. So press Shift plus A, and here you can find the lattice object. So click on lattice, and this is what a lattice looks like. Now we'll select our UV sphere, click on add modifier, and in the deform select lattice. Now in this object section, click on this eyedropper and select this lattice here. Now this lattice has been assigned to this sphere. So we'll select this lattice and let's move it in X direction like this, and let's scale it up. Now with this lattice selected, if I tab into the edit mode, and now if I select one of its vertices from here and try to move it, you will notice that the UV sphere will also show the transformations. And this is how the lattice modifier is used. Basically, if you will notice, all the deform modifiers will help you to change the shape or structure of your object or your mesh very easily. Like in this case, with this lattice object, you just need to select your vertices and move them around, and your object will also transform. And so that's all in this lattice modifier. And the next modifier on our list is the mesh deform modifier. So the mesh deform modifier deforms your mesh with a cage mesh, and it is very similar to a lattice modifier, but instead of being restricted to the regular grid layout of a lattice, a cage can be modeled to fit around the mesh object being deformed. And to see what it really means, let's go to the object view and press A and then X to delete all objects. And now let's add a Suzanne or the monkey model in our scene, and to make a cage around it, let's add a cube. Let's turn on the X-ray mode to see both the objects properly. Let's tab into the edit mode with the cube selected and scale it up in X direction so that it completely covers the monkey or the Suzanne model. And let's subdivide this cube 2 to 3 times so that it would be easy to deform our monkey or the Suzanne model. Now select the Suzanne model, go to add modifier, and in the deform section, select mesh deform. Now we need to add this cube as the object here. So click on this eyedropper and select this cube, and you have to click on bind. It might take 1 or 2 seconds based on your PC, and then it will show unbind here, which means that both the objects are binded with each other and the mesh deform will work now. So let's select this cube, tab into the edit mode and select some of the vertices from the top face. And now if I try to move them, let's see what happens. So I'll press G and try to move them, and you can see that our Suzanne model is also deforming. And this is what the mesh deform modifier does. It allows you to create a cage around your object, and then you can easily edit your object shape or structure with the help of the vertices of this cage. Because whatever transformation you do to this cage, or basically its vertices or edges, The same transformations will also apply to the Suzanne or the monkey model or whichever object you have added in your scene. And now it's the time to explore the next modifier, that is the shrink wrap modifier. As the name suggests, the shrink wrap modifier takes a mesh and shrinks it down, basically wrapping the mesh around another object. And to practically see how it works, let's go to the object mode, turn off the X-ray mode, press A to select all and X to delete, and let's add a new UV sphere in our scene. Also, we'll add a plane, move it upwards in the Z direction, enter the edit mode with this plane selected, and let's scale it down, and let's apply subdivision 2 to 3 times and return to the object mode. Now to see the effect of shrink wrap modifier properly, we need to assign some colors to these objects. First, let's go to the material preview mode. With this plane selected, go to the materials panel, click on new and assign any random color to it. So let's assign it blue color. Now we'll select this sphere and let's also assign it a color. So let's assign it yellow color. Now to make its surface smooth, we'll right click and select shade smooth. Now select this plane, go to the modifiers option, click on add modifier, and in deform select shrink wrap, and we observe that nothing happens. That's because we have to choose our target object on which this plane would wrap around. So click on this eyedropper and select this sphere, and now you can see that the plane is wrapped around the sphere in a way that it's not even properly visible. To fix this, we need to increase the offset a little bit. So let's change this offset to a very small value like 0.012, and now the plane is properly visible, and you can see that the plane is now wrapped around the sphere, and that's how the shrink wrap modifier is used. So you can basically use this shrink modifier whenever you want to wrap one object over another. And now let's explore the next modifier, that is simple deform modifier. So let's return to the solid mode by pressing Z and move your cursor towards solid. Press A and X to delete all. Now let's add a cube in our scene, tab into the edit mode, and let's scale it up in the Z direction, and let's apply subdivide. Increase the number of cuts to 8. I have taken 8 cuts just randomly. You can even increase the number to 10 or decrease it to 6 or anything. Now the modifier that we are going to use, that is the simple deform modifier. It basically takes the origin point as its reference by default, that is where this 3D cursor is located. And to ensure that it's applied properly, we need to move this cube upwards in the Z direction like this. Now let's come out of the edit mode. Now we'll go to add modifier, and in deform section click on simple deform. Here you can see that it has created a strange effect on our cube. Since the twist option is selected here, so it has twisted our cube in the X direction. To see the effect properly, we can change this angle from here, and we can even change the axis from here. Let's keep the axis to Z axis and let's increase the angle like this, so it will create this beautiful twist effect on our object. So at 360 degree you can see that our cube has completely twisted, and this is how it looks. Let's try the other options also, like this bend option. So you can change the angle from here like this, and even the axis from here. So let's set it to X axis, and if I decrease the angle, then you can see that at 0 our object look like this. But if we increase the angle, then our object will begin to bend, and this is extremely useful if you want to animate your objects and want to show them like bending or twisting. Then this tool is very useful. Let's try the taper effect. Let's change the axis to Y, and let's increase this factor. So you can see how this is creating a tapering effect on our cube. Similarly, if I go to the stretch option and change the axis to Z axis and increase the factor, then you can see that it is creating a beautiful stretch effect on our cube. So if you want to animate your stuff and it involves twisting, bending, tapering or stretching, then you can use this simple deform modifier, and then you can do it in seconds. And now let's come to the next modifier, that is the smooth modifier. To understand it, let's delete it first, and let's add a monkey or the Suzanne model. Now what the smooth modifier does is that it smoothens the mesh object by softening the angles between the adjacent faces, and this even shrinks the size of the original object. To see how it practically works, with this selected object, go to add modifier, click on deform, and in the deform section select smooth, and if I zoom in, you might notice that there is no much visible effect on it. But if I change the factor to 0, you can see how it originally looked, and now if I change it to 1, we can see that its size has shrinked and its surface is much smoother now. You can even increase the smoothness further by increasing this factor from here, but if you try to increase it too much, then your object will be destroyed and it won't be helpful. So keep the factor to around 1 or 2 to see the best results. And now the next modifier on our list is the smooth corrective modifier. Now this modifier is mostly used to smooth the mesh during character creation process, and so it requires the knowledge of character modeling. As a result, we won't be covering it in this chapter right now, and so let's move to the next one, that is the smooth Laplacian modifier. For that, I'll delete this Suzanne model. Now the smooth Laplacian modifier is used to smooth a mesh which has become irregular after its vertices have been manipulated during detailed modeling. And to understand this practically, let's add a plane in our scene, enter the edit mode and subdivide it 2 to 3 times so that it gets more vertices. Now to understand the smooth Laplacian modifier, we have to make its surface irregular first. So select any random vertex, Turn on proportional editing by pressing O and move this vertex upwards and scroll up your mouse wheel to reduce the circle of influence, and we'll left click to finalize. And now if I go back to the object mode, you can see that the surface of this plane is very irregular now, and to smoothen this surface we can use the smooth Laplacian modifier. So go to the modifier properties editor, click on add modifier, and in the deform section select smooth Laplacian. Now to remove this irregularity or basically smoothen it, you need to increase this lambda factor from here, and now you can see that our surface of this plane has become much more regular than before, and if I further increase it, then it becomes much more regular, and this is the use of the Laplacian smooth modifier. In simple words, you can understand it in this way, that it helps to smoothen an irregular surface of any mesh. And now the next modifier on our list is the surface deform modifier, and to see how it works, let's delete this and add a cube in our scene. Tab into the edit mode, let's scale it up in y direction like this, and to increase the number of vertices we'll subdivide it 2 to 3 times. Now return to the object mode, and the surface deform modifier will require another object in your scene which will be used as a target, and any transformation that you will do to that object will also be seen on this object's surface. For example, if I add a plane in my scene and rotate it in y direction by 90 degrees, tab into the edit mode and scale it up like this, and let's also scale it up in y direction. And we should increase the number of vertices in this plane also. So let's subdivide it 2 to 3 times. Now let's go back to the object mode and let's apply the surface deform modifier to this cube. So I'll select this cube here, go to add modifier, and in deform category select surface deform. Now we have to set this plane as the target object. So click on this eyedropper and select this plane. And to bind both the objects, you have to click on this bind button. Now if I select this plane and tab into the edit mode, and now if I randomly select some vertices and try to transform them, like moving them in upward direction like this, then we notice that our cube is also getting transformed in the same way. Also if I try to rotate it, then this cube will also show the same transformations. Similarly, if I scale it up, then also this cube is deforming, and that's the use of the surface deform modifier. Basically, the surface deform modifier is similar to the mesh deform modifier that we previously discussed. The only difference is that the controlling mesh, that is the plane in this case, does not have to surround the object, and this is the use of this modifier. Let's go to the object mode now. And the next one is very interesting, and it's the warp modifier. To understand it, let's delete all this. Press Shift plus A to add a plane in our scene. Now let's tab into the edit mode, and to increase the number of vertices, we'll apply subdivide. Let's increase the number of cuts to around 16 and increase its size like this. Now we'll come out of the edit mode, and to use the warp modifier, you need to add 2 empty objects in your scene. For this, press Shift plus A to add object, and in the empty, select plane axis. Let's duplicate it by using Shift plus D and move it in Z direction like this. One of the empty objects should be at the bottom and the other one should be upwards in the Z direction. Now let's select this plane and apply the modifier. So in deform category, we'll select the warp modifier. Now you can see that there are 2 options here. One is object from and the other is object to. So we'll assign one of these empty objects to object from and the other one to object to. So let's click on this eyedropper and select this one, that is the empty object, as the object from, and click on the eyedropper of this object to, and we'll select the other empty object, and now you can see that something has happened here. So basically the warp modifier allowed you to deform your mesh object in object mode by manipulating the target objects, that is the empty objects that we have added in our scene. To show what it means, I'll select this empty object, and if I try to move it, you will notice that our plane object is also deforming. So basically the working of this modifier is such that it starts from the object that we have entered in object from, that is the one at the 3D cursor, and it will show the deformation till the object 2, that is the object that we have added in this object 2 section. And you can even change the strength from here, and this is the warp modifier. So selecting this empty object and moving it will deform it, and if you select this plane and change the strength, then also you can see the changes or the transformations in your object. And now is the time for the last modifier of this chapter, the wave modifier. And it's an amazing modifier and a very simple one to learn. So let's start with it. So I'll press A and X to delete all, and let's add a plane in our scene. Go to the edit mode, and let's subdivide it. Let's keep the number of cuts to 16 and let's scale it up also. Return to the object mode, and now we can apply the wave modifier. So click on add modifier. In deform section, select wave modifier. And you can see that the object is now transformed. But that's not enough. If you press on this play animation button, then you can see that our plane is showing a wave animation. And from the wave menu here, you can even change the height of your wave like this. Let's reduce it. Similarly, you can also change the width of your waves and also the narrowness of your waves like this. And also if you go to the time section here, you can even change the speed of your waves. For example, if I increase it to the maximum level, then it will be very fast. And if I reduce it to something near 0, then you can see that the speed of our waves has reduced. And that's that's all in the wave modifier. And we have now covered deform modifiers in this chapter. But before ending this chapter, there's something to tell you. The purpose of creating these two chapters, that is this chapter and the previous one, is not that you will memorize each and every modifier of Blender, but to make you understand the fundamentals and the working of each modifier. But if you want to learn each and every modifier in Blender, which again is not really mandatory, you will require a lot of practice for that. And to start with, you can add and select random objects in your Blender scene and try applying different modifiers to see what happens. And from the next chapter, we'll be starting with materials, textures and nodes. From this chapter, we'll be beginning our journey of exploring materials, textures and nodes, and all this would be covered in the upcoming 15 chapters of this course. The reason for having so many chapters is to understand all aspects of materials, textures and nodes in Blender. And in this introductory video, we'll begin with these topics that will help us to understand fundamentals of node components. So let's begin with it. Now by default, Blender opens in this layout workspace, and Blender gives you the option of a separate workspace for working on materials, textures and nodes, and to access it you have to click here where it's written shading workspace. And from here you can change the material of your object, but in this course we won't be working in this way. We'll be having a better interface to work on materials, and to create this you have to go back to the layout workspace. Now if I take my cursor over here, then if I right click, it will give me two options, vertical split and horizontal split. So I'll click on horizontal split, and now I can drag this line and I'll take it to around half of the scene, and I finalized it with a left mouse button click. Now let's adjust it a little bit, and we'll change this to the shader editor, and here we'll see the output. So click on this icon here and select shader editor, and here these blocks are known as nodes or nodes components in Blender, and basically by using these you will be making your materials in Blender. For example, if I want to change the cube's color, I'll zoom in, click on the base color, and I can adjust the color of my cube from here. For example, if I want to set it to blue, I'll drag it to blue, but you won't notice any change here, and that's because we are in the solid mode right now. And to see the materials in Blender you have two modes. One is the material preview mode that you can access from here, in which you can see how your material is looking in Blender, and the other one is the render view, which is basically the fourth option from here, and it basically shows you how your 3D object would look like when it is finally rendered. Now the way your final render would look depends on which render engine you're using. So Blender basically has two main render engines. To see what they are, you have to click on this render properties icon here, and from here you can set the render engine. Now here you can see that there's a list of three render engines. The default one is the Eevee, the second one is the workbench, and it shows the same thing that you see in the solid mode. So we won't be using this because it won't show any materials on our object. And the third one is the cycles. Now the cycles render engine is the most important render engine out of the three. That's because the quality of output in this render engine is the best as compared to the other two. And due to this reason, it even takes a lot of time to render even a single image in cycles. But that largely depends on the specifications of your PC. If your PC is good enough to handle it, it might take less time. But if you are having a low-end PC, then it might take some more time to render in cycles, but the final quality will be amazing. But the other engine, that is the Eevee, it doesn't take much time to render. It hardly takes 4 to 5 seconds to render, but its quality is a bit low as compared to the cycles render engine. In this course currently we will be using the cycles render engine while working on materials, textures and nodes. And this is just an overview of the render engines. We'll be discussing about the render engines separately in some future chapter as well. Now the way the material on your object looks also depend upon the lighting of your scene. A poor lighting can have a bad effect on how your material looks. So right now we'll be learning about the basics of lighting, and there are two ways by which you can properly lighten your scene. One is the 3-point light and the other one is using HDRIs. Let's see the 3-point light system first. As the name suggests, in this system there are three lights. One is the key light, which is the main light. The other one is the fill light, which basically fills your scene with light, and the third one is the backlight. Let's explore the key light first. For this I'll delete this default light, press X to delete. Now you can see that there are no lights in my scene, so I'll press Shift plus A, select light, and I'll add the area light. Let's move it up in Z direction, and let's scale it up by pressing S, and this light should be such that it faces the front of the cube. For this I'll move it in Y direction, bring it down in Z direction like this, and to make it point towards the front face of the cube, I'll press R to rotate and X to rotate it in X direction, and now I can rotate it like this and left click to finalize. Now if I go to the camera view by pressing 0 on numpad, there is still not much light. And you can change this from the object data properties here. You can change the power of light from here, so I'll increase it, and we'll change the location and rotation of this light so that both the faces have proper lighting. For this, let's zoom out, press G and X to move it in X direction, and let's rotate it in Y direction like this. Let's come out of the camera view by pressing 0 on numpad again, and let's try to adjust the lighting properly. For this, I'll press 7 to go to the top view, press G and adjust it like this. Now I'll press R to rotate it, and I want to rotate it only in X and Y direction, so I'll press Shift plus Z so that the rotation remain restricted in X and Y direction only, and let's finalize it here. Let's go to the camera view by pressing 0, and now both the faces have a proper lighting. We can further increase the power from here, and maybe I should increase the power to something around 700 or maybe 550, and this one looks good. And now we'll add the second light in our scene, that is the fill light. For this, press 7 to go to the top view. With this light selected, press Shift plus D to duplicate, and we'll move it here. Let's change its rotation by pressing R and Shift plus Z so that it doesn't rotate in Z direction, and let's finalize it here. Since it's not the main light, so we'll reduce its power to around 300. Let's go back to the camera view, and let's move this light a little bit in Z direction like this. And now let's add the backlight. For this, we'll again go to the top view by pressing 7 on numpad, press Shift plus D to duplicate it, and move it at the location behind this cube. Left click to finalize, and now we'll rotate it also so that the light point towards the cube and not away from it. So press R and Shift plus Z and rotate it 180 degrees. I entered the number from the numpad and then pressed enter to rotate it 180 degrees. Let's move it here just behind the camera and the object, and its power should be very low, like 100 or 50 watts, because it won't be visible and only its slight effect will be visible while rendering. So we'll reduce its power to something around 100, and let's go back to the camera view. Let's bring this backlight down in the Z direction like this, and now it's done. But you might feel that this lighting system is a bit complicated, and the solution for this is using HDRIs, which is the second method of lighting. And for this, we'll select all these lights. First, let's come out of the camera view. With Shift key hold it, I'll select this light and this one also. Press X to delete them. And now if I go to the camera view again, you will see that there are no lights in our scene. Now to add an HDRI in my scene, I need to download it first. And there are many websites to download it for free, but there are 4 to 5 good ones, and I'll drop their links in the description. For now, I'll be downloading an HDRI from this polyheaven.com website, and here you can find a large number of HDRIs for your Blender projects for free, and you can find a good variety also on this website. For example, if I go to the studio category here, you can see that there are a lot of HDRIs here, which will basically lighten up your scene as if there was a studio around your object. Similarly, there are HDRIs for skies, indoor scenes, artificial lights, etc., which you can download and use for your Blender files. Suppose I select this HDRI, and from here you can download it. You can even change the resolution from here if you want 2K or 4K or 8K or 16K. The higher the resolution, the more power Blender will use. So let's set it to 4K and let's click on download. Now we'll return back to Blender, and to add the HDRI in your scene, in the world properties, click on this yellow dot against the color and select environment texture. Click on open, and now you have to open that specific file that you have downloaded as the HDRI. So I've selected the file and I click on open image. Now you can see that the HDRI is now added in my scene, and it is creating this lighting effect. And that's what an HDRI do. It will automatically create a balanced lighting effect in your scene without the use of adding any lights in your scene. Similarly, you can also try adding other HDRIs by downloading them from different websites and trying them in your scene. Now if I select this cube, you will notice that these will again appear here. But right now let's delete them by pressing X on our keyboard, and now our object has no material. The reason for deleting is that we'll be creating a new material on our own, and before adding any material we need to add a map to it, and the map basically defines a pattern which the object material would show. To understand it, press Shift plus A and you will see a menu here. To add a map, we'll go to input, and the most common one is the texture coordinate. So I'll select texture coordinate from this list, and then you can left click to finalize its position. Now you can see here that there are 7 different ways to map, like generated, normal, UV, etc. And each one is a different way to tell the material how should we map a pattern. But we need to connect it with some kind of pattern. For this, I'll press Shift plus A, go to texture, and this is a list of all the textures in Blender. We'll be exploring each one in detail later on in this course, but for now let's select this magic texture and left click to finalize its position. Now always remember that you have to connect the dots of same color with each other. For example, any of these purple dots can be connected to this purple dot of vector since they are of same color. So suppose I left click on this generated one, and if I drag it near to the vector, they will be connected. But we won't see any changes here because we need to add a shader that we'll put on the surface of this material. So press Shift plus A, go to shader, and here you can find a list of so many shaders, but the most commonly used is the principled BSDF shader. So I'll select this and let's add it here. Let's zoom out a little bit, and if you want to navigate here, then you can press your middle mouse button and drag like this. Now we'll connect the color from here to this base color in the principled BSDF, and what it basically do is that it will give a color to this texture. But you might be thinking, why can't we see any texture or any material here? And the answer to this is that there's no output option here. For this, press Shift plus A, go to output, and we'll add material output because we are working on materials right now. So I'll select this and left click to finalize it. Now there are two main ways to connect the material with the colors and textures. One is the surface and the other one is the volume. medium. In most of the cases you will be using this surface one, so we'll connect this BSDF with this surface. And now you can see here that our cube has a basic texture and a color. This one, that is the magic texture, helped to add a texture to our object, and the principal BSDF added a base color to our object, that is the white color, and the output one generated this output for us. And now it's the time to learn how to apply materials to different objects. For this, let's delete this cube by pressing X, and let's add a new cube in our scene. And to apply a material or a color to it, we have to go to the shader editor, click on new, and we'll change the base color from here, and let's set it to red. Now let's add a few more objects in our scene. So I'll press Shift plus A, and let's add a UV sphere, move it up in Z direction, and let's create a duplicate of it by pressing Shift plus D. And to change the color of this UV sphere, we'll again go to the shader editor, click on new, and change the base color from here. Let's change it color to yellow. Now to apply the same yellow color to this UV sphere also, we'll select this, go to the material properties editor, and click on this icon. Here you will see a list of all the materials that are assigned to the various objects in your scene. So we'll select this yellow color, and this yellow color will get assigned to this UV sphere also. Now suppose I want to change the color of these spheres to the red color of this cube. Now one way is to select this UV sphere, click on this icon, and then select it from here. But there's a better method to do this, and it's called the link materials method. For this, we'll select this sphere, and with the shift key hold it, select other UV sphere, and at last we'll select this cube. Now using the link materials tool, the last selected object's color will apply to the others. For this, press Ctrl plus L, and this link menu will appear, and from here select link materials. And now you can see that the color of this cube has been assigned to the UV spheres as well, and that's the use of the link materials tool. And now our next topic is to explore the 3 common maps in Blender. So basically, maps tell us about where the material is to be placed on an object, and we are going to see the 3 most commonly used maps. For this, let's delete this by pressing X, and let's add a new cube in our scene. Click on new for a new material. So first we need to add an input node. For this, press Shift plus A, and in input select texture coordinate and left click to finalize. And now we need to add a texture. For this, press Shift plus A, go to texture, and let's add a brick texture and left click to finalize. Let's connect the color to the base color. Now you can see that even though the texture look good on the top, it doesn't look so nice on the sides. On this side, it's not generating a complete brick texture, and this side is completely black. And the reason for this is that the brick texture supports only X and Y axis and not the Z axis. And we can even change the appearance of this texture. And to do this, we have to change the parameters in this brick texture node. For example, if I set the offset to 0, you will see that the texture looks like this. And to see the difference that it made, let's undo it. So when the offset is 0.5, you can see that the brick texture is starting alternatively. To understand what I mean, let's zoom in, and now you can see that this brick face is not complete, but the second one is complete. Similarly, the third one is not complete at the beginning, and the fourth one is complete. That's because the offset is set to 0.5. But if I set it to 0, then you will notice 2 things. One is that the faces are uniform now, and the other thing is that the texture on this face has disappeared. Now let's try changing some other parameters. You can see here that the faces are very small, and to increase the size of these faces, go to the scale option and let's set it to something like 2. And now you can see that the number of faces have reduced, but their size has increased. And another way to change the size of these brick faces is to change the value of brick width and row height from here. For example, if I set the brick width to 1, then this width is now equal to 1 meters or 1 unit. And if I change the row height to 1 also, then this height here is now 1 meters or 1 unit. And because both the width and height are equal, it now makes square faces. Now suppose I want 9 squares on the top. For this, I'll change the scale value to 3. Changing the scale to 3 means that we now want 3 faces in both the X and Y directions, and all these faces are square since the width and height here are the same. Now some of you might have noticed here that we have not connected this texture coordinate with the brick texture. Earlier we used to connect generated to vector, but now if I connect generated to vector, then you won't notice any difference here. And the reason is that we should not use generated in this case. Let me explain it properly. There are 2 basic cases where you should not connect the socket of this generated to the socket of vector. These little colored dots are called the sockets. So what are the 2 cases when you should not use the generated socket? The first one is that the object doesn't show any pattern on the sides, or basically any texture on the sides. And the second thing is that if I try to scale this cube, suppose I press S and Y to scale it in Y direction like this, then you will notice that the faces of this brick texture are no more squared shape. The texture is also scaling up, and to fix this we have to use the object socket. So left click on this object socket and connect it to vector. Now we see one of our problems is solved, that is the faces are now uniform, but still the second problem is not solved, that is the side faces are still black. And to solve this problem we have to use UV. Now UV is a map that tells how every side of your object should look in your scene. And to access it, we have to add a UV editor in our scene. For this, take your cursor here and this double-headed arrow will appear. Now right click, and to split this area, we have to select vertical split. Now we'll drag a cursor here and left click to finalize. And to convert this into a UV editor, click on this icon and select UV editor. But we can't see anything here. To fix this, with your cursor hovering over the 3D viewport, press tab to enter the edit mode, and now you can see the faces here. Every square on this UV map is a face of this cube. And now since we are using the UV editor, we have to connect the UV socket to the vector. So left click on the UV socket and drag it to the vector. Now the UV is connected to vector and it appears like this. The texture is not looking good, and to fix this, we have to increase the scale value, and now it looks something like this. Now let's try to use this UV editor to change this texture. For this, with the mouse hovering over the UV editor, press A. This will select all the vertices of the face in our UV editor. And now if we try to rotate it by pressing R, you will see that the texture is also rotating. And that's how you can change the texture of your object by using the UV editor. And you can finalize the texture by clicking left mouse button. Also, you can select any of these vertices, and if I press G to move them, then you can see that the texture on this face is also transforming as per the movement of this vertex. So you can use this UV editor to change this into anything that you like. So you can try experimenting different things to create different types of texture by using this UV editor. And also this UV editor solved our problem of not being able to see the texture on the sides. Now all the sides of our object has a visible texture on it. And the UV editor is also used for applying image textures on your object. And for those of you who don't know what an image texture is, basically we have an image on our system and we bring it to Blender and apply it on our object. Then that image is stretched and it applies to all the faces of our object. Now let's see how can you download some image textures online. So if you go to google.com and search for texture images, let's go to the images option, and here you can find a number of texture images. Suppose I select this one. Let's visit this website, and this website offers you many image textures for free. So let's click on this one and you can download it for free. And now the image texture is downloaded. So let's return back to Blender. And to bring the image in Blender, we'll press Shift+A here, go to texture, and from this list we have to select image texture. And to add the image, click on open. Now this window will appear and you have to choose your file from the required location and click on open image. Now you can see that even though the texture is added here, but you can't see it on your object because it is not connected to this principal BSDF. And to connect them, click on this color socket and we'll join it to the base color. Select this one and with the shift key hold it, select this one. Let's move them a little away. Now we'll select this one and let's take it here. Now you can see that our object has this wood texture on it from the image that we applied here, but we should also add an input here. So we'll bring the texture coordinate here, and even though the UV is connected to this brick texture right now, but if I click on this UV and connect it to vector, it will connect to the image texture also. And now if I go to this UV editor and press A and try to rotate it or scale it, then you will notice that the changes that I make here are also visible on the object here. And so you can use this image texture to apply any image as a texture on your object. And so that's all in this chapter. Now there are two important things to tell you. The first thing is that if you are learning material textures and nodes for the very first time, then it might be possible that you might have doubts in some concepts right now. And the solution for this is to rewatch the video, or maybe that specific part where you feel that you have some doubts. Because for most of the people, it's not possible to understand all such concepts which are so complex at the first time. And also you can write your doubts in the comment section and I'll reply to them. The first thing that we are going to do in this chapter is to explore different ways of adding color to our material. But first let's add a shader editor here. For this, place your cursor here, right click and select horizontal split. We'll drag this line and left click to finalize. Click on this icon here and select shader editor. Now this is the default material assigned to our object, but we'll try something new this time. So click on this principal BSDF, press X to delete it, and let's add a new one. By pressing Shift+A, go to shader and let's select emission shader and we left click and place it here. Now to see the output, let's connect this emission to the surface. Let's go to the render view, and what this emission shader does is that it will make your object emit light. That means if I select this light and press X to delete it, then we won't need any external light in our scene. But right now the render engine is set to EV by default, so let's go to the render properties and change the render engine to cycles. To see a better effect of this emission, go to the world properties by clicking on this globe here, and by clicking on the color, we can change the color of our scene. To make it completely black, left click here and bring this slider down. Now you can see that our scene is completely black and there are no lights. But if I go to the camera view by pressing 0, our object is still visible, and that's because it is emitting light with the use of emission shader. I can also change the color of this light from here. Suppose I select something like blue or green, then it will emit light of that specific color. But let's set it to white right now, and it looks very simple. So let's add some texture to it. So with your cursor in the shader editor, press Shift+A, go to texture and let's select magic texture. Let's place it here. Now the magic texture has two connecting options. The first one is color and the other one is FAC, which stands for factor. This FAC, that is the factor one, is basically for the values, and to be more particular, it's for the values that are between 0 and 1. There might be some exceptions, but in most of the cases, this factor value is for values between 0 to 1. We'll understand it later in this course, but for now let's connect this color to the emission color. Now if you want to change the texture or the colors, you can do this by using this distortion value. For example, if I set it to 0, then the colors will disappear, as it would mean that there is no distortion and no colors in your object. But if I take it to something like 3, then it will add many colors to our object. Basically, a higher distortion means more colors and a more complex texture assigned to your object, and lesser distortion means that there are less colors and a lesser complex structure is assigned to your object. But there's one problem with distortion. At a value of 1, it generates this texture along with these colors. But if I change the value to around 2, the texture along with the colors is changed. But it might be the case that you want the same texture but different colors in your object. But changing the distortion would mean changing both the texture and the color. So if I want this texture and some other colors in our object, we have to use another node component, which is called the color ramp. For this, I'll press Shift plus A, go to converter and select color ramp. Let's place it here. Let's move the magic texture and place the color ramp here. Until now, this node is not connected with any other node. Now this color ramp has a value of 0 to 1. So if I select this pointer here it shows the position value of 0. And if I select this pointer, then it shows a position value of 1. So the color ramp has a value from 0 to 1. Now I'll connect the factor of this magic texture to the factor of color ramp. And for the output, I'll take this color and connect it to the color of emission. And now our object is black and white. So the magic texture is creating this texture on this object, and the color ramp will control which color should appear on this object. The emission node will make your object emit light, and the material output will help you to generate the output of this cube with the texture, color and the emission. Now let's try to add some colors to this cube. For this, click on the first pointer, then click on this black area, and to view the colors, drag this brightness slider upwards, and now the colors are visible. And let's change the color to blue, and now you can see that there's some blue color on our object. Let's click on the second pointer, click on this white area, and let's change the second color. So if I set it to red, then you can see that our object has red and blue color. That's because one of the colors selected is blue and the other one is red. Now suppose you want to add some more colors. For this, press on this plus icon here, select this pointer, and let's change the color from here. So let's change it to green color. Now you can see that our object has blue color, green color and red color. Let's make this red color darker. So I'll click on this and drag this here. Now there are these three colors on our object. Suppose you want more red color on your object than the other two colors. For this, left click on this pointer and drag it like this. And now you can see that the amount of red color has increased. Similarly, if you want more blue color, so left click on this blue pointer and drag it like this. Now the blue color has increased on the texture of our object. And this is how you can add various colors to your object which has a texture assigned to it, and you can try different variations from here to give the texture of your object an exciting look. And now that we have learned how to add colors to a material, let's also understand about the textures, like when to use which type of texture and what happens on applying some specific kind of textures. Even though there will be a separate complete chapter on textures alone, but still let's try to understand the basics of adding texture or some pattern on our material or the object right now. So I'll delete this color ramp by pressing X, and let's also delete this magic texture, and let's begin with the brick texture first. So I'll press Shift plus A in the shader editor, go to texture and select brick texture. Let's place it here. And right now you can see that our object doesn't have any kind of texture or any pattern applied to it. It is only emitting light because of this emission node. So to apply this brick texture to this cube, we'll connect this color socket of the brick texture to the color socket of emission. So press left click and let's connect it here. And now you can see this brick texture on our cube. We even discussed about the basics of this brick texture in our last chapter, and we also observed that although this brick texture is applied perfectly on the top, but it's not so perfect on the sides. And we even fixed it by using the UV maps in Blender. But in this chapter, let's understand when to use this brick texture in Blender. So if your object has a lot of squares or rectangles with some edges around them, then in most of the cases it's good to use the brick texture for your object. For example, if you're creating a tile wall, then you can use this brick texture to create tiles on your faces. And to make all these faces uniform, we have to decrease the offset from here. At offset value of 0, all these faces will uniformly start from the same point and will end on the same point. But if the offset is set to 0.5, then they look something like this. They are basically starting from alternate points. One is complete and the other one is not complete. But let's undo it so that we get uniform faces. And right now these tiles or the faces are rectangular in shape, but if you want them to be squared shape, then you have to change the width and height from here. If both the brick width and the row height are equal, then the faces will be squared shape. So if I change the row height to 0.5, then all these faces will be squared shape now. Now suppose we want to rotate this texture in a particular angle, like for example 45 degrees. For this we need to add another node here, and it's the mapping node. So I'll press Shift plus A, go to vector and select mapping. Let's place it here and let's zoom out for a better view. And if I connect this vector to the vector of brick texture, then my object will turn black, and that's because we have not added any input node here. So to add an input node, press Shift plus A in the shader editor, select input, and we'll add texture coordinate. Let's place it here, and we'll connect the default generated socket with the vector socket here. So I'll left click here and connect it to the vector. and now you can see that the texture is visible. So to rotate this texture by a specific angle, we need to change the rotation values here. Suppose I want to change the rotation by 45 degrees, then I'll go to this Z axis rotation and type 45 and press enter. And you can now see that the texture is rotated by 45 degrees in the Z axis. Now suppose you want to change the thickness of these edges here. For this you need to change the value of motor size. Right now it's set to 0.02. Suppose I increase it and set to 0.1. Then you can see that the edges are thick now. And if you want to make them smooth, then you can change this motor smooth value. Right now it's set at 0.1, but if I increase it to something like 0.5, then you can see that the smoothness has increased. And suppose you want to remove all the edges completely. For this, you need to decrease the motor size to exact 0. And now you can see that the edges have completely disappeared from our texture. So that's how you use the brick texture on your object. Now let's try another texture, that is the Voronoi texture. For this, first select these three, press X to delete them, and we'll add the Voronoi texture by pressing Shift+A, going to texture and select Voronoi texture. Let's add it here. And to connect this node with the emission node, left click on the color socket and connect it to the color socket of the emission. And now you can see that it generates this colorful geometric pattern type of texture on our object, and you can use these parameters to edit your texture. So suppose you want more of these shapes on your texture. For this you can increase the scale value. Right now it's 5, but if you increase it to something like 20, then the texture changes to something like this. And you may also notice that the shape of all these patterns is very random, like all of them are of the different shapes, and that's because the randomness value here is set to 1. But if I change this value to 0, then you can see that all of them have the same size and all are square shaped now. That's because the randomness has been reduced to 0. One more thing to note here is that right now we are not exploring each texture in detail. There will be a separate chapter where we'll discuss everything about the textures and we'll explore the common textures that we use. But right now we are just trying to see how do you add different patterns to your material. And so basically by using different types of textures and adjusting the parameters from here, you can add different types of patterns to your material. And now that we have learned about the basics of adding patterns or basically texture to our object, so now it's the time to look at the structure of our material, or in simpler words, we'll try to create some 3D effects on our material. And in Blender we can do that by creating bumps on our object. By creating bumps on our object, it will give our texture a 3D appearance. And to do this, first I'll save this file and I'll close this file and create a new Blender file so that we can start from the beginning. So here I have created a new Blender file and we'll add a shader editor to the top. For this, let's place our cursor here, right click and select horizontal split. Now we'll drag this line here and press left mouse button. Now click on this icon and select shader editor. Now we have the shader editor at the top and the 3D viewport editor at the bottom. Now giving a texture to your object basically means creating fake heights and bumps, and that too without changing the geometry of the object. And we'll practically understand it by using a height map here. But first let's go to the render view. Now we need to add some texture to object first. So I'll press Shift+A, go to texture and let's add the noise texture. So I selected this and let's place it here. Now before connecting them together, there is one more thing to change. That is we need to change the render engine to cycles. So go to the render properties and change the render engine from EV to cycles. And now let's connect this color socket to the base color and this texture appears on our object. But as you can see here that this entire texture or this pattern is completely flat on the surface. And to give it a 3D effect or basically to create bumps on it, we need to add a bump node here. For this, press Shift+A, go to vector and select bump. Let's place it here. Now to connect this node, we have to connect this purple colored normal socket with the normal socket of the principal BSDF. So let's connect them together, and to connect the texture with it, we'll take this factor socket and let's connect it to the height. And now you can see that it has created some sort of bumps on our object. However, if you notice closely, especially at the edges, then these bumps are very flat. They don't look that realistic, and this can be fixed by changing the parameters of this noise texture. So if I try to increase the scale like this, then you will observe that this texture looks a little better. Similarly, if I increase the detail, then it looks way too much realistic than before. And to see some more changes, let's try to change this distortion value here. Currently it's set to 0, but if I increase it to 1, then our object appears like this. So basically by changing the scale, detail and distortion, you can give your texture a better look. So you can try experimenting with these values and see which one looks the best according to you. Now to change the strength and the color of these bumps, you have to change these parameters in the bump node. So suppose I decrease the distance from here and set it to 0, then the object won't show any bumps or any 3D effect. That is because the distance is set to 0. But if I slightly increase it to something like 0.1, then you will notice slight bumps on your object, and higher the distance, more will be the bump size. And you can even control the intensity of this black color of your bumps. For this you have to change the strength value from here. So now I have decreased it, and now you can see that the black color has reduced. So higher the strength, more will be the black color of your bump, and if you lower it, then the black color will reduce. Right now let's set it to 1, and so that's how you add bumps or basically give a 3D look to your object's material. And you can even change the roughness of your texture from this roughness parameter of your noise texture. Currently by default it's set to 0.5, But if I reduce it to 0, then you can see that all the roughness is gone and the texture has a very smooth appearance. And also remember that lower the roughness, higher will be the reflection on your surface, which means that at 0 roughness, your object surface will have maximum reflection. But suppose if I set the roughness to 1, then you can see that the roughness of this texture has significantly increased. But for creating realistic renders, in most of the cases, you will be setting the roughness to somewhere around 0.5 only, because at roughness of 0.5, you can see that the texture has a very realistic look on the object. Now to revise all the concepts that we have covered till now, and also to understand some more concepts of texturing, let's try to make this simple looking brick wall texture in Blender. For this, let's first delete this cube by pressing X on keyboard, and let's add a new cube in our scene. To add a material to it, click on the new material button here. Now to add a brick texture to this cube, go to the shader editor and press Shift+A. Now in the texture, we have to select the brick texture. Let's place it here, and if I connect the color socket with the base color of the principal BSDF, you can see that this brick texture is generated here, but it's black and white in color. Currently we'll be working on the texture on the top face of the cube only. So let's go to the top view by pressing 7 on the numpad. Let's zoom in. And suppose you want to change the color of these bricks or these faces and the edges in between them. For this, let's understand about a new node, which is the mix color node. To add it here, I will press Shift+A, go to color and select mix color. Let's place it here. Now this will allow you to change the color of these faces and the edges in between. So I'll connect the factor socket of brick texture with the factor socket of the mix color node, and to generate the output, that is the color, I'll connect this result with the base color socket of the principal BSDF. But right now you will see nothing because we have to change the colors from here. So let's select this color A and change the color to red. So basically the color A represents these brick faces and the color B represents the edges in between them. Let's try to change the color of these edges also. So I'll go to color B and let's make them dark gray in color. So I'll bring this brightness slider down like this so that it looks realistic. Now this was one way of doing this, but there's another way which is more often used by people, and that is to use the mix shader. This one was the mix color node, and the one that we are going to use right now is the mix shader. So with this selected, press X to delete it, and by pressing Shift+A, we'll go to shader and let's add the mix shader. Let's place it here. Now what I'm going to do is that I'll take this material output and let's shift it here. Now we'll directly connect this mix shader with the output. So click on this shader socket and connect it to the surface. To see the changes here, we have to connect this BSDF socket with the first shader socket here. Now to see the texture on a surface, we have to connect this brick texture with this mix shader. For this, select this factor socket and connect it to the factor socket of the mix shader. Now you can see that the texture has appeared here, and to change the color of these brick faces, you have to click on the base color here and let's change it to red color. And this is how it looks now. Now suppose you also want to change the color of these edges here. For this, we have to create a duplicate of this principal BSDF and connect it to the mix shader. So left click to select this principal BSDF, and to duplicate it, we have to press Shift+D. Let's place it down here, and to connect both of them, we have to connect the BSDF with the shader socket number 2. The first shader socket is connected to this one and the second one is connected to this. Let's click on the base color. First change the color to white, and to turn it into gray, we have to bring down this brightness slider like this. So let's try to understand this in a better way. We added a texture here, that is the brick texture, and connected it to the mix shader. Then we needed colors on our texture, so we added these two principal BSDF and also connected them to the mix shader. And for the output, we use this material output node. Now if you look closely, then it looks very simple, and that's because we have not added any 3D effects like bumps to our object. So let's try to do that. First let's place it here, let's bring it here, and this one also. Now this one is for the red colored bricks and this one is for the edges. Now to create bumps on it, we have to press Shift+A, go to vector and add bump. Let's place it here, and we'll connect its normal to the normal of this principal BSDF, and let's also try to add a wave texture so that it looks much more realistic. So I'll press Shift+A, go to texture, and let's add this wave texture. Let's see what kind of impact it creates. I'll connect the factor of this wave texture to the height to connect them together. Now you can see that some straight lines have appeared on our object, and I can control them from the parameters here. For example, currently its scale value is 5, but if I increase it like this, then the number of lines are also increasing. Also they look very straight, but in real life the textures are not so perfect, and for this you have this distortion parameter. So let's try to change it. We'll increase it, and you can now see that they are no longer straight. And to make it look a bit more realistic, we can increase this detail from here. Currently it's at 2, but let's set it around 8 so that it would give it a much realistic look than before. Now let's revise what all we have done here till now. First we needed to add a brick texture, so I added this brick texture and connected it to the mix shader. I used the mix shader because I needed two different colors on this texture. One was the red color and the other one was the grey color for the edges. Then to make the brick faces look more realistic, I added this wave texture with this bump and connected it to this one because it was controlling the material of our brick face, that is the red color. Similarly, if I have to create some 3D effects on the edges, then I have to do this using this principal BSDF because it is giving the material of this dark grey color to the edges. So now suppose you want to add some noise texture to your edges, and to create a bump effect on these edges, for this press Shift plus A, go to Vector and add bump. Let's place it here and connect the normal to the normal of the BSTF. Let's also add the noise texture by pressing Shift plus A, go to Texture and add noise texture. Let's place it here. Now connect the factor socket to the height socket of the bump, and now it looks like this. But you can see here that the edges look very smooth or basically very shiny, which makes it look unreal. To fix this, we need to add some detail. Currently the detail parameter is set to 2 and it can go to a maximum of 15. So let's increase it to the maximum, and now you can see that it looks way too much better than before. It has added some detail and roughness to it, which makes it look realistic. So that's all in this chapter. And yes, if you have not understood how different textures work, then you need not worry, because in the upcoming chapters we are going to explore all the important textures in complete detail. Currently we are only understanding how these node components are connected with each other and what change can you expect by either connecting them or by changing these parameters. In this chapter, we'll be covering all these topics to understand the node components in Blender. So let's begin with it. So let's first add a shader editor. So right click here, select horizontal split, and let's split the area into two parts. Left click to finalize, click on this icon and select shader editor. Let's go to the render view also, and I'll change the render engine to cycles. So whenever you're working on a material, you have to start with a map or basically an input node. And so in this chapter, first we'll see how these maps work by using a separate XYZ node. For this we have to add an input node here. So press Shift plus A, go to input and select texture coordinate, and let's place it here. Now these are the 7 maps that are available in this texture coordinate node, and now we have to add a separate XYZ node. For this press Shift plus A, go to converter, and from here you can add the separate XYZ node. Let's place it here. The reason for adding this is that we'll be connecting this texture coordinate with the principal BSTF through this separate XYZ node, and in this way we'll see how we get different results by using different maps here on our object's material. So first let's try this generated one, and let's connect it to the vector. And now if I connect this X socket with the base color, you will notice some changes here. Now in most of the cases you should connect the sockets of same color together, but it won't give you any error if you connect different color sockets together also. So right now I've connected this X socket with the base color and we get this result. Let's see what does it mean. But before that, you need to understand one thing, and it's that the black color always stands for the value of 0 and white color always stands for the value of 1. So now if I see this cube, then we notice that it changes its color in the X direction from black to white. That's because we use this X socket here. So basically here in the beginning it has a value of 0, and so it's black colored, and as it moves further in the X direction, that is at this end, it has a value of 1, and so it's white colored. Similarly, if I connect the Y socket to the base color, you will notice the same with Y axis as well. Initially in the Y axis it is black colored, and as you go forward in the Y direction, then it turns into white, that is the value of 1. Also if I use the Z socket and connect it to the base color, then you can see that at the lowermost end it's black colored, and as you move upwards in the Z direction, it turns white, that is from value of 0 to value of 1. But this thing will change if I change this generated to object. So I'll select this object socket and connect it to the vector. Now the object map works in a slightly different way. Instead of going from 0 to 1, it works from -1 to 1. Since the Z axis is selected here, so at the lowermost point its value is -1, at the middle it's 0, and at the top it's 1. Now always remember that if its value is -1 or basically anything less than 0, then also it will appear as completely black. Only when you move from 0 to 1, you will notice the change of color from black to white. So basically the generated map has the value from 0 to 1, and the object map has the value from -1 to 1. And we can even verify this by using a math node. So first let's see what a math node does. First I'll select these and let's move them here. Press Shift plus A, go to converter and add math node, and let's place it here. So first let's understand what this math node is. Actually, Blender allows you to use a math node in order to do some mathematical operations on the values that are coming from input, and it has many options available here. So if I click on this drop down, then you can see that there's so many functions here like add, subtract. So basically you can use these to perform a particular mathematical operation on any particular number, or maybe 2 or 3 numbers as well. For example, if you want to add 2 or 3 numbers or basically the values, then you can use this add function, or similarly you can also use the subtract, multiply and other things. We'll be exploring this in detail while covering the geometry nodes, but currently let's select the absolute function from here. Now for those of you who don't know what absolute function is in mathematics, it is a function which basically takes the value of a number as an input, and if the number is negative, then it converts it into a positive number, and if it's 0 or positive, then the value will remain same. For example, if I take -5 and apply the absolute function on it, then the output that it will give will will be equal to 5. But if I apply this function on a positive number like 6, then it would return the same number as the output since it is positive. So as I told you that when you're using this object map with the z axis, then at the lowermost point the value will be -1, in the middle it will be 0, and at the top it will be 1. And since I applied this absolute node here, so it took -1 as the input, which was at the bottom, and converted it to 1, which makes it look white now. But at the middle the input value was 0, and when the absolute function is applied over 0, then the result would also be 0, so it looks black. Also on the top the input value was 1, and after applying the absolute function the value will still remain 1 since it is positive. And in most of the cases you will be using either the generated one or the object one out of these 7 maps. Also sometimes you will be using UV when you have to do texture mapping on your object with the help of an image, which we learnt in our previous chapter, but mostly you would be using generated map or the object map. And now that we have covered the concept of these important maps, there's one more thing to tell you. It might be possible that you would be facing some difficulty in understanding the function of each of these nodes, especially if you're exploring these materials, textures and nodes for the very first time in Blender. And that's completely fine, because currently you should not focus on the complete functionality of each and every node. Because see, there are over 100 nodes in Blender, and I'll be covering all of these nodes in the chapters related to geometry nodes in this course. There we'll be understanding each and every node in complete detail. So currently your focus should be only on understanding what are the different options available to create different types of materials, what happens on connecting different types of things together, what results you can expect here, and other similar things. And with this, we have established a solid foundation in node components of Blender. After understanding the concepts explained in these 3 chapters, that is this one and the previous 2, you now have the essential knowledge that will be needed to build upon in the future chapters. So that's all in this chapter. From the next chapter, we'll begin with the understanding of textures, and we'll understand these 4 textures in complete detail. Currently in this chapter, we'll go through these 4 textures in Blender in complete detail. So let's begin with it. First, let's add the shader editor here. For this, right click here and select horizontal split, and let's divide it into 2 parts. Left click to finalize, click on this icon here and select shader editor. Now the first texture with which we'll start is the brick texture. For this, go to the shader editor and press Shift+A, go to texture and select the brick texture. Let's place it here. Now to connect this brick texture with the principal BSDF, take this color socket and connect it to the base color of the principal BSDF. Let's go to the render view, and by default the Eevee render engine is turned on. So I'll go to render properties and select cycles. Now you can see this brick wall texture here. To see it properly, let's go to the top view by pressing 7 on the numpad and let's zoom in. So the first basic thing that you can make with this brick texture is this brick wall, but you can also make a tile wall with the use of this brick texture. For this, we have to focus on 2 things. The first one is that the brick width and the row height should be equal, and it's even better to set both of them at a value of 1. So I'll select this brick width, type 1 and press enter. Let's also go to the row height, type 1 and press enter. So basically it changes the width and the height of our tiles in our texture. But if you notice closely, then it starts from alternate ends. For example, the first tile here is incomplete, but the second one is complete. Similarly, the third tile is also half and the fourth tile is complete. And that's because the offset here is set at 0.5. But if I change it to 0, then you will notice that all the faces start from the same end. That is, all of them look uniform now. But right now it looks very simple. So suppose you want to rotate this texture by an angle of 45 degrees. And to do this, you have to add a vector mapping node here. For this, press Shift+A, go to vector and select mapping. Let's place it here. To connect this vector mapping to the brick texture, take this vector socket and connect it to the vector socket of the brick texture. Now both of them are connected, but we need an input node here. So press Shift+A, go to input and select the texture coordinate. Let's place it here and we'll use the generated map. So let's connect it to the vector. Now this is the input which I connected to the mapping node, because we want to transform this texture, like rotating it or maybe scaling it. Then this brick texture is providing this texture on our object. We use this principal BSDF for basically shading our object, and the material output provides you this output that you are seeing in the 3D viewport. Now to rotate this texture in a particular angle, let's say 45 degrees, so you have to go to the rotation, and since we have to rotate in Z direction, so I'll go to Z, type 45 and press enter. This will rotate the texture by an angle of 45 degrees. Now you might have noticed that this brick texture gives you 2 options of coloring. The color 1 1 is set at white color and the color 2 is set at grey color. And you can see these colors on your texture on this face as well. But how do you control the impact of these colors? For this you have to use this bias parameter. Currently it's set at 0, but if I change it to its lowest value, that is -1, then it will show only the color 1 on all the faces. Similarly, if I set it to its maximum value, that is +1, then it shows only color 2 on all the faces. And at the default value of 0, it displays both the colors on our texture. Now you can even change these colors from white and grey to some other colors. For example, if I go to the color 1 and change it to something like orange, then it will show a combination of both the colors, that is the slight orange color and the grey color, that is color 2. Let's select this color 2 also and let's change it to something like blue or purple, and now it appears like this. So you can try a combination of different colors to see different types of color textures on your object. Now the next option here that you can see is the scale option, and it helps you to change the size of these brick or tile faces. Currently it's set at 5, but if I increase it, then you can see that the number of faces or the tiles have increased and their size has reduced. Similarly, if I decrease it like this, then their number has reduced but size has increased. And let's set it to the default value of 5. Also, you can change the size and color of these edges here, or basically the motors. By default, its color is set to black, which you can change from here. So if I select it, increase the brightness with the help of this brightness slider, now you can see that the color has turned to something like gray. Similarly, if I take it to red, then these edges will turn reddish brown in color. Also, you can change their size from the motor size option here. By default, it's set at 0.02, but if I increase it to something like 0.1, then you can see that the width or the size has increased. To change it to the default value, let's press Ctrl+Z for undo. Now the texture on the top looks good, but if we look at the sides, then it's not what we were expecting. And to fix this, go to this texture coordinate and instead of generated, connect the UV map to the vector. Then go to the edit mode by pressing tab, select the UV option from here and click on cube projection. Let's return back to the object mode, and here you have the brick texture on all the faces of this cube. So that's all in the brick texture. And now the second texture on our list is the checker texture. For this I'll add a new cube, but first let's move it in Y direction like this and left click to finalize the position. Now press Shift+A, go to mesh and let's add a cube. Now we need to add a material on this cube. So in the shader editor, click on the new material, and to see how the second texture of this chapter, that is the checker texture, works, then in the shader editor press Shift+A, go to texture and select the checker texture. Let's place it here, and to connect this texture with the principal BSDF, take the color socket and connect it to the base color of the principal BSDF. Now you can see here that as the name suggests, it creates this check texture on our cube, and in most of the cases you will be using this to create maybe the kitchen tiles or a chessboard or something similar. And you can even change the color of these cubes here. And in this texture, every alternate cube has the same color, meaning that if this face 1 has a black color, then the face next to it will have a different color, but then the next face will again have the black color. And the same happens with all the other faces. And you can even change the color of these faces. To change the colors, go to this checker texture, click on the color 1, and from here you can change the color. By default, one of the colors is set to white, and here in the color 2 you can see that the second color is by default the gray color. Let's go to the color 1 again and let's change its color to red. Now you can see here that the color of these alternate faces have changed from white to red. Similarly, if I go to the color 2 and if I increase the brightness from here, let's change it to blue, then your texture will appear like this now. So you can add various colors as per your specified requirement in this texture, and you can even change the size or the number of faces that should appear on this texture, and for this you have to use this scale option. If I increase this scale option, then you will notice that the number of these faces on the texture will increase but their size will reduce. Similarly, if I scale this down, then the number of faces will reduce but their size will increase individually. By default the scale value is set at 5, so let's change it to 5. And now this is all we have in the fundamentals of this checker texture. So moving ahead, the third texture on our list is the gradient texture. But before exploring that, let's move it in the Y direction and left click to finalize the position. Now instead of adding a cube, this time let's add a UV sphere. Press Shift+A, go to mesh and select UV sphere. But here we need to improve the lighting so that the other part of the face is also visible. So select this light here, press Shift+D to create a duplicate, and to move it only in the X and Y direction, press Shift+Z, and now its movement will get restricted to only the X and Y direction. And so let's place it here and left click to finalize. You can position this lamp anywhere depending on the effect of lighting on your objects. Now let's focus on this UV sphere. So I'll select this and we need to add a material here. So press the new material button, and now it's the time to add the gradient texture. For this, press Shift+A, go to texture and select the gradient texture. Let's place it here. Now connect this color socket to the base color and you will notice some changes changes here. So the gradient texture tells your object to transition between one color to the other, and to be more specific, then in this case between black and white color. But if you closely notice, then the colors applied are really not very perfect. Even if I applied the shade smooth, then also the color is not perfectly showing the transition from black to white. To fix this, we need to add a color ramp. So press Shift plus A, go to converter and select the color ramp. Let's place it here, and with the help of these pointers, you can change the extent of these black and white colors on your object and also its appearance. Suppose I take this first pointer, that is the black one, and if I move it like this, then you will observe that the darkness is increasing on this side, or basically the amount of black color is increasing on this side. Similarly, if I take the second pointer, that is the white one, and I left click on it, and if I drag it like this, then you will notice the same with the white color as well. Now the black and the white color are clearly distinguishable in the texture of this UV sphere. Now let's try to add some different colors to see the transition. For this, first select this first pointer here, that is the black one. Let's reduce its effect by dragging it like this, and now to change its color, click here. To see the colors here, we have to first increase the brightness with the help of this slider. So I'll increase the brightness, and let's change the color to blue. Now I have assigned blue as the first color of this gradient texture. So you can see that with the help of this gradient texture, it shows a transition on this UV sphere from blue color to white color. Similarly, if I take this second pointer here, drag it in this direction, and to change its color, click here, and let's change the color to red. And now you can see how amazing this looks. With the help of the gradient texture, your UV sphere is having a material which shows transition between blue color to red color. And similarly, you can try this with other colors also, and you can even do this with more than 2 colors. To do this, you have to click on this plus icon, and now a third pointer is added at the middle. So with this third pointer selected, I'll go to this color and let's change it to yellow. And now you can see that it's showing a transition from blue color, then in the middle it's yellow, and then to red color. And this is how the gradient texture works. You can even adjust these colors by moving these pointers like this, and it will increase or decrease the impact of those particular colors. So you can use this to create some amazing gradient textures in Blender. Also, you can adjust the position or the rotation of these colors by connecting this gradient texture with a mapping node. For this, press Shift plus A, go to vector and select mapping. Let's place it here. Now I'll take this vector socket and connect it to the vector socket of the gradient texture. But this is not the result that we were expecting, and I have told you this reason every time I use this mapping node, and that is to connect the mapping node with an input node, for which I need to press Shift plus A, then in the input select the texture coordinate. Let's place it here. Now connect the generated socket with the vector socket, and the texture reappears. And now you can use these location, rotation and scale values to affect how these colors or the texture appears on your object. For example, if I try to change the rotation in the Y direction, and if I increase it like this, then you will notice that the texture will also change. Also, you can use this location to change the appearance of the texture. For example, if I change the location in the X direction, then we notice that this completely turns into red color. Similarly, if I take it in negative of X direction, then we see that it completely turns to blue color. But since we want the gradient texture to appear properly, let's change the location in X direction to 0, and let's also change the rotation in the Y direction to 0, and now it looks like this again. And the last one, that is the scale one, is very useful in the gradient texture. So if I take this X direction scale, and if I try to increase it, then you will observe that the blue color has reduced if I scale it up in the X direction, and if I reduce it again, then you can see that the blue color will slightly increase. So you can use this scale option to adjust how your texture would look. In most of the cases, you will be using this scale option only to alter this gradient texture here. And so this is all in the gradient texture. Now the fourth texture on our list is the magic texture. So now we'll add a new cube in our scene. Press Shift plus A, go to mesh and select the cube. Let's move it in Y direction and let's place it here. Let's give it a material by clicking on the new button here. And to apply the magic texture, press Shift plus A in the shader editor, go to the texture and select the magic texture. Let's place it here. Now this magic texture is used to create some repetitive patterns. For example, if you are making a wallpaper or maybe texture for some fabric, in all these cases you will require a pattern which is repeating itself many times, and so you should use the magic texture in these cases. Now to see its effect on our cube, let's take this color socket of the magic texture and connect it to the base color of the principal BSDF, and here you can see that the magic texture is applied and it gives a random pattern of colors to our object's material. And you can alter these colors and the patterns with the help of these parameters like the depth, scale and the distortion. For example, if I change the scale value, then it appears like this, and I can even change the depth value to get more variations. For example, by default it is set at 2, but if I change it to something like 4, then we can see that we get variations in the color. Earlier it was blue and green, but now you can see that it's mainly pink and yellow colored. So you can get some variations by changing the depth value. Also, if I change it to 3, then you will get these colors. For now, let's keep it to the default value of 2. Now you might think that it looks very simple, like there's no complexity in it. And to fix this, Blender gives you the option of this distortion value. By changing this distortion value, you can basically blend or mix these patterns more and more, which will give it a complex look. By default, it is set at at a value of 1, but if I increase it, then you can observe that the texture is no more simple. So you can set this distortion level as per the level of complexity that you want in your object's pattern or basically the texture. Now one important use of this magic texture is to create fabric textures, and to do this basically you have to set the scale at a very high value and reduce the distortion. So let's try to do this, and before that I need to add an input node also. So I'll press Shift plus A, go to input and select the texture coordinate. Let's place it here. Now I'll take this object socket and connect it to the vector. I'll decrease the distortion to its default value of 1, and it is appearing like this right now. To convert it into a fabric like texture, we have to increase its scale value to a very high level. Currently it's set at 11, but if I increase it to something like 60, and if I zoom in now, then you can see that it looks a bit like some fabric or some cloth. And to see its effect more properly, we can add a bump vector node in the shader editor. So press Shift plus A, go to vector and select bump. Let's place it here. Now to connect this bump node with the magic texture, I'll take this factor socket and connect it to the height socket here. Now I'll take this normal socket and connect it to the normal socket of the principal BSDF. And now you can see that it looks way too more realistic. Like it might take some time to render, but after rendering you can see that it very much looks like a texture of a fabric. Now you can even combine different types of textures together to create some stunning materials. For example, let's try to make this tablecloth by combining the magic texture with the checker texture that we learned in this chapter. So with this cube selected, I'll go to the shader editor and let's add a checker texture. For this, press Shift plus A, go to the texture and select the checker texture. Let's place it here. Now see, the reason for choosing the checker texture is that it will create checks on our cube like we have on this cube here. So you can understand it like the checker texture will give the color and this magic texture will make it look like a real fabric. So I need to connect the checker texture to the principal BSDF using this color socket. So I'll take this color socket and connect it to the base color of the principal BSDF. Now here is a black and white checker texture combined with a fabric like texture which is due to this magic texture. We can even change the color of these squares to give it a more realistic look. So I'll select this color too and let's set it to red color. Let's also increase the brightness from here and it looks like this now. And now it looks like a real cloth fabric. So this is all in the magic texture, and also this brings us to the end of this chapter. Today we discussed about the fundamentals of the 4 important textures in Blender, that is the brick texture, the checker texture, the gradient texture, and in the end we explored the magic texture and even combined it with the checker texture to get this result. In this chapter, we'll be exploring the fundamentals of these 4 textures. So let's begin with it. For working on the materials, I would need a shader editor. So I'll take my cursor over here, right click and select horizontal split. I'll drag this line and place it here, and left click to finalize. Now to convert the upper area into the shader editor, click on this icon and select the shader editor. Now the first texture that we'll explore today is the noise texture, but for exploring the noise texture, we'll not use this cube. So I'll press X to delete it, and let's add a monkey or the Suzanne model. So I'll go to mesh and select the monkey model. Now to give it a new material, I'll go to the shader editor and click on the new button. Also let's change this to render preview by clicking on this icon, and by default the render engine is set to EV. So I'll go to the render property and change it to cycles, but I see that there's not enough lighting in my scene. So I'll zoom out, select this lamp. Let's create a duplicate of it by pressing Shift plus P, and I need to move it only in the X and Y direction, not in the Z direction. For this, press Shift plus Z, and now it won't change its position in the Z direction. Let's place it here in front of the Suzanne model and left click to finalize. Now let's zoom in to see it properly. So before understanding the noise texture, first let's give it a simple color and try to change the parameters in this principal BSDF. So I'll go to the base color and let's give it a dark blue color. So now it looks very simple. And to make it look better, one thing that we can do is to select this monkey or the Suzanne model, right click and select shade smooth. Now its surface is smooth. And here you can see that the principal BSDF gives you the option to adjust the metallic strength or the roughness of your model. By default, the metallic strength is set at 0 and the roughness is set at 0.5. Now if I try to reduce this roughness and take it to 0, then all the roughness is gone and the object is very smooth and shiny now. Also suppose you want your surface to be a little metallic, so you can go to this metallic parameter and increase it. And now you will notice that the surface of your object now has a slightly metallic look. But I think that to make it look realistic, the roughness should not be 0. We should increase it a little bit. So let's keep it to a value of somewhere around 0.2, and let's also reduce the metallic strength. So let's keep it to somewhere near 0.1, and now it looks like this. The reason for doing all this before discussing the noise texture is that it would help us to see the effect of the noise texture properly on this material. So to add the noise texture, we have to press Shift plus A, go to the texture and select the noise texture. Let's place it here. Now you can see here that there are 2 sockets for the output, the factor socket and the color socket in noise texture. In most of the cases, you will be using this factor socket to connect the nodes while using the noise texture, but also in some cases you will be using this color socket. Let's first connect this color socket to the base color of the principal BSDF, and now we see some texture on our object. It looks like a gradient of many colors, and it basically depends on the values in these parameters of the noise texture. For example, the first parameter here is the scale. So if I increase the scale, then we observe that it basically increased the noise created on our object, or basically the noise created on this texture. And the next option here is the detail option. By default it is set at 2, but if I decrease it, then simply there is less detail on the texture, which means that the colors are not blending with each other and the colors are more like patches on our object. But if I increase the detail from here, then you will notice that the colors are blending with each other and the object texture now has a very realistic and a detailed look. So by using the scale and the detail, you can adjust how your texture would look like on your object on the basis of its size or the blending. And the next parameter is the roughness. So as the name suggests, the roughness parameter defines how rough your object's texture would look. By default it is set at 0.5, but if I increase it to its maximum value of 1 and if I zoom in, then we see that the colors are completely blended and the object's material looks something like a marble or some stone, and also there is more detailing in the noise texture. But suppose I take this roughness value and reduce it to its minimum value of 0, then now all the roughness is gone and the object looks very smooth and shiny, and you can see that all the colors are very much visible now and it has very low detailing also. So adjusting the roughness creates a lot of impact on how your material would look like. But to create realistic renders, in most of the cases you will be using a roughness value of approximately 0.5 or 0.7, something near these values. So let's keep it to 0.5 only. And also we have this distortion value here. By default it is set at 0, and let's see what happens if I increase it. So I'll slightly increase it, and if I zoom in to see its effect, then you will notice that the texture now has some band-like patterns which were not present before. So more the distortion, more unnatural your object's texture would look. For example, when the distortion was 0, then see, it gives a very natural look, like the colors are blending with each other and it looks kind of realistic. But as you increase it, it seems as if the texture colors are creating a pulling effect and forming these band or ring like structures, which really gives it a very artificial look. And while using this noise texture, mostly you will be setting the distortion to the default value, that is 0. So these are all the options and the result when you connect your noise texture with the principal BSDF through this color socket. But as we discussed earlier, you can also use this factor to connect it to the principal BSDF. Now suppose you want to cut this node or basically the connection, and to do this you can hold the control button, and now if you right click and drag it like this, then this knife will appear, and if I release it, then the node connection is no longer there. And you can use this to break any kind of node connection. Now one thing to notice here, which is not connected to this noise texture or the materials, is that the structure of this Suzanne model is not very perfect. Like if I zoom in, you can easily see the imperfection in the structure of eyes and the ears, and to fix this you have to use a modifier, which is the subdivision modifier. If you remember, we covered all the generate and deform modifiers in our previous chapters, and we discussed this subdivision modifier in detail there. So to apply it, I'll go to the modifier section, click on add modifier, and in the generate category I'll select subdivision surface, and now our Suzanne or the monkey model looks perfect. So I'll zoom out and let's come back to the noise texture. Now you can use this factor socket in the noise texture to connect it to anything like roughness or the displacement or a color ramp, anything. So first let's see what happens if I connect this factor socket to the roughness socket of the principal BSDF, and we notice some changes here. And to see the changes properly, let's undo it by pressing Ctrl+Z. Now before connecting the noise texture with the roughness of the principal BSDF, our object look like this. It's very smooth, shiny and highly unrealistic. Like mostly in real life, you won't see objects that are too much shiny or smooth, but if I redo by pressing Ctrl+Shift+Z, then the roughness is fixed now, or basically the object is no more unrealistically smooth or shiny. It now has a balanced material on its surface. Also, if you notice closely by zooming in, then we can see that it has also added a little bit noise on the surface. To see it properly, we can use this scale option, and if I increase the scale, then now you can see it properly. So the noise texture has added noise to the object's surface, giving it a very realistic look. So you can use this noise texture by connecting it to the roughness if you want your object to have some noise on the surface and to give it a very realistic look, and in this way your object's material won't be too much shiny or too much smooth, making it unrealistic. And with the help of this texture, you can also create a texture with noise, or basically these patches of different colors at different locations. To see how this works, we need to add a color ramp here. So I'll press Shift+A, go to the converter and select color ramp. Let's place it here. Now I'll select these these two, left click to move them and release to finalize the position. Now to connect this color ramp with the noise texture, I'll take this factor socket and connect it to the factor socket of the color ramp. Now to break the node connection between the noise texture and the principal BSDF, hold down the control key, and if I click the right mouse button and drag it, and now if I release it, then we no longer have the connection. Now to connect this color ramp with the principal BSDF, I'll take this color socket and connect it to the base color of the principal BSDF. And here is our texture. You can notice these black patches or the noise on our Suzanne model. The reason why it appears like black and white is that in this color ramp, there are two pointers, one is black and the other one is white. And we can even adjust these colors, so I'll click here and let's change the first color by increasing the brightness and let's change it to light blue. Similarly, I'll select the second pointer, that is the white one, and to change its color, I'll click here and let's change the color to yellow. Now you can see that this Suzanne model has yellow color on its surface and some blue patches. So whenever you're modeling something which requires a texture with a lot of noise and patches of different colors like this, then you can use this noise texture and connect it to the color ramp and it will give you an output like this. Now one of the best uses of this noise texture, which is also my personal favorite, is using noise texture to add emission light to our model. For this we have to open this emission drop down and we have to connect our noise texture with this emission color through this color ramp. So I'll take this color socket and connect it to the color socket of the emission, and also I need to break the node connection of the color ramp with the base color. So I'll hold the control button and right click and drag like this, but we can't see any change here. That's because first we have to increase the emission strength from here. By default it is set at 0, but I'll increase it to 0.8. and now to change the colors, I'll select the first pointer and click here. Now I need to make the first pointer very dark, so I'll take this brightness slider and decrease it all the way down, and for the second pointer I'll move it like this, and also the first pointer, let's move it like this, and now you see some texture appearing on your object. Even though it's not perfect, but you can see that the base color of your model is blue and it has some noise on it which is yellow colored and is emitting light. To see this light properly, you can increase the strength to a higher value like 5 or 6, and let's also reduce the scale from here. Currently it's set at 54, but let's lower it down to a value like 20 or maybe 25. Let's also increase the roughness. This will give it a more realistic look. And let's also increase the detail. So I've set the detail to 8.3, and to adjust this yellow color, try to adjust these pointers at the position where they look the best. If I take this black pointer and move it towards the yellow one, then the area of this yellow noise, or basically the emission, will reduce. And you can also change the color of this emission. We have set it to yellow, but if I click on it and change it to red, then it looks like this. So you can use the noise texture connected with the color ramp and then connect it to the emission to create textures like this. And now it's the time for the second texture, which is the Musgrave texture. So let's move it in the X direction and let's place it here. Now to understand the Musgrave texture, let's add a UV sphere in our scene. Press Shift plus A, go to Mesh and select UV sphere. To give it a material, click on the new button. So just like every other texture, if I go to the shader editor, press Shift plus A, go to texture and search for the Musgrave texture, then I see that there is no such texture present here. And that's because previously in Blender there used to be a separate texture which was known as the Musgrave texture. But when Blender released this 4.1 version, it removed the Musgrave texture from its software. But still we can use it by altering the noise texture. Let's see how it happens. So I'll press Shift plus A, go to texture and let's add the noise texture. Let's place it here, and before applying the textures, let's first right click and shade smooth. Now we have to remove this principal BSDF because it's not required in the Musgrave texture. So with this selected, I'll press X to delete. Now take this factor socket and connect it to the surface socket of the material output. Now you can slightly see these patches here on this object. But see, this is not how the Musgrave texture actually looks. And to see the real Musgrave texture, go to this noise texture and uncheck this normalize box. And this is the Musgrave texture. You won't be using this texture very often, but still it's good to learn it because might be in some case you would need to add this Musgrave texture, and so it's good to understand it. Now you can also alter its appearance from the roughness, detail and the scale values here. So if I reduce the roughness from here, and let's also reduce the detail from 2 to 1, and now it looks like this. So you can adjust these parameters as per your requirement, and also you can make some pretty cool textures like this one. For this you have to take this roughness value to its maximum level and also increase the detail to something around 16, and now it has a very realistic texture. So whenever you feel the need of adding a Musgrave texture, just add this noise texture, connect it to the material output, uncheck the normalize box and change the parameters from here. Now it's time for the third texture of this chapter, that is the Warner texture. So I'll move it in the X direction like this and left click to finalize. So let's add a cube in our scene by going to Mesh and selecting the cube. To give it a new material, in the shader editor, click on the new button. Now press Shift plus A, go to texture and and select the Warner texture. Let's place it here. Now take this color socket and connect it to the base color of the principal BSDF. So the Warner texture creates this colorful pattern on our object. But this is the simplest thing that you can do with this Warner texture. And you can see here that there are 3 different ways to connect Warner texture with other nodes. So suppose I take the distance and connect it to the base color socket, then I get this very faint gradient as the texture on my object. But yes, you can adjust the scale from here. So if I increase it, then it looks like this. And also another important parameter is the randomness. So if I take it to 0, then the pattern has no randomness. It is completely uniform. It's just repeating itself in a single line. But if I increase it to its maximum value, then now it is completely random. Similarly, if I again connect the color to the base color, then you can alter this pattern by using the scale option. So if I increase it, then it looks like this. And similar is the case with randomness also. If I take it to 0, then there is no randomness, just that there are some square faces with different colors in a straight line repeating itself. And if I increase the randomness to the maximum, then the pattern has various faces of different shapes and colors. And similarly, if I connect the position to the base color, then we get this beautiful gradient like texture on our object. And you can also alter this with the help of this scale option. So if I reduce the scale, then the texture would look like this, and if I increase it to a very high number, then this gradient would look very smooth. So you can use these 3 different outputs as per the requirement while using the Warner texture. So you can use this Warner texture whenever you want to create a gradient texture like this, or maybe a colorful pattern with different shapes like this. So in these cases, you can use the Warner texture to create your object's material. And so this is all in the fundamentals of this Warner texture. And now let's move to the 4th texture of this chapter, which is the wave texture. Now the wave texture node adds procedural bands or ring with noise distortion. To understand it practically, let's add a new cube by pressing Shift+A, go to mesh and select a cube. Let's move it in X direction like this and left click to finalize. Now let's give it a material by going to the shader editor and clicking on this new button here. Now to add the wave texture, press Shift+A, go to the texture and select the wave texture. Let's place it here. Now if I connect this color socket to the base color, then we observe that some bands are generated on our object. Now let's look at some options here. The first one is the bands and the rings. Suppose I select the rings, I can't see much difference here. To see a wave texture of rings on all the faces, go to this second option and change the rings direction to spherical. Now here we have spherical rings as texture that are radiating like this from here, and you can also use these values like the scale value to increase or decrease the scale, and also you can use this distortion value to make the pattern irregular. So if I increase it, then the rings would appear like this. Also to make it look a bit more realistic, you can increase the detail from here. So these are the 3 main options available in the wave texture. Now let's change the pattern to the bands again, and here in the band direction you have the option of diagonal. So previously the texture was running straight like in the X direction, but now the texture is applied diagonally on the object. Also you can go to the wave profile here and change it to saw, and now the texture appears like this. Similarly, if I go to the triangle profile, then the texture looks like this. So it depends which one to select based on your requirement. Right now let's set it to the default sign, and suppose you want to rotate this texture. So for this I'll go to the shader editor, press Shift+A, go to vector and add the mapping node. Let's place it here and connect the vector to the vector of wave texture. But as I even told you in the previous chapters that you need to add an input node here. So I'll press Shift+A, go to input and select the texture coordinate. Let's place it here. Let's connect the generated map to the vector like this, and here we have the texture. Now suppose I want to rotate the texture in a particular angle, let's say 45 degrees in Z axis. So I'll go to the rotation in Z axis, type 45 and press enter. This will rotate the texture by an angle of 45 degrees in the Z direction. Similarly, you can also use the rotation in other axes and other angles to change how your texture would look. Even though you can also use the scale values here, but it's better to use the scale values in the wave texture. And so this is all in the fundamentals of this wave texture. And now we have covered all the 4 textures in this chapter, and let's summarize them. The first one was the noise texture, where we connected this noise texture with a color ramp, then we connected it to the base color, roughness, and in the end we also connected it to the emission to create some cool effects. The second one was the Musgrave texture, but because it no longer exists in Blender 4.1, we used the noise texture to create this Musgrave texture. And yes, the special thing in this was we deleted the principal BSDF and directly connected the noise texture to the material output. And also remember to turn off the normalize in order to get this Musgrave texture. Then the third texture was the Warner texture, where we got this colorful pattern of different shapes and also a gradient when we connected this position to the base color like this. And the fourth one was the wave texture, which gives us 2 options. The first one is the bands and the second one is the rings. We have selected the bands right now, and if I select the rings, then it looks like this. And to rotate this, we added this mapping node and connected it to the texture coordinate and the wave texture. So that's all in this chapter. So in this chapter we'll be discussing about how do we add images like these as textures on our object. So in order to give this cube any type of texture, we first need to add a shader editor. For this, I'll take my cursor over here, right click, and I'll select the horizontal split. I'll drag this line to the center and left click. Now to convert this into a shader editor, click on this icon here and select the shader editor. Now the next thing to do is that we'll go to the render view, and since the Blender has Eevee render engine turned on by default, I'll go to the render properties and switch it to cycles. And now we need to get some image textures for our object. So for this I have opened a browser, and see there are many websites which offer you free image textures for Blender, and I'll drop the links in the description. Currently the one that we are going to use is ambientcg.com, so I'll search for it, and this is the ambientcg.com website. And the best part about this website is that you will get lots of free materials, textures and HDRIs from here, and that too under the Creative Commons license. For those of you who don't know what a Creative Commons license is, it basically means that you can freely use it for commercial purposes without the need of paying any fees or giving any credits to anyone. So this one is a good website. I'll drop the link of this website in the description, and suppose we want to get a brick texture for our object. For this, let's click on this explore all assets, and here you can find lots of textures. Like this one is a brick texture, this one is a wood texture, this one is a ground texture with slight patches of grass, this one is a marble texture. So you can get any texture from here, and even the HDRI is like these, and to search for any type of texture, you can do that here. So suppose I type brick and press enter, then it will show me all the brick textures that are available on this website. So we'll select this one for our object. So I'll click on this, and here you can see that there are so many options to download it, and all these depend on the file type and its resolution. The 16K is the highest, and also the PNG will take more sizes compared to the JPG. So if you want the best quality, then you should go for 16K, and currently I'll be downloading the 8K file, and you can download any of these, either the JPG or the PNG. For now let's download the 8K PNG file, so I'll click on it. Now I have downloaded this here, and since it is a zip folder, so before using this in my Blender file, I need to extract it first. So I'll click on extract all and click on extract, and now this folder is created. And if I open it, and now it has all the files and the images for the texture, like the roughness, displacement and all the other files. And now let's see how to import them or add them in our Blender project. So we are back on Blender, and to apply that image texture to this object, go to the shader editor, press Shift+A, go to texture and select the image texture. Let's place it here, and to open that image texture, click on the open button. Now you have to browse and open that particular folder where the texture is present, and from all these images you have to select the image which ends with color.png, or if you have downloaded some other texture, then it might end with col.png or the JPG file. So I'll select this and click on open image, and to see the changes here, we need to connect this image texture to the principal BSDF. So let's take this color socket, left click and connect it to the base color of the principal BSDF, and here is the brick texture applied on our object, but it doesn't look very impressive. And to fix this, we'll go to the shader editor, and we have to add an input node. So press Shift+A, go to input and select the texture coordinate. Let's place it here, and we have to connect this to the image texture. So I'll take this object socket and connect it to the vector socket. Now you can see that the texture looks good on the top. It kind of looks perfect here, but if you look at the sides, then it doesn't look so nice, because this is not the brick texture that we were expecting to be applied on the side. We expected it to be same as that on the top face, but you can easily fix this by going to the image texture, and here in the second drop down menu you can set the image projection. By default it is set at flat, and that's why it appears like this. But if I change the image projection from flat to box, then the brick texture is applied perfectly. But there's also one more way to do this, and in fact it is better than this one, which is to use UV maps. For this, let's go to the projection method and let's change it to flat. Go to the texture coordinate, I'll take this UV socket and connect it to the vector socket. Now even though the texture appears on all the faces properly, but its scale is not correct, which means we need to adjust it by going to the UV map. For this we need to add UV editor in our scene. So I'll take my cursor over here, right click, select vertical split, drag this line over here and left click. To change this into the UV editor, click on this icon and select the UV editor. Now in this 3D viewport with this object selected, I'll enter the edit mode by pressing tab, and here if I zoom out in the UV editor, then we have this UV map here. So to adjust it, I'll press A to select all in the UV editor, and now I can press S to scale it, and you will notice the changes in your 3D view editor also. So let's scale it a bit more, left click. Let's also adjust it by pressing G, and let's take it down like this and left click to finalize. And we can even fit this entire image in this face. So let's scale it up again, left click and press G to move it like this. and now it looks perfect. Let's come out of the edit mode by pressing tab key in the 3D view editor, and now we can close this UV editor. So with my cursor over here, I'll right click and select join areas. Now I'll take this pointer over here and left click. To see the texture properly, let's go to the top view by pressing 7 on the numpad. Now if you see this image closely, we'll notice that it's completely flat, and to fix this we need to add some PBR images. Now the PBR images are these images that came in the zip folder that we downloaded. These PBR images will define the roughness or the displacement and various other things which will give this texture a completely different look. So the first one that we're going to see is the normal, and to add it here, I'll select this image texture and create a duplicate of it by pressing Shift plus D, and let's move it here. But this image texture has this color file added, and we need to add the image of the normal map. For this, click on this icon to open the image. Then you have to go to that particular folder, and here in this folder we have two normal files. One is normal GL and the other is normal DX. So you can add any of the two. It won't make much difference. For now, let's add the normal GL and click on open image. Now in this node with the normal image, go to the color space and change it to non-color. The reason for doing this is that the normal map does not have any color. It only creates a bump effect on our object. It does not give any color to our object. So that's why we have to change the color space to non-color. But if you look at the previous image texture, which was the color image, the color space was set to sRGB because this image had the color which got assigned as the texture on our object. Now we need to connect this normal to the principal BSDF through this normal socket. But for this we need to add a normal map in the shader editor. For this, I'll press Shift plus A, go to vector and select the normal map. Let's place it here. Take this color socket and connect it to the color socket of the normal map. Now I can take this normal and connect it to the normal of the principal BSDF. Let's zoom out for a better view. Let's move this slightly, but we don't see any changes here. For this, first I'll take the UV of the input node and connect it to the vector, and also you have this option of strength here. So if I increase the strength, you will begin to notice some changes in the image texture. You will notice that higher the strength, more realistic your object texture would look now. This is because the normal mapping here adds a 3D effect to our image texture, and that's why it looked much more realistic than before. And now the next thing that we can add here is the roughness. For this, I'll select one of the image textures and create a duplicate of it by pressing Shift plus D, and let's place it here. To give it the roughness image, I'll click on the open image, select this roughness.png and click on open image. Also, I need to change the color space from sRGB to the non-color. Now we can connect the roughness to the principal BSDF by taking this color socket here and connecting it to the roughness of the principal BSDF. You will notice some changes here, but first let's also connect the UV of input node to the vector here. And now you can see that some roughness is added to our image texture. You might not see a significant change in the quality, and that's because roughness basically depends on the lighting of your system. And now the next one that we're gonna add is the displacement. For this, I'll select one of the image textures and create a duplicate of it by pressing Shift plus D, and let's place it here. Now I'll go to open image and select the displacement.png and click on open image. Now we need to connect this displacement image to the normal of the principal BSDF to see its effect. But for this we need to add a bump node here. So I'll press Shift plus A, go to vector and select bump. Let's place it here. Now I'll take this color socket and connect it to the height, and right now the normal socket of the principal BSDF is connected to this normal image, but we want to connect the displacement with the principal BSDF through the normal. For this, I'll take the normal socket of the normal map and connect it here in the bump node. Then I'll break this connection between the normal of the normal map and the normal of the principal BSDF by holding the control key, dragging right mouse like this, and now I'll take the normal of the bump node and connect it to the normal of the principal BSDF. Now you notice some changes here, but before observing the changes, let's go to the texture coordinate, that is the input node, take this UV and connect it to the vector of the displacement. Also change the color space of the displacement to the non-color, and now we see here that a lot of detail is added to this texture. You can notice slight cracks, shadows and a lot of detailing, and to adjust this 3D or the bump effect added, you have to go to the bump node, and here you have the option of the strength. So if I reduce the strength, the effect will get reduced. So let's keep it to a value of somewhere around 0.5, and now it looks like this. So all these nodes here basically give your texture a very realistic look. Previously it looked like this, and right now you can see that it has changed a lot, and that's the use of all these PBR images. And now we have to move to the last one, that is the ambient occlusion. And after understanding this one, we'll revise all of them one more time to get a better understanding. So to add the ambient occlusion, I'll select one of the image textures, and we need to create a duplicate of it. So I'll press Shift plus D, let's place it here, go to open image, and we'll select the ambient occlusion. Click on open image again. Now this ambient occlusion basically adds fake shadow to your object's texture. To see how it works, we first need to change the color space to the non-color, and now we need to add a mixed color node here. For this, I'll press Shift plus A, go to color and select the mix color. Let's place it here. Now the ambient occlusion will work with this color.png node which assigns color to your object, which means that we need to break the node connection from here. Take this color socket and connect it to the color B of the mix color. Then take this color socket and connect it to the factor. And to connect this entire node system to the principal BSTF, I'll take this result socket and connect it to the base color. We don't notice any change here. To see the changes here, first let's take this UV and connect it to the vector. Now to see some colored shadows here, you have to go to the color A, and suppose I change this to blue color. You will notice that some blue shadows are added here, and this is what the ambient occlusion does. As I told you, it adds fake shadows to your object's texture, and if you select a particular color from here, then the shadow of that particular color will appear on the object's texture. Similarly, if I go to the color A again and change it to green color, then you will notice the green lighting and shadows like this. So it's a very powerful image map which you can use if you want to give some colored shadows to your object's texture. And now it's the time to revise all the images or the image maps that we have covered in this chapter. So the first one that we started with was this color.png. It basically gave this simple brick texture to our object, but since it looked flat, we had to add these other PBR images to our texture. So first we added this normal, which gave it a 3D and a realistic look. Then we added this roughness, which gave the texture some kind of roughness, and then we added this displacement, which gave the texture this 3D effect or this bump effect that you are seeing. And then the last one that we discussed was this ambient occlusion, which provided these fake colored shadows to our object's texture. And so this is all in this chapter. So to understand about the working of Vertex Paint, let's first delete this cube by pressing X, and we'll add a Suzanne or the monkey model in our scene. So let's select the monkey model. Now here we have the Suzanne or the monkey model, but right now if we go to the edit mode, then we can see that the number of vertices of the Suzanne model are very less. For this we'll add a modifier by going to the object mode, then to the modifier properties, and we'll add the subdivision surface modifier. Click on add modifier, go to generate and select the subdivision surface. Let's increase the levels viewport to 3, and now it looks very smooth. Also if I apply this modifier by clicking on this drop down menu and apply, and now if I go to the edit mode, you can see that the Suzanne model now has a high number of vertices. So let's go back to the object mode now, and to use the Vertex Paint, you have to go to the Vertex Paint mode. For this you have to click here where it's written object mode and then select the Vertex Paint. Now before understanding how to use this Vertex Paint, there's one more important thing to show you. So I'll go to the object data properties by clicking on this green icon here, and here you have an option of the color attributes. So if I click on it, you have something here which is named as attribute, and all the data that you change in this Vertex Paint mode is saved here in the attribute. Now coming back to the Vertex Paint, let's first see how we can use this Vertex Paint to add some smudge or some dirt to our object. For this I'll go to this paint option here, and here you have an option of the dirty vertex colors. So if I select it, and now you will notice that your object has become a little dark, or basically some dirt has been added to it. But you can see here that this monkey has dirt only on some faces, and suppose you require the dirt or this darkness on the complete monkey or the Suzanne model. So for this you have to go to this drop down menu of dirty vertex colors, and here you have an option of normalize. So if I uncheck this, you will notice that now this dirt or the darkness is spread all over the monkey head. But if I go back to the object mode, we can't see the smudge or the dirt effect on it. In fact, even if I go to the render view and we need to add some lights in our scene, so I'll select this light here and create a duplicate of it by pressing Shift plus D, and let's move it in the Y direction, and let's also move it in the X direction like this. And now you can see here that it does not show the changes that we did in the Vertex Paint, and that's because we have not assigned any particular material to it. To give it a new material, we have to add a shader editor here. So I'll take my cursor over here, right click and select horizontal split. Let's divide the area into two parts and left click. Now to change this into the shader editor, I'll click on this icon here and select the shader editor. Now to give a new material to it, I'll select this and click on new, and here you have the default material assigned to the Suzanne or the monkey model. But as I already told you, all the changes that we did in the Vertex Paint mode are saved here in the attribute, and so we need to connect this material of the Suzanne or the monkey model to this attribute to see the changes here. And to do this, you have to go to the shader editor, press Shift plus A, and in the input you have this attribute. So I'll select this and let's place it here. And now before connecting them together, we first need to change the render engine. By default it is set to Eevee, but we'll go to the render properties here and change it to cycles. And now to connect them together, I'll take this factor socket and connect it to the base color, and here you see that it has completely turned to black color. That's because we have to assign the specific attribute that we had in this object data properties to this attribute node. To do this, you have to go to this name option here and type attribute and press enter. And here you can see that you have your Suzanne or the monkey model with the smudge or the dirt effect added to it. But in most of the cases you will be using this vertex paint to change the color or paint some specific part of your object. For example, if I change the object mode to the vertex paint, and now suppose I want to paint the color of these eyes. So for this, I'll first go to the solid view here, and right now you can see that it's showing the dirt added to it, whose data we have stored in this attribute. And to remove this, I have to click on this minus icon here, and here we have our default Suzanne model. So to paint these eyes, I need to add a new color attribute here. So I'll click on the plus icon here, and here we have the option to change its name. So I'll change its name to eyes, and this color would define the color of your Suzanne model. So I'll change it to white color by clicking on it and increasing the brightness with the help of this brightness slider, and then I'll click on OK. Now to set the color that we want, you have to click on this white color here, and let's change it to red color. And now I can zoom in, and if I left click and drag my cursor like this, then you can see that the eyes of this monkey model are being colored red. Similarly, I'll go to the other eye, click left mouse button and drag it like this, and the color of this eye will also change. So now our monkey model looks like this. Let's also change the color of this nose to red color. So I'll left click here and drag it like this, and now this is our Suzanne or the monkey model. And now if I go to the render view, you can see that our model is completely black. That's because in the shader editor, we still have that old attribute connected with the principal BSDF, but since we have deleted it, so it has turned to black color. So to change the name, I'll click here and type eyes, and remember that it is case sensitive, which means that you have to take care of the capital and the small letters. So now I'll press enter, but here you can see that the eyes are not red colored. They are colored separately, but still they are not red colored like we painted in the vertex paint. To fix this, go to the shader editor, press shift plus A, and we'll add a mix color node. So I'll go to color and select the mix color. Let's place it here, and now I have to connect this attribute to the mix color, but before that I need to break this node connection. So I'll hold the control key, click right mouse button and drag it like this. Now I'll take this color socket and connect it to the color B, then I'll take this result socket and connect it to the base color. And now you can see that the red color of the eyes and the nose have appeared on this Suzanne or the monkey model. And you can even change the color of the remaining monkey model with the help of this color A. So if I select this and change it to light blue colored, then you can see here that the part of the model except for the one which we painted is now light blue colored. So you can use the vertex paint option whenever you want to paint color on the surface of your object. And one more important thing to remember is that while using the vertex paint, you are not changing the color of these vertices. In fact, you are applying a mask on it. To understand it, you can see this image where the selected object has the same default color or the material, but we have added this colored mask over it with the help of vertex paint. And now let's also try it with some other part of this object, let's say the head of this monkey model. So I'll go to the solid view again, and I'll add a new color attribute for it. So I'll press on this plus icon, and I'll change the name to head, and the color is set to white color. So I'll click on OK. So the color of the eyes is stored in the eyes color attribute, and now whatever new changes that we'll make will get stored in this head attribute. So I've selected the head attribute now, and I'll change the color from here. Let's change it to green color. Let's adjust the view properly, and now if I left click and drag my cursor like this, then the green color is being applied over the head of the monkey model. So the eyes attribute here has the data of the red colored eyes and nose, and the head attribute has the data of this green colored head. Now if I go to the render view again, and let's change this to object mode, we can see that the green color of the head has not appeared here, and that's because we have not added the head attribute in this shader editor. For this, I'll select this attribute and create a duplicate of it by pressing shift plus D, and let's place it here. Now I'll change the name by clicking on the name option, and I'll type head and press enter to confirm. And to connect this to the remaining node system, I need to create a duplicate of this mix color also. So I'll select this, and we'll create a duplicate of it by pressing shift plus D. Let's place it here, and we need to adjust it. So I'll take these two and left click to move them, take this mix color, and let's place it here. Now to connect this head attribute to the remaining node system, I'll take this color socket and connect it to the color B of this mix color. Now to get the data of both the eyes and the head, I'll take this result socket and connect it to the color A of the mix color. Now I'll break the connection between the older mix color and the principal BSDF by holding the control key, clicking right mouse button and dragging like this. Now I'll take this result socket and connect it to the base color, and here you can see that the data of both the attributes is now applied on this Suzanne model. And suppose you want to change the strength of these colors. For this, you can increase the value of this factor here. This one will help you to control the strength of this green color, and this one will help you to control the strength of this red color. So if I increase the factor from here, you will see that the red color has increased, and if I change it to its default value and go to the other one, and if I increase its factor value, you will see that the strength of the green color has increased. But right now I'll be setting them to the default value of 0.5. So this was all in the vertex paint. Even though you will be using this vertex paint option in very rare situations like modeling some character or painting something specific on a particular object, but still it was important to understand it. And this brings us to the end of this chapter. So in this chapter we'll be learning about a very useful node in Blender which is called the Object Info node. And the first question before starting anything is, what exactly is the use of this Object Info node? So the Object Info node is used to add different colors to different objects while you are still using the same material. And to understand it practically, we'll open our Blender file and let's delete this default cube by pressing X. Now let's press Shift plus A, go to Mesh and let's add a UV sphere. And now to give it some material, I need to add a shader editor in my scene. For this, I'll take my cursor over here, right click and select horizontal split. Now I'll take this line in the middle and left click to split the area into two parts. To convert this upper area into the shader editor, click on this icon here and select the shader editor. Now to give it a new material, click on this new button and here you have the default material applied to the UV sphere. Now let's go to the render view, and by default the render engine is Eevee, so I'll go to the render properties and change it to cycles. Now if I go to the material and click on the base color to change its color, we can set the color of this object from here. So I'll change it to red color right now. And now if I create some duplicate of this UV sphere by clicking Shift plus P and moving it in Y direction and left click to finalize. Similarly, I'll create 2 or 3 more duplicates by pressing Shift plus D, moving in Y direction like this, and let's create 2 more this side also, Shift plus D again and moving in Y direction, and now the last one, Shift plus D, and let's move it in Y direction again. So now we have 5 duplicates of this UV sphere which have the same material, that is the material with the name material.001. So all of them are assigned the same material and so they are showing the same red color. But suppose you want all these UV spheres to have the same material but different colors, meaning that the metallic, the roughness and all the other things should be same, but only the color should be different. And for this you can use the Object Info node. So to add the Object Info node, I'll go to the shader editor, press Shift plus A, go to input and select the Object Info. Let's place it here. And here you can see that this Object Info node has 6 options of output. And in this chapter, we'll be covering these 2 options because they are the most commonly used. And currently we'll be starting with this random output option. So this random output option basically assigns random colors to your object. Like one of them will be blue colored, one of them will be yellow colored, and all of them will still have the same material, that is the material 0.001. See, the material is identified not only by its color, but also by its metallic nature or the roughness and all the other things like emission also. For example, if I increase the metallic nature, you will notice that all these UV spheres now look very shiny and have a metallic surface. But to give them different colors, I'll be using this Object Info node, and to set those different colors, I'll be using a color ramp. So I'll press Shift plus A, go to Converter and select the color ramp. Let's place it here. Now I'll take this Object Info node and move it here. And since there are 5 different UV spheres, we have to create 5 different colors. But currently there are only 2 pointers by default in the color ramp. One is this black colored and the second one is this white colored. To add new pointers, click on this plus icon here. Now there are 3 pointers and I'll add 2 more. And now we have 5 pointers. And I'll change their position so that they look equally placed away from each other. So I'll place this one here and I'll take this third pointer and adjust it in the middle. And you can even change the position from this POS option, which stands for the position. So if I select this and to place it in the middle, I'll type 0.5 and now it's in the middle. Similarly, I'll also select this one and I'll set the position at 0.75. Now I'll select this second pointer here and change its position to 0.25. Now they're perfectly placed away from each other at equal distances. And to set different colors, I'll select the first pointer here, click on this black area to change the color, and we'll increase the brightness with the help of this brightness slider. Now suppose I set the first color to blue color, and to see the changes here, I'll go to the Object Info, take this random socket and connect it to the factor, and in the color ramp, go to the color socket and connect it to the base color. It appears like this because one of the pointers is blue colored while the others are either gray or white colored. But let's first set different colors on each pointer. So I'll select the second pointer here, go to the color menu, increase the brightness, and let's change this color to green color. Similarly, I'll select the third pointer and let's also change its color by going here, and I'll increase its brightness again. And let's change it to red color. Similarly with the fourth pointer, and I'll change its color to yellow, so I'll take this to the yellow color. Similarly with the last one, I'll go to this color option and let's change it to pink color. Now it appears like this because the colors at different pointers in the color ramp are not constant, they are blending with each other. And to make them constant, click on this drop down menu where it is written linear and select the constant. And now you can see here that these UV spheres are having different colors except for these 2 UV spheres which are having blue color. And that's because we have selected the random output here, which means that it will randomly assign these colors to any UV spheres and in any number, meaning that the UV spheres will have random colors and some of them might have some common color as well. And you can even adjust these colors by moving these pointers in different directions. Like when I just moved this last pointer, then the color of this UV sphere changed from yellow to pink. And that's how the random output for this Object Info node works. Now the second output socket that we'll discuss here is this Object Index socket. So if I take this and connect it to the factor, I see that all of these UV spheres now have the blue color assigned to them, and that's because we have to assign each UV sphere a separate object index number manually in Blender. For this you have to go to the object properties here, then you have to click on the relations, and here you have an option of pass index. Now the pass index means the same as object index. So different objects can have different pass index values, and based on these values they will be assigned different colors here. So suppose I take the first one and change the pass index value to 1, then I see a color change here, but we'll observe it later on. First I'll select the second one and let's change the value to 2. Similarly the third one, and let's change the value to 3 again. Fourth one, we'll assign the value 4, and fifth one, we'll assign the value of 5. Now all of them are having the same color, that is the pink color, and the reason for this is that the object info transfers the value to the color ramp in between 0 and 1 only. But right now we have set value in the pass index or the object index which is greater than 1, so it is restricting all the values to a value of 1, meaning that the object info is sending the output that all of these UV spheres have the object index value of 1 and not their respective values. And since the color ramp also works from 0 to 1, where we have assigned the blue color to 0 and it gradually increases here, and at the position of 1 we have this pink color, and as a result all these UV spheres now have the pink color assigned. To fix this we need to add a new node here, which is the math node. So basically I'll use the math node to change the output that is generating from the object info node, and to see how this works I'll press Shift plus A, go to converter and select the math. Now I'll place it in between both these nodes and left click to finalize, and now they are connected together. Since I need to reduce their value from numbers like 1, 2, 3, 4, 5 to a value between 0 to 1, I need to divide them. So I'll go to this drop down menu, and here you have lots of functions that we'll discuss in this course in the future chapters, but right now we'll select the divide, and in the value option you have to enter the number of UV spheres in your scene. Since we have 5 objects, so I'll enter 5 and press enter, and here you see that you have objects with 5 different colors but the same material assigned to them, and this is the use of this object index socket in the object info node. So whenever you are modeling something where you have a large number of objects which need to have material with same roughness or the same metallic nature, or basically the same material but you want them to have different colors, then you can use this object info node to assign them some random colors. So this was all in the object info node. Although this was a very short chapter, but it's one of those powerful tools which you must know while learning Blender. And so this brings us to the end of this chapter. Till now in this course we have understood about the Blender interface, all the modeling tools in Blender, and we even discussed about all the modifiers in complete detail. And in the recent chapters we explored the node components, tried to create some textures, and even understood about the working of some node systems. And now we are ready to create our own materials with all this knowledge. And so in this chapter we'll begin with understanding the basic shaders, and we'll be creating these materials in Blender. Now before starting with the creation of our materials, there's one important thing to discuss with you, which is also the first topic of our chapter, and it is the Node Wrangler add-on. So the Node Wrangler provides various tools that will help you to work with nodes quickly and efficiently, but to use it we have to enable it from the Blender preferences. So click on the edit menu on the top and select the preferences. Now here in the Blender preferences you have so many options, but we'll select the add-ons and we have to search for the Node Wrangler. So I'll go to the search bar and type node, and here on the third number you have the Node Wrangler add-on. To enable it you have to check this option, and now the Node Wrangler add-on is enabled. So I'll close this Blender preferences now, and now to see how exactly this Node Wrangler add-on helps us, we have to give it a material, and for this we need to add a shader editor here. So I'll take my cursor over here, right click and select horizontal split. Let's take our cursor over here and left click to split the area. Now to change this into the shader editor, click on this icon and select the shader editor. Now we have the default material assigned to our cube. For example, if I want to add some image texture to my cube, then one way to do this is to go to the shader editor, press Shift plus A, then you can go to the texture to add the image texture, and suppose you want to rotate or scale your texture, then you would need a vector mapping, and also you would have to add an input node which is the texture coordinate. But you don't have to do all this if you have the Node Wrangler turned on, which means that if I select the principal BSDF alone and press Ctrl plus T, then it would generate all the nodes that are required for image texture. So instead of adding each one separately, you can use this shortcut of Ctrl plus T to add the entire node system for image texture. And this is one of the uses of the Node Wrangler add-on. Now before making our first basic shader, we need to do some changes. The first thing is that we'll delete this default cube by pressing X on the keyboard, and let's add a UV sphere. So in the add menu and in the mesh, I'll select the UV sphere. Let's move it upwards in the Z direction like this, and left click to finalize. Right click and apply the shade smooth, and now we need to add a plane below the UV sphere which will basically become the base. So I'll press Shift plus A, go to mesh and select the plane. To adjust it, I'll tab into the edit mode. Now we'll go to the top view by pressing 7 on the numpad, and we should scale this up in the Y direction. For this press S and then Y and scale it up like this. Left click to finalize. Let's also scale it up in the X direction by pressing S and then X and scale it up like this and left click to finalize. And now our scene looks like this. But we would also need a face at the background, and for this I'll go to the edge select mode by pressing 2, then I'll select this edge, and to make a face at the background we need to extrude it up in the Z direction. So I'll press E and Z to move it up in the Z direction and left click to finalize. Now it looks like this. To make it look realistic, we should change the angle here to something like a curved angle. For this we'll use the bevel tool on this edge. So with this edge selected, press Ctrl plus B, move the cursor slightly away, and to increase the number of segments you can use your scroll wheel. So let's add some more segments and left click to finalize. And now it has a perfectly curved angle. And now we can come out of the edit mode by pressing the tab key again. So if I go to the camera view by pressing the 0 on the numpad, it seems that we have to adjust our camera position. To do this, press N to open the properties toolbar, click on the view option and select the lock camera to view. We learnt about using this in our previous chapters, so if you haven't watched them yet, you can check the link in the pinned comment. Now to move my camera view, I'll hold down the middle mouse button, and if I drag it, then the position of this camera would change. So I'll keep it here. To move it upwards, I'll hold the shift key and the middle mouse button and move it up like this. Now I'll adjust it in such a way that we have this scene of this UV sphere with the base and the background in front of the camera view. So this view looks perfect and I'll finalize it. So I'll uncheck the lock camera to view option, and to make it perfectly aligned with the object and the entire scene, click on this item option here, then select the camera. You can select the camera from the scene collection here also. And here you can see that you have the location and rotation of this camera. So here the location in the X direction is very near to 0, and to make it perfectly aligned with the object and the scene, I'll set it to exact 0. Now I can use the location in the Y axis, so I'll adjust it here. Similarly, you can use the location in the Z axis to move upwards or downwards, so I'll set it here. Now in the rotation part, the rotation in the X is set to 75, but to make it perfectly aligned, we'll change it to 90 degrees and press enter. Now we'll change the location in the Z axis with this option, and I'll reduce it and I'll finalize this one. Now here the rotation in the Y direction is very close to 0, so I'll change it to 0 and press enter. Also in the Z axis, the rotation is very close to 0, so I click on it and enter the 0 value. So the main thing here is to keep the rotation value at either 90 degree or 0 degrees, and then you can adjust the location of your camera using the Y and the Z axis like this. So here I have finalized this position of my camera. Now to prevent your camera from being accidentally moved or rotated at some angle, you can lock these values here. To do this, click on this lock icon here, and now the location of X axis is locked at 0 meters. I'll also do this with the other parameters like the location in all other axes and also the rotation. So now with the camera selected, if I press G and try to move it, you will notice that nothing happens. That's because we have locked the editing of the location of our camera. So basically the camera is now locked in our scene. Similarly, I'll also select this UV sphere and we lock its transformation from here as well. So we'll click on this lock icon to lock the editing of the location. Similarly for the rotation also, and for the scale value as well. Also we'll select the plane at the back, and we'll also lock its transformation. And yes, to apply lock on all these values together, you can press the left mouse button and drag your mouse like this. Now all the transformations are locked for all our objects except the light in our scene. And if you look closely, then you will see these straight lines at the back which are appearing on this plane object. To fix this, with the plane selected, click right mouse button and select Shade Smooth by Angle. And now it appears smooth. And now we can go to the render view to see how it looks. So I'll click on this icon here, and here we have the rendered view of our object. But currently it's showing only the scene lights, and that's why it appears like this. But Blender also have some default HDRIs which you can access by clicking on this drop down menu and unchecking the scene world option. And to change the HDRI, you need to click here, and here you have different type of HDRIs. And to know about each HDRI, you can simply clip your cursor over it and it will display you the name of that HDRI. This one is named night.exr, meaning that if I apply it, then it will give me a lighting setup that you would expect to see if you kept your object somewhere outside during the night time. Similarly, there are others also. Like this one is the interior studio lighting, this one is the forest lighting. Currently I think that we should work with the interior lighting setup, so I'll select the fourth one, and this one looks perfect for our scene. And now is the time to adjust the lighting. So if I zoom out and select the lamp here, with a left mouse button click, I can move it by pressing the G key, and you will see the influence of this light on your object and the surroundings as well. So I think that we should place it here. So I'll left click to finalize its position, and to get a better view of its location, you can go to the top view by pressing 7 on the numpad. And now if I'll move it, then the light would move only in the X and Y axis. So we'll keep it here in front of the UV sphere and left click to finalize the position. And to add some more lights, I'll create a duplicate of it by pressing Shift plus D and I'll place it here. Left click to finalize the position, and let's go back to the camera view by pressing 0 on the numpad. I'll zoom in to adjust the view, and we can even change the color of these lights. For example, if I select the light here by left clicking on it, and if I click on this green light icon, here I have the properties that I can change for this light. So if I go to the color option and change it to something like pink, you will notice the reflection of some pink light on this side of the UV sphere. And right now the render engine is set to EV by default. To change it to cycles, go to the render properties here, click on EV, and from this drop down menu you can choose the cycles render engine. And for a better rendering, do make sure that this denoisy option is turned on in the viewport as well as in the render. And now we'll give a simple material to this background. So I'll select this plain background, go to the shade editor and click on new material. And I think that the color of this background should be a little dark. So I'll go to the base color and let's turn this into gray color. For this I'll take this brightness slider and bring it down like this. This much looks perfect. And also you have various options like metallic, strength and roughness. So we'll increase the roughness to around 0.9 so that the surface of the background is completely rough. And right now you can see that the area which is outside the camera region is also being showed to us in the viewport, and it's always better to hide this area. And the biggest advantage of doing this is that you would be saving some of your render time while being in this 3D viewport. And to do this you have to select your camera, click on this camera icon to edit the properties, go to the viewport display option. Here you have an option of passe part out, and if I increase it to 1, then now we'll see only the area that we have to render and not the surroundings. Also, one more thing that we need to do is to select this UV sphere, and if I tap to the edit mode and press 1 for the vertex select mode, then you can see that the number of vertices on this UV sphere are very small in number. And to make better models with nice shaders and materials, you should have a model with high number of vertices. For this I'll go back to the object mode and we'll apply the subdivision modifier over it. So I'll go to the modify properties, click on add modifier, and in the generate we can find the subdivision surface. And you can even save this as your default startup file, meaning that whenever you will open Blender, you will have your shader editor here and a 3D viewport here with this UV sphere and a background at the back along with the entire lighting system that we are having right now. Basically everything that you can see in your Blender file right now will be added to your new file by default whenever you open Blender. And for all our upcoming chapters related to materials, textures and nodes, we'll be starting with this layout or the interface only. So to save this as the startup file, click on the file option at the top, go to defaults, and here you have the option of save startup file. So I'll click on it and then it will ask for a confirmation to save the startup file. So I'll click on it again and now the startup file is saved. It might have asked you to save or to name your file if you didn't save your file before. So now whenever you open a new file in Blender, you will see this layout by default in your Blender scene. And now the next topic for today's chapter is creating a material library. So with this UV sphere selected, I'll go to the shader editor and click on new material. Now we have the default material applied to our UV sphere. And now let's explore the various options in the principal BSDF. The first option that you have here is the metallic strength. So if I increase it to its maximum value of 1, you will see that the object's material now has a very highly metallic look, meaning that its surface is now very shiny and reflecting. And the second option here is the roughness. So if I reduce the roughness to its minimum value of 0, you will see that the object surface or the material is now highly smooth. That's because we have reduced the roughness to 0. So basically metallic strength would control how shiny and reflecting your object surface is, and the roughness would control how smooth your object looks. Lower the roughness, more smooth the object will be, and higher the roughness value, lesser will be the smoothness of the object surface. And you can see here that it no longer even looks like a metal. It simply looks like a rough ball with no smoothness at all. And to make this material look like a realistic metal, you should keep the roughness to somewhere around 0.3 or 0.4. So let's keep it to a value of 0.35, and now it looks like a realistic metal. And always remember that if your PC is not too fast, then regularly save your file by pressing Ctrl+S so that you don't lose your work due to some crash or any other error, because right now we are in the rendered view, and moreover we have turned on the cycles render engine, and the cycles render engine uses more power and memory to create the renders. But one thing that you can change if you are having a low-end PC is the sample number. Basically, when I change my view, you can see some sample numbers here. Basically, a high number of samples means a better quality but with slower render times, and so it also takes more memory and power. So if you're having a low-end PC and you want to reduce the number of samples, go to the render properties here, and from here you can decrease the number of samples in the 3D viewport. So you can keep it to a lower number like 128 or anything like even 100 or 50 would work fine. But these are the number of samples that you will see while you are in the 3D viewport only. But when you finally render your image, it will still have a high number of samples. And to reduce those samples, you can go to the render option here, and here you have the option of maximum samples. By default, it is set to 4096, but you can lower it to a value near 100 or 200 if you're working on some simple projects. And right now I'll be keeping them to the default value. And now coming back to the materials, we'll try to create the chrome material in Blender. So first I'll change the name of this material by clicking here, and I'll type chrome. Now to make the chrome material, I have to reduce the roughness to a very low value, but it should not be 0 because that would make it unrealistic. So let's reduce it to a value of something like 0.05, and now it looks like this. And now I can save this material by creating a material library in Blender. And in order to do this, you have to go to the edit option, click on preferences, and now from this list you have to select the file paths. And here you have an option of asset libraries. And this is where you will be saving all the materials that you create so that you can use it even in some other Blender files. And here you can set the path of that file. So if I click on this folder icon here, then you can browse all your files and folders here and select a particular location where you can create a folder to save all the materials. Now when you have selected that location and you want to create a new folder, click on this icon, and I'll change the name to materials and press enter. Now click on accept and again click on accept. Now you will have the new path assigned to your asset libraries. And if I close this, and if you want to save the material in that folder, go to this file option, click on save as, browse that particular location where the folder is saved, and I'll open the materials folder, and from here I can change the name of this file, and I'll name it material1 m81 and click on save as. Now we have saved the file at that location, but to save this chrome material in our asset library, we have to go to this scene collection here, click on the drop down, then you will see that there are two options, one is sphere and the other is modifiers. And if I select the sphere option and click on this drop down, here you have the chrome material saved. So if I click on it and then right click, here you have an option of mark as asset. So if I select this, you will see this icon of a stack of books appearing along the material name, which means that this material is now saved in our asset library. And to check this, we'll change this shader editor into the asset browser. To do this, click on this icon here, and here in the data you have the option of asset browser. So if I select this, you will see some default assets added to your asset library, and one of them is this chrome material that we just saved. So whenever you are working on a Blender file and you want your object to have this specific material, then you can simply open this asset browser, select this chrome material, and by left clicking on it and dragging like this, you can assign it to your object. Right now our UV sphere was already having this material, so you can't see the changes, but if I left click and drag it to the background, then you can see that the background's material has also changed to the chrome material. For now, I'll press Ctrl+Z to undo, and this is how you use the asset library in Blender. It's a really very useful thing if you work on big projects and you want the same materials or some same assets in more than one scene. And to see only those assets or materials that you have yourself added to the asset library, click on this drop down menu where it's written all and select the user library. Here you will see only those assets and materials which you created on your own and saved them in the asset browser. Right now we have saved only the chrome material, so it's showing the chrome material here. And now the next topic for today's chapter is creating some more metallic materials. Just now we created this chrome material, and now we'll be learning about creation of some more metallic materials. For this, I'll change this into the shader editor again by clicking on this icon and select the shader editor. Now this UV sphere has this chrome material assigned to it, but to create more materials, I will have to create a duplicate of this UV sphere. So I'll select this, press Shift+D and right click to cancel the movement. Now you can see here in the scene collection that you have this sphere, and this is the duplicate that is created. For now, I will hide this previous sphere by clicking on this eye icon, and here we have the duplicate UV sphere in our scene. To give it a new material, we first have to remove the existing chrome material. To do this, click on this cross icon and now click on the new material. And here in the principal BSDF, if I increase the metallic strength to its maximum value of 1 and reduce the roughness slightly, then you can see here that the object surface has a material which is similar to that of a stainless steel. And here you have some more options like the subsurface, transmission, specular. So if I select the specular, here you will find the anisotropic option. And if I increase it to its maximum value of 1, you will notice some changes here. It is basically stretching the highlights or the reflections on your object's surface. Or we can also say that it is adding a brush effect on the surface of the object. You might have seen a brushed aluminium surface, and this material surface looks very much similar to it. And here you have this anisotropic rotation option. So if I change this, you will notice that this anisotropic effect is now being rotated on the object surface. So if I finalize it here, you can see that this pink highlights here are due to the pink light that we added in our scene, and these white highlights are due to the reflection from the white light that we added in this direction. Also right now the surface is slightly more reflecting and smooth, and to reduce this, I'll go to the roughness and increase it. Let's keep it to a value of something around 0.25, and now it kind of looks like a brushed metal or brushed aluminium. So now we can save this material also in the asset library. For this I'll go to the shader editor, then we'll change the name from here and let's rename it to brushed aluminium. And now if I go to the scene collection and click on the drop down menu of the selected UV sphere, and then if I click here, then we can find the brushed aluminium in this list. And if I select it and right click, we have this option of mark as asset. So I'll click on it, and now this brushed aluminium material is saved in our asset library. To view the asset browser, click on this icon, and from this list you can select the asset browser. Now here the user library is selected, and you can see that we now have two different materials in our asset library or the material library. One of them is the chrome metal and the other one is the brushed aluminium. So if I take this chrome material, left click and drag it on my UV sphere, then the UV sphere will get assigned the chrome metal. Similarly, if I left click on the brushed aluminium and drag it on the UV sphere, it will get assigned the material of the brushed aluminium. And now to create another material, I'll turn this into the shader editor again by clicking on this icon and selecting the shader editor. Now I'll select this UV sphere and we'll create a duplicate of it and right click to restrict the movement. Now we'll go to the scene collection. This is the hidden sphere which we use for creating the chrome material, and to hide these things you can click on this drop down arrow. Similarly, this is the second UV sphere which we use for creating the brushed aluminium material, and we'll hide this one also. So I'll click on this eye, and to collapse this I'll click on this drop down arrow. Now this third sphere, that is the sphere.002, will be used to create the third material of this chapter. For this, first I'll remove this material from it by clicking on this cross icon and we'll give it a new material. And again we'll be creating a different type of metal, so we'll take the metallic strength to its maximum value of 1, and by default the color of our metal is white, and to change this I'll go to the base color, and this time I'll change it to grey color. So for this I'll use this brightness slider and bring it down, and this much looks good, so I'll finalize it. And to give it a better look, I'll reduce the roughness from here, and now it looks perfect, and finally it looks like a dark metal. Also, if you want to make it even more darker, you can go to the base color and further reduce the brightness from here, but I think that I should keep it somewhere in the middle of the brightness slider, and this much looks good. And now let's rename this material, and I'll name it as dark grey and press enter. And now to save this material in the asset library, go to the scene collection, click on this drop down arrow, then click here on the drop down arrow, and here you have the material of the dark grey metal. I think that we should change the name to dark grey metal instead of dark grey. So one way is to go over here, left click and then change the name, but you can also do it in the scene collection here. For this I'll double click, and now you can edit the name from here. So I'll type metal and press enter to confirm. Now to save this material in the asset library, right click and select the mark as asset, and to view the asset browser here, click on this icon and select the asset browser, and it's showing only these two materials because it is not refreshed. And to refresh the browser, click on this refresh icon, and now you can see that you have all the three materials in your asset library. This one is the dark grey metal, this one is the brushed aluminium, and this one is the chrome metal. And now we'll be creating another material which is the gold metal. To do this, I'll go back to the shader editor, and now we have to create a duplicate of this UV sphere. So I'll select it, Shift D to create duplicate, right click to cancel the movement, and to hide the previous UV sphere, I'll go to the scene collection and click on this eye, and let's collapse this by clicking on this drop down arrow button. And to give it a new material, I'll first remove the existing material and click on the new button here. Now the gold metal is very metallic and shiny. As a result, I'll take the metallic value to the maximum value of 1, and to make it shiny I have to reduce the roughness to a very low value. Currently it's set at 0.5, but let's reduce it to a value of somewhere around 0.1. Now to set the gold color, one way is to go to the base color and change it to something like yellow or orange, and it might even work in most of the cases. But if you are very specific about the gold material, then you can see that you have some options here. This one is the RGB, where you can influence the color by adjusting the red color and the green color, similarly the blue color. So by increasing or decreasing these values, you can create different types of colors. Then the second one is the HSV, which is the default one, and the third one is the HEX, which uses the hexadecimal values to set your colors. So every color has an HEX value assigned to it, and to know the HEX value of gold, you can search it up on Google, and when I searched for it, it showed me this value D4AF37. So I'll type it here, D4AF37, and press enter. And now this material has the perfect gold color. In fact, you can use this for any kind of material or any kind of metal that you are making in Blender. You just type the metal name on Google and add HEX in front of it, and then you will get the color code or the hexadecimal value of that particular color or the metal. And now let's change the name of this material to gold. So I'll type gold and press enter. Now to save this in the asset or the material library, I'll go to the scene collection again, click on this drop down arrow, then click here, and here you have the gold material. So after selecting it, if I right click and go to the mark as asset option, then this gold material is now saved in the asset library. To view the asset browser here, click on this icon and select the asset browser. Now we'll refresh it, and here we have all the 4 materials that we have made till now. The first material that we created in this chapter was this chrome metal, the second one was this brushed aluminium, the third one that we created was this dark grey metal, and the fourth metal that we created just now was this gold metal. And now it's the time to move to the last topic for this chapter, which is creating glossy base materials. So now we'll change this to the shader editor again, click on this icon and select the shader editor. Now I'll select this UV sphere and we'll create a duplicate of it to create the glossy material. So I'll press Shift plus D and then right click, then I'll go to the scene collection here and I'll hide the UV sphere which was used to create the gold material, and let's also collapse this by clicking on this down arrow and this one also. Now to create the glossy material on this UV sphere, first I need to remove this gold material. So click on this cross icon, and to give it a new material, click on the new button, and now we have the default material assigned to our UV sphere. Now the most important thing while creating glossy materials is that the roughness of this material is completely 0. So let's go to the shader editor, and in the principal BSDF I'll reduce the roughness to 0, and now if you look at the UV sphere, its surface is very shiny, and that's a characteristic of glossy materials. And to change its color, I'll go to the base color and let's change this to blue color, and now it looks like this. And it's not necessary that you have to give only blue color to it. You can assign any color of your choice to this material. Now one of the most important things to notice here is that the surface of this UV sphere is very reflecting, and the reason for this is that I have reduced the roughness to 0. However, this reflecting nature is different from that of a metal. Suppose I go to the metallic property and increase it to its maximum value, you can see here that this material is also reflecting, but it's different from our glossy materials. It's showing the complete reflection on the surface, but if I reduce the value to create a glossy material, then you will still notice some reflections and some lights, but you can't completely see them on the surface. And that's what make glossy base materials different from metals. And now this blue glossy material looks ready, and you can even try different colors from here. Right now it's set to a blue color, but you can even create different materials by changing the colors from here. Like right now it looks like a blend of yellow and red color, and if I change it to green color, it looks like this. So you can make any number of materials with the same properties of roughness, metallic and other things, and just simply by changing the colors. So for this one I'll set the color to green, and now we can save this in our asset library. For this I'll go to the scene collection, click on this arrow, then click here, and here is our material. So I'll double click on it to change the name, and we'll rename it as glossy green and press enter to rename. Now to save this in our asset library, we have to right click and select mark as asset, and now let's view it in our asset browser. So I'll click on this icon, go to asset browser, and I'll refresh by clicking on this icon, and here we have the glossy green material. So now we have added these 5 materials in our asset or the materials library. And now to manipulate the looks of your glossy material, you can use the roughness of the principal BSDF. So let's try to create a new material which will also be glossy but with a different roughness. For this, click on this icon and select the shader editor. Now I have to create a new duplicate, so I'll select this, press Shift plus D and right click. Now in the scene collection, if I scroll down, here we have the new sphere. Let's also collapse this by clicking on this icon, and I'll hide the previous UV sphere. So on this UV sphere, we have this glossy green material applied, and instead of creating a new material again and doing all these settings, we can even create a duplicate of it and do the changes on that material. And to do this, click on this icon here, which is the new material icon, and now you can see here that the name of this material is glossygreen.001, which means that it has created a duplicate of the previous material. And now if I go to the roughness and increase it slightly, you will notice that the look of your material has changed. It still looks like a glossy material, but the reflections or the highlights on the surface have now reduced, and at a roughness value of approximately 0.23 or 0.24, it appears like a painted glossy surface. I think that we should round off the roughness to 0.25 for a better look, and now it looks perfect. So I'll change its name from here. Let's remove this 001 at the end, and I'll type painted and press enter to finalize. Now this is the glossy green painted material, and we'll save this in the material library. For this, go to the scene collection, click on this arrow, then click here, and here you have the glossy green painted material. So I'll click on it, right click, and then mark as asset. To open the asset browser, click on this icon and select the asset browser. And if I refresh, so one of these materials is the glossy green and the other one is the glossy green painted. So this brings us to the end of this chapter. In the previous chapter, we begin with the practical usage of materials, textures and nodes in Blender, and we even begin the creation of some realistic materials in Blender. And in this chapter, we'll take a step ahead and we'll be creating some more materials like the clear coat shader, glass shader, the candle emission shader, a simple cloth shader and a lot more. So let's begin with it. Here we have this layout as the default because in the previous chapter, that is the chapter number 21, we created this layout for creation of materials and made it the default layout which will always appear whenever we open a new file. And the first topic for today's chapter is creating a simple clear coat shader. So the first thing is, what exactly is clear coat shader? Clear coat means a transparent and a glossy layer of paint which is applied over a surface, and this coating provides hardness and resistance to various chemicals, and we'll be making this clear coat shader in Blender. So first let's turn on the render view by clicking on this icon, and to check the render engine, click on this icon. And here it is set as Cycles Render Engine. So to create a new material, we'll go to the shader editor, click on the new button, and here we have the default principal BSDF applied to the UV sphere. Now the clear coat material show a lot of reflection on its surface, and we explored in the previous chapter that the reflection or the highlights on the surface are controlled with this roughness value. So if I need to increase the reflections, I will have to reduce this roughness value from here, and here you can see that our UV sphere is showing some reflections of these lights, and to view it properly, let's change the base color by clicking here, and we should change it to a dark color. So I think we should change it to purple. This one looks good, and now these highlights or the reflections are clearly visible on the surface. And if you want to increase the reflections even more, then you can reduce the roughness value to exact 0, and now the surface is 100% reflecting all the light that is falling on it. Let's also go to the base color, and to make it darker, we can use this brightness slider from here. So if I reduce this, you can see here that the UV sphere is now colored as dark purple. The reason for doing this is that the reflections are more clearly visible on a dark colored object as compared to light colors like white or yellow. So we needed a dark color here, and we used the dark purple color on this surface. And now to make it look like a clear coat or a painted surface, go down in the principal BSDF, and here you have the option of coat. So if I select this, then here you have the option of weight, and this basically controls the intensity of the clear coat or the paint that will be applied to your object. So if I increase it to its maximum value of 1, it will basically add a layer of paint or a coating on your object surface. And suppose you want to make the surface look like it has been recently painted, meaning that the surface should be a little wet, the paint should be visible on it, and to do this, we have to use a texture which is the noise texture along with a bump node. For this, go to the shader editor, press Shift plus A, and in the texture, select the noise texture. Let's place it here, and to add the bump node, press Shift plus A, go to vector and select the bump. Let's place it here now. Now to connect them together, take this factor socket and connect it to the height, and take this normal socket and connect it to the normal here. And now the surface looks as if it has been recently painted, but right now it looks unrealistic because the strength of this bump node is very high. And if I reduce this, you will notice that it now looks realistic. It looks as if a purple colored paint is applied on this UV sphere. And this is the clear coat material or the clear coat shader. And now it's the time to save this clear coat shader in our asset or the material library that we created in the last chapter. And for this, we need to save this file first. So I'll press Ctrl plus S, and we'll have to save this file in the same folder where we saved our last file, because only then it will save our materials in the material library. So I'll save this with the name m82.blend, and I'll click on Save Blender File. Now to save this material, first let's rename it from here, and I'll rename it as clear coat and press enter. Now we'll go to the scene collection, click on this drop down arrow, then click here, and here you will find the clear coat material. So I'll select this, right click, and now you will find the option of mark as asset. And if I select this, then this clear coat shader or the clear coat material will now be saved in the asset or the material library, and we can even view it in this Blender file. For this, click on this icon, and here you have the option of the asset browser. This will show you all the assets that are saved in your Blender file, including the default ones and also the ones that you created on your own. To view only those materials that we created, go to this drop down menu and select the user library. Now these are all the materials that we have created so far in this course. In this chapter, we created this clear coat material, and all the others were created in the chapter number 21. So now this material is saved in the asset library, and now we'll be creating some more materials to add here. And the next topic for this chapter is creating a simple glass shader. For this, I'll change this back to the shader editor, click on this icon, and select the shader editor. So to create a glass material, we first need to remove this material that is applied on the UV sphere. So I'll select this and we'll create a duplicate of it by pressing Shift plus D and right click. Now in the scene collection, I'll select the previous UV sphere and we'll hide it by clicking on this eye. Let's collapse this menu by clicking on this drop down arrow. Then I'll select this UV sphere And to remove this material, click on this cross icon. The reason for creating a duplicate was that we wanted to have both the materials in our Blender file. The clear coat shader that we just made, which is now saved in this hidden sphere, and also the glass shader that we are creating right now. So to begin with, we'll go to the shader editor, click on this new button, and here we have the default material applied to this UV sphere. Now the most basic characteristic that sets the glass shader apart from all the other materials is the transmission. So in the principal BSDF, if I select the transmission, we have this weight option here, and if I increase it to its maximum value, you can see here that the object looks like this. Right now it does not look like a real glass because it has a lot of roughness on its surface, and as a result we can't see through the glass right now. To fix this, go to the roughness option here and reduce it to 0. So now you can see through this UV sphere. For example, if I select this plain background and change its color from the principal BSDF, like if I change it to blue color, you can clearly see the blue background through the UV sphere. But right now I'll undo it by pressing Ctrl+Z, and so our glass shader is now ready. But if you want to give it a more realistic look, then instead of keeping the roughness value to exact 0, you can slightly increase it to a very low value like 0.01 or 0.02, something near it, and this will add a slight roughness to your object, which will give it a realistic look. And one more important thing to note here is that we are right now in the Cycles render engine, and with this node system you will get a glass shader like this only in the Cycles render engine and not in the EV. So do ensure that you have selected the cycles in the render properties. And now to save this material, I'll go to the shader editor, click here to rename, and I'll type glass, press enter to confirm. Now go to the scene collection, and with this sphere selected, click on this drop down menu, then click here, and here you have the glass material saved. So I'll select this, right click, and select the mark as asset option. Now this asset is saved in our material or the asset library. To open the asset browser, click on this icon and go to the asset browser. And here we have the glass material saved. And to see how it will look on a different object, I'll select this UV sphere and press H to hide it. And let's add a Suzanne or the monkey model by pressing Shift+A, go to mesh and select the monkey. Let's move it upwards by pressing G and then Z to move it in Z direction, and left click to finalize. Before applying the material, I'll right click and shade smooth, and let's also apply a subdivision modifier by going to the modifier properties, then add modifier and select generate. Here you will find the subdivision surface modifier, and now if I select this glass material, left click, drag it and place it on the Suzanne model, then now this model is having the glass material on its surface. So whenever you're working on a project where you need a glass material to be applied on any object, you can simply go to the material library, select this glass shader and apply on that object. And now the third topic of our chapter is to create the model of a candle and give it some material. And to begin with it, I'll delete this Suzanne model by pressing X. Let's also bring the shader editor here by clicking on this icon and selecting the shader editor. And now to begin with the actual modeling, I need to add a cube in my scene. So I'll press Shift+A, go to mesh and select the cube. So here we have the cube added in the scene, and this will be the base on which the candle will be placed. But I think that we need to move it down by pressing G and then Z and left click to finalize the position. And to get a better view, let's also move it in the Y direction towards the camera. So I'll press G and then Y, and let's bring it forward in the Y direction. Let's also bring it slightly upwards by pressing G and Z, and this looks perfect now. And to give it some material, I'll go to the shade editor, click on this new button, and let's change the base color from here, and let's change it to yellow color. And now our base for the candle looks perfect. Now to place the candle on the top of this base, we first need to place our 3D cursor here. To do this, hold down the shift key and right click at the top of the base, and now we have the 3D cursor placed on the top of the cube. Now to create the candle, we'll be using a cylinder. So I'll press Shift+A, go to mesh and select the cylinder. Now let's tab into the edit mode, and we need to scale it down. So I'll press S and let's scale it down like this, and left click to finalize. Let's also move it upwards in the Z direction. Now we need to scale it up in the Z direction also, and this much looks perfect. So I left click to finalize. So the model of our candle looks like this right now, but I think that we need to scale it down in the X and Y directions. For this, I'll press S, and because we only need to scale down in X and Y directions and not in the Z direction, so I'll press Shift and Z, and now I can scale down in the X and Y direction simultaneously. Now it looks perfect, so I'll left click to finalize, and I'll go back to the camera view by pressing 0 on the numpad. Let's move it downwards by pressing G and then Z, and it looks like this now. And now to make it look like a real candle, we need to go to the face select mode by pressing 3, and also I think that we should go to the solid mode instead of the render view since we are modeling this candle right now. So click on this icon to go back to the solid mode, and now to model the candle, select this top face, press I to inset, and let's inset the face this much and left click to finalize. And if you want to change the size of this face, you can press S to scale it up or scale it down. But I think that this much should work, so I'll left click to finalize it. And what I'm gonna do with this face is that I'll extrude it in the Z direction. Let's move it downwards and left click to finalize. Now I'll inset this face again by pressing I and left click to finalize. And the reason for doing all this is that we want to make the wick of the candle. And to do that, we now have to extrude this face. So press E and let's move it upwards in the Z direction and left click to finalize. Now we'll scale this down like this. Now let's insert it one more time by pressing I and taking the cursor towards the candle. Now we'll be making this very small because this is going to be the base of the candle's wick. So I think this much should be fine. So I left click to finalize this. And now to make the wick, we need to extrude this face. For this, press E and move it upwards and left click to finalize. But one problem with this is that the wick is completely straight, but in reality it does not look like this because it is slightly bending or slightly curved. And to make it appear slightly bending, we'll first move this down by pressing G and then Z like this and left click to finalize. Now we'll rotate this face by pressing R and let's rotate it a little bit like this and left click to finalize. Now we'll extrude again and left click. Now you can see here that the wick of the candle is now being bent like this. Similarly, we'll again extrude it 2 to 3 times by first rotating it a little bit, left clicking and then pressing E to extrude it and left click again. Now this looks good. To make it look better, I'll scale down this face by pressing S and let's scale it down like this and left click to finalize. And now our candle looks like this. We'll go back to the camera view by pressing 0 on the numpad. Now you might have noticed that in real life, the melted wax of the candle looks like this. And to create this thing in our candle model, we need to view the top face of this candle model, and with the face select mode enabled, we'll select some random faces from here. So with the shift key holded, I'll select some random faces like this. But here you can see that the tip of the candle wick is also selected and we do not need that. So to deselect it, hold down the control key and left click and drag like this. Now the face at the tip of the candle wick is now deselected. So we'll continue with selecting the random faces here. So you can select any random faces that you wish. It's not mandatory to select only those which I am selecting in my scene right now. And now with these faces selected, press G and then Z to move them downwards like this and left click to finalize. Let's go back to the camera view by pressing 0, and now the model of the candle looks like this. To make it look realistic, we'll return back to the object mode and we'll apply some modifiers. We'll be applying 2 modifiers. The first one is the bevel modifier and the second one is the subdivision modifier. So in the modify properties, click on add modifier, then go to generate and select the bevel. Then again go to the add modifier, and in the generate you will find the subdivision surface. Let's increase the level viewport to 2 or maybe 3, and you can also make it more realistic by going to the bevel and increasing the number of segments. By default it is set at 1, but let's change it to a higher number like 3, and now it looks like this. So if I go to the camera view again, then the candle model looks perfect now. And now to make the flame of this candle, we'll be adding a UV sphere at this point. So let's first place our 3D cursor here at the tip of the candle wick. For this, first I'll zoom in and then hold the shift key and right click here. Now to add the UV sphere, press shift plus A, go to mesh and select the UV sphere. Tab into the edit mode and we should scale it down like this. Let's zoom in to get a better view, and we would be making a simple flame out of this UV sphere. It wouldn't be very complex, but it would be kind of cartoonish and would look very simple, and then we'll be applying our material over it. So for this, we need to turn on the vertex select mode by pressing 1, and now to make its shape look like that of a flame, we have to select the vertex at the top of the UV sphere. So we'll select this vertex here and then turn on the proportional editing from here, or you can even use the shortcut which is O, and now we'll move it upwards by pressing G. And to see the circle of influence of the proportional editing tool, you have to scroll up your middle mouse wheel or the scroll wheel, and here you can see that we have the circle of influence. And now if I move it in the Z direction by pressing the Z key and moving it upwards like this, you can see that it now looks like a little droplet or like a flame. So we'll finalize it now with the left mouse button click Let's go to the camera view again by pressing 0 on the numpad, and now it looks like this. Now we'll turn off the proportion editing tool, press G and then Z, and let's move it in upwards direction like this. Let's return back to the object mode now, and we should now check whether the candle flame is properly placed on the tip of the wick or not. From the camera view or the front view, it appears perfect. Let's also go to the side view by pressing 3 on the numpad, and it looks like this from this view. I think that we should move it in Y direction by pressing G and then Y, and let's move it like this and left click to finalize. Let's also go to the top view by pressing 7 on the numpad, and it looks fine from this angle. So we'll go back to the camera view now by pressing 0 on the numpad. Now to make it look smooth, right click and select shade smooth. And now the modeling of the candle is complete, and so we should move to applying the materials now. So we'll go to the render view, and currently we have enabled the cycles render engine. So with this flame selected, go to the shade editor and press new to give it a default material. We'll change the color of this flame from here. Let's set it to yellowish, and we should zoom in to view it properly. Right now it looks kind of orange in color, but I think that we should keep the color to yellow. So I'll again go to the base color and let's keep it to yellow. Now since the candle flame should look like burning or basically emitting light, so we have to go to emission here, and we need to set the same yellow color to the emission color also. And to do this, you can basically left click and drag this color, and now to drop the color in the emission color, simply release the left mouse button click, and now both the base color and the emission color is same. To see the emission effect here, we need to increase the strength, so let's increase it to a very high value like 40. And to see how it actually looks, we need to turn off all the lights in our scene. So we'll go to the scene collection, and we have these two lights in our scene right now. So we'll click on this I button, and similarly for this one. And now there are no lights in our scene, and all the brightness is because of this candle flame. But yes, right now we have a default HDRI added in Blender, which is also contributing to the light in our scene. And to disable it, click on this drop down here, and here you have the option to control its strength. So we'll reduce it to 0, or maybe to a slightly higher value like 0.1, or I think that we should lower it down to 0.05, and now it looks like this. Now most of the light in our scene, or to be more precise, more than 95% of the light in our scene is coming from the flame of this candle. Now the candle flame looks perfect, but another thing to consider is the material of the wick of the candle. We'll go to the shade editor, click on the new button, and here you have the default material applied to this candle. Now we have to go to the base color and change it to complete black. To view it properly, let's try to change the angle, because earlier the background was also black, so the candle was not visible properly. But now from this angle we can clearly distinguish between the candle and the background. The next thing to do is that we have to increase the roughness value to its maximum. So we'll increase it to 1, and we'll be using this material not for the candle but only for the wick of the candle. But because both the candle and the wick are part of the same object, both are having this black color. To fix this, tab into the edit mode, and we have to go to the side view by pressing 3 on the numpad. I think that for editing we should increase the strength of the HDRI so that all the things are clearly visible. So we'll go to this drop down menu here, and let's increase the strength to something like 0.5, and now we have a better lighting in our scene. So let's zoom in, and now what we are gonna do is that we'll be selecting only the wax part of the candle, or basically the main body of the candle, and we'll assign it a different material. To do this, first enable the X-ray mode by pressing Alt plus Z. Take your mouse cursor over here, left click and drag it, and if I release the left mouse button click, then the entire candle body except for the wick is now selected. And to give it a different material, we'll go to the materials properties, click on this plus icon, and then click on this assign button. Now if I go to the object mode, you can see here that the candle body is having the white color, but the candle wick here is having a slight dark color. Let's go back to the camera view now by pressing 0 on the numpad, and now our candle looks like this. Now to create the wax material of this candle, I'll select this body, and in the shader editor, click on this new material button. Let's go to the base color and change it to slight yellow, and this looks fine. Now one of the most important characteristics of the wax material is that it allows some light to pass through its surface. That is, it shows slight patches on its surface where light is being passed. You can see this image of a real candle and how it is allowing some light to pass through it. And to create an effect like this, in Blender, you have to go to the principal BSDF, and here you have the option of subsurface. So I'll select this, and to see its effect, we have to increase the weight from here. So let's try to increase it, and now if I zoom in, you will notice that there are some slight red patches here. It might not be properly visible from this angle, so let's try to change the angle. Let's zoom in a little bit, and now if you observe closely, then you can see that there are some slight red patches here which are due to this subsurface, and now it looks like a real wax material. With this, the model of a candle is now ready, and while creating this candle we basically made 3 different materials. One was this flame material, the second one was this wick material, and the third one was this wax material. So we'll now save all of them in the material or the asset library. So first, with this wax selected, let's go to the shader editor, and from here we'll change its name. Let's change the name to wax. Now let's go to the flame material. So I've selected this flame, go to the shader editor, let's rename it from here, and I'll type flame and press enter to confirm. To do the same with the wick material, click on this candle object, and here in the material properties tab, we have two materials. One is the material.003, which is the wick material, and the other one is the wax material. So we'll select this black material, which is the wick material, go to the shader editor, and let's rename it to wick. Press enter to confirm. Now to save these materials in the material library, go to the scene collection, click on the drop down arrow of this cylinder, then click here, and here you have two materials, the wick and the wax material, which are assigned to this candle object. So I'll select this wick material, right click and mark as asset. Similarly, I'll go to the wax material, right click and mark as asset. Now for the flame material, left click on this flame, go to the scene collection, and we'll scroll down, click on this drop down arrow, and then click here. And here you have the flame material. So I'll select this, right click and click on mark as asset. Now to view the asset library or the material library here, click on this icon and go to asset browser. This one is the flame material, this one is the wax material, and this one is the wick material. So we have now saved all these materials in the material library, and now it is the time to move to the next topic of this chapter, which is creating a simple cloth shader. And for this, we'll save this file and open a new Blender file. So I've created a new Blender file here with this layout, which we saved as the default layout in the chapter number 21 for all the files. And to create the objects for the cloth shader, we basically have to delete all this setup. For this, press A and X to delete all. And now we'll be adding an icosphere in our scene. So I'll press Shift plus A, go to Mesh and select the icosphere. The icosphere is different from the UV sphere because of its structure. You can see these pointing vertices at the surface of the icosphere, whereas if I add a UV sphere by going to the Add menu, and in Mesh if I select the UV sphere and move it in X direction, then you can notice the difference between the two. So in this case, we'll require an icosphere and not the UV sphere. So with this selected, I'll press X to delete it. Let's select this icosphere. Now this icosphere will be used to place our cloth object. And to create the cloth object, press Shift plus A, go to Mesh and add a plane. To increase its size, let's tab into the edit mode and press S to increase the size. I think around this much size should work fine. So I'll left click to finalize it, go back to the object mode, and let's move it upwards by pressing G and then Z. And now we need to subdivide this plane. For this, right click and subdivide, and to increase the number of cuts, click on the subdivide menu, and we'll change the number of cuts to somewhere around 50. And let's get back to the object mode. Now to make it look like a real cloth, we'll be applying some simulation to it. Currently in this course we have not understood simulations, but it's basically used for creating stuff like clothes, water, fire, and all the other similar things. And to apply these simulations, go to the properties editor, and here you have this icon of the physics properties. Here you will find all the simulations that you can apply to your object. Now there are two objects in our scene. This plane would act as a cloth, and it will fall on this icosphere. As a result, this icosphere would act like a collision object. So I'll select this icosphere, go to the physics properties and apply the collision. We'll be learning all these physics properties or the simulations in the future chapters of this course as well. But right now let's look at the collision. So here we have applied the collision physics to this icosphere, meaning that it will now become a colliding object, and we'll see its effect later on. Now I'll select this plane, and to make it a cloth, go to the physics properties and select the cloth. And right now we'll keep the default values that are present here. We won't be changing anything. First we'll look at the impact that these default settings would make in our scene. But before moving further, let's first save this file. So I'll press Ctrl plus S, and we'll save this in the same folder where I saved the previous two files. So let's change the name from here, and let's keep it cloth shader. Press enter and click on the save blender file. Now this file is saved, and to see how this cloth physics will work, go to this animation timeline that is present here and press this button to play the animation, or else you can simply press the space bar to view the animation. So I'll press the space bar, and this is how the cloth simulation is working. This plane object has now turned into a cloth which fell on the icosphere, and we created this simple animation from it. And to make the collision look better and more realistic, go to the physics properties here, and we'll scroll down, and here we have an option of collisions. So I'll select this, and if I scroll down again, you will find an option of self collisions. And if I turn this on and go back to the frame 0 by left clicking here and dragging it on the frame 0. And now if I play it, you will notice that now the clothes and the collision looks much more realistic than before. So the only thing that you should do right now in this physics properties is to turn on the self collisions. Although everything looks perfect right now, but if you look at its geometry, the cloth material looks very rough, and to fix this, simply right click and select shade smooth, and now it looks like a real cloth material. And to fix these pointing vertices or the edges, simply go to the modifier properties. Here this cloth modifier is appearing because we have applied the cloth simulation to our object. But if I go to the add modifier, then in the generate, I'll find the subdivision surface. So I'll apply it, and now that roughness is completely gone and our cloth objects look perfect now. If you want to give it even more realistic look, you can simply increase the levels viewport in the subdivision menu. Right now it is set to 1, but let's increase it to 2, and now the subdivision has increased in the cloth object, which makes it look better. Now everything in this cloth object is perfect right now except for the thickness. If you look closely, you will notice that our cloth object has no thickness. It simply looks like a paper, and to give it some thickness, we have to apply the solidify modifier. So I'll go to the modifier properties, click on add modifier, and in the generate you will find the solidify modifier. And now you can see that some thickness is visible on our cloth material. And now our cloth object looks perfect. And so it's the time to give it some material. But before that, we need to get the lighting set up first. For this, I'll press Ctrl+S to save all the changes. And now I'll be opening the same file where we created the candle. For this, press Ctrl+O, select that file and click on open. And here we have the file where we made this candle. Now I'll select this candle, and with shift key holded, I'll select this flame, press H to hide them. Now to bring the cloth object and the icosphere in this scene, we need to import them. But before that, let's place this 3D cursor at the center by pressing Shift+C, and now it's at the world origin. To import the cloth material, click on this file option and we'll go to append. Always remember that whenever you have to add any object from another Blender file, you choose the append option. Whereas if you want to add a 3D model which is downloaded from some website, or basically it is not in a Blender file but it's simply a model, then you have to use the import option. But right now we have the file saved on our system, so I use the append option, and here we have the cloth shader file. So I'll select this, click on append button, and in this list we'll go to the collection, then I'll select this collection and click on append. We studied about adding different objects from other Blender files as well as the 3D models from some external websites in this chapter of this course. But currently let's go to the camera view by pressing 0 on the numpad. Let's zoom out. Now we need to move the camera so that we can view everything properly. So I'll select the camera from the scene collection. Let's scroll up, and here we have the camera. In the chapter number 21 we locked its position, but right now we need to change it. So I'll unlock it from here. Similarly with the rotation also, I'll unlock them, and now I can change the position of our camera. For this, go to the view option and select lock to camera view. Now if I zoom out, the camera view will also change. Let's select this cube here and press X to delete. Let's also select this icosphere, and with the shift key holded, I'll select this plane, and let's move them upwards by pressing G and then Z like this, and left click to finalize. Now to get a proper view from the camera, we'll select the camera from the scene collection, and to move it, I'll click on this item, and from here you can change the location and the rotation of your camera. So let's increase it in the Z direction to move it upwards. Now I'll reduce the rotation in the X direction. Let's again move it upwards in the Z axis, and now it looks perfect. Let's also turn off the lock camera to view. For this, go to the view and turn off the lock camera to view. Now let us zoom in, and this is the icosphere object which has the collision physics applied to it, and this is the cloth object. Now to give it some material, first I'll play the animation by pressing the space bar and press the space bar again to stop it. It looks perfect like this, and I think that we should move the cloth and the icosphere upwards so that it is completely visible. For this, with the shift key holded, go to the scene collection and select the icosphere. Now before changing their position, there's one more important thing to do, which is to go to the timeline and take the pointer back to the frame 1. And now to move them together, press G and then Z, and let's place them here. And now if I play the animation by pressing the space bar, we can now see the complete cloth object in our scene. Now moving to the materials part, first let's turn on the render view by clicking on this icon. Now to get a better lighting in my scene, I'll unhide those two lights which we hided while creating the candle. For this, go to the scene collection, and here we have the two lights. To unhide them, click here. Similarly with this one also, and now we have a proper lighting in our scene. And now to give it some material, we'll first change this to the shader editor. So click on this icon and select the shader editor. Click on this new material button, and here we have the default material applied to it. So I'll select this cloth material, and we'll do some changes in the material to see how it looks in our scene. So the most basic thing for our cloth is its base color. So I'll go to the principal BSDF, click on the base color, and we can change the color of the cloth from here. You can choose any color that you would like to see on your object, but in this case I'll be going for the red color, so I'll select the red color here, and our cloth object looks like this now. I think that the strength of these lights is very high in our scene. So first I'll select this light, go to the object data properties by clicking here, and from the power I can control the strength of this light. Right now it is set at 1000, but I think that we should reduce it to 200 watt and press enter. Similarly with this one also, I'll select this, go to the power option and change it to a lower value like 200, and now it looks perfect. The red color of our clothes is now clearly visible. Now, as you must have observed, almost all the clothes have a rough surface, but right now this cloth object looks very smooth. So we'll go to the roughness and increase it to the maximum value, that is 1, or to make it realistic, we'll reduce it to a slightly lower value like 0.95 and press enter to confirm. And now it looks like this. This will give some roughness to our cloth object, and to give it some texture, we'll go to the shade editor, press Shift plus A, go to texture, and let's add a magic texture. I'll place it here, and then we'll add a bump node here. So I'll press Shift plus A, go to vector and select the bump. Let's place it here. Now select this factor socket of the magic texture and connect it to the height socket. Then take this normal socket of the bump node and connect it to the normal of the principal VSTF. And now you will notice some patterns on your object's material. So if I zoom in to view it properly, it appears like this. But in real life, no cloth has a pattern like this. So to adjust this pattern, you will go to the magic texture and increase the value of the scale. By default, it is set to 5, but let's increase it to a very high number like 50. And now you get this realistic looking pattern on your object's material. To make it look even more realistic, you can further increase the scale. So let's increase it to around 60, and now it looks like this. Now if I zoom in to view it closely, you will observe that it really looks like a real cloth fabric. It has a pretty decent texture on its surface, and you can even control the strength of this pattern or this effect from the bump node here. So here you have the option of controlling the strength. So you can play with different options here, try to change the values, and you will end up making some different and some new patterns for your cloth object. Also, we'll try to add a noise texture which will give a slight roughness and a realistic look to the cloth material. So I'll press Shift plus A, go to texture and select the noise texture. Let's place it here. Now I'll take this factor value and connect it to the height of the bump. Then I'll change the scale to a very high value like 50. Also I'll increase the detailing from here to give it a realistic look. Right now it is set to a value of 2, but if I increase it to a higher value like 16, and it looks like this now. But I think that we should increase the scale even more, because right now it's not looking realistic. Like in real life, you won't see a material like this. So let's increase the scale to see the changes. So I'll go to the scale option in the noise texture, and let's scale it up to a very high value like 300 or 400, and then press enter. And now this is what our material looks like. It has a higher roughness on its surface, which is giving it a very realistic look. And all this is because of this noise texture. So this noise texture provided it a very rough look, and earlier when we used the magic texture, then it gave it a specific pattern. Also, I can connect both of them together to see the effect of both the textures on my clothing object. For this, I'll select the magic texture and let's place it here. And to connect them together, we'll use the mix node. For this, press Shift plus A, and in the color you will find the mix color. Let's place it here. Now take this factor socket of the noise texture and connect it to the B. Then take the color socket of the magic texture and connect it to A. Now to connect the mix node with the rest of the node system, we'll take the result socket and connect it to the height socket of the bump node. And now you will notice that our object's material would show a combination of both these textures. That is, it will have a realistic looking roughness due to the noise texture and this pattern because of the magic texture. And so we have created this simple clothing shader in our scene. Let's also save this material in the material or the asset library that we created. For this, go to the shader editor. Let's rename it from here and let's keep its name as red fabric. So I'll enter the name and press enter to confirm. Then go to the scene collection, click on this arrow, then click here, and here you will find the red fabric material. So I'll select this, then right click and go to the mark as asset option. To view the asset browser, click on this icon and select the asset browser. And here we have the red fabric material saved in our library. So till now in these two chapters, that is this one and the previous one, we created these 12 materials and even saved them here so that we can use them whenever we are done with the modeling of any object and we need to apply some material to it. And this also brings us to the end of this chapter. In the previous two chapters, that is chapter number 21 and 22, we discussed about basic shaders. We also learned to create a material library and made a lot of basic materials in Blender. And from this chapter, we'll be taking a step further as we'll begin understanding the procedural shaders. Here we'll be working more on the textures and combining different types of nodes together to get different types of results. So let's begin with it. We have this default layout applied to the Blender, where we have this shader editor on the top, 3D viewport at the bottom, and a simple setup of a UV sphere and some lighting. If you also want to set up the same as the default for your Blender file, then you should check out the chapter number 21 of this series, where we discussed about all this in detail. But right now let's go to the camera view by pressing 0 on the numpad. So the first topic of today's chapter is shader nodes. To understand it, if I go to the shader editor and press Shift plus A, here you will find a category of nodes which is the shader, and within this category there are a lot of shader nodes here, and in this chapter we'll be understanding the functioning of each one in detail. And for this we'll turn on the render view first, and I have enabled the cycles render engine by default. Now I won't be using this UV sphere right now, so I'll press X to delete it, and let's add the Suzanne or the monkey model. For this press Shift plus A, go to mesh and select the monkey model. Let's move it up in the Z direction by pressing G and then Z, and let's place it here. To give it a better look and to make it realistic, we'll be doing two things. One is to right click and shade smooth, and the other thing is go to the modify properties, click on add modifier and select the generate. From here we'll be applying the subdivision surface modifier. Let's also increase the levels viewport to a higher number like 3, and now it looks perfect. Now to give it some material, I'll go to the shader editor and click on the new button. Here we have the principal BSDF applied to this monkey object. In fact, the principal BSDF is the most commonly used shader node in Blender. Even in the basic shaders chapter, most of the things that we did were related to principal BSDF, like changing the color, the metallic property from here, the roughness, and in fact it is a combination of many different shader nodes. Because if I go to Shift plus A and then shader, we find nodes like emission, refraction, subsurface scattering, glass BSDF, glossy BSDF, translucent BSDF, sheen, and transparent BSDF, and all these are combined and put together in the principal BSDF only. For example, if I go down, I'll find this emission option, and it is the same as the separate emission node that we just saw in the shader menu. Similarly, the sheen, transmission, subsurface scattering, all of these can be accessed separately by using their respective shader nodes, but Blender combines them together in the principal BSDF. And this makes the principal BSDF the most important and the most useful shader node in Blender. Now the next node that we'll explore is the diffuse BSDF node. For this, go to the shader editor, press Shift plus A, go to shader and select the diffuse BSDF. Let's place it here. Now to break the connection between the principal BSDF and the material output, hold down the control button, right click and drag your cursor like this, and now the principal BSDF is removed from a monkey object. Now I'll take this socket of the diffuse BSDF and connect it to the surface socket of the material output. Right now it looks the same as what we saw when principal BSDF was connected, but here you have the option of the color, and if I click on it and change it to blue color, then simply the color of the object changes. And this is the basic use of the diffuse BSDF. It does nothing except for giving you the option to change the color of your object. And as I already told you, a lot of shader nodes are combined together in the principal BSDF only. So even if you have not added this diffuse BSDF, you can use the principal BSDF and change the color of your object from the base color option. Now the next one on our list is the subsurface scattering. So I'll go to the shader editor, press Shift plus A, and in the shader, here we have the subsurface scattering. So I'll select this and let's place it here. Now this subsurface scattering works in the same way as the subsurface option in the principal BSDF. We learned about the subsurface scattering in the chapter number 22 of this course, where we modeled this candle and created it material with the help of subsurface scattering. But to explain it in simple words, it is basically a process or a mechanism in which the light passes through or penetrates the surface of some translucent object and it is scattered by interacting with the material. To explain it with the help of an example, you might have observed that when you keep your hand in front of some light source, it looks like this. Basically, the light tries to pass through your hand, which is the translucent object in this case, and as a result it looks like this. And to see its effect here, I'll take this socket and connect it to the surface socket of the material output. Right now we can't see any effect here, and that's because of two reasons. One of them is that the scale value is very less, so if I increase it to a value of 1, we see some light scattering around the eyes of this monkey object, and it is appearing like this because we have added only two lights in our scene. One of them is this white light and the other one is this pink light. To understand it more deeply, I'll select this light. Let's go to the top view by pressing 7 on the numpad, and let's zoom out, and I'll create a duplicate of this light by pressing Shift plus D, and let's place it behind the monkey or the Suzanne model. Left click to finalize. Here in the object data properties, we can change the color and the intensity of this light. So let's go to the color and I'll change it to red color. Let's also increase the power. Right now it is set at 1000 watt, but let's increase it to 5000 watt. Now I'll go to the camera view by pressing 0 on the numpad, and to see the effect of the subsurface scattering, I'll move the light behind the monkey model. So with that light selected, I'll press G to move it, and if I take it close to the ears of this monkey model, you will observe that the model is now acting as a translucent object which is showing the subscattering effect. If you look at the other ear, it does not appear to pass any light through it right now, but this ear is allowing the light to penetrate through its surface and show the subsurface scattering effect. And that's That's because we have the subsurface scattering applied to this monkey object. In fact, to see this effect on the rest of the object apart from this ear, you can go to the subsurface scattering and increase the scale from here. Right now it is set at 1, but if I take it to 5, then you will begin to see this effect on other parts of this object as well. The effect will surely be visible more on this ear because the light is close to it and lesser on the other side. And this is the subsurface scattering node. But instead of using this node separately, you can simply go to the principal BSTF, and in the subsurface option, you can change all these settings which are the same as the settings in this node. Now the next one that we are going to discover is the glossy BSTF. So press Shift plus A, go to shader and select the glossy BSTF. Let's place it here, take this socket and connect it to the surface socket of the material output. So this glossy BSTF is a simple node which is used to control the reflections on your object surface. So if I go to the roughness option here and reduce it to 0, you will notice that the object surface is now reflecting all the light that is falling on it. And if I take the roughness to its maximum value of 1, it won't reflect any light that is falling on it. And this is the use of the glossy BSTF. Just like the other two nodes, this one can also be controlled from the principal BSTF. Because here you have the option of roughness, and if you increase or decrease it, you will see the same effect which you expect while using the glossy BSTF. Now the next one is the anisotropic BSTF. Earlier in the previous version of Blender, the anisotropic BSTF used to be a separate node, but now you can control the anisotropy from the glossy BSTF also. So here you have the option of the anisotropy, and if I increase it to a higher value like 2 or 3, you will notice some changes here. So this anisotropy basically creates a brushed effect on your object's material. We learnt about this one also in detail in the chapter number 21 of this series, where we created this brushed aluminium material. Let's return back to the camera view by pressing 0 on the numpad. Now before going further, I'll delete the light at the back that we created. So I'll go to the scene collection and select this light.002 and press X to delete it. Then I'll select this monkey model again. And now the next one that we'll discover is the refraction BSTF. So press Shift plus A, go to the shader and select the refraction BSTF. Let's place it here. Take this BSTF socket and connect it to the surface socket of the material output. And now we notice some changes on the material of a monkey model. Now for those of you who don't know what refraction is, it means bending of light in simple words. And if I try to change the view, you will notice that our monkey object has a material which looks similar to a glass. Also in the refraction BSTF, we have some more options. Here you have the roughness option, which is currently set to 0, and that's why it looks like this. But if I increase the roughness to a higher value like 0.4, it looks like this. So whenever you want to create a material whose surface is refracting, you can add the refraction BSTF and change the settings from here. Now moving to the next node, we'll add the translucent BSTF. So press Shift plus A, go to shader and select the translucent BSTF. Let's place it here. Now take the socket and connect it to the surface socket of the material output. And to see the effect properly, we need to reduce the lighting in our scene. So I'll select this lamp, and here in the object properties, let's reduce the power to a lower value like 100 watt. Similarly with this one also, I'll select this, go to the power option and change it to 100 watts. Now I'll go to the camera view to see how the object looks. So this monkey object now has the translucent BSTF applied to it. You must have studied about the difference between transparent and translucent objects in your school. Basically, the transparent objects allow all the light to pass through them. And one example of the transparent objects is glass. Then on the second number, there are translucent objects which allow only some light to pass through them. And an example of the translucent objects is a stained glass. And the third type is opaque objects, which are simply those objects which do not allow any light to pass through them. For example, a wooden table or a wooden chair. So coming back to the translucent BSTF, it makes your object looks translucent. And to explain it in detail how it works, I'll go to the top view by pressing 7 on the numpad, then zoom out, and we'll add some light at the back of the monkey model. So I'll select this light here, press Shift plus D and move it here. Left click to finalize the position, go to the object data properties, and let's increase the power to a higher value like 1500 watts. Press enter to confirm, then go to the color option and let's change it to blue color. Now let's return back to the camera view by pressing 0 on the numpad, and now if you will look closely on the monkey model, you will notice that this monkey model is allowing some blue light to pass through its surface. Although you won't see the same effect as you would see when the light passes through a glass, but still it is passing light through it because of the translucent BSTF node. And now the next one that we'll see is the emission node. But before that, let's remove the light from the back, go to the scene collection, select this light.002 and press X to delete it. Now to add the emission node, go to the shader editor, press Shift plus A, and in the shader, you will find this emission shader. select this, place it here. Now take this emission socket and connect it to the surface socket of the material output. And to see some changes, we need to reduce the lighting in our scene. For this, go to the scene collection, and here we have two lights in our scene. We'll hide them for now by clicking on this I button. Similarly with this one also. Also, we have added a default HDRI in our scene, and to disable it or reduce its strength, click on this drop down arrow and you can reduce the strength from here. So we'll reduce it to a very low value like 0.1, and now you can see that even with almost no lighting in our scene, this monkey or the Suzanne model is emitting light, which is because of the emission shader. This emission shader allows your object to emit light of any color and any strength. Suppose you want to increase the strength, then you can simply go to the strength option here and increase it to a higher value like 5 or 6, and now the intensity of light has increased. Similarly, if you want to change the color of this light, you can click on this color option, and if I select the yellow color, the color of the light will change to yellow. And now the next one is the transparent BSDF. But before exploring that, let's bring back the lighting in our scene. So I will unhide these two lights. Also, I will click on this drop down arrow and increase the strength of the HDRI to its previous value of 1, and now we have enough lighting in our scene. Now to add the transparent BSDF, go to the shader editor, press Shift plus A, and in the shader, you will have this option of transparent BSDF. Let's place it here. Take this BSDF socket and connect it to the surface socket of the material output. The object will disappear, and that's because we have used the transparent BSDF. Now there is one way to see your object here, which is to change the color. So if I click on this color and change the color to blue or any other color, then you will be able to see your monkey or the Suzanne model. Or else there is one more way to view it when it gets transparent. So I will press Ctrl plus Z to undo it, and now it is again transparent. Go to the color option and reduce the brightness with the help of this brightness slider. So if I reduce this slightly, the monkey model again reappears in our scene. So whenever you want to make your object transparent, you can simply add this transparent BSDF and connect it to the material output. And now moving ahead, the next one on our list is the glass BSDF. For this, press Shift plus A, go to shader and select the glass BSDF. Let's place it here. Now I'll take this BSDF socket and connect it to the surface socket of the material output. And now the material of this funky model changes to glass. And this will simply make your object's material look like a real glass. You can even change the color of this glass from here. So suppose I take it to green color, then it looks like this, and similarly for all the other colors. So whenever you want to create any glass and even apply some color to it, you can use this glass BSDF. And now the next one is the sheen BSDF. So I'll press Shift plus A, go to shader and select the sheen BSDF. Let's place it here. Now I'll take this socket and connect it to the surface socket of the material output. And we see some changes here. One important thing to note here is that in the previous versions of Blender, the sheen BSDF was also known as the velvet BSDF. Now you must have seen a velvet cloth or a velvet material. It is a kind of fabric which gives a very soft feel. And in Blender, this velvet BSDF is used to add some reflection to your material, especially when you're working with cloth objects. So whenever you want to create a velvet material for your cloth in Blender, you can use this sheen BSDF. You can even control the sheen from the principal BSDF. If I go down, you have this option of sheen, and if I select this, you will get all these settings that were available in the sheen BSDF. And now the next one is the toon BSDF. To add it, go to the shader editor, press Shift plus A, and in the shader, you will find the toon BSDF. Let's place it here. Take this BSDF socket and connect it here. Now this toon BSDF is used to create glossy materials or diffuse materials with some cartoon light effects. In most of the cases, you won't be using this shader node in Blender, but if you're making cartoon type of animation, then you might use this toon BSDF. And to view its effect, I'll change the angle, and now with the help of this toon BSDF, you can control the highlights or these reflections that are falling on your object, and this would also change the look of your object. To do this, go to the toon BSDF, and with the help of this size option, you can control these highlights. So if I reduce the size, you will see that the highlights have reduced. Similarly, if I increase it, you will notice that these pink highlights have increased. Also, you can use the smooth option to adjust the look of your object. And if I click here, you will find two modes to use this toon BSDF. One is the diffuse mode and the other one is the glossy. Now what this glossy mode does is that it will make your object look like a metallic object but with a toon effect. To notice the changes properly, we'll go to the size and reduce it to a much lower value like 0.2 or 0.3. And now you can observe that the material of this monkey model is giving a metallic look, and the reflections or the highlights on its surface due to these lights are very much different from the regular highlights. And all this is due to the toon BSDF. Now let's return back to the camera view by pressing 0 on the numpad. And now we'll look at some volume shaders in Blender. And we have 3 volume shaders. The first one is the principal volume, the second one is the volume absorption, and the third one is the volume scatter. To add the first one, which is the principal volume, press Shift plus A, go to the shader and select the principal volume. Let's place it here. Let's also move this material output and place it here. Now to break this node connection of the surface socket, hold down the control button, right click and drag like this. Now take this volume socket and connect it to the volume socket of the material output. And we see some changes here. So the principal volume is basically used to create a smoky or a fog effect like this. Applying this principal BSDF will turn your object into smoke or fog. You can even change the color of this fog from here. You have this color option, and if I select this and change it to red color, then the color of this smoke or the fog will change to red. And you can even control the density of this fog from here. So if I increase the density, it will appear like this. This will result in a highly dense fog or smoke of the same shape as the monkey object. Similarly, if I reduce it to a very low value like 0.4, then the density would be reduced. Now let's move to the next one, which is the volume scatter. For this, go to the shader editor, press Shift+A, and in the shader, you will find the volume scatter at the end. Let's place it here. Take this volume socket and connect it to the volume socket of the material output. Now this one is similar to the principal volume. It will also create a smoke or fog like effect on the Suzanne or the monkey model, and you can control the density from here, change the colors from here. So there's not much difference between the two. And now the next one is the volume absorption. To add it, press Shift+A, go to shader and select the volume absorption. Let's place it here. Take this volume socket and connect it to the volume socket of the material output. Now the volume absorption node allows the light to be absorbed as it passes through the volume. And just like the other two, you can control the density from here. If I increase the density, it will turn darker, and even the color from here. So if I change it to blue color, it will appear like this, and if I change it to red color, it appears like this. And this is all we have in the shader node. And now we'll understand everything that we have learned till now in this chapter with the help of an example. And this is also the next topic of this chapter, which is creating a procedural car paint shader. So I've opened up a new Blender file with the same default layout, and this time we'll be working with the second render engine, which is the EV render engine. So go to the render properties, and from here you can change the render engine. Till now we have used cycles, but for this topic we'll see how the EV render engine would work. So I've selected this, and let's go to the render view. Now the main difference between the EV and the cycles render engine is that EV takes very less time to render your images and animations, and that's because it does not consider so much detailing which the cycles does, and that's why the cycles render engine takes a lot of time to render. And now to give it some material, I'll go to the shader editor and click on this new material button. Here we have the default principal BSDF applied to the UV sphere, and I'll change its name from here. Let's name it as simple car paint. So I've named it as simple car paint. And let's change the base color from here. I think that we should change it to red color, and to make it dark, we'll use this brightness slider. So let's bring it down, and this much looks perfect. Now to make it surface reflecting, we have to reduce the roughness from here. So we'll reduce it to its minimum value of 0, and it looks like this. And now the surface is reflecting all the lights that are falling on it. Now you must have noticed that there is usually a layer of paint on the car, or basically a coating, which you can create here with the help of clear coat. For this, go down in the principal BSDF, select this coat option, and we can increase the clear coat from here. Right now it is set at 0, but if I increase it to 1, we have this additional layer or coating of paint or reflection on our object's material. And if you look closely at the reflections or the highlights of these lights falling on it, all of them can be controlled with the help of this clear coat reflection. If I increase it, you will notice that the reflecting area of these highlights have increased. Similarly, to reduce it, I'll reduce the roughness from here, and now it appears like this. So to make it look realistic, we should be having some more highlights or the reflections of these lights on our object. So we'll increase the roughness slightly. Let's keep it to a value of 0.1, and this looks perfect. Now the next thing that we will be doing is to make it look more metallic. But if I go to the metallic strength here and try to increase it, you will notice that the reflections will pick up a lot of color from the background, which we don't want for our material. And to fix this, I'll reduce the metallic strength from here, and Blender gives you the option of specular. So if I go to the IOR level in specular and try to increase it, you can see the changes in the material of this UV sphere. But one thing special about this IOR level, which is not present in other parameters, is that even though it appears like its maximum value is 1, but you can even go beyond 1 by clicking on it and entering a number. For example, if I type 2.5, then it would take that value and present the changes here. I think that a value of around 2.5 or 2 would give it a nice metallic look, and that too without too much colors from the background. And here you have an option of specular tint, and if I select this and apply any color, you will notice some slight effect of that particular color appearing on your object. And in this case, I think that I should choose the base color, which is the red color, and now it looks perfect. And now to give it some texture, we'll add a noise texture here. So press Shift+A, go to texture and select the noise texture. Let's place it here. Now one way to connect it with the node system is that you can take this factor socket and connect it to the nodes, but a better way is to use the shortcut, which is to select this noise texture, press Ctrl plus Shift, and then if I left click on it, it will directly get connected to the material output. But this thing will only work if the Node Wrangler add-on is turned on. We learnt about this in the chapter number 21, and to check if that Node Wrangler add-on is turned on in your Blender or not, you can go to the edit option here and select the preferences. And here in the add-ons, you will find a list of all the add-ons in Blender. So I'll go to the search bar and type Node. And here you will find the Node Wrangler turned on. If it is not turned on, you can check the box here and then the Node Wrangler add-on will be enabled. So I'll close it now. And now if you notice here, we no longer have the base color that we applied in the principal BSDF. That's because the noise texture directly connected to the material output and it is no way connected to the principal BSDF. But we'll connect it later on because right now we'll work on the texture part. So we'll be creating some spots on a material, and to do this we have to increase the scale from here. Let's increase it to a very high number like 200 or 300. And now if I zoom in, it looks like we need to adjust the amount of black color and the way how this texture would look. For this we'll add a color ramp here. So press Shift plus A, go to converter and select the color ramp. Let's place it here, and now it is connected to the noise texture and the material output. To create the spots on a material, click here and change the interpolation to constant. It appears like this because now the colors won't blend with each other because constant is selected. Either it will be black or it will be white based on the position of these pointers. So if I take the second pointer, which is a white, and move it like this, you will begin to see some white spots here. But suppose I want the background to be white and the spots to be black. For this you have to take this pointer and move it close to the black pointer. And now you will begin to notice that the base color now looks white and the spots on it are black colored. To change the size and the look of these spots, you can select the white pointer again and move it like this. If I take it very close to it, you will hardly see any spots on the surface. So I will adjust it like this, and now it looks perfect. To increase the detailing on these spots, you can simply go to the noise texture and change the detailing from here. So if I increase the detailing, it would look like this, and you can even change their looks from the roughness value here. Like if I reduce it, the roughness would reduce, and if I increase it, it would look like this. So you can change these values to arrive at a texture which you think would look the best for your car paint material. I think that this looks perfect, so I'll finalize this one. And now to give some color to this, we have to use the mix color node. For this I'll select these two, let's move them here, and now press Shift plus A, go to color and select the mix color. And if I place it here, it will get connected between the color ramp and the material output. And to see the colors here, you have to take this color socket and instead of connecting it to the color A, connect it to the factor. To break this node connection between the color and the color A, I'll zoom in, hold down the control key, right click and drag like this. Now we'll also be using the principal BSDF because it is carrying the material information like the specular, the roughness and the other things. So I'll select this, and if I drop it here, it will directly get connected with the mix and the material output. And for the color part, take the color B and change it to that color that you want as your base material. In this case, we want the red color to be the base material. So I'll take it to red color, and now we have red color as the base material and some gray spots on it. These gray spots are due to the color A, and suppose I want green color on it or maybe blue color, and I can increase the brightness from here. Now you will notice that the base color is red and the color of these spots are blue, which is the color A. Now it's not necessary that you have to select only these colors or the exact scale value or the detail values here. You can try to change these values and get different results each and every time. So try to play with these values, try to create different materials by changing these colors, and you will end up in learning in a much better way. In simple words, use the texture and the parameters here to change the look of your texture. Use the color ramp and these pointers to change the size and the color of these spots on your material. Change the base color from the color B and change the color of the spots from the color A. Then you can manipulate how your material would look like from the principal BSDF, like the metallic nature of the material, the roughness of the material, adding effect of any color from the tint option here. So you can do all this and create any material that you want. But right now I think that I should finalize this, and we'll save this one in the material library that we created in the chapter number 21. For this, first I need to save this file. So press Ctrl plus S and I will save it at the same location where I saved my other files like cloth shader file and material 1 and material 2 files. So I'll change its name to material 3 MAT3 and press enter. Now to save this material, go to the scene collection, click on this drop down arrow, then click here, and here you will find the simple car paint material. So I'll select this, right click, and here you have the option of mark as asset. Now this simple car paint material is saved in our material library, and to view it here, click on this icon and go to the asset browser. To view only those materials that we ourselves created, click here and select the user library. Here you will find all those materials that we have created till now, and this one is the simple car paint material. And also this brings us to the end of this chapter. In the previous chapter, that is chapter number 23, we discussed about the procedural shaders in complete detail, and we even created a simple car paint shader. And in this chapter, we'll go deeper into the procedural shaders by creating a sand shader in Blender and by understanding and revising all the procedural shaders that we have covered till now. So let's begin with it. Now I have opened up the default Blender file and my screen layout looks like this because we made it the default layout for understanding the shaders in the chapter number 21 of this course. We placed this plane, this UV sphere and some lighting in our scene and made it the default layout. So if you also want to set the scene in this way, you can check the link of the chapter number 21 and all the remaining chapters of this course from the pinned comment. But for now I'll go to the camera view by pressing 0 on the numpad and we'll be making a basic sand shader. So I'll delete this UV sphere by pressing X and we'll add a monkey or the Suzanne model. So press Shift plus A, go to Mesh and select the monkey model. Let's move it upwards by pressing G and then Z and place it here. Let's apply the shade smooth by right click and selecting shade smooth. And to make it look perfect and realistic, we have to apply the subdivision surface modifier. Now one way to apply the subdivision modifier is to go to the modify properties, click on add modifier and in the generate, you will find the subdivision surface. But there's a shortcut available in Blender using which you can directly apply the subdivision surface modifier to your object, and that is to press Ctrl and then press any number. For example, if I press Ctrl plus 3, then it will apply the subdivision modifier, and here in the levels viewport, the number of subdivisions will be 3. Similarly, if I would have pressed Ctrl plus 2, then the levels viewport number would have been 2 instead of 3. So you can use this shortcut to apply the subdivision surface modifier directly to your object. And now to give it some material, we'll go to the shader editor, press on this new button, and here the default material is applied to the monkey object. Let's also go to the render view by clicking on this icon, and by default we have the cycles render engine turned on. And you can check it from the render properties option here. Here we have the cycles render engine. And to get a better view of this monkey object, I'll rotate it in the Z axis. So press R and then Z and let's rotate it like this and left click to finalize. Since right now we'll be making the sand shader, so I'll change the name of this material by clicking here and typing sand. And now the material is renamed to sand. Now to give it some texture, we'll go to the shader editor, press Shift plus A, go to texture, and we'll add the noise texture. Let's place it here, and to add an input node, press Shift plus A, go to input and select the texture coordinate, and I'll place it here. To connect them together, I'll use this object socket and connect it to the vector socket here. Now to connect this noise texture to the output, one way is to left click on the factor socket and then connect it, but a better way is to hold Ctrl plus Shift and then if I left click on the noise texture, it directly gets connected to the material output. But to use this shortcut, do ensure that the Node Wrangler add-on is turned on. We learned about the Node Wrangler add-on in the chapter number 21 of this course. Now if I look closely at the texture, it doesn't actually look like a sand texture. And to make some changes here, we'll go to the noise texture and let's try to change the scale option. Right now the scale is set at a very small value and we'll be increasing it to a very high number like 500, and now if I zoom in, you will see that it has this grain-like texture on it, which is similar to that of sand. In fact, you can add different layers of noise texture on this material. To do this, with this noise texture selected, press Shift plus D to create a duplicate. And let's place it here. I'll zoom out. This second noise texture will act as a second layer of texture for this material, and I'll be reducing the scale value for the second layer of texture so that it looks different from the first layer. So I'll go to the scale value and let us reduce it to a slightly lower number like 250, and let's also create one more layer of texture by again pressing Shift plus D and placing the noise texture here. Let's also change the scale of this texture, and I think that we should keep it to somewhere around 100 or 150. Right now these two textures, that is the second layer and the third layer textures, won't be visible on the object's material, and that's because they are not connected to the material output. Currently only the first noise texture is connected to the material output. Now to connect all these textures together, select one of the textures, press Ctrl and Shift, and if I right click and drag like this, I can mix two textures together. So if I release, these two textures will now be connected to the mix node here, which will be connected to the material output. And now we have two layers of texture on our object, but we need to do some changes here. So I'll go to this option of mix and change it to multiply, and now we have some sort of rough grain like texture. You can change the way it looks with the help of this factor value. So if I increase it, we get a much better texture. So I will keep it to a value of 1, and to connect the third layer of noise texture, left click on this node, press Ctrl and Shift, and with right mouse button click and dragging like this, I can connect both of them together to this mix node. Just like I changed this to multiply, I'll select this one also and change this option of mix to multiply. And we can also control the factor value here. So if I increase it, we'll get a texture like this. Let's zoom out to get a better view. But even right now, it does not have a realistic looking grainy texture. That's because the texture is not having any 3D effect on the object's material. And to get the 3D effect, we use the bump node. So I'll go to the shader editor, press Shift plus A, go to vector and select the bump. Let's place it here. I'll take this material output and place it here. Similarly, this principal BSTF, and I'll place it here. Now, to connect the bump node to the rest of the node system, we have to take this result socket of the multiply node and connect it to the height of the bump node. Then for the output of the bump node, take this normal socket and connect it to the normal of the principal BSTF. And to connect the principal BSDF with the material output, simply take this BSDF socket and connect it to the surface. And now we are having this white color on the object's material because of the base color of the principal BSDF, and this rough grainy texture is because of the combination of these noise textures in the shader editor. Now to look at the texture properly, I'll zoom in, and now we can see how this texture actually looks. Now it's not compulsory to set the factor value here at exact 1. You can change the value at any number like 0.5, but then you will get a different result here. You might not notice the exact changes, but if you are very precise about the texture quality and about the scale of the noise texture, then you can use this factor value from here. Right now this one looks good, so I've set the factor value of this multiply node to 0.5. Now one more thing to note here is that these three noise textures can also be used to give a detailed rough look to your object's material, and for this I'll take this result socket and connect it to the roughness of the principal BSDF. And now the roughness will consider that value that it will get from these three noise textures. Also, it's not necessary to take only this multiply node for the roughness. You can select this one also. So if I take the result socket of this multiply node and connect it to the roughness, the other one will get disconnected and you will get a roughness based on the combination of these two noise textures. And now to give this sand some color, we'll go to the shader editor, press Shift plus A, go to color and select the mix color. I'll place it here, and also do remember to save your file so that you don't lose any work due to any error or some crash. And now moving to the color part, we have to choose two different colors that will combine together to make the sand color. So I searched on Google which two colors should I mix to make the sand color, and there I found that these are the two colors which we should combine to make the beach sand color. One is the cadmium yellow medium and the other one dioxazine purple. And so I searched for the HEX code of cadmium yellow medium on Google, and it showed me this code, which is FDD-A0D. So we'll go to the color A, and in the HEX I'll enter FDD-A0D and press enter to confirm. We can't see any changes here because this mix color node is not connected to the output right now. We'll do that stuff later, but for the color B, which is the dioxazine purple, the HEX code is this 5C3A93. So we'll go to the color B, and in the HEX I'll enter 5C3A93 and press enter to confirm. Now to see the changes here, take this result socket and connect it to the base color of the principal BSDF. And now the color of this monkey object looks like the beach sand color. And don't worry if you're not seeing the same results of textures that are being shown here, because Blender takes some time to render these samples, and only after the completion of a particular number of samples you begin to see the texture properly. And if I change anything here, it restarts the sample count, and that's why the object texture looked different initially. Even if I zoom out, you will see here that the sample count will restart from 1 and slowly it will render, and it might take a few seconds or even 1 or 2 minutes based on the specifications of your PC. But right now the texture is clearly visible on the object's material. And also I think that we should change the lighting here. We have added two lights in our scene. This one is the white light and this one is the pink light. But I'll select this light, and to change its color, go to the object data properties here, which is the bulb icon in case of this lamp. Go to the color option and let's change it to white color. To make it look perfect white, you can go to the HSV option here, change this value to exact 1 and this one to exact 0. And now we have the perfect white light in our scene. Let's go back to the camera view by pressing 0 on the numpad, select this monkey model, and here we have all the nodes in the shader editor. And now we'll be moving to the next topic of this chapter, which is understanding the sky texture in Blender. For this I'll first zoom out, and we have to delete this plain background from the scene. So I'll select this, press X to delete it, and we'll be adding a new plane. So press Shift plus A, go to Mesh and select the plane. Tap into the edit mode and press S to scale it up. Let's scale it up even more, and this much should work fine. So I'll left click to finalize this, and now we have this monkey model with the sand shader and a simple plane in our scene. Let's come out of the edit mode by pressing the tab key. Now the sky texture is basically used to add a procedural sky texture in your scene, and the special thing about this texture is that it is not applied to any object. Instead it is applied to the environment around the scene. As a result, I'll go to the shader editor, and to add the sky texture here, first we need to click on this option and change the shader type from object to world. So I'll change it to world, and here you have a background node which controls the color and its strength which you see around your 3D viewport. Now to add the sky texture, press Shift plus A, go to texture and select this sky texture. Let's place it here. Now to connect the sky texture, we'll take this color socket and connect it to the color socket of the background. But we do not see any changes here, and that's because we have added a default Blender HDRI. And to disable it, click on this drop down arrow and turn on the scene world. and now we see this sky texture, or basically this environment, applied in our scene. And to adjust how it looks, we can change the parameters from here. The first thing that I'll do is to reduce its strength from here. So we'll reduce it to a lower value like 0.1, and now we can clearly see the sky texture around the 3D viewport. Suppose you want to change the size, rotation and position of sun, so you can try to change these values. If you want to increase the intensity, you can go to the sun intensity value and try to increase it. Right now I have set it to very high value, that's why it's appearing like this, but if I reduce it to its default value of 1, it would appear like this. Similarly, you can go to the sun elevation option and try to change the angle of sun from the horizon. Also, you can rotate the sun with the help of the sun rotation option. Basically, this will impact the shadows in your scene and the lighting of different objects. Then you have this option of altitude, which will define the position of the source of light, which is the sun, from the sea level, which means the base. So if I increase it to a very high value, then the altitude of sun will increase. Similarly, if you want to change the color of this environment, you can go to these values of air, dust and ozone. If I take the air value and increase it, the environment will get more of yellow or orange look. But if I reduce it to its default value and try to increase the dust, then it appears like this. And if I change it to 1 and try to change the ozone value, this will change the environment or the sky to blue color. But there are some specific parameters that you can use if you want a perfect environment for your scene. For example, we'll set the sun size to 5, sun intensity will be set to the default value of 1. Now we'll set the sun elevation to somewhere around 100 degrees, sun rotation to 90 degrees, and we'll set the altitude to a value of around 5000 to 6000 meters. And now we have a blue sky background or the environment in our scene. We'll set the air and the dust values to the default 1 and ozone to a value of 10. And now we have a perfect sky texture applied to the background. So whenever you want a sky texture as the environment, you can simply add the sky texture with this world selected as the shader type, set these parameters and connect it to the background, set the strength to 0.1, and you will end up making this simple looking sky texture. And this brings us to the end of this chapter and also to the part of materials, textures and nodes, because from the next chapter we'll be starting with another exciting topic of Blender, which is scene lighting and cameras. But before that, we need to do one more thing. Actually, in the chapter number 21 of this course, we made this layout as the default layout of Blender to work on the shaders and materials part. But now this layout is no longer required as the default layout, and to get back the older layout, which is the default Blender's layout, you have to go to the file option here, then select the defaults, and here you have the option of the load factory settings. So I'll select this load factory settings, click again to confirm, and here we have the default Blender layout. Now if I again go to the file option here, in the defaults, we have this save startup file. So we'll select this and click on the confirmation. So from now on, whenever I'll open Blender, this default Blender layout would appear and not the one that we created for the purpose of understanding shading in Blender. Now in this chapter, we'll be understanding about the lighting in Blender, the functioning of cameras in Blender, and so here we have this default file open in Blender, and the first topic for this chapter is understanding about lighting. So here we have this default point light object in Blender, and to see its effect, we have to go to the material preview mode or to the render preview mode. Right now we'll select the material preview mode. If I try to move it by pressing G and move around like this, you won't notice any difference on the cube, like there are no reflections, no shadows, and this is because the scene light and the scene world are not activated. And to fix this, click on this drop down arrow, and here you have the option of scene lights and the scene world. We'll turn on both of them, and now if I go back to the 3D viewport, with this light selected, press G, and if I move around like this, you will notice the reflections appearing on your default cube object. And for now, I'll fix its position here, so left click to finalize. Now we can even change the color or the type of this light, and to do this, we have to go to the object data properties. So with this light selected, click on this bulb or the light icon, which is the object data properties, and here you have the 4 types of lights. The first one is the point light, the second one is the sunlight, the third one is the spotlight, and the fourth one is the area light. We'll see the effect of each one, but right now let's select the point light, and here we have this option of color. So using this, you can change the color of your light, and then you have this power option, which is basically used to increase or decrease the intensity of light. Now to see the effect of different lights, I'll remove this default cube from the scene by pressing X, and we'll add a Suzanne or the monkey model. So press Shift plus A, go to mesh and select the monkey model. Let's move it upwards by pressing G and then Z, place it here, and let's rotate it in the Z axis by 90 degrees. So press R, then Z, and press 90. Then enter to confirm. We'll also be adding a plane below this monkey model so that we can see the shadows properly. So press Shift plus A, go to mesh and add the plane. Tab into the edit mode and let's scale it up by pressing S and left click to finalize. Let's get back to the object mode. Now I'll select this light, and to see the difference between the 4 types of lights, we have to place this light exactly at the top of the monkey model. For this we'll try to adjust this light's position from different views. First we'll go to the front view by pressing 1 on the numpad. It's appearing like a side view because we have rotated this monkey model by 90 degrees. And now to move it, we'll first look at this axis. Since it is colored as red, so it is x-axis. And you can even confirm it from here. The red one is the x, the green one is the y, and the blue is the z. So currently we'll move it in x direction. So press G and X and we'll move it like this. Left click to finalize. Then for the side view we'll press 3 and we'll move it in y direction. So press G and Y and let's move it here. Let's go to the top view by pressing 0 on the numpad, and here we have this lamp perfectly placed in the middle. Now if I try to change the angle, you will notice that this light is falling only on the head of the Suzanne or the monkey model, and as a result only the reflection of its head part is visible on this plane. We can't see the face of the monkey model because light is not able to reflect on it, and this is how the point light works. Basically this point light is an omnidirectional point light source, and to view the face of the monkey we'll move it by pressing G and then X, and let's move it here and left click to finalize. Now we can clearly see that the face of the monkey is now visible, and also the position of the shadow has now moved. The lighting in Blender works in a very similar way to the lighting in real world. If you move a light in real world, you will also notice a change in the reflections and change in shadows, and the same is true for Blender also. Also, to change the color of this light, you can go to the object data properties, click on this color option, and from here you can change the color of your light. By default it is set to white, but suppose you want your light to be yellow colored, so you can change it to yellow color from this color wheel, and the color of this light would change to yellow. Also, if you think that the intensity of this light is too high, then you can go to the power option here and reduce it to a lower value like 300, 400, and then the intensity or the power of this light would reduce. But right now we'll change it to its previous value of 1000 watt. So I'll go to the power value and change it to 1000 watt. Now the second type of light is the sun. So if I select this, you will notice that now our scene has a lot of lighting, and that's because the strength of the light is too high for the sun type of light. Usually the strength of this sunlight is kept between a value of 0 to 10 for a perfect lighting, but right now it is set to 1000, and that's why it appears like this. So I'll go to the strength option and let's change it to a value between 0 to 10. I'll change it to 6, and now the lighting looks perfect. Now the main difference between the point and the sunlight is that you have this line originating from the light source, and this line basically defines the angle at which this light would fall. And to change this angle, simply click R and move your cursor. You will notice that as you rotate it, the influence of light on the objects in the scene would change. And to move it even more accurately, you can press X to rotate it only in the X direction, similarly Y to rotate it only in the Y direction, and Z to rotate it only in the Z direction. Now the angle that you want to finalize would depend on what exact objects you're having in your scene, at what angle the lighting looks perfect. Right now I feel that lighting at this angle looks perfect, so I left click to finalize it. And now moving to the next type, we have the spot type of light. So I'll select this, and to see the light properly we need to increase the power from here. So we'll set it to a higher value like 1000 watt, and now we see some light in our scene. As the name suggests, the spotlight is basically a directional cone light source. To explore it properly, let's press G and then Z to move it upwards. Now this one also works similar to the sunlight because you can rotate it by pressing R and moving around your cursor like this, and also you can rotate it in specific axes like the X axis or the Y axis or the Z axis by pressing their respective shortcut keys. But to make it look perfect, we'll first have to scale this down. So I'll press S and let's scale it down like this. Scaling it down won't impact the reflection or the intensity of light in any way. Now to move this light, simply press G, and now you can move this light. Let's place it here. Now suppose we want to rotate this light in such a way that we will be able to clearly see the monkey face. For this, with the light selected, press R, and first let's try it in X axis. So press X and try to move your cursor. We see that by rotating it in X axis, we got a perfect lighting for our scene. So we'll finalize this by left mouse button click, and this is how the spotlight works. You can also change the color of this light from here. Suppose you want red color or blue color or any other color, then you can change the color of the light from here. Let's keep it to light blue color, and now let's move to the fourth type of light, which is the area light. So I'll select the area light from here. Let's zoom out. Now this area light is basically a directional area light source, and by default it is rectangle in shape, but you can't see any rectangle shaped light here, and that is because it is very small in size. To see it in our scene, we have to scale it up. So press S and move your cursor away, and you will begin to see a rectangle near the source of light. Now if you remember, I told you that in the spotlight type, even if you increase the scale, it won't affect your object's reflections or its shadows, but this is not true in case of area light. If I scale it up by a very high number, for example I press S, and to scale it by 10 times I press 1 0 or maybe 100 times by pressing another 0, then you will notice that the lighting would reduce. To cancel this, I'll right click, and you can understand it in this way that more the size of the area light, lesser will be the lighting on your object. And the reason behind this is very simple. When you scale up the area light, the same light intensity is now spread over a larger surface area. This results in the scene receiving the same amount of total light but spread out in such a way that it appears to be dimmer. And just like you could rotate the light in case of sun and spotlight, you can even do the same in the area light. For this, press R and move your cursor to rotate the light. Also, just like every other light, you can change the color from here. You can change it to any color that you like, and you will see that particular color as the color of the light in your scene. So these are all the 4 types of lights in Blender. You can even add some more lights by pressing Shift plus A, and here you have the option of light, so you can select the type of light from here. So suppose I add the point light, it will get added at the location of the 3D cursor, and to move it upwards press G and Z. Let's move it upwards, and whenever a new light is added, by default its color is white and the power is 10 watt. And this is all in the lighting in Blender. See, there is one more important thing to remember. The best type and the placement of lights depend on the scene you are creating. So whenever you're working on a project, you need to experiment with different types of lights and their parameters like the color, the power, the size of the light to find what would work the best for your project. And it always takes a lot of practice and time to create realistic lighting in Blender. And now we are moving to the next topic of this chapter, which is understanding the cameras in Blender. So by default we have this camera in our scene. To enter the camera view, press 0 on the numpad, and suppose you want to change the position of this camera. For this, one option is to press G and move your camera like this, and press R to rotate it like this. But a better way is to use the lock camera to view option, and to enable it press N, go to the view option here, and here you have the lock camera to view option. So I'll turn this on, and now if I try to move my scene, the camera will also move along with it. Suppose I finalize the location and the rotation here and come out of the camera view by pressing 0 on the numpad, we'll notice that the position of this camera has changed. Previously it was located over here, but now its position has changed to this point. Also, you can add multiple cameras to your scene, and you would be doing this when you're working on big projects where you need to render animations or your scene from different angles. And for this we have to press Shift plus A to add the camera. Here you have the camera option, so I'll select this, and the new camera is added at the position where the 3D cursor is located. To change its position, I will press G and then Z to move it upwards, and suppose I want to enter the camera view of this newly added camera. But if I use my previous method, that is to press 0 on the numpad, we will see the camera view of the default camera. Let's press 0 to come out of the camera view, and to enter the camera view of the second camera, we have to use the shortcut, which is to hold the control button and press 0. And now this is the camera view of the second camera that we added in our scene. Here the lock camera to view is enabled, and so if I try to move around the scene by holding the middle mouse button and dragging my cursor like this, and then if I scroll down, we can see here that we now have a different view of the scene. So in simple words, if you have to come out of the camera view, you have to press 0 on the numpad, and right now if I press 0 on the numpad, you will enter the same camera view. That's because in the scene collection we have this camera.001 selected. But if I come out of the camera view by pressing 0 on the numpad again and go to the scene collection, select the default camera, and now if I press Ctrl and 0 on the numpad, we'll enter the camera view of the default camera. This might be confusing if you're learning it for the first time, but in reality it's very simple. You just have to come out of the camera view by pressing 0 on the numpad, select the specific camera whose camera view you want to see. Suppose I select the camera.001, and now to enter the camera view, press Ctrl plus 0 in the numpad. And this is how you can work with multiple cameras together. Now if you come to the object data properties, you will find some camera settings here, but the most important ones are the type of camera and the focal length. For now I'll select the default camera, and here in the object data properties, if I select the type, we have 3 types here. By default it is set to perspective, but if I change it to orthographic, you will observe that the camera changes. Let's enter the camera view to see the changes. So I'll press Ctrl plus 0 on the numpad, and here we see that instead of getting a 3D view or a perspective view of the 3D viewport and the object, we are getting an orthographic view. We learnt about the difference between the perspective and the orthographic view in this chapter of the series. But coming back to the lens type, in most of the cases, or maybe even more than 99% of the cases, you will be using the perspective type only. So I'll change the lens type to the perspective, and we again have this 3D or a perspective look of the 3D viewport. Then you have this focal length option, and by using this option, you can change the focal length of your camera lens. By default it is set to 50, but if I increase it, the focal length of the camera will increase, and if I reduce it, the focal length of the camera would reduce. Let's get back to the default value. To view its effect properly, I'll come out of the camera view by pressing 0 on the numpad, and if I try to increase the focal length, you will notice that our camera is basically being stretched up like this. This is because the focal length of the camera has changed. In the real world, different lenses of cameras have different focal length, and any change in the focal length of the camera also changes the result or the output it produces. For example, if I go to the camera view by pressing Ctrl+0, we observe that we are getting a zoomed in output because we have increased the focal length. But if I reduce it, we get a zoomed out result. In reality, the concept of focal length is a bit complex to understand, but to understand it simply, you just need to remember that to make it look like a real camera view, you have to set your focal length somewhere between 35mm and 50mm. By default, Blender sets it to 50mm, so I'll change the focal length again to 50mm. And also this brings us to the end of this chapter. In this chapter, we learnt about the 4 types of lights in Blender, tried to rotate and change the position of these lights, also explored the color and the power options here. Then we moved to the next topic, which were the cameras. We understood about changing the position of camera by enabling the lock camera to view. Then we discovered about multiple cameras in Blender and also about how you can switch between the 2 cameras. So to begin with, let's first understand what exactly is animation. And the answer to this is simple. Animation is nothing but an illusion. It is an illusion of motion. There are several images which are compiled into a video clip or sequence, and that's how an animation is made. Here, each and every image is said to be a frame in an animation sequence. So basically, if you're making an animation in Blender, you will be making several frames and then Blender will compile them to form an animation. Now, coming to the animation in Blender, we basically have to focus on 2 areas. One is this 3D view editor where you will be having all your objects, and the other one will be this timeline editor where we will be animating our frames. Now, the best way to understand about animation is to practically create a basic animation scene in Blender. So suppose I want to create this animation where this cube simply scales up and then scales down. So to make this simple animation with this cube selected, we have to insert a keyframe here. Inserting a keyframe means that we'll be telling the timeline editor that at frame number 1, our object would look like this. That is, it won't be scaled up, but it would just be a simple cube. But before that, there's one more important thing to note here, and this is related to the frames. Since I already told you that frames are the images which form the animation, but one question that may come in your mind is that how many frames are there in 1 second of animation? And the answer to this question can vary, because an animation can be made at 24 FPS, meaning frames per second, or even 30 FPS, or even 60 FPS or more. An animation of 24 FPS would mean that each second of the video or the animation will show 24 still images. Similarly, an animation of 30 frames per second would mean that each second of the animation will show 30 images. So it totally depends upon you that how much frames per second you need for your animation. But if you are a beginner, then I will suggest you to go for 24 or 30 frames per second. Let's suppose you choose 24 frames per second and you want to create an animation of 5 seconds. This would mean that your animation will have a total of 24 times 5, meaning 120 frames. So here at the frame number 1, I need the object to be at the default location with the default rotation and scale applied to it. And to make this the frame 1, we have to insert a keyframe here. The shortcut to insert the keyframe is to press I, and now a keyframe is inserted here. To view it properly, I'll expand the timeline editor, take the mouse cursor here and left click and drag like this. Here you can see a yellow dot, which means that a keyframe is inserted at the frame number 1, carrying the information that this cube is located at a particular location, having a particular rotation and also some scale. To view all this information mathematically, you can go to the object properties here, and here you can see that the location in all the 3 axes is 0 meters, the rotation of this cube in all the 3 axes is 0 degrees, and the scale is 1. We decided that the animation would be 5 seconds long and having 120 frames. But right now in the timeline editor, we can see that there are frames from the frame 1 to the frame 250, and to restrict it to 120 frames, here you have the option of the starting frame and the ending frame. The starting frame is set to 1, but we'll change the ending frame to 120 and press enter. Now only the area between frame 1 and frame 120 is highlighted. Now to make that animation of the cube scaling up, we have to select a frame here. Let's suppose the frame number 40, so I left click here, and now the frame number 40 is selected, and if I make any changes to this cube and insert a keyframe at the frame number 40, we'll get a small animation starting from frame number 1 to the frame number 40. Let's try to do this. So to scale it up in the Y direction, press S and Y and move your cursor away and left click to finalize. Now to insert a keyframe at the frame number 40, press I, and now we have a keyframe here. This keyframe is carrying the information that at the frame number 40, this cube will be scaled up like this in the Y axis. Now to check this animation between the frame number 1 to frame number 40, we have to take this pointer to the frame number 1. So you can either left click like this, or else you can also left click and drag like this. So we'll take it to the frame number 1, and to play the animation, press the space bar. Press space bar to stop the animation. And so this was a basic example about how animations are made in Blender. Similarly, I can create an animation after the frame number 40. So suppose I take this timeline to the frame number 80, and here I decide that the animation should be like it is scaling up in Z direction. So for this, I will press S and then Z and scale it up like this. Now to insert a keyframe, press I, and here in the timeline editor, we have a keyframe inserted at the frame number 80. So if I again take this to the frame number 1 and play the animation, you will see that it first scales up in the Y axis and then in the Z axis. And now suppose I want that at the frame number 120, which is the last frame, the object should return back to its default state. So one way to do this is to go to the object properties here and change the value of scale back to 1 in all the 3 axes. But a better way is to go to the timeline editor, left click on this keyframe at the frame number 0. Now the other two are no more yellow colored, that's because they're unselected. Now we'll create a duplicate of this keyframe at the frame number 0 and place it at the frame number 120. For this, press Shift plus D, and remember that while doing this, your mouse cursor should be in the timeline editor and not in the 3D viewport. Otherwise, it will create a duplicate of the cube in your 3D viewport instead of this keyframe. And now we'll drag it like this and place it at the frame number 120. Left click to finalize. And now if I go to the frame number 1 and play the animation, then it first scales up in the Y axis, then in Z axis, and finally it scales down to its original scale value of 1. And also, apart from scaling, you can create an animation of an object moving in a particular axis or rotating. For example, if I had a UV sphere, by pressing Shift plus A, going to mesh and selecting the UV sphere, placing it in Y direction by pressing G and then Y, and let's place it here. Now, one thing to note here is that the keyframes that were previously present here are no longer visible in the timeline editor, and that's because they were assigned only to the cube, not to this UV sphere or any other object in the scene. So suppose I want to make an animation of this UV sphere in which it is changing its location from one point to another. For this, we'll go to the frame number 1. You can also change the position of your frame from here, which is the current frame value. Suppose I type 20, then the current frame will be set to 20. But right now, since we want to place this pointer at the frame number 1, so we'll type 1 and press enter. Now at the frame number 1, we'll move it up in the Z direction like this. Let's zoom out, and to insert a keyframe at this position, press I, and here we have the keyframe inserted. And now if I go to any frame like frame number 60, which is exactly in the middle of frame 1 and frame 120, and move it in Y direction like this, and if I now insert a keyframe by pressing I, then here we have another keyframe inserted at the frame number 60. Now we'll go to the last frame, which is frame number 120, and I'll create a duplicate of the frame number 0 by pressing Shift plus D and placing it at the frame number 120. And now if I play the animation by pressing the space bar, you will notice that both the objects are now animated. The cube scaled up in the Y and the Z axis and then scaled down, and similarly this UV sphere changed its location from its current position to a new position in the Y axis and then returned back to its original position. And this is how the animation works in Blender. Now you can even animate the colors or basically the materials of your object. And to show how it works, I'll delete these objects in my scene. So with the UV sphere selected, hold down the Shift button and select this cube, press X to delete them, and let's add the Suzanne or the monkey model. So press Shift plus A, go to mesh and select the monkey model. To make it smooth, right click and select the shade smooth, and to fix its geometry, go to the modify properties and we'll apply the subdivision surface modifier. So click on add modifier, go to generate, and here you will find the subdivision surface. So I'll select this. Let's increase the levels viewport to a higher value like 3 or 4. And now to create an animation including the materials or the colors, we first have to give some material to this monkey object. So I'll go to the material properties here and click on the new material. Now here we have the default material applied to this monkey object. You can also open a shader editor to set up a new material for this monkey object as we discussed in the chapter number 21 to 24. But right now we'll be assigning the material from here in the material properties editor only. And before assigning any color to it, let's first turn on the material preview mode. You can even turn on the render preview from the fourth icon here, but right now I will be working on the material preview mode only. Now if I go to the base color and assign it any random color, for example blue color, then this object will be having blue color as its material, and that too for all the frames here. For example, if I drag this timeline editor and release it anywhere in the timeline editor, we'll notice that our monkey object is having the same blue material, and that is because we have not not yet assigned any keyframes here. Only when I will assign some keyframes, then that particular frame will carry a specific information about the material, and then we will be able to see the animation. For example, if I go back to the frame 1 and if I want that this monkey object should have blue color at the frame 1, so I'll go to the material properties here, and here you have a small dot which is basically used to set up keyframes. So if I left click on it, you will notice that this circle turns into this shape, and here in the timeline editor we have this first keyframe inserted at the frame number 1. And now suppose I take it to the frame number 120, and at this frame suppose I want the color of this object to be red. So I'll go back to the material properties, select the base color and change it to red color. To insert a keyframe here, click on this icon against the base color, and now a keyframe is inserted at the frame number 120. Now if I place the cursor over frame number 1 and play the animation, you will notice that the color of the object slowly changes from blue to red color. And this is how you animate colors or materials in Blender. You can do the same with other properties as well, like the metallic strength, roughness, or even the emission. So basically any parameter that has this small dot against its name can be animated just by inserting two keyframes at different places, and then the animation will be created. For example, if we have to animate the roughness, then go to the timeline editor, take this to the frame number 1, and we'll assign the default value of roughness, which is 0.5, to this frame. So at this value, click on this small icon to insert a keyframe, and now the keyframe that you are seeing here is carrying two informations. One is about the base color, which is blue, and other is about the roughness, which is 0.5. And now we'll go to the frame number 120, and suppose at this frame I want the roughness to be exact 0. To insert the keyframe, I will click on this icon, and now this last frame, that is frame number 120, is also carrying two informations. One is about the base color, which is red, and the other one is about the roughness, which is 0. To see the animation, we'll take this pointer to the frame number 1 and press the space bar. Now you will notice two things. One is the color change from blue to red, and the other thing is the change in roughness from 0.5 to 0. Initially at the frame number 1, our object was blue colored and having high roughness, but at the last frame, it is red colored and having a reflecting surface with no roughness. And now to revise all the concepts that we have covered in this chapter so far, we'll be making this simple loop animation in Blender. So to begin with it, I'll first delete this monkey object. So press X to delete. Now if you look closely at this animation, you will notice that we first need to make this base and the hollow spaces where these balls will fall. And for creating this base, the best object to start with will be a cylinder, because we'll scale it down to form a disc-like structure. So let's come back to Blender, and to add the cylinder, press Shift plus A, go to Mesh and select the cylinder. Now tab into the edit mode, and let's scale it down in the Z direction by pressing S and then Z, and scale it down like this. Left click to finalize and get back to the object mode by pressing the tab key. Now to make the hollow spaces, we'll be using the Boolean modifier. We learnt about this modifier in this chapter of this course. Now since we need to make hollow circular shapes like this, we'll be adding cylinders and then apply the Boolean modifier. So press Shift plus A, go to Mesh and select the cylinder. Tab into the edit mode, press S to scale it down. Let's scale it down further. Let's move it slightly upwards by pressing G and then Z, and left click to finalize. To view the size properly, we'll go to the top view by pressing 7 on the numpad, and I think that we should scale it down further. So I'll press S and scale it down like this. Left click to finalize, and let's move it upwards in the Y direction to place it here. But right now we need 4 such cylinders. So let's come out of the edit mode, press Shift plus D to create duplicate, move it down in the Y direction, and after placing it in the middle, left click to finalize its position. Now let's move it in X direction by pressing G and then X, and let's place it here. Left click to finalize. Let's try to change the angle, and here we have 2 cylinders added here. Now to create 2 more duplicates, I will select both of them together and then create a duplicate. So with this one selected, hold down the Shift button and left click to select the other cylinder. Go back to the top view by pressing 7 on the numpad. Now press Shift plus D and place the duplicates here and left click to finalize. Let's change the angle, and now we have 4 different cylinders. To create the hollow space, we need to see the depth of these cylinders inside this base. So we'll turn on the X-ray mode for this, but before that we need to enter the solid mode, because the X-ray mode cannot be accessed from the material preview mode. So I'll go to the solid mode, press Alt plus Z to turn on the X-ray mode. To view the depth properly, we'll go to the side view by pressing 3 on the numpad, and to create the hollow space, we need these cylinders to have more depth inside this base. So I'll select all 4 of them by dragging like this, and now if I release, all the 4 cylinders will get selected, and I'll move them down in the Z axis by pressing G and then Z, and let's place them here and left click to finalize. Now I'll turn off the X-ray mode by pressing Alt plus Z, and to create the hollow spaces, we'll use the Boolean modifier. So I'll select this base, go to the modifier properties, click on add modifier, and in the generate, you will find this Boolean modifier. Now I have to add all these 4 cylinders in this object option here, and for this I would need to create 4 duplicates of this Boolean modifier. But a better way is to take all these 4 cylinders and join them together into a single object. For this I'll select one of them, and with the Shift key holded, I'll select select the other 3. To join them together, press Ctrl plus J, and now they are converted into a single object with the name as cylinder.002. Let's select the base again, go to the object, click on this eyedropper, place it on one of the cylinders and left click. Now in the object option, we have the cylinder.002 assigned. To apply this modifier, press Ctrl plus A, and now to view the hollow space, select this group of cylinders and press X to delete them. Here we have these hollow spaces created in our base. Now to give it a better and a realistic look, we'll apply the bevel modifier. So go to the modify properties, click on add modifier, and in the generate, you will find the bevel modifier. So I'll select this. Let's change the number of segments to a high value like 3 or maybe 4, and now it looks perfect. Now to make the balls, we'll go to the top view by pressing 7 on the numpad. Then we'll place the 3D cursor over here by pressing shift and right click, and we'll add a UV sphere. So press shift plus A, go to mesh and select the UV sphere. Tab into the edit mode and scale it down. Left click to finalize. Let's view it from a different angle. I think that we should move it upwards in the Z axis. So press G and then Z to move it upwards and left click to finalize. Now we'll need 3 more UV spheres. So I'll again go to the top view, come out of the edit mode, and I'll create a duplicate of it by pressing shift plus D and move it in the Y direction. Let's place it here and left click to finalize. Now again press shift plus D and place this duplicate over here and left click to finalize. Now we'll create one more duplicate and place it here. So press shift plus D and press X to move it in X direction and place it here. Left click to finalize, and now we have this base and these 4 UV spheres or these balls added in our scene. To make them look realistic, I will select all 4 of them by holding the shift button and left click to select each one of them. Now we'll make them smooth by right mouse button and applying the shade smooth. And now to make this rotating rod with its tiny stand, we need to place our 3D cursor over here. So press shift plus C. Now here we have the 3D cursor relocated at the world origin. So to make the stand of the rod, we'll add a cylinder here. So press shift plus A, go to mesh and select the cylinder. Tab into the edit mode, press S to scale it down and left click to finalize. Now I'll zoom in, and to view it here, I need to move it upwards in the Z direction. So I will press G and then Z to move it up and left click to finalize. I think that we should scale it down even further, so I will press S and move my cursor towards it and left click to finalize. And to move it slightly upwards, I will press G and Z and move it like this. Left click to finalize, and now we have this stand ready. So I will come out of the edit mode, and to make the rotating rod, I will add another cylinder in my scene. So press shift plus A, go to mesh and select the cylinder. To scale it down, we'll go to the edit mode and press S. Left click to finalize. Now we should scale it up in the Z axis. So press S and Z and scale it up like this. Now to adjust the size of the rod properly, I will again press S to scale it and scale it down like this. Let's move it upwards by pressing G and then Z and place it here. Now we need to rotate it in the X or the Y axis. Both of them will work, because if I press R and X and rotate it like this, then it is perfectly aligned. But if I right click and then press R and Y to rotate it in the Y axis and then move my cursor like this, then also it will get perfectly aligned. So you can choose any of the 2 axes, either the X axis or the Y axis. For now I'll be choosing the X axis. So press R and X, and I need to rotate it by exact 90 degrees. So I will type 90 and press enter. Let's bring it down by pressing G and then Z and place it over here. To make the rod thinner, I will scale it down again, and to make it long, I will scale it up in the Y axis. So let's scale it up like this and left click to finalize. Now I'll go to the front view by pressing 1 on the numpad. Let's zoom in. I think that we should move the rod slightly downwards, so I will press G and Z to move it down in the Z axis, and let's place it here and left click to finalize. Now we have all the objects ready in our scene. Let's come out of the edit mode. We have this base, all the 4 balls, this rod which will be rotating, and this rod stand. Now to create the animation, there is one important thing to keep in mind. If you carefully notice here, you will observe that the base and the rod are rotating in opposite directions. And to create an animation like this, we first have to rotate this rod in the Z direction by 45 degrees. The reason for doing this is that now the animation will start with the rod being in this position. Previously, if I press Ctrl plus Z to undo, it was placed like this, and with this position of rod, it would not have been possible to move the balls up and down, because otherwise the ball would collide with this rod, and that is why we rotated it by 45 degrees. To get that rotation back, press Ctrl plus Shift plus Z, and here we have the rotated rod. To insert a keyframe, press I, and here at the frame 1, we have this keyframe inserted. Now I'll go to the frame 120, and since we are creating a loop animation, we want this rod to rotate completely and return back to its original position at the last frame, so that the rotation would be same as that at the frame number 1. For this, we have to rotate this by 180 degrees. So press R and then Z, type 180 and press enter. To insert the keyframe, press I, and now if I go to the frame number 1 and play the animation, you will observe that this rod would rotate in the Z axis by an angle of 180 degrees, but its rotation animation is very slow, and to fix this, we'll reduce the number of frames here. Instead of having 120 frames, we'll be keeping a total of 60 frames. To do this, go to this end option and change it to 60. Now to move this keyframe to the 60th frame, select it with the left mouse button click, and you can simply move it just like you move any other object in your 3D viewport. Go to the timeline editor and press G to move it. So I will place it at the frame number 60 and left click to finalize. Now if I go back to the frame number 1 and play the animation, you will notice that the rod rotated by 180 degrees, and this time it was faster than the previous one. Now we need to rotate this base in the direction opposite to that of this rod. So I will select this, go to the frame number 1, press I to insert the keyframe, then we'll go to the frame number 60, and to rotate it, press R and Z, and to rotate it in the opposite direction, I will type -180 this time. Press enter to confirm and press I to insert the keyframe. Now if I go back to the frame number 1 and play the animation, you will notice that the base and the rod moved in directions opposite to each other. And now we'll move forward and we'll be animating these balls. So we'll go to the frame number 1 and I'll select this ball, and with the shift key hold it this ball. Now initially at the frame number 1, all these balls will not be inside this hollow space. We will be moving these two balls slightly upwards and the other two will remain in the hollow space. To do this, press G and Z and let's move it upwards by a small value like 0.2 meters. So I type 0.2 and press enter. To insert the keyframe here, press I, and here we have the keyframe inserted. Now the position of these UV spheres will be the same on the frame number 1 and the last frame. So we'll go to the frame number 60, and with this keyframe selected, press Shift plus D and move it to the frame number 60. Now if I go to the frame number 1 and instead of playing the animation, this time we'll be dragging a pointer like this to check at which frame we need to animate these balls. So we'll check for the frame where these balls are just above the hollow space, and at frame around 30 it looks perfect. But to confirm, we'll go to the top view by pressing 7 on the numpad, and these two balls are selected here. So at frame number 31 it looks like this, and if I go to the frame number 30 it looks like this. So I think that we should keep it to frame number 31 since it will be exactly in the middle. So I will press I to insert the keyframe here. Then if I move forward, we notice that the next frame where these two intersect or appear together will be somewhere near the last frame, and we already have a keyframe inserted here. Let's change the angle, and now to show the motion of the balls moving upwards and downwards, we again have to go to the frame number 1 and we'll drag this pointer to somewhere in the middle of the first keyframe and the second keyframe. So we'll take it to somewhere near 15 or 16, and at this position we'll move them upwards because the animation will be like the rod and the base are rotating and the ball first moves up and then comes down. So with both the balls selected, press G and Z and let's move them upwards by a value of somewhere around 1 meters. So I type 1 and pressed enter, press I to insert the keyframe, and now let's check how it looks. So I'll go to the frame number 1, press spacebar to play the animation. One thing that we noted here is that the animation was a little bit quick. As soon as it reached the top, or basically its maximum height, instantly on the next frame it began to go downwards. But in reality, if a ball is thrown upwards, it remains at its maximum height for a fraction of a second. And to fix this, I'll select this frame and we'll create a duplicate of it. Let's move it here. The reason for doing this is that now the ball will go from this point at the frame number 1 to its maximum height at frame number 15 or 16 and will stay there till the frame number 20 or 21, and then it will come down at the frame number 31. So now if I go to the frame number 1 and play the animation, we see that it now looks a bit more natural than before. And now we'll make these balls go inside this hollow space, and for this I will press G and Z, and since previously we moved them upwards by 0.2 meters, so to move them down we have to type -0.2 and press enter to confirm. Press I to insert the keyframe. Let's go to the frame number 1 and play the animation. Now there's one more problem here, which is the animation from the frame number 31 to 32 is very fast, and that's because the two keyframes are just adjacent to each other. To set them apart, I'll select the first one, press G to move it, and let's place it here. Left click to finalize the position. Let's go back to the frame number 1 and press spacebar to play the animation. And this time it looks better than before. Right now we'll be seeing only the animation till the frame number 30 or 32 because we have not yet animated the part ahead it. So our basic animation looks good, but still there are some things which we can fix here to make it look perfect. For example, at the frame number 31, the position of these balls is not perfect. You can see that both of these balls are colliding with the base object. To fix this, I'll select this base object, press R and Z to rotate it in the Z axis, and we'll slightly rotate it. Left click to confirm and press I to insert the keyframe. One important thing to note here is that the rotation in the Z axis should be very slight, otherwise the animation will not look natural. So again I'll go to the frame number 1, drag this pointer like this to check if there is some mistake or not. Like here at the frame 30, you can see that these two balls are again colliding with this base. So I will rotate it again, press R and Z, and let's slightly rotate like this. Left click to finalize, press I to insert the keyframe, and now it looks perfect. You can also go to the next frame with the help of the arrow keys. So if I click the right arrow key, you will jump to the next frame. Similarly, if you have to go back to the previous frame, you can click the left arrow button. Right now the frame number 30 looks perfect. Also frame number 31 and 32 are looking perfect as well. Now moving ahead, I'll reselect these two balls, take this pointer somewhere in between frame number 32 and 60. So I'll take it to somewhere near 45 or 44. Let's move them upwards in the Z direction to reach their maximum height. So I will press G and Z and we'll move them upwards by 1.2 meters. Press enter to confirm and we'll insert a keyframe here. Now we'll go to the frame number 32 and instead of playing the animation, I will use the arrow keys to check each and every frame, and this is how our animation would look like. Till now it looks perfect. Even till frame number 57 it looks perfect. 58 is also fine and 59 and 60 are also perfect. So we are done with the animation of these two balls. So we'll go to the frame number 1 and we'll check if the animation looks natural or not. So press spacebar to play the animation and this is how it looks. So at the beginner level it looks perfect, and now I'll select the other two balls. I selected this one and with the shift key holded I'll select the other one. So we'll go to the frame number 1 and insert a keyframe. Press I and here we have the keyframe inserted. Now to check the next frame where these two balls would be at the same position at that of the hollow space, we'll drag this timeline cursor. So we'll drag it like this and somewhere around the frame number 30, the balls will be at the required location. So I will press I to insert the keyframe, and to check if the position of these two balls is perfect or not, we'll go to the top view by pressing 7 on the numpad. This ball looks perfect, but we can adjust this ball so that it appears somewhere in the middle. So I will select this one, press G to move it, and since we are in the top view, whatever change in location we will do will only affect the location in X and Y axis. So we'll place it over here and left click to finalize. Press I to insert a keyframe. In fact, even this ball also appears to collide with the base. So I'll select this one, press G to move it, let's place it here, I to insert the keyframe, and now it looks perfect. So I'll change the angle, select these two balls again, go to the last frame which is frame number 60, and we'll insert a keyframe for these two balls at these positions. For this press I, and here we have the keyframe inserted. Again, to check the perfection of their positions, we'll go to the top view and they look almost perfect. So we'll not do any more changes here, and now it's the time to move these balls up and down. For this, I'll take this pointer to the frame number 1, drag this pointer like this, and we'll stop it somewhere in the middle of these two frames. Let's move them upwards by 1 meters. So I will press G and Z, type 1 and press enter. To insert a keyframe, press I, and here we have the keyframe inserted. And if I play the animation, we again notice the same problem that we faced in case of these two balls, which is that at this frame they are at their maximum height and just at the next frame they begin to fall, which gives it a slightly unrealistic or an unnatural look. To fix this, I'll select this keyframe, move it like this, and create a duplicate of it and place it here. And now if I play the animation, by dragging this cursor, we will observe that the two balls will stop in between and then go downwards. We did the same for these two balls as well, but yes, we did one small mistake here that you can see in the timeline editor. We created a duplicate of this keyframe, that is the keyframe at the frame number 16, and placed it at the frame number 20, but we did not do the same with this one. Always remember that if the area between any two keyframes is shaded like this, it means that the second keyframe is the duplicate of the first one. As a result, we can say that these two are the same keyframes, but there are no more duplicates in the timeline editor. So with this keyframe selected, we'll create a duplicate of it. So press Shift plus D and move it like this, left click to finalize the position. Now I'll select the other two balls and we have the animation of the first 30 frames completely ready for all the 4 balls. So now let's move to the next 30 frames. We'll take the pointer to somewhere between the 30th and the 60th frame, like somewhere near 45 or the 44th frame. We'll move them upwards so that they reach their maximum height at this frame. So press G and Z and let's move them up by 1 meters. Press I to insert the keyframe, and we'll create a duplicate of this keyframe also so that it stops at its maximum height for a fraction of a second. So I'll select this one, move it by pressing G, we'll place it here, press Shift plus D to create a duplicate and place it over here. Now I'll take this pointer over the frame number 1, slightly change the angle to view all the balls perfectly, and we'll check each and every frame with the help of the arrow buttons. So I will use the right arrow to go ahead in the timeline. Let's also keep changing the view or the angle. Let's move ahead, and somewhere it looks perfect till now. We have completed 30 frames and there is no such visible problem or any imperfection in our animation. Let's move ahead by clicking the right arrow, and the main issue that you might face will be somewhere near the ending frames or the middle frames. So on the frame number 56, there's no such issue. We'll go ahead to the frame number 57 and still it looks perfect. Similarly 58 and 59, and there is no such imperfection, and the last frame, which is frame number 60, also looks perfect. And so we have created our first basic animation in this course, and to give it some material, we'll be using the shaders from the library that we created in the chapter numbers 21 to 24 of this course. There we learnt about materials in complete detail and also created some basic and procedural shaders. And to get that material library here, we have to add a new window here. So I'll take my cursor over here and this double-headed arrow would appear. Then right click and select the horizontal split. Take it in the middle to divide the area into two equal parts. Now to convert this into the material or the asset browser, click on this icon and select the asset browser. To view only the specific materials that we ourselves created, click here and select the user library. We created all these materials in the chapter number 21 to 24 of this course, and also we'll be creating some more materials when we learn about advanced shaders further in this course. But for now, to give these objects some material, we'll go to the render preview mode. Let's change the render engine to cycles. So go to the render properties. By default it is set to EV, but I'll change it to cycles. And to get a proper lighting, click on this drop down arrow and turn off the scene world. And now we have a proper lighting in our scene. First we'll assign some material to this base. So I'll select this and let's apply the simple car paint shader to it. So I'll select this and drag it over like this, and if I release it, this material would get assigned to the base. Similarly, I'll select the stand of this rod and let's assign it the dark gray metal. So I'll select this and drop it over the rod stand, and here the material of the stand of the rod will change to dark gray metal. Similarly, we'll assign this brushed aluminium to this rod. So I will select this, drag it and place it over the rod, and the material is assigned. For the balls, we'll be using this glossy green paint, but we'll change the color of the balls later on. So I'll select this, drag it and place it on all the 4 balls. Similarly for the third one also, and for the fourth one as well. Now to change the color of these balls, I'll change this to the shader editor. So click on this icon and select the shader editor. Now I'll select one of the balls, zoom into the shader editor, and if I try to change the color from here, you will notice that the color change will be visible on all the balls, and this is because all these 4 balls are having the same material. To fix this, we need to create a duplicate of this material and we'll make changes in that duplicate. To do this, click on this icon here, and now we notice that the name of the material changes to glossy green painted.001. This .001 means that it is the duplicate of the glossy green painted material. And now if I try to change the color from here, suppose I choose the yellow color, then in my 3D viewport, only the color of this specific object will change and not the others. Now I'll select the second one, create a duplicate, and let's change the color to blue color. Similarly the third one, create a duplicate, go to the base color, and we'll change its color to green color, and let's keep the fourth one as the pink color. Now we have assigned the materials to all the objects in our scene. So I'll close this shader editor by right clicking here and selecting the join areas. Take this pointer towards the shader editor and left click. And now in the end, we'll learn how can we produce an output of this animation, or basically how can we render it. So the first step is to go to the camera view by pressing 0 on the numpad, and to change the camera view, press N, go to the view and turn on the lock camera to view. Now I'll zoom in and let's also adjust it like this. Right now the output that you will get will be in this landscape mode, but suppose you want to change it to the portrait mode. To do this, you have to open the output properties by clicking on this icon. Here you can control all the settings related to the output that you will render. Here you can see that the resolution is set to 1920 pixels in the X and 1080 pixels in the Y, which means that you will get the output in this landscape mode. And if you want to render it in the portrait mode, or basically that mode in which you watch YouTube shorts or Instagram reels, then you just need to reverse these values, meaning that in the X resolution I will type 1080, press enter, and in the Y resolution I'll type 1920 and press enter. To see the entire view properly, I'll turn off the lock camera to view. Now if I zoom out, this is the area that you will be seeing in the output which will be rendered. The frame rate here is set to 24 FPS, and since we are having 60 frames, so the total length of the final video will be 60 divided by 24, that is 2.5 seconds. But you can extend it even longer since it is a loop animation. Now we'll scroll down here, and here you have the output settings. The most important thing to change here is the file format. By default it is set to PNG, meaning that it will generate image outputs of each and every frame instead of generating a video. But because we need to render a video, so I'll go to the file format and change it to FFmpeg video. Now you also need to tell Blender at which particular location it should save your file. To do this, you have to use the output path option. To set a particular location, click on this icon, and then you can browse a particular location or some folder, and if you have to create a new folder, then simply click on this icon and a new folder will be added. Let's name it videos and press enter to finalize. Now since I want to save the video in this folder, so I'll double click on it and let's change the name to something like first animation, then press enter and click on accept. And now we are ready to render the animation. So I'll click on this render button and select render animation. Now this screen will appear here, which will show you the frame number that it is rendering and the sample count here. So it would take some time to render the entire video depending on the specifications of your PC. And you can also see the results here frame by frame. Also here I feel that we should have added a plane at the bottom to give it a better look. But right now it is rendering. So suppose you want to cancel it, so you can simply press escape key and the render will be cancelled. Now I'll close this, and to add a plane here, I will press Shift plus A, go to mesh and select the plane. Let's move it downwards downwards by pressing G and Z and place it over here. Left click to finalize the position, tab into the edit mode, and I will scale it 10 times. So I will press S and 10, and now it looks like this. But here in the camera view, the end of this plane is visible. To fix this, we'll scale the plane even more. So I will press S, and to scale it twice, press 2 and then enter. And it's still not perfect, so I will scale it even more by pressing S and left click to finalize. Now I'll get back to the object mode, and let's change the color of this plane by going to the material properties here, click on the new button, and now the default material is applied to the plane object. To change the base color, click here. And for a better contrast, we'll make the plane a little dark. So let's change it to grey color or maybe light blue color. Let's reduce the brightness even more, and now it looks perfect. So we'll render this again by clicking on render and selecting the render animation. And now our final output looks like this. And also this brings us to the end of this chapter. One important thing before ending is that if you are learning animation in Blender for the very first time, it might be possible that your rendered video might be a bit different, or there may be some problems in it, some imperfections, and the best way to deal with this is to go to that specific part of the video where we discussed about that problem or the imperfection and try to resolve it in your Blender project. And if you have any doubts, then you can write them down in the comments below. In this chapter, we'll be learning about some advanced tools which are used in Blender animation, such as F-curves and graph editor. Now the first topic for this chapter is F-curves, and whenever we animate our object, that is we insert keyframes at different positions in the timeline editor, then Blender automatically creates F-curve, which is used in airfall design and interpolation. And to understand this concept, we first have to make a simple animation with this cube. To do this, let's first expand this timeline editor by left clicking here and dragging like this. Now to start the animation, I first have to insert a keyframe at the frame number 1, which will carry the information that the cube is at a particular location, rotation and scale value. And for this, I will press I, and here we have the keyframe inserted. Now suppose I want the animation to be of 100 frames, so I'll take this pointer to the frame number 100, and let's suppose we want to create an animation where this cube moves from its current position to somewhere in the Y axis, and for this I will press G and Y, and let's move it like this. Left click to finalize the position, and to insert a keyframe at the frame number 100, press I, and here we have the keyframe inserted. And to play the animation, I'll take this pointer to the frame number 1 and press the space bar. You will observe that its motion is slow in the beginning, faster in the middle, and it again slows down as it approaches the ending. Basically, you can say that the motion of this cube is not linear. Now we can even confirm it manually by checking the location in the Y axis at each and every frame. We made this animation of 100 frames, and initially at the frame number 1, its position in the Y axis was 0 meters, and at the frame number 100, which is the final frame, we moved it to somewhere near 15 meters. In simple words, we can say that with movement of each frame, it should have moved approximately 15 divided by 100, meaning 0.15 meters in the Y axis. So to check this, we'll go to the frame number 1. Here it is 0 meters, and if I use the right arrow key to jump to the next frame, we see that the position in the Y axis is less than 0.15 meters, meaning that its initial speed was very slow. Similarly, on the next frame also, the value is still less than 0.15 meters. But if I take it to somewhere near 40th frame, then mathematically, we expect that its position in the Y axis should be somewhere around 0.15 multiplied by the number of frames, which is 40, which is equal to 6 meters. But if I check here, the location in the Y axis is close to 5 meters, meaning that even till the frame number 40, the speed of the motion or the animation was a bit slower as compared to what we expected. We expected a uniform motion, but in reality it does not happen. But now if I go to the frame number 70, and this time according to us, its position in the Y axis should be 0.15 meters multiplied by 70, which is equal to 10.5 meters. But if I check here, the location in the Y axis is very close to 12 meters, which means that initially the motion was slow, but somewhere in the middle, the speed of the motion increased. And this is how the default animation works in Blender. To summarize everything, you can understand it in this way. For the initial frames, the speed will be slow, then in the middle, the speed will be very fast, and at the end, the motion will again slow down. And suppose you want to edit or manipulate this speed, then you would have to use the F-curves. And to see the F-curves here, we'll change this timeline editor to the graph editor. So click on this icon, and here you will find the graph editor. So I'll select this. Let's expand this by dragging it like this, and this is called the F-curve. To zoom in or zoom out, you can simply use the scroll wheel of your mouse. Now here on the left hand side, you will see a list of all the objects that are animated in your scene. Since we animated this cube, so here you have the cube in the list, then any change in the position or the rotation or the scale of a particular object while animating will be saved in this cube action. Since we changed the position of this cube from 0 meters to somewhere near 15 15 meters in the y-axis, so you can see this object transformation here, meaning that we changed the position of our object in our scene. And since we changed the position in the y-axis, here in the graph editor, this curve is also representing the y-axis, and this is because it is green in color. Here in the 3D viewport, you can see here that the x-axis is represented by the red color, y-axis by the green color, and z-axis by the blue color. So in the graph editor, this green curve is representing the object transformation in the y-axis. Now to observe this graph, let's first zoom out, and if you look closely at this graph, you will notice that the graph is not linear. A linear graph would have meant that the speed of the motion of this cube would have been uniform throughout. In the beginning, you have a flat slope here, then in the middle, it looks somewhat linear, but in the end, it again has a flat slope. As a result, in the beginning and the end, the speed of the motion was slow, and in the middle, it was faster. But now suppose you want the motion to be of uniform speed, and in that case, you would need this graph to be linear. To do this, simply right click, go to interpolation mode, and select the linear. And now this graph is linear, and if I take this to the frame number 1 and play the animation, you will notice that the cube moves from one point to another with a uniform or a constant speed. And all this is because we changed the interpolation of this graph to linear. Also, if you right click and in the interpolation mode, you will find some more graph types. For example, suppose I select the sinusoidal, then the graph would look like this. The shape of this graph turns from linear to sinusoidal. Now, if I move my pointer like this, you can notice here that there are 2 points on this green graph. One is this point at the frame number 1, and the second point is here at the frame number 100. These 2 points indicate that we have 2 keyframes inserted at these frame values. And since both of these points are selected because they are highlighted with yellow color, any change that I make to the interpolation will be applied to the graph between these 2 points. Now you may notice here that you also have this blue line intersecting this y-axis graph, and this blue line represents the animation of this cube in the z-axis. But during the entire animation, we did not change the position of this cube in the z-axis, and that is why it appears like a simple straight line from the frame number 1 to the frame number 100. It does not seem to change its value at any point between the 2 frames. But moving back to the graph of the y-axis, suppose you have to deselect both of these points, so you can simply left click anywhere in the graph editor and all the points will be deselected. Now to select a particular keyframe or a point, simply left click on it, and now this is selected. But if you look at the other point at the frame number 1, it is still deselected. Now with only the second point selected, if I right click and change the interpolation mode to linear, you will not notice any difference in the graph or this curve. And the reason for this is that this is the last key point of the curve and there is no next key available after this point to apply the change. But now if I select the first keyframe, the other one will get deselected, and if I right click and in the interpolation mode select linear, you will notice that the curve will change from sinusoidal to linear. Now suppose I want the animation to be a little longer, like from the frame number 1 to frame number 100, the object should move in the y direction, and then from the frame number 100 to frame 200, it will return back to its original position. For this, we'll take this pointer to the frame number 200, go to the object properties and change the location in the y-axis to 0. Go to the 3D viewport and press I to insert the keyframe. Now in this graph, we have 3 points. One is at the frame number 1, second one is at the frame number 100, and the third one is here at the frame number 200. Now suppose I want that the first half of this graph should be linear like this, but the other half, that is from the frame number 100 to 200, should be sinusoidal instead of linear. To do this, select the frame from where this curve starts, that is the frame number 100. Then right click, go to the interpolation mode and select the sinusoidal. And now the first half is linear and the second half is sinusoidal. Now Blender also gives you the option to manually adjust the graph instead of changing the interpolation type. And for this, we first have to select all these 3 points in the y-axis curve. So here the second key point is already selected. So with the shift key holded, I'll select the first one and also the third one. And now all of them are selected. Then right click and in the interpolation mode, you will find this Bezier option. So I'll select this, and now here we have these points here which we can move to change the curve. For the first key point, that is this one, these 2 are the points which you can use to change the position of the graph. For example, with this selected, if I left click and drag like this, you will notice that the graph changes. If I leave it here, then in the beginning, we have a linear graph here. Similarly, if I want to change the structure of the graph in the middle, select any of these 2 pointers. Suppose I select this one and left click and move it like this, I can again change the graph structure. Similarly, for the third point, these 2 are the pointers which you can use to manipulate the graph. So suppose I select this point, left click and drag it like this, then now we can change the structure of the graph from this point. So initially, we change the graph to linear, then by the time it reaches the frame number 100, it appears curved like this, and then due to this steep slope, the motion of this cube will be faster in the ending. To view this, I'll take this pointer to the frame number 1 and press the space bar. So initially it moves with a normal speed till the frame number 100 and then it begins to return back, and after a few frames the speed of the cube increased. So always remember one basic thing, that if you want to slow down the motion, then the graph should be basically flat or a bit horizontal, and if you want the motion to be fast, then the graph should be more like vertical. To explain this, suppose I want the beginning to be slow and the ending to be fast. For this, with one of the pointers selected, I'll left click and drag like this, and now it appears more flat than before. Also, I'll go to this key point, and we already made this faster by making the curve like this. But if you want to increase the speed even more, then select one of the pointers and drag like this. If I move the cursor like this, then you can see here that the line with the pointers is now vertical, meaning that the speed of the motion will be fast. Similarly, if I go to this pointer, select one of the pointers, and to make it slow, I will drag it and make it horizontal, and now it looks perfect. Now initially this is horizontal, meaning that the motion will be slow, and in the end it is vertical, meaning that the animation or the motion will be faster. To check this, we'll go to the frame number 1 and play the animation. Now in the beginning, the speed of the animation is a bit slow till it reached the frame number 100, and when it begins to come back to its original position, the speed increased in the end. And now suppose you want to change the time for which the motion should be slowed down or should be faster. To do this, simply select one of the pointers, left click, and now instead of rotating it, I move it like this. Then here I basically increased the timing for which the motion is slowed down. Previously, if I press Ctrl plus Z, the motion was slow only from the frame number 1 to somewhere around frame number 30. But if I redo, then now the slow motion effect is applied from the frame number 1 to the frame number something close to 70. Similarly, if I go to the third key point, move the cursor like this, select one of the pointers, and to increase the timing for which the speed is increased, I left click on it and drag it like this. Release the left mouse button to finalize, and if I go to the frame number 1 and play the animation, then the number of frames or the time for which the motion was slow has increased, and a similar effect was seen for the faster motion as well. So basically in this way, you can edit or manipulate the curve and create a motion profile that suits your requirement for a particular animation. Now suppose you want that when the object reaches the maximum position in the y-axis, that is at the frame number 100, it quickly bounces back and moves towards its original position. To do this, we'll take one of these pointers and with the shift key holded select the other pointer, and now we need to reduce the frames for which the object stays here before bouncing back. To do this, simply go to the graph editor, and to scale down, press S and scale it down like this. Left click to finalize, and now if I go to the frame number 1 and play the animation, you will notice that initially the speed is slow, then it reaches the frame number 100, it stayed there for a fraction of a second, and then after bouncing back, the speed of the motion increased. Now one thing to observe here is that after the frame number 100, if I play the animation, the speed of the cube is slow, and this is because the curve is not too much steep like this. This part of the curve is steep, and that's why the motion is faster here, but this part of the curve is not that steep, and that is why the motion appears to be slower. And now suppose you want this curve to change back to how it previously looked. For this, I'll select this point, with the shift key holded select this point and then the third point. Right click, go to interpolation type, and from here you can change it back to any mode like the linear or the sinusoidal. So if I select the linear, the pointers here will get removed and we'll get the default linear curve in the graph editor. Now suppose we want that while moving our cube object in the y-axis, it should also vibrate in the x-axis, and for this Blender gives you the noise modifier. And now since we want to apply the noise modifier in the x-axis, I need to select the curve or the graph of the x-axis. For this, click on this drop down arrow, and here you will find the x location. So I'll select this. Now go to the modifier, click on add modifier and select the noise. Now here you will see this slight noise added to the curve of the x location, and to make it stronger, go to the strength option here and let's increase it to a higher number like 5 or 6. And now if I go to the frame number 1, and before playing the animation, let's adjust the view properly so that we can see the vibration of this cube in our scene. Press spacebar to play the animation, and now you see that the object moves in the y-axis and it is also vibrating in the x-axis, and this is how the noise modifier works. But if I play the animation after the frame number 200, it won't show any motion in the y-axis and it only vibrated in the x-axis, and that is because the motion in the y-axis was set only from the frame number 1 to frame number 200. But suppose I want that the animation should repeat itself a specific number of times, like if I want it to repeat itself 5 times, then for this we first have to increase the number of frames here. Right now we have set the maximum number of frames to 250, but if I want the motion to repeat itself in the y-axis, then I have to increase the frame number to a value of 200 multiplied by 5, which is 1000 frames. To do this, click on this icon, change it back to the timeline editor, go to this end option and type 1000, press enter to confirm. Now again click on this icon and go back to the graph editor. Now to make the motion in the y-axis to repeat itself 5 times, click here on the y location, and now the curve in the y-axis is selected, and now we'll use the cyclic modifier. To apply it, go to the y location, right click, and here in the extrapolation mode, select this make cyclic modifier, and now we have the graph of motion in the y-axis repeated throughout the timeline. To view the animation now, I'll go to the frame number 1 and play the animation, and now you can see that our object or this cube is basically vibrating and also moving in the y-axis, and after reaching its default position, it will again start the motion in the y-axis and also show the vibration. And this is how the cyclic modifier works. And also one more thing to notice here is that we applied the cycles modifier by right clicking at the y location, going to the extrapolation mode, and here we have this cyclic modifier. But if I go to the modify properties here, you will find that Blender automatically added this cycles modifier here as well. And suppose you want to clear this cycle, then one way is to go to the y location, right click, go to extrapolation mode and select the clear cycle, or else you can go to the modify properties and click on this cross icon. And so this brings us to the end of this chapter. Today we learned about how the graph editor works, what exactly is the meaning of these curves and these points, how can you manipulate the curves to control the speed of the motion, then we added the noise here, and we even understood about the cycles modifier. In this chapter, we'll be understanding about non-linear animation and all the concepts related to it. Now, the first question is, what exactly is the non-linear animation? So, non-linear animation allows manipulation and repurposing actions without the need of handling the keyframes, or else in simple words, it is the process of moving, rearranging, manipulating and blending different animation clips to produce a new series of motions. And now here is the default Blender scene, and to understand about non-linear animation, we first have to remove all these objects. So press A to select all and X to delete. Now we'll add the Suzanne or the monkey model. So press Shift plus A, go to mesh and select the monkey. To make it look realistic, right click and apply shade smooth. Also go to the modify properties, click on add modifier, and in the generate you will find the subdivision surface. Let's increase the levels viewport to a higher number like 3, and now we have a realistic Suzanne model. Now while practicing non-linear animation, we have to use a dope sheet, and to open the dope sheet, I'll first expand this timeline editor and we'll change this timeline editor to the dope sheet. To do this, click on this icon and here you will find the dope sheet. So I'll select this, then click here where it is written dope sheet and change the mode to the action editor. So this is the action editor, and whenever you create an animation in Blender, the data related to that animation is called action, and all this data is saved in your Blender file whenever your file is saved. Now since we'll be understanding about non-linear animation, so here we also need to add a non-linear animation editor, and for this take your cursor over here, right click and select the horizontal split. Let's divide the area and left click to finalize. Now I'll expand the area of the action editor by left clicking and dragging like this. Now to change this into the non-linear animation editor, click on this icon, and here in the animation section you will find the non-linear animation. So we'll select this, and this is the non-linear animation editor. So basically whatever animation that you will do in the 3D viewport will be saved as an action and will be displayed here. So to create a new action, click on this new button and a new action is created. So suppose you want to create a simple animation with the Suzanne model, showing that initially at the frame number 1 this object will be at its default position, but then at the frame number 50 we'll move it upwards in the z-axis, and then it will come down again when it reaches the frame number 100. And to do this, with the pointer at the frame number 1, we'll insert a keyframe by pressing I, and here we have the keyframe inserted. Now since the position of this object at the frame number 1 and the frame number 100 will be the same, so I'll take the pointer to the frame 100, and to insert a keyframe here I will press I. Now here you can see that the area between the two keyframes is highlighted with an orange color, and this means that there is no change happening between these two frames. The position, rotation and the scale of the object and all the other properties will remain the same between these two frames, but we needed to make the animation where it goes upwards in the z-axis. For this, I'll take this pointer to the frame number 50, go to the 3D view editor, and to move it upwards press G and Z, and let's move it upwards by 5 meters. So I will type 5 and press enter. To insert a keyframe, press I, and now we have a keyframe inserted here. And now let's play the animation by taking the pointer to the frame number 1 and pressing the space bar. So this was the animation that we created, and now it is stored as an action here. You can even change the name of this action by clicking here, and because it first goes up and then comes down, so let's change its name from action to up down. Press enter to confirm, and now our action is renamed. And suppose you want to create another animation, so first you need to remove this animation of up down from the timeline, and to remove it, click on this cross icon. The animation that we created is now removed from the timeline, but that particular animation is saved in the form of an action, and to check it, click on this icon, and here you have the up down action saved. Now suppose you want to create another animation and save it as an action in your file, so to do this, click on this new button and a new action is created. And suppose we want that in this particular action our object or the monkey model should rotate, so we'll take this pointer to the frame number 1 and let's insert a keyframe at this point. So press I, and here we have the keyframe inserted. Let's take it to the frame number 50 and we will be creating an animation where this cube rotates by 180 degrees in the Z axis and then returns back to its original rotation. For this, press R and Z and type 180, press enter to confirm. Now this object is rotated by 180 degrees in the Z axis, and to insert a keyframe at the frame number 50, press I, and here we have the keyframe inserted. Now we'll take this pointer to the frame number 100, and to change its rotation back to the original rotation, I'll select this point with the left mouse button click. Previously both of them were selected, so both of them were highlighted as yellow, but now only this one is highlighted, and we'll create a duplicate of this and place it at the frame number 100. So press Shift plus T and move it like this and take it to the frame number 100 and left click to finalize. Now to play the animation, I'll take the pointer to the frame number 1 and press the space bar, and this is how the animation shows our object getting rotated by 180 degrees in Z axis and returning back to its default state. Now we'll change the action name to something related to the animation that we created. Since we created a rotating animation, so we should rename it to rotate, and since we rotated it in Z axis, so I will type Z, press enter to confirm, and now if I click this icon, we have two actions saved here. One of them is this up down and the other one is this rotate Z. So basically by using non-linear animation, you can apply multiple animations to your object at the same time very conveniently. And to do this, we need to add these actions in the non-linear animation editor here. And adding these actions in this editor is known as pushing down. So suppose I select the up down action from here and click on this push down button. Then here we have this up down action added in the non-linear animation editor. To add the second action, click on this icon again and select this rotate action. Click on this push down button, and now here in the non-linear animation editor, we have two actions added. One is the rotate and the other one is the up down. But now if I go to the frame number 1 and play the animation, you will notice that our object is showing only the rotation animation but not this up down animation, and this is because this rotation action is placed in the upper layer of the non-linear animation editor. This editor works in a very similar way to the video editing softwares like Premiere Pro or DaVinci Resolve. Here we will be getting the output only of the action which is in the upper layer, and since the rotate action is placed above the up down action, so here in the animation we can see only the rotation and not the up down animation. Now suppose we want to see the up down animation and not the rotation, so for this you can uncheck this box here by left clicking on it, and now if I play the animation by pressing the space bar, our object will show the up down animation and not the rotation, and this is because even though the rotation is still present in the upper layer, but we have disabled it from here. As a result, it will only consider this up down action and the object will play this animation. And you can even try this with more than two actions in your scene. So suppose I create a new action from here, take this pointer to the frame number 1, and we'll be creating an action where this cube moves in the X axis. So to insert a keyframe at the frame number 1, press I, then go to the frame number 40 and let's move it in the X direction by pressing G and X and moving it like this. Press I to insert the keyframe, and this time instead of making the animation of 100 frames, we'll be keeping it to 80 frames. To make the object return back to its default position, I'll select this point at the frame number 1, create a duplicate of it by pressing Shift plus D and placing it at the frame number 80. Left click to finalize. Now let's play the animation, and this is how it looks. Let's also change the name of this action from here, and because it is moving in the X direction, so let's name it Move X. Press enter to confirm, and now if I click here, we have 3 actions saved. And to bring this Move X action in the non-linear animation editor, click on this push down button, and here at the top layer we have this Move X action inserted. And now if I go to the frame number 1 and play the animation, only the action at the uppermost layer will work, which is the Move X action. Now here we can see that we have disabled the Rotate Z action. So first I'll enable this, and now suppose you want only a particular animation to be played here regardless of the order of these actions in the editor. For example, if I want the Rotate Z action to be played, simply click on this star icon, and now if I go to the frame number 1 and play the animation, then our object will show only the rotation animation in the scene. And you can even move these actions in the non-linear animation editor. And to do this, if I click on this Move X with the left mouse button and drag it like this, we can simply move it in the timeline editor. Also, you can change the layer of this action in this editor. For example, if I left click and bring it down, then now this movie MoveX action is in the second layer where this rotation action was placed. So now if I go to the frame number 1 and play the animation, you will notice that the object first rotates in the Z axis and then it will begin to move in the X axis and returns back to its original position. And now suppose you want to see multiple actions played together to form an entirely different animation. To put it in simple words, we'll be basically blending two actions together. For example, this MoveX and the rotate Z action, and the result would be that this monkey would move in the X direction and will also rotate in the Z axis. But to do this, first with this action selected, left click and drag it upwards. Let's also place it here and we'll remove the star from here, and now all the layers are activated. And now to combine multiple actions together, we have to work on this toolbar. But first let's expand this window by left clicking here and dragging like this, and here we have the toolbar. If you are not able to see this, then simply press N to toggle this toolbar. So here in the strip option selected, you have the information about the frame starting and the frame ending for the selected action type. But since we need to combine two actions, we have to go to blending option, and if I select the combine, then it basically creates an animation where the move X action will be combined with the action below its layer, which is the rotate Z action. So if I take the pointer to the frame number 1 and play the animation, you will notice that the object moves in the X axis and it is also showing the rotation in the Z axis. Also, if I go to the blending option again, then we have the add option, and if I select this, it will work in a similar way as the combine option. So if I take it to frame number 1 and play the animation, you will again notice that our monkey object show both the actions, the moving action in the X axis as well as the rotation in the Z axis. And now suppose you want all the three actions to be played together. For this, we have to go to the second layer, and here in the blending, we'll change this to the combine option, and this will combine the rotation and the up down animation. So now if I go to the frame number 1 and play the animation, you will notice that our object is showing all the three actions. It moves in the X axis, rotated in the Z axis, and also showed an up down animation. And so this is how the non-linear animation works. One more important thing is that the practical use of non-linear animation is mostly in character animation, because while you're animating your character, you would need to add different types of actions, and there you will be using the non-linear animation. So after covering the chapters related to character modeling and rigging in this course, we will also understand about the use of this non-linear animation in animating your characters. So this brings us to the end of this chapter. In this chapter, we learnt about creating and saving different actions, about working in the non-linear animation editor. Then we learnt about combining different types of actions together to create a completely new animation. I will first delete all these three objects by pressing A and then X to delete, and to add the text here, press Shift plus A, and here you have a separate object type named as text. So I'll select this, and here we have the text object added to our scene, and by default it displays the word text on it. And just like you move, rotate and scale any other object in Blender, you can do the same with this also. To move the text, simply press G and move around like this. To rotate it, press R and rotate like this. Similarly, to scale the object, press S, and in this way you can scale up or scale down the text in your scene. One more important thing to note here is that the text object added to our scene is two-dimensional and not 3D. This is because it does not have any thickness added to it. We will be exploring about how you can increase the thickness of this text and give it a 3D look. But before that, let's first understand that how can you edit the letters and the words that are displayed in this text object. And to do this, we first have to enter the edit mode by pressing the tab key, and now you can change the text to anything that you want to be displayed here. To remove the letters, simply press the backspace, and now you can type anything with the help of your keyboard, and those specific letters and words will be displayed here in the text object. And once you have finalized, simply come out of the edit mode by pressing the tab key again, and now we have changed the text in our scene. And now to check the properties and the settings of this text object, we have to open the object data properties, and for this, click on this icon here, and all these are the properties or the settings related to this text object. Now the first option here is the resolution preview, and this controls how realistic and smooth your text object looks in the 3D viewport. Usually a value of somewhere around 10 to 12 looks good in most of the cases, so we'll keep it to a value of 12. And then the next option is the render resolution, and this one controls how realistic and smooth the text would look like when it is finally rendered. The default value of this render resolution is set to 0, and this 0 means that it takes the same value as that of the resolution preview. So both of these default values are fine, And the next tool here is the fast editing. And if I turn it on, the text will not be filled while you are editing it. However, it will still give the same output when you finally render it. And the benefit of using this is that when the filling is disabled, then it would take less time to calculate the lighting and everything else, and will help you in editing the text faster. Now the fill mode is whether the front or the back of the text should be filled in, and you can even choose that none of them should be filled by clicking on this none option, or if you want both of them to be filled, then you can select both in the fill mode here. And this fill mode that we just discovered is basically used when you convert your text from 2D to 3D. And to give this text a 3D look, click on this geometry option here, and here from the extrude, if I increase it, this will give a 3D effect to our text object. Right now it is extruded too much, so let's reduce it, and I'll change the extrusion to a lower value like 0.15, and now it looks good. To get a better view, I will rotate this in x-axis, so press R and X, and let's rotate it by 90 degrees, press enter to confirm, and now our text looks perfect. Now the next useful tool in the object data properties for this text is the bevel option here. If I increase the depth from here, it will basically give a bevel effect to the text in our scene. You can control the depth of this bevel effect from here, and even the resolution. Higher the resolution, more will be the number of segments, more smoother will be your text, and it would even give it a realistic look. By default it is set to a value of 4, and its default value usually works fine, but to give it a slightly better look, you can increase it to 6 or 8, and this will increase the smoothness of the text and will add some realism to it. Now suppose you want to change the font of your text. For this, in the object data properties, you have this option of font. So I'll select this, and here you have 4 different font options to choose: regular, bold, italic, and the last is bold plus italic. But we'll only be using the regular font and not the other ones, because we can do all the changes in the regular font as well. If I click on this icon here, this will display me a list of all fonts that I have used in my file. But right now it is showing only the default font that is applied to this text object. And to change the font, you have to click on this folder icon against the regular font. So I left click on this, and this will open up the folder where all the fonts are stored in your device. And from here, you can choose any particular font that you want to apply for your text. And in case it does not show this list, then you simply have to locate that particular folder where all the fonts of your PC are saved. For Windows users, that particular path will be this. So you can write down this path in the file path option here, and then it will display a list of all the fonts in your device. And to add any particular font, simply click on it and select open font. Now that particular font will get applied, and to change the size and appearance, go to this transform option, and from here you can increase or decrease the size of your text. The next thing is shear, and this basically controls the slant of the font. If I increase it, the slant will increase in this side, and if I reduce it, then the slanting will be on the opposite side. It only allows a value from -1 to 1. At a value of -1, it will show the shear effect or the slanting in this negative side. If I take it to a value of 0, then it won't show any such effect in any of the two directions. And if I increase it to a value of 1, then it shows the italic or the slant effect in this positive direction. Right now, I'll change the shear value back to 0, and the next useful setting here is the text on curve. But before using this option, we first have to add a curve in our scene. So press Shift plus A, go to curve, and select the Bezier curve. It is added here. Press G and Z and move it like this, and we'll be placing it just above our text. So press G and X and move it in X direction. You might not be able to see the curve right now while moving it in X direction, because the red color of the X axis and the curve are blending with each other. But you can see this tiny yellow dot and estimate the position of the curve. So I'll place it in the middle, press left mouse button to finalize, and now we have to go to the front view by pressing 1 on the numpad. And now I'll select the text again, and in the object data properties of this text, in the transform section of the font, here you have the option of text on curve. So with this text selected, I'll click on this eyedropper, and we have to select the Bezier curve. So I'll take it over the curve and left click, and we notice some changes in our text. Basically, the text on curve allows you to deform the curve, which will then control the appearance of your text. To understand this, I'll select the curve, and if I press S to scale it up, the text will also get scaled up like this. Similarly, if I tab into the edit mode and deselect all these points, then here in the Bezier curve, I have 2 points. One is at the beginning, and it has these 2 pointers, and the other is at the end, and this one also has these 2 pointers. The pointers here help you to deform the curve. For example, with this pointer selected, if I press R to rotate, then the text will get reformed. To cancel this, I will right click, and you can even try one more thing, which is to select the particular pointer, and instead of selecting the 2 Bezier pointers here, we will directly try to deform with only this one selected. So suppose I press R and try to rotate the curve, then we'll see the deformation. on this curve as well as our text object. Similarly, you can try to move the curve by pressing G, or maybe scale the curve by pressing S, and you will see similar deformations on your text object. However, you will be using this curve to deform your text in very rare cases, but it's always better to understand the concept so that you at least have the knowledge about the basics of that tool. Right now, I will come out of the edit mode by pressing the tab key, and I'll be deleting this curve by pressing X and then delete. Now all the deformations will get removed on deleting the curve object. Now I'll select this text, and here in the object data properties, if I scroll down, we have this segment of paragraph, and it basically defines the alignment and the spacing in your text object. In the alignment, you have two options. One is the horizontal and the other one is vertical. And if I go to the horizontal alignment and change it to center, then it will basically take the Z axis as the center of alignment and will place the text like this. Similarly, if I change it to right, then the text object will show right alignment in respect of the Z axis. But right now, I will change the horizontal alignment to the default left, and the next option you have here is the vertical alignment. And this vertical alignment basically considers the X axis as the center. Right now it is set to top baseline, and that is why it appears like this. But if I change it to top, then the alignment would change. Similarly, if I change it to middle, then it appears like this. So you can use these different options of alignment to perfectly align your object as per your specific requirement. And next you have the character spacing, and this basically controls the spacing in between the letters or the characters of this text. If I increase it, the spacing between the characters or the letters will increase, but right now I think that I should reduce it to a value of somewhere around 1.1 or 1.2, and it looks perfect now. Then next you have the word spacing, and this basically controls the spacing in between the words of your text, which means that the space between JB and 3D and also between 3D and Studio will be controlled with this word spacing. So if I increase it, the spacing or the distance between the words will increase, and for now I will change its value to the default one. Then next you have the line spacing, and this basically controls the spacing or the distance between multiple lines in your text. Right now we have only one line, but to add a new line, I will enter the edit mode by pressing the tab key, and to move to the next line, press enter, and now if I type anything, then it will be seen in the next line of the text. And if you want to bring this subscribe text to the center, then take the cursor here and press the spacebar like this. This looks perfect, so I'll come out of the edit mode, and now if I go to the line spacing and try to increase it, then the distance or the spacing between the line 1, that is JB3D Studio, and the line 2, which is subscribe, will increase. But for now I will keep it to the default value of 1 so that the spacing and the distance between them is decreased. And there's one more way by which you can reduce the spacing between JB3D Studio and this subscribe, which is to actually subscribe to this channel. And now moving ahead, you can even create a simple animation of this text, and this is because here in the object data properties, again some of the options, you have these small dots which indicate that you can insert keyframes and animate these values. For example, if I go to the extrude option here and change the extrusion to 0 and insert a keyframe by clicking on this dot, then here in the timeline editor, a keyframe is added at the frame number 1. Now if I take the pointer to the frame number 50, and here I'll change the extrusion to a higher value like 0.15 and insert a keyframe at the frame number 50 as well. So now if I go to the frame number 1 and play the animation, you will notice that our text in the scene is getting extruded and getting a 3D look. So you can try to animate different properties here and observe the changes in your scene. Also, if you want to give it some material, then first I'll go to the material preview mode, then we'll go to the material properties editor, click on the new button, and we'll change the base color from here. Let's change it to yellow color, and now it looks like this. But now suppose you want that the upper text should be yellow, but this subscribe text should be red colored. And for this, we'll be using a very useful tool, which is the convert to mesh tool. As I told you earlier, the text that we added here is a separate object type and not a mesh. A mesh can be a cube, a cylinder, or a UV sphere, and other similar objects. And to convert this into mesh, go to the object option here, then go to convert and select mesh. Now this text object is converted to mesh, and now there are some slight changes that we can see in our file. The first change is that the keyframes that we added here are now removed, and even the animation is gone. And this is because we converted this text object to mesh. In fact, if I go to the edit mode now, I can no longer type anything which would be displayed as the text in our scene. Since it is converted to mesh, so now it has these vertices, edges and faces which you can select and try to edit them. But we won't be doing that right now because it already looks perfect. And to change the color of some specific word of the text, we'll first go to the front view by pressing 1 on the numpad, and now we have to select all the vertices of this subscribed text. So I left click and drag my cursor like this, and if I release it, then all these vertices are selected, but if I change the view, then you will notice that the vertices at the back face are not selected. And to fix this, we have to use the X-ray mode. Press Alt plus Z to turn on the X-ray mode, and now if I go to the front view again, deselect all the vertices, left click and drag like this, then in this case, all the vertices of this text will be selected. To change the color, I will go to the material properties, click on this plus icon, and to give it a new material, click on the new button. Let's change the base color from here, and I will change it to red color. To apply this material to the selected text, click on this assign button, and now if I go to the object mode, then you can see here that this upper text is yellow colored and the subscribed text is red colored, and this is how the text works in Blender. Also, this brings us to the end of this chapter, and from our next chapter we'll begin with the understanding of geometry nodes in Blender. And this amazing topic of geometry nodes will be completed in 20 plus chapters, because we'll be discovering about almost all the geometry nodes that are present in Blender, and we'll also be making a new scene in every chapter with the help of the particular geometry nodes that will be covered in that specific chapter. So far in this course, we learnt about the modeling tools in Blender, then we covered all the modifiers in Blender. After that, we understood about the materials, textures and nodes, created lots of basic shaders and procedural shaders. Then we covered the basics and even understood the advanced level of animation. And from this chapter, we'll be starting our journey of understanding the geometry nodes in Blender. Understanding this amazing concept will require us a total of 20 plus chapters, because we'll be covering all the geometry nodes that are present in Blender, and in each chapter we'll be creating different scenes with the help of the geometry nodes that we would have covered in that specific chapter. And in this chapter, we'll first understand about how the geometry nodes work, and then we'll cover all these nodes in complete detail, and we'll be using these nodes to make this snowman in Blender. Now, to start with the geometry nodes, we first have to switch to the geometry nodes workspace. So click on this workspace, which is named as geometry nodes, and this layout appears. Here, this is called the spreadsheet. This is the geometry nodes editor, and this is the 3D viewport. Now, to get a geometry node, we have to click on this new button, and this is the basic geometry node applied. In the modify properties here, you can see a modifier named geometry nodes added automatically. So basically, geometry nodes is a modifier, and that is why it is appearing here. And now moving ahead, here in the spreadsheet, we have information about the object that we have selected, which is the cube in this case. The first option here is the vertex, and it basically tells about the number of vertices and their positions in the 3D viewport. Then here you have the option of edges, then the faces and the face corners, and a lot of other things. And we'll be discovering all these options later on when we dive deeper in the concept of geometry nodes. But for now, we'll be understanding about the mesh options in the spreadsheet. The first one is the vertex. Here you can see the number 8, which represents the number of vertices. And here you can see that you have the position of the specific vertices in the X, Y and Z axis. Here one thing to notice is that the indexing of the vertices is not starting from 1. Like usually when we are counting things, we count it like 1, 2, 3, 4. But in this case, the counting or the indexing is started from 0 and then 1, 2 and then it ends on 7. Similarly, here you can see that we have 12 edges or 6 faces and 24 face corners. But for now we'll move to the geometry nodes, and here you can see in the geometry nodes editor that we have this group input and this group output. The group input basically represents this cube that we are having right now. Whatever changes that we'll make in between these two will get applied to our cube object, which was the input, and the output that will be generated will get connected to this group output and will also be seen on this cube. But since we are not having anything in between the geometry input and the geometry output, as a result we are not able to see any changes here. But if I go to the geometry nodes editor and break this connection by holding the control button and right clicking and dragging like this, then a cube will disappear, and that is because the connection between the input and the output no longer exists. As a result, whatever information this group input was carrying about the cube is not able to reach the group output, which has to generate the output in a 3D viewport, and therefore we can't see anything. And if I take the geometry socket and connect it to the geometry socket of the output, then a cube will reappear. And if you want to add any specific geometry node, then you simply have to press Shift plus A, and here you will find a list of all the categories of geometry nodes that are present in Blender. Also, you will find this category of texture nodes about which we learned in the previous chapters of this course, but we'll be learning about them again while understanding the geometry nodes. Now, suppose I ask you to change this cube into a UV sphere, and that too with the help of geometry nodes. Usually you would have gone to the 3D viewport and deleted this cube and then would have added a UV sphere. But with geometry nodes, you simply need to press Shift plus A, and here you have an option of mesh. And if I go to the primitives, you will find a list of the mesh primitives that we used to add in our scene by pressing Shift plus A. So if I select the UV sphere, then this node will appear, and if I left click to place it here, now to convert this cube into a UV sphere, I have to take this mesh socket and connect it to the geometry socket of the group output. And here we have the cube converted into the UV sphere. Basically what we did here is that we broke the connection between the group input, which was carrying the information of the cube, and the group output, and we made a new connection with this node carrying the information about a UV sphere and connected it to the group output. And now if I go to the spreadsheet and select this vertex, we now observe that we have different values about the vertex in the mesh as compared to the ones that we had when this object was a cube. And this is how the mesh primitive works in the geometry nodes. So whenever you have to change the structure of your object to any other mesh, simply press Shift plus A, go to mesh, and in the primitives, you can select that particular mesh type. For example, if I select the cylinder and place it here, and to change the structure of this UV sphere into a cylinder, I'll take this mesh socket and connect it to the geometry. And here we have a cylinder in our scene. And there's one more thing that you can do, which is to select a particular node and hold down Ctrl plus Shift and left click, and then this viewer node will appear, which basically allows you to preview things quickly. For example, if I go to the cylinder and press Ctrl plus Shift and left click, then we'll be able to view the cylinder. So you can easily switch between different mesh primitive nodes with the use of this viewer node. And also, one more thing to notice here is that here in the UV sphere and the cylinder node, you have these options of changing the settings of that particular mesh. For example, the vertices, the radius, the depth of the cylinder. So you can use these settings to change the way how your mesh would look like in the 3D view editor. And yes, this shortcut of holding Ctrl Shift and left clicking will work only if you have the Node Wrangler add-on turned on. We learnt about this add-on in this chapter of the course, and for now I will delete this cylinder node by selecting it and pressing X, and will connect this UV sphere to the group output. Let's also select this viewer and press X to delete it, and now we simply have this UV sphere node connected to the group output. And now we are moving to the next topic of this chapter, which is the transform node. And this transform node is basically used to change the position, rotation and scale of your object directly from the geometry node editor. To add it, press Shift plus A, go to geometry, and in the operations you will find this transform geometry. We'll place it in between the UV sphere and the output, and it will get directly connected to both. And you can simply change these values to change the position, rotation and the scale of your object. For example, the translation here basically means the position of this object in the 3D view editor. For example, if I change the translation in the x-axis, then it will move like this in the x-axis. Similarly in the y-axis and also in the z-axis. And if I go to the rotation and change the rotation in x-axis, then it will begin to rotate in the x-axis. Similarly the y and the z-axis also. Then you have the scaling option, and if I change the scale value in the x-axis, then it will get scaled up like this in the x-axis. So you can try to change these values to easily transform the geometry of your object, and that too in the geometry node editor. To change these to the default values, one way is to left click and drag like this, and now if I press 0 and press enter, the position is now again set to the default value of 0. But another way to return back to the default value is to hover your cursor over some value and press backspace, and now the rotation in all the three axes is set to the default value of 0 degrees. Similarly, if I go to the scale and press backspace, it will turn the value to 0. However, we need the default values to be 1 in order to see the object. So I'll select all three of them and type 1, press enter, and here we have the UV sphere again. So till now we understood about adding some specific mesh with the help of the mesh primitive. Then we learnt about changing the position, rotation and the scaling of your object with the help of the transform geometry. Now suppose you want to make a snowman with the help of these geometry nodes. For this, we have one of the UV spheres added to our scene, but we'll need another one at the top of this UV sphere. For this, I will select this node, press Shift plus D to create a duplicate, and let's place it here. And right now we can see only one UV sphere in our scene. That is because the second node is not connected to this node system. We need to join both these UV spheres together in order to view both of them in the 3D view editor. For this, we'll be using a new node which is called the join geometry node. To add it, press Shift plus A, go to geometry, and here you will find the join geometry. Let's place it here, and you can notice here that the geometry socket here is not circular in shape. It is somewhat oval in shape. This indicates that it can accept more than one inputs at a time. For example, if I break the node connection in between the transform geometry and the group output by holding the control button and dragging the right mouse button like this, and take this geometry socket and connect it to the geometry socket of the join geometry. Similarly, if I go to the UV sphere and take this mesh socket and connect it to the geometry socket, then it will accept both the inputs in this socket. And to get a preview of the result here, simply hold down Ctrl plus Shift and left click on the join geometry. Here you might be thinking that only one of the UV spheres is present, but it is not true. Actually, the position of both the UV spheres is same, and that is why it appears like this. But if I go to the transform geometry, which is connected to the first UV sphere, and let's suppose I change the translation in the z-axis to something like 1.2 meters, then this UV sphere will move upwards, and now we can see both the UV spheres in our scene. And since we'll be making a snowman with the help of these two UV spheres, we have to reduce the size of the upper UV sphere. So I'll go to the transform geometry node, select the 3 scale values, and let's reduce it to a lower number like 0.7 or 0.8, and now it looks perfect. And so this is how the join geometry node works. In fact, it can even be used to join more than 2 nodes together. For example, if I select this UV sphere and the transform geometry, press Shift plus D to create a duplicate and place it here. Let's zoom out, and now if I take the geometry socket of this third UV sphere and connect it to the join geometry, then it will take it as an input and will add another UV sphere in our scene. To view that UV sphere, we have to change the translation in the z-axis. Right now it is set to 1.2, but let's increase it to a higher number like 2 meters or maybe 2.2 meters, and now it looks like this. This UV sphere will act as the head of our snowman, so let's reduce the scale value to something even lower like 0.6, and now it looks perfect. Now suppose you want these UV spheres to be smooth. Earlier you simply used to right click and select the shade smooth, but it does not work in this case, and that is because we have to use the geometry nodes only to apply the shade smooth to it. To do this, we'll be using the next node, which is the set shade smooth. So for this, press Shift plus A, go to mesh, and here in the right you will find this set shade smooth. So I'll select this and let's place it here. And to connect it to the rest of the node system, simply select it and move it in between the join geometry and the viewer node, and here the shade smooth is applied to all the 3 UV spheres. And now suppose you want that the shade smooth should be applied only to the middle UV sphere and not to the others. For this, we first have to remove this shade smooth from this connection between the join geometry and the viewer. To do this, simply hold down Alt and left click to drag it, and it will get disconnected. And since it is no more in the connection, all the 3 UV spheres are shaded flat again. And to apply shade smooth only to the second UV sphere, that is this one, we have to connect this set shade smooth node in between the transform geometry of the second UV sphere and the join geometry. So I left click on it and drag it, and let's bring it here, and if I release, then it will get connected to the second UV sphere and the join geometry. And as a result, we see here that only the second UV sphere is now shaded smooth and not the others. Previously, we connected the set shade smooth in such a way that it took input from the join geometry, which was carrying information about all the 3 UV spheres. As a result, all of them were shaded smooth. And since we are making a snowman, so we'll need the shade smooth applied to all the 3 UV spheres. As a result, I have to place this set shade smooth node in between the join geometry and the viewer node. For this, I will again hold down the Alt button and left click to remove it, and let's place it in between join geometry and the viewer node. And do ensure that you are not holding down the Alt button while dropping it in between the 2 nodes. And now this shade smooth is applied to all the 3 UV spheres. And now the last thing is to give some material to our snowman. For this, we'll be using another node, which is the set material node. So press Shift plus A, go to material and select set material, and we'll place it after the set shade smooth. This set material node will help us to give some material to this snowman. Previously, whenever we needed to give any material to any object, we either used to go to the material properties here and do the changes, or we used to open the shader editor. But since we are working on the geometry nodes, as a result, we'll be using the set material node to make the changes in the material. But yes, we'll still be working on the material properties here, and we'll drop down that particular material that we create in this material option of the set material. For example, if I change the name of this material to snow and go to the base color, and let's change it to blue color, let's also turn on the render view, and to see the material on our object, we'll go to the set material, and here in the material option, we'll select snow, and here the snow material is applied to our object. And since it is placed after the join geometry node, so the material will be applied to all the 3 UV spheres. Now to make it look like a real snow texture, we'll be doing some changes in the material in shader editor. To open the shader editor here, I will change this spreadsheet into the shader editor. So click on this icon and select the shader editor. Let's close this toolbar by pressing N, and to increase the size of this window, simply take your cursor over here, left click and drag like this. Let's zoom in, and now to create the snow material, we'll be using the noise texture. So press Shift plus A, go to texture and add the noise texture. Let's place it here, and to get the input node and the mapping node connected to it, I will use the shortcut Ctrl plus T, but this shortcut will only work if you have the node wrangler rectangular turned on. Now here in the texture coordinate, we'll change the input to the object socket and connect it to the vector. And to connect the noise texture to the output, hold on Ctrl plus Shift and left click on the noise texture. The basic noise texture is now visible on our object. And now we'll be using two noise textures and we'll mix them together to create the snow material. For this, with this noise texture selected, press Shift plus D. Let's place the duplicate over here, and to combine both of them, press Shift plus A, go to color and select the mix color. Let's place it here. To mix both of them, I'll take this color socket of the noise texture and connect it to the color A. Similarly, I'll take the color socket of the noise texture number 2 and connect it to the color B. And to connect this mix socket to the output, hold down Ctrl and Shift and left click on it. And here we see that both the noise textures are applied to our object. Let's do some changes in the noise textures. For example, in the second one, we'll keep the roughness to a very high value like 500 or 600. Let's also reduce the detailing to a very low value like 0.1 and also the roughness to a very low value like 0.1 again. The reason for doing this is that we'll be using a combination of both the noise textures to create a realistic looking snow material. So one of them has a low scale value with high detailing and roughness, and the other one has a high scale value with low detailing and low roughness. But we'll be needing more effect of the noise texture number 1 because it is having low scale but high detailing and roughness. And to do this, we simply have to reduce the factor to a lower value like 0.1, and now it will have influence of the first noise texture much more than the second. And to give it some color, we'll be adding a color ramp. First, let's take the material output and let's place it here. Right now this principal BSDF is disconnected, but we'll place it in between the mix node and the output. And to give it some color, press Shift plus A, go to converter and select the color ramp. Let's place it here. Now with the pointer number 1 selected, I'll click here to change the color. Let's increase the brightness with the help of this brightness slider, and let's change the color number 1 to light blue color. And for the color at the pointer number 2, let's keep it to white color only, and now it looks like this. But to make it look realistic and to give it a 3D bump effect, let's add a bump node in the shader editor. So press Shift plus A, go to vector and select the bump. Let's place it here. Take this normal socket and connect it to the normal of the principal BSDF. Then take this result socket and connect it to the height socket of the bump node. And here we see the bump effect added to the material of our object. One more thing to notice here is that the result socket of this mix node is connected to the height socket of the bump node, which means that this yellow colored socket is connected to this gray colored socket of the bump node. In one of my previous chapters, I told you that usually we connect the sockets of same color together, but there is no hard and fast rule for this. You can even connect sockets of different colors together and you will end up getting some different results. In this case, this mix node was carrying information about these two noise textures and was having only one option, which is the result socket as the output, and we needed to apply the bump node to the combination of these two noise textures. As a result, we had to use the result socket of the mix node and connected it to the height socket of the bump node. And now moving ahead, you can even try to change the strength of this bump effect from the strength option here. Right now it is set to its maximum value of 1, but I think that we should reduce it to something like 0.5 or 0.4, and now it looks better. Similarly, you can also control the roughness from here in the principal BSDF. And in this way, we created this simple looking snowman in our scene with all these geometry nodes and this snow material. And suppose you want to add a plane below this model, and that too by using the geometry nodes. But if I press Shift plus A and go to mesh, then in the primitives there is no option of plane. But to add the plane, we have to select this grid option. And if I place it here, and if I connect it to the join geometry by taking this mesh socket and connecting it to the geometry here, the plane will get added in our scene. But we have to increase its size from here. So I'll change the size value in the X direction to a higher value like 8, and also in the Y axis, let's keep it to 8 meters. And to move it downwards, we have to add the transform geometry node. So for this, press Shift plus A, go to geometry, and in the operations, you will find the transform geometry. Let's place it here. Take this mesh socket and connect it to geometry. Then we'll break the node connection in between the grid and the join geometry by holding the control button, right clicking and dragging like this. And then I'll take this geometry socket and connect it to the geometry socket of this join geometry. And now I can use the translation in the Z axis to move this plane downwards. Let's keep it to a value of somewhere around minus 0.3 or maybe minus 0.6, and now it looks perfect. And there's one more important thing to note here. If I go to the layout workspace again, you will notice that our object is not visible here. To fix this, go to the geometry nodes workspace again, and here in the geometry nodes editor, we have not connected the entire node system to the group output. For this, I'll take this geometry socket and connect it to the geometry socket of the group output. And now if I go to the layout workspace again, here we have our snowman added. Let's turn on the render view from here, and this is how it looks. So we created this simple scene in this chapter with the help of all the geometry nodes, and we even understood about each one in complete detail. And this also brings us to the end of this chapter. In this chapter, we'll be exploring all these topics in complete detail, and we'll also be creating this simple scene of these buildings with the help of all these topics. So to begin with, the first topic for today's chapter is Extrude Mesh Node. And to understand it, we first have to open the Geometry Nodes workspace. So click here to open the workspace and click on the new button. Now to add the extrude mesh node, press Shift plus A, go to mesh, and in the operations you will find the extrude mesh. So I'll select this and let's place it here. And to connect it to the rest of the node system, if I left click and drop it here, then it will get connected, and we notice some changes here. As the name suggests, the extrude mesh node basically extrudes up the faces of our cube object. Now here in the extrude mesh, you have some options. The first one is the mode of extrusion. By default it is set to faces, and as a result the faces of this cube are being extruded individually. But here we have some other options as well. So if I select the vertices, it will basically extrude the vertices of this cube object. The next option available is the edges, and just like the other two, this one will extrude the edges of the cube. But right now I will change the mode back to faces, and here you have the offset value, which basically defines the offset or the amount of extrusion that is applied to your cube. For example, if I increase it, then the extrusion will increase, and if I reduce it to somewhere near -0.2 or -0.3, then the faces will get extruded inwards. And here in the extrude mesh node, you can also see that you have these two options of selection and offset, but we'll study about them later on because it will require the use of some other nodes that we have not yet covered in this course. So for now, you need to focus on the mode of extrusion and the offset value here. Now there's also one more option available here, which is the individual, and it is turned on by default. It basically means that the extrusion will be applied to the individual faces. To understand it better, if I turn it off, then it would mean that the extrusion is not applied to individual faces but to the object as a whole. So if I increase the offset from here, you will notice that the object is getting extruded as a whole and not its individual faces. So this individual option is basically used to set whether you want the extrusion to be applied individually or as a whole on the object. And you can even apply this extrude mesh to any other type of mesh, such as a UV sphere. So suppose you want to apply this extrude mesh to a UV sphere and add it in our scene. For this, in the geometry nodes editor, we'll first add the UV sphere node. So press Shift plus A, and since the UV sphere is a type of mesh primitive, so I'll go to mesh, and here in the primitives we have the option of UV sphere. So I'll select this and let's place it here. Now to apply the extrusion to it, I'll take this extrude mesh, which is right now applied to the cube, and to create a duplicate of it, press Shift plus D and let's place it here. Now I'll take this mesh socket of the UV sphere and connect it to the mesh of the extrude mesh. And now if I take this output socket of the extrude mesh and connect it to the group output, here we have the UV sphere with the extrusion effect applied to it. And suppose you want to see both the cube and the UV sphere in the same scene. And to do this, we'll be using a node which we explored in the previous chapter, and this is the join geometry node. To add it, press Shift plus A, go to geometry, and here you have the option of join geometry. So I'll select this and let's place it here. Now I'll take this mesh socket which is carrying the information about the extruded cube and connect it to join geometry, and also I'll take the mesh socket of the extruded mesh which is carrying information about this extruded UV sphere. So I'll select this and connect it to the join geometry. We'll break the node connection in between the mesh socket here and the group output. So hold down the control button, right click and drag like this. Now I'll take this geometry socket and connect it to the output. It appears like this because both the cube and the UV sphere are placed at the same position, which is the origin of the 3D world. And suppose I want to shift this UV sphere in the x-axis, and for this we'll be using another node from the last chapter, which is the transform node. To add it, press Shift plus A, go to geometry, and in the operations you will find the transform geometry. So I'll select this and let's place it here in between the extrude mesh of the UV sphere and the join geometry. And to move the UV sphere in the x-axis, I will go to the translation and let's change the position in the x-axis. And now here we have the cube and the UV sphere properly placed in the scene, and both of them are showing this extrusion effect applied to them. And now let's revise whatever we did in this geometry node editor. First we have this group input which is carrying the information about this cube in the scene. Then we use this extrude mesh to apply extrusion to all the faces of this cube individually. Then to add the UV sphere, we added this UV sphere node and connected it to the extrude mesh because we wanted to apply the extrusion effect on its faces individually. Then we had to add this transform geometry because we needed to move this UV sphere in the x-axis. And in the end we connected both of them to join geometry in order to see both the cube and the UV sphere in our 3D viewport. And at last we connected it to the output to see the final output here. Now moving ahead, the next thing that we are going to discover, instance on points node. To see how it works, I will add a plane without deleting all these. To do this, press Shift plus A, go to mesh, then in the primitives we have this option of grid. So I'll select this and place it here. We studied in the last chapter that we have to use this grid node to add a plane plane in our scene. To see the output here, I will break the connection between the join geometry and the output. So hold down the control button, right click and drag like this. Let's take this group output and place it here. Now to connect them together, take this mesh socket and connect it here, and here we have the plane in our scene. Here you can see that in the grid we have some settings like the size and the vertices. So if I increase the size in the x-axis, then it will get scaled up like this. Similarly in the y-axis, and here you have two more options, which are the vertices in the x and y axis. And to understand about them, we first need to go to the wireframe mode. For this you can click on this icon, or else there's a shortcut which is to hold down Z and take your cursor to the wireframe. And this is the wireframe display of the plane object. If I move it slightly in the y-axis by pressing G and Y and placing it here, and also in the x-axis by pressing G and X and placing it here, then now you can see here that in the x-axis it is having 3 points. One of them is here where it touches the edge, the second one is at the middle, and the third one is again here where it touches the other edge. And the number of vertices in the x-axis is controlled from this option in the grid. Here it is set to 3, but suppose if I increase it to a number like 5, then now we are having 5 points in the x-axis. One is here touching the edge, the second one is this, the third one is in the middle, the fourth one is this one, and the fifth is this last one, which is again touching this edge. Similarly, in the y-axis, the number of vertices is set to 3, and as a result, as we move along the y-axis, we have 3 points. First one is this, which is touching the edge, the second one is in the middle, and the third one is here at the end. You can change the value of vertices in the y-axis from here. So if I change this one also to 5, then now it looks like this. In simple words, you can understand it in this way, that this vertices option in the x and y axis is basically similar to the subdivision that we used to apply to our object. It helps to increase the number of vertices of our plane. And now coming back to our topic of understanding the instance on point node, we'll first add it here. So press Shift plus A, go to instances, and here you have the option of instance on points. So I'll select this and place it here in between the grid and the output, and suddenly our plane object disappears. And that's because we have to add some instance here, which in simple words means any object. For example, if I add a cube by pressing Shift plus A, going to mesh, and in the primitives, here I have the option of cube. So I'll select this and place it here. Now I need to connect this cube to the instance. So I'll take this mesh socket and connect it to instance, and we see some changes here. To view it properly, we'll go to the solid mode again, and here we first need to reduce the size of these cubes. So I'll select the sizes in all the 3 axes by left clicking and dragging like this, and I'll type 0.1 meters and press enter to confirm. And let's try to understand what happened here. Basically what this instance on points does is that it places the instances, meaning the cubes in this case, on the points or the vertices of our plane object. If you remember, we changed the number of vertices in the x and the y axis to 5 here, and as a result we are having 5 cubes placed in the x axis and also in the y axis. In simple words, as its name suggests, it places the instance or the mesh which is connected to the instance here on the points of a particular object which is connected to the points here. You can even control the number of these cubes from the vertices option in the grid node. For example, if in the x axis I reduce the number to 3, then here we have 3 in the x axis and 5 in the y-axis. Now you can also try to do some changes here. For example, you can apply the extrusion to all these cubes by going to the geometry nodes editor, and to add the extrusion, press Shift plus A, go to mesh, and here in the operations we have the extrude mesh. Let's place it in between the cube and the instance on points, and it appears like this because the offset value is too high. So let's reduce it to a lower number like 0.1 or maybe 0.01, and now it looks perfect. Also, I think that we should change the number of these cubes to 4 in both the x and y axis. So go to the grid node, select the vertices in the x and y axis, type 4 and press enter. Now we have 4 cubes in the x axis as well as in the y axis, and you can even try to scale them up from the size option here or from the scale option in the instance on points. So you can choose any of the two, both will work in the same way, and I think that we should scale them up to a slightly higher value in all the 3 axes. So let's change the scaling to 0.2 meters, or maybe let's reduce them down to a slightly lower number like 0.16 meters, and now it looks perfect. And yes, we'll be using these cubes to make the scene of the buildings. Now to convert these cubes into building, we have to make them taller, and for this we'll be using another node, which is the combine XYZ node. But before adding it, let's first zoom out, and we'll be deleting this entire node system because it is not required anymore. So I'll select all of this except this group input because it will be required for making these buildings. So to deselect it, simply hold down the control button, left click and drag your cursor over the group input like this. Now it is deselected, and to delete press X, and now they are deleted. Now we'll take this group input and place it here, and now moving back to changing the height of these buildings, we'll be adding the combine XYZ node. So press Shift plus A, go to utilities, and here in the vector you will find the combine XYZ. So I'll select this and place it over here. Since we need to manipulate the size of these cubes, so I'll take this vector socket and connect it to the size, and we can't see anything here because the size of these cubes is now being controlled by these values in the combine XYZ, and because they're set to 0. As a result, we can't see anything here. To scale them up, I will select all the 3 axes and type 0.16 because that was the size that we previously entered as the size of these cubes. Now you might be thinking that what exactly is the use of adding this combine XYZ when you could have simply used the options in the size here to change the height of your building, and you will get to know this answer in a little while. But before that, we need to first understand about this group input node. You must have noticed here that in the group input node you have this empty socket here, and suppose I take the socket of the Z axis and connect it to this empty socket, then it basically creates a new socket with the name Z. And also if you go to the modify properties in this geometry node modifier, you can directly control the scaling in the Z axis from here. So basically whatever you connect to an empty socket will be created as a new socket in the group input node, and then you can control that specific value from the modify properties here. And this was the reason why we added this combine XYZ instead of using the size option in the cube. By doing this, we can now simply change the height of these buildings just by going to the modify properties and changing the Z axis. And now moving ahead, there are some more settings that you can do with this newly created socket in the group input node. For this, we first have to open the toolbar here by pressing the N key, and here you can see that we have a list of 3 items here that are present in group input and the group output. The first one is the geometry node, the second geometry node, and here on the third number we have this Z socket that we ourselves created. You can even change the name of this socket by double clicking here, and suppose I change the name to height and press enter to confirm, and here in the geometry node editor the name of this socket is changed. You can even control the type of value that can be added as an input in the height value here. By default it is set to float, meaning that you can add decimal values to the height here. But suppose I change it to integer, then in this case I can only add the integer values like -1, 0, +1, +2, and not the decimal values to it. But in this case I'll be changing the type back to float. Let's go to the height again and let's increase it to 0.16 meters for now. So this is how the group input node and the combine XYZ node works. Now moving ahead, in order to change the height of these buildings, we have to change the height value from here. But if I increase it, you will notice that the height changes both in the upward and the downward direction. But if you want to increase the height only in the upward direction and not in the downward, then for this we have to use another node, which is the math node. And the math node is probably that one node which has the maximum number of options in it. To add it here, press Shift plus A, go to utilities, and here in the math we'll select this math node. Let's place it here, and now if I click on this drop down, you can see here that we have a lot of options in the math node. By default the add function is selected here, but we'll be learning all these options as we move further in this course while learning the geometry nodes. Now as the name suggests, this add option in the math node basically adds 2 values together. Here we have the option to add 2 values, and by default both of them are set to 0.5. As a result, it would add these values and return the output, which is 1, from this value socket. In fact, you can even connect these sockets against these values if you want to influence or change these values. And now to get a better view of the buildings, we'll go to the front or the side view by pressing 1 or 3 on the numpad. And now to increase the height of the buildings, if I go to the geometry node modifier and increase the height from here, we see that the height increases in upward as well as downward direction. Basically, in other words, we want that as we increase the height, all these cubes should move upwards in the Z axis so that they start from their origin point here. And whenever we have to change the position of our cubes in any direction, then we have to use the transform node. So we'll add it here by pressing Shift plus A. Let's go to geometry, and in the operations, here we have the transform geometry. So I'll select this and let's place it after the cube node. And now if I go to the geometry nodes modifier and increase the height, then now I can move them upwards to their origin point with the help of translation in the Z axis. So if I slightly increase it by holding the Shift button and increasing it by dragging like this, then they will move upwards and will begin up to their origin points perfectly. But whenever I will change the height from here, they will again get scaled up in the downward direction, and again I have to go to the Z translation and change the value from here. And to solve this problem, we'll be using this math node. So let's first undo everything by pressing Ctrl plus Z 3 to 4 times. Now I'll take this math node and place it over here, and since I need to make the changes only in the Z axis, so I'll be using the combine XYZ node. Here we have already added it, so I'll select this, press Shift plus D to create a duplicate and place it here. Now take this value socket of the math node and connect it to the Z axis, then take this vector socket and connect it to the translation. Now to see the cubes here, we have to zoom out, and to bring them down, we'll be using this math node. Here this math node is controlling the translation in the Z axis with the help of these values. Right now these values are set to 0.5 each, and as a result, when they will get added, height, the output will be 1. Therefore, the position of these cubes will be 1 meters upwards in the z-axis. Also, you can control the position in the x and y axis from here, which is set to 0.16 because we created a duplicate from here which was controlling the size, and therefore we are having these values here. So I'll select both of them and reduce it to 0. But even after doing all this, our problem is still not solved, because if I go to the height option here and increase it, we again have the same issue of the cube scaling up in both upwards and downwards direction. And this is because in the math node here, the two of these values are controlling the position of these cubes. But instead of these values, it should actually be the height which would control their position in the z-axis. To understand this properly, I will take this height socket of the group input and connect it to one of this value socket. And now what it does is that it will add the value of height, which is 0.6 right now, to the second value, which is 0.5, and assign that particular value to the translation in the z-axis. So if I go to the height option and increase it, then now we notice that this height option is controlling two things here. One is the scaling of these cubes, and the second thing is the movement in the z-axis. For example, if I increase the height to a very high value, then the cubes will move up in the z-axis, and if I reduce it, then their position in the z-axis will also reduce. Even though the movement in the downward direction is now reduced to some extent, but still it's not completely fixed, and that is because we are using the add option in the math node. Because whatever value I will assign to the height, this add option will increase it by 0.5 meters, and as a result, these cubes will go upwards in the z-axis. To fix this, we have to change the option from add to divide. And now if I increase the height from here and try to adjust the second value here to that particular point where it touches the x-axis, then our problem will be fixed. And here at a value of somewhere around 1.8 and 1.9 with the height set to 0.82, it appears to be perfect. And now if I increase the height from here, we see that the buildings are only getting scaled up and down, and their position is not getting affected. And let's also understand how this divide option in the math node is working. Basically, the first value is set to the value of height here, which is 0.82, and the second value is 1.89. As a result, it will generate the output, which is 0.82 divided by 1.89, which is equal to 0.433 meters to the translation or the position in the z-axis. And as a result, the cubes appear like this. So you can basically use this math node with the divide option and connect it to the translation in the z-axis, and in this way you can change the height from here without facing the problem of these buildings or the cubes moving downwards in the z-axis. Now one thing to notice here is that the height of all these buildings is exactly the same, but to give it a realistic look and to have random heights for each of the buildings, we'll be using another node, which is the random value node. To add it here, press Shift plus A, go to utilities, and here you have the random value. So I'll select this and place it here. And now since we need to change the height or basically the size of these buildings, we have to connect this random value to the scaling here with the help of a combine XYZ node. So for this, I will press Shift plus A, go to utilities, and in the vector you will find the combine XYZ node. So I'll select this and place it here. Now the height of the buildings is controlled from the scaling in the z-axis. As a result, I'll take the value socket of the random value and connect it to the z-axis, then take this vector, and to connect this vector we have two options here. One of them is the scale of this transform geometry node, which is connected to this cube, and the other one is the scale option in the instance on points. And if I take the vector socket and connect it to the first scaling option, then we see that everything disappears and this connection line is turned to red color, which indicates some error. So I will press Ctrl plus Z, and let's try the same with the scaling in the instance on points, and this time also we see no output here, everything is disappeared, but this time this node connection is not red colored, which means that at least there is no error in this case. And in fact, connecting this vector socket to the scale option of the instance on points was the correct choice, because if I go to the combine XYZ and change these values in the x and y to 1, then these buildings will reappear, and this time we are having some random heights applied to each of these buildings. Now let's also understand how this random value basically worked. We connected the random value node to the z-axis of the scaling through this combine XYZ node, and here you can see that it has two values. One is the minimum and the other one is the maximum. The minimum value is set to 0 and the maximum is set to 1, meaning that it will generate an output between 0 and 1 and assign it to the z-axis, and that particular value will be a decimal or float value, because here in the type of data we have the float selected. You also have other options like integer, vector, boolean, but in this case we required only the float, and so it assigned random heights between 0 and 1 to all these cubes. Now you might be having one more doubt in your mind, which is that why did we receive error when we connected the vector to the transform geometry but not in case of instance on points? And the reason is very simple. See, the transform geometry was carrying the information about this cube as a whole, whereas the instance on points was carrying information about all these instances which are the cubes. And since we needed a random height for each of the cube or the instance, we had to connect the vector to the scaling to the instance on points. Now here in the random value, you have another option which is seed, and by changing this, you will basically generate another output with different random values assigned to the height of each of these buildings. So basically you can generate different outputs with the help of this seed value. Right now, I will change it back to 0, and now let's move to the next topic, which is understanding the index node. And we'll be understanding this index node by first creating a simple cube here. So for this, let's move upwards in this geometry nodes editor, and for those of you who don't know, you can move around the nodes editor simply by holding the middle mouse button and dragging your mouse like this. So let's go over here, and to add a cube, press Shift plus A, go to mesh, and in the primitives, here we have the cube. So I'll select this and place it here. Let's also add the index node. So press Shift plus A, go to geometry, and in the read, you will find the index node. Let's place it here. Now to view the cube object here, simply hold down the Control plus Shift and left click on the cube, and here we see our object. And also, this shortcut will work only if the node wrangler add-on is turned on. Now, to understand the working of this index node, we should first extrude the faces of this cube, and for this I will add the extrude mesh node. So press Shift plus A, go to mesh, and in the operations we have the extrude mesh. So I'll select this and place it in between the cube and the viewer node. Now here you can see that all the faces of our cube are now extruded, but suppose you want that only a specific face or some particular edge or vertex should have been extruded instead of all of these, and for this we use the index node. Now if I remove the extrude mesh from the connection in between the cube and the viewer by holding the Alt button and left clicking to remove it, and if I select the cube, then here in the spreadsheet you can see that with the vertex option selected, you have some numbers written over here. These numbers start from 0 and go on till 7. We learned in the previous chapter that these numbers are the index values of each of the vertices of this cube. See, every vertex, edge and face has a particular index value which you can use to manipulate the way it looks. Similarly, if I go to the face option here, then you can see that the index value of face is also starting from 0 and goes on till 5, meaning that there are 6 faces in this cube. Now suppose you want that this extrude mesh should be applied to only one of the faces and not all of them. To do this, I will first select this extrude mesh and place it here, and now we have to connect this index socket to the selection socket of the extrude mesh. This selection socket allows you to select which particular vertex or face or edge you want to be extruded. But to tell this selection socket that exactly which face at what index number should be extruded, we have to use another node which is compare node. So press Shift plus A, go to utilities, then in the math section you will find the compare node. So I'll select this and place it here. Now click here and change the operation to equal. We'll understand about this in a couple of minutes. I'll take this index socket and connect it to the socket A, then take this result socket and connect it to the selection. And now let's understand what exactly happened here. Previously, the extrude mesh was working on all the faces of the cube, but now with the help of this selection socket, we gave input to this extrude mesh that we want a particular face of some specific index value to be extruded, and to calculate that index value, we use this compare or the equal node. And here we have two options. One of them is A and the other one is B. And as the name suggests, it basically makes the value of A equal to B, meaning that since A is connected to index, therefore the index value will be equal to the value of B, which is 0. So it will give the output or the result to this selection socket that this extrude mesh has to work on that face whose index value is 0. And suppose I change the value of B to some other number like 1, then here you can see that another face is extruded now. Previously the extrusion was working on the bottom face, and as a result it looked like this, and when I changed the index value to 1, the extrusion took place on the front face. Similarly, you can even try other values like 2, 3, 4, 5, and it will create an extrusion effect on that particular face. And this is how the index and the compare node works. And now returning back to the buildings that we were creating, let's select all of this and press X to delete. And now let's give some material or some colors to our buildings. For this, first let's go to the render view by clicking on this icon. Let's also change the render engine by going to the render properties and changing it from EV to cycles. To get a proper lighting, click on this drop down arrow and turn off the scene world, and here we go. Now before creating the material, let's first add the set material node. So press Shift plus A, go to material and select the set material. Let's place it here. Now to create a material, let's change the spreadsheet window to the shader editor. So click on this icon and select the shader editor. Now we basically need to create a texture which will make it look like there are actually some windows on these buildings. To do this, we'll be using the Voronoi texture texture. So press Shift plus A in the shader editor, go to texture and select the Warner texture. Let's place it here, and to get the input and the mapping nodes, simply press Ctrl plus T, and here we have the input texture coordinate and the mapping node added. Here take this object socket and connect it to the vector, and to view the texture, simply hold down Ctrl plus Shift and left click on it. And we are not able to see the texture here because we have not assigned this material in the set material node. So I'll click here and choose this material, and this is how the texture looks like right now. Now here we are having some random spot-like texture on our buildings, but we really don't want that. To change the way it looks, click on this option where Euclidean is selected and change it to the other types. With the second option selected, which is the Manhattan, the texture looks like this, and this is also not perfect, so we'll go for the third option. And let's also try to change some settings here, for example the randomness, and if I reduce the randomness, it's giving a slight texture which somewhat looks like the windows of a building. And to make it look perfect, let's reduce the randomness even more, so I'll change it to 0. Let's change the scale value, so if I increase it, we see some slight texture which resembles the structure of windows on buildings. To make it look even more better, let's further scale up the value to something like 10, and now it looks like this. Now you might be thinking that exactly how do you know that you have to use the Warner texture and try to change these settings in it to achieve a specific result? And the answer to this is that it basically comes with practice. You have to keep in your mind how each texture would look like on your object's material. For example, the noise texture would add some noise to your material, the Warner texture would add some spots to your material and make it look like this. Similarly, the brick texture and all the other textures also work in some specific manner. So my suggestion to you would be that you should try to practice by adding different types of textures, changing the values here, trying different options, and try to do this with all the textures that we have studied in this course so far. And if you want to add some more windows here, then you can use the scale value. Right now it is set to 10, but if I increase it to something like 12, then it looks like this. You can even use the scale options here to change the size and the number of these windows in the texture. So suppose I go to the scaling in y-axis and let's increase it to something like 1.5, and now it looks like this. Now to give some color to these windows and the building, we'll be using the color ramp. So press Shift plus A, go to converter and select the color ramp. Place it in between the texture and the output, and to change the colors and the intensity, we have to move these pointers and change the colors from here. So first I'll take the second pointer and move it like this. Similarly the first pointer, and let's move it like this. Now here one thing to notice is that this principal BSTF is not connected anywhere in this node connection, and there is a reason for this. Basically we will need two different principal BSTF added here, and that's because one of them will be for the windows and the other one will be for the rest of the building. So to create a duplicate of this, press Shift plus D and place it here, and to connect both of them, we'll be using the mix shader. And to add it, press Shift plus A, go to shader and select the mix shader, place it here. Now let's take the output of one of the principal BSTF and connect it to the first shader. Similarly, let's take the other one and connect it to the second shader, and then take this color socket of the color ramp and connect it to the factor. And here we can no longer see the texture of the buildings in the 3D scene, and this is because previously the color was being controlled from this color ramp, but now since we have connected the shaders to this principal BSTF and both of them are having the white base color, as a result we can't see the texture here. To see the texture right here, I'll take the base color of one of the principal BSTF and let's change it to black color, and the texture is visible here. Now you can do one more change in order to make these buildings look very realistic, which is to go to the color ramp here and change the interpolation to constant, and now you can see that you have these windows on all the sides of the buildings and it looks way too much realistic than before. And it might be possible that some of you might be having some doubts here, so let's revise each and everything that we have done in the shader editor till now. See, to get these windows, we first added this Warner texture, made some changes here and ended up in getting some square spots which slightly look like windows. Then we added this color ramp and we used the pointers here to change the position, or basically the thickness of the borders of these windows. For example, if I increase the whiteness with the help of the second pointer, then the buildings would look like this. Similarly, if I increase the blackness, then the buildings would look like this. Then to have different materials like the color and the roughness for the windows and the rest of the building, we added two separate principal BSTF, and to join them, we used the mix shader and connected it to the material output. And now suppose you want to change the color of these buildings, so you can simply go to this base color option here and increase the brightness from here and change the color to anything like blue or green, and the color would change here. But suppose you want that these buildings should have some random colors, and for this we'll be using the Musgrave texture. And to add it, we first have to press Shift plus A, then go to texture, and you will observe that there's no such texture here. And I told you in the previous chapters that in the recent Blender 4.1 version, the Musgrave texture was removed and it was replaced by the noise texture. So we'll add the noise texture and place it over here. Now turn off this normalize, and now we can use this noise texture just like the Musgrave texture. Now since we'll be using this noise texture to give random colors to the windows of the building, I'll take this factor socket and connect it to the principal BSTF, which has the black base color, using the base color socket, and we see some Musgrave texture here. To give it some colors, let's add a color ramp here. So I'll select this color ramp and let's create its duplicate by pressing Shift plus D and place it here. To change the colors, let's select the first pointer and click here to change the color. Increase the brightness, and suppose I change it to red color, but now all the buildings are turned to red. To add some new colors, click on this plus icon icon and let's change this color to something like blue, but here you can see that it is not giving the desired result. It is basically applying all these colors to the textures and not to the different buildings. To fix this, we'll be using the object info node. So press Shift plus A, go to input and select the object info. Place it here. Now to tell this noise texture that we want the colors to be applied to different buildings, we have to use this location socket here. Let's connect it to the vector, and if I change the scaling from here, you will begin to notice that some random colors are being assigned to different buildings here. Let's even increase the number of colors from here by clicking on the plus icon, and let's change it to green color. Now this little building here is colored green, and let's also try to move these pointers to change the color of the buildings. Let's select this blue one and move it here. Similarly this green one and move it here. Let's also change the color of this white pointer by clicking on it and changing it from here. So let's change it to yellow color. To get the random colors properly, we have to play with the scale value and the position of these pointers here. So let's try to change the scale value and also these pointers in order to get some different results. And let's also try to change the scale value from here. Like if I reduce it, we'll get different results. So you should try to change the scale values and the position of these pointers. Try to add some more colors and you will get different results each time. But I think that right now this combination looks perfect. So let's finalize this. And suppose you want to change the color of the rest of the building. Right now it is set to white color, but suppose you want some other color. So let's go down, and here in the second principal BSDF we have the base color option. So if I change it to black color, you will observe that the borders of the windows, or basically all the part except the windows, is now colored black. And as I told you before, you can change the thickness of these borders or simply these lines with the help of this color ramp. So if I take the second pointer and move it like this, the thickness or the width will basically change. But I think that this much is fine, and you can even change other things, like to make them look metallic. You can increase the metallic nature from here or make them look rough from here. So you can try to change these different settings to change the material of the windows or the rest of the building. This principal BSDF will work for the windows, and the second principal BSDF will be used for the remaining building. And here I think that we should change the roughness of the windows to exact 0 in order to make them shiny and reflecting. And now our buildings are completely ready. But if you remember, we added this grid or the plane and used the instance on points to add these cubes at the position where the points or the vertices of this plane were located. As a result, whenever you want to increase the number of these buildings, you can simply go to the vertices option here, and right now their value is 4. But suppose you want to increase it to a higher number like 8 or 10, then the number of these buildings will increase, but you need to adjust their size from the size option here. So if I increase the size in the x-axis, then these buildings will move apart in the x-axis like this. Similarly, to move them apart in the y-axis, I'll take this size in the y-axis and increase it, and now it looks like this. So you can try to change these values to change the number of buildings in your scene and also the distance between them with the help of the size option in the x and the y-axis. And also if you want to change the random colors that are assigned to these buildings, you can again go to the noise texture and change the scale value from here, or you can also go to the color ramp and change the position of these pointers from here. But I think that we should finalize this one, and this is how the final output looks like. I added a simple plane below its surface, added some lighting, and this is the final rendered output. Also, this brings us to the end of this chapter. In this chapter, we'll be understanding all these topics in complete detail, and we'll be using these topics to create this fence. And our target for the upcoming videos will be to create a landscape with this fence, some grass and rocks. But for today's chapter, we'll focus only on creating this fence. Now, the first topic for today's chapter is understanding the resample curve node. But before that, let's first open the geometry nodes editor. And now instead of working on this cube, we'll be adding a Bezier curve. So press X to delete it, press Shift plus A, go to curve and add the Bezier curve. Now we'll be using this curve to make the fence. So first let's go to the top view by pressing 7 on the numpad. Let's zoom in, and if I enter the edit mode of this curve by pressing the tab key, then here you will notice that we have a tool called draw. And if I select this, then I can draw the curve just by left clicking and dragging like this. And this is going to be very useful while we are creating the fence. Right now let's undo. Now to start working on the geometry nodes, first let's enter the object mode by pressing the tab key and take on the new button. Now we'll be adding the resample curve by pressing Shift plus A. In the curve, we'll go to operations, and here we have the resample curve. Let's place it here. And yes, one more important thing is that you do not need to memorize the location of each and every node in this add menu. You can simply search for the specific node from the search bar here. For example, if I type object info, then you will get the object info node here. Similarly, you can search for any other node and easily add it in the geometry nodes editor. Now we'll understand this resample curve node in a little while, but before that, let's also add the instance on points. So press Shift plus A, go to instances and select the instance on points. Let's place it before the output, and we learnt about this node in the previous chapter of this course. Now we'll also need an instance object here, and for this we'll be using a simple cube. So press Shift plus A, go to mesh, and in the primitives select cube. Let's place it here and connect it to the instance, and we notice some changes here. But before understanding that, let's reduce the scale of these cubes from here. Suppose I change it to 0.2 or maybe 0.1, and now we can view them properly. Now let's come back to the resample curve node. If I tab into the edit mode, you will notice that our curve is still present here and it has 2 points. One is this point and the other one is this point. And also whenever you select one of the points, this handle will appear and this middle point is known as the control point of the curve. By pressing G, I can move the curve like this. Now to understand the working of this node, I'll first remove it from here by holding Alt, and if I left click, it will get removed. Now without using this resample curve node, we observe that we have 2 cubes placed only at the vertices or the center points of this curve, and that's because the instance on points node is connected here. It will place the instance, which is the cube in this case, to the points of the curve, and then if I select the resample curve and place it here, it basically creates more of these points throughout the curve, which can be controlled from the count number here. Previously I showed you that without using this node, you had only 2 instances or the cubes added at the center points, but right now the count value here is set to 10, and as a result we are having 10 cubes placed at different points on this curve. And also if I press G to move this point and extend it like this, you will notice that the number of these cubes will still remain the same. Only the length of this curve will change, but not the number of these cubes, and that is because the mode here is set to count. But if I change it to length, then basically this length value will control the distance between 2 instances or 2 cubes. So if I increase the distance, the number of cubes will reduce. That's because within the same length of the curve, the increase in the distance between 2 cubes will result in lesser space for the other cubes. As a result, the number of these cubes will reduce. But if I press G to move it, you will notice that as the length increases, the number of these cubes will also increase. And this is the use of the length mode in the resample curve. And now the third option that you have here is the evaluated. And if I select the evaluated mode, basically it allows you to control the number of these cubes by going to the object data properties and changing the resolution from here. Higher the resolution, more will be the number of cubes, and lesser the resolution, lesser will be the number of cubes. And this is how the evaluated mode works in resample curve node. Now suppose you want that instead of the cubes here, you should have the monkey or the Suzanne model. But if I go to the geometry nodes editor, press Shift plus A, in the mesh primitives, you will find that you don't have the option of selecting the Suzanne model. To fix this problem, we have the object info node. So suppose I delete this cube by pressing X. Let's come out of the edit mode, press Shift plus A to add a monkey, go to mesh and select the monkey. Let's place it in the Y direction by pressing G and Y and move it here. To select the curve again, go to the scene collection and select the Bezier curve. Now to assign the monkey to the instance, we'll use the object info node. So press Shift plus A, go to input, and in scene, you will find the object info node. Let's place it here, and this node is basically used to input any particular object from the scene in the geometry nodes editor. For example, if I click on the object here and select the Suzanne, and then if I connect the geometry to the instance, you will notice that just like the cubes, now we are having these monkey objects placed at different points in the curve. You can reduce their number from the resolution preview here because we have enabled the evaluated mode in the resample curve. Now there's also an easy way to add the object info node, which is to go to the scene collection, and suppose I need the Suzanne model, so I'll drag it by left clicking and drop it in the geometry nodes editor. And now we have the object info node added with the Suzanne selected. Now in a very similar way, we can create a fence, but for that we'll first add a cube in our scene. So press Shift plus A, go to mesh and add a cube, tab into the edit mode, and we'll be making one part of the fence. So let's scale it down in the X and Y axis by pressing S and X and scale it down like this. Similarly in the Y axis, press S and Y and scale it down like this. Now go to the front view by pressing 1 on the numpad. Let's also move it upwards by pressing G and Z, and let's place it here. Now to create the remaining part of the fence, I will create a duplicate by pressing Shift plus D and right click to cancel the movement. And let's rotate it in the Y axis by 90 degrees. So press R, Y and 90. Enter to confirm, and we'll place it here. Left click to finalize the position, and this is how this part of the fence is looking right now. Let's also scale this down in the Y axis by pressing S and Y and scale it down like this. Let's also create a duplicate of this part and move it downwards. So press Shift plus D, right click, press G and Z to move it downwards. Let's place it here, and now the part of a fence is ready, and we'll be using this part to create the entire fence. For this, select the Bezier curve. I will delete this object info node by pressing X, and here in this object info node, I'll change the object from the Suzanne to cube. Now you can see here that the fence is somewhat visible, but it's not perfect, and that's because we have to change the scale value of this fence. So I'll go to the scale value here, and let's increase it by left clicking and dragging like this, and if I move my cursor, then the scale will increase or reduce. And right now, the increments with which the scale is changing is very high. And to fix this problem, hold on the Shift key, and now if I scale it up and down, we get smaller increments. And I think that a value of somewhere near 0.2 would look fine, because at this value, all the parts of the fence seems to connect with each other. But another problem that you can see here is that the rotation of this fence is not right. It's not aligned to the rotation and the structure of the curve. And to fix this, we'll be using another node, which is the Align Euler to Vector node. To add it here, press Shift plus A, go to Utilities, and in the rotation, select Align Euler to Vector. Let's place it here. here. Now I don't know if the pronunciation of this word is right or not. I am pronouncing it as Euler, but a lot of people also pronounce it as Euler, so you can search for the pronunciation of this word if it's Euler or Euler or something else. Now the use of this node is that it basically helps to align the rotation in the x, y and z axis as per the vector values here. So if I connect the rotation of this align unit to vector to the rotation here, you will notice some changes here. Basically, the x axis is selected here, meaning that it will align the x axis as per the vector values here. And here you can see that the vector value in the z axis is set to 1. As a result, the rotation that you were seeing previously is now aligned like this in the z axis. Similarly, you can change the axis to align from here. For example, if I select y, then they will get aligned like this. Similarly, the z axis, and it looks like this. It won't show you any change in the z axis because aligning the z axis to the vector will mean that you are aligning the same axis in the same direction of the vector, as the value of z in vector is set to 1. Now if you're understanding it for the very first time, it might be possible that you can't understand it completely, but in simple words, it basically aligns a particular axis according to the vector values that you are having here. Now to rotate this fence along the curve, we have to add another node, which is the curve tangent node. So press Shift plus A, go to curve, and in read select the curve tangent. Let's place it here, and now I'll go to the top view by pressing 7 on the numpad. Then I'll take this tangent socket and connect it to the vector, and to get them properly aligned with the curve, change the axis from here. At x axis it looks fine, and you can see here that there are still some imperfections in this model. And to fix this, we'll first reduce the scaling in the x axis so that the fence part will just touch each other. Then to increase their count, I'll go to the resample curve, change the mode from evaluated to count, and if I increase it, you will notice that the fence will now look perfect. In fact, let me show you one more thing. If I go to the top view by pressing 7 on the numpad, tab into the edit mode, and with this draw option selected, if I left click and draw a curve, you will notice that a fence will get created that will be perfectly aligned with the structure of that curve. And that's how you can simply create any fence just by drawing a curve. So if I go to the top view again, we can draw 3 to 4 curves like this. But one thing to notice here is that as I increase the length of the curves, the number of these instances will remain the same. And if I go to the count and try to increase them, you will notice that the number of instances in the smaller as well as the bigger fence will increase. And so we'll try a better approach, which is to change the mode from count to length. And now we can set a particular length which will be the minimum distance between two instances. So if I reduce it, you will notice that the distance between the two instances will reduce, and at a particular value they will get connected to each other and make a perfect fence. And now let's move ahead to the next topic of this chapter, which is the delete geometry node. And this node is basically used to delete some random parts of your mesh, and to explore it in detail, we'll add it in the geometry node editor. So press Shift plus A, go to geometry, and in the operations select delete geometry. Let's place it here. Now here you can see that in the domain you have some options, which means that in any mesh or the object that you select, you can delete the points, the edges, the faces, the spline or basically the curves, and even the instances. And from here you can select the mode of deleting, meaning that if you want to delete only the edges and faces, or if you want to delete only the faces. And now to see how it works, we'll take it and drop in between the resample curve and the instance on points. And here we observe that it deletes everything, and that's because we have not given any information to the delete geometry node about which part of mesh it should delete. And suppose you want to delete some random parts. For this we'll add the random value node by pressing Shift plus A, going to utilities, and here we have the random value. So I'll select this and place it here. Now here you have some options in the data type like float, integer, vector and boolean. The data type will basically define the output that it will generate. For example, with the float selected, it will basically give the output between the minimum and the maximum values, that is 0 and 1, and the output will be a float value or a decimal value. Similarly, you have integers, vectors, but we'll be selecting the boolean. And for those of you who don't know what a boolean is, it basically means true or false. In fact, here you can see that you have this probability bar which is set to 0.5. To discover how it works, we'll take this value socket and connect it to the selection, and here you can see that now some random parts of the fence are deleted here. See, the function of delete geometry is simply to delete the mesh or any part of the mesh, but if we don't give any information to it about which part to delete, it will delete everything. Therefore, we needed to add the random value node with the boolean selected, and this probability option will basically define the probability or the chances of each part of the fence getting deleted. Since the probability is set to 0.5, it means that the chances of each fence to get deleted is 50-50. And if you want more part of the fence to be deleted, you can increase the probability from here. And now you can see here that as I increase the probability, the part of the mesh which is getting disappeared will increase. But to create a realistic looking fence, we lower the probability to somewhere around 0.2 or 0.1. Then you have this seed option here, and if I change it, you will notice that it generates a completely different output. So you can use this seed value to generate some random outputs with the same probability value. But I think that I will change it to this seed value as it looks better right now. So you can try to change the probability value from here and also the seed value to get some different results each and every time. And I think that this output looks perfect, so I'll finalize this one. And now moving ahead, let's give this fence some basic material. For this, I will change this spreadsheet into the shader editor by clicking on this icon and selecting the shader editor. Press N to close this toolbar and click on new button. Here we have the default material applied to the fence. Let's go to the material preview mode or maybe the rendered preview mode, and we should increase the lighting in our scene. So I will select the lamp here, and in the properties, I'll change the type of light to sun. Let's reduce the strength from here to something like 10 or maybe 20. Let's also rotate it in the x-axis by pressing R and X, and let's rotate it like this. And now we have a better lighting in the scene, but right now I think that the strength is too high, so I will reduce the strength slightly and I'll keep it to somewhere near 10, and it looks perfect. So I'll again select the fence and let's create the material. We'll be creating a basic wood material to apply to this fence, so let's rename the material to wood. And yes, if you have not learned about the material textures and nodes, then you can check the previous chapters of this course where we understood about the node components, the basic and procedural shaders, image textures, and a lot more. But for now, we'll be creating a simple wood texture by adding a noise texture here. So press Shift plus A, go to texture and add the noise texture. Let's place it over here. Press Ctrl plus T to get the input and the mapping node. This shortcut will work only if the node wrangler add-on is turned on. Then connect this object socket of the texture coordinate to this vector socket, and to view the texture here, press Ctrl plus Shift and left click on the noise texture. But here we need to zoom in to view the texture on this fence. Now the reason why we can't see anything here is that we have applied this material to the Bezier curve, but instead of that, we should have applied this material to this fence object. To do this, in the material properties, click on this icon and select wood, and now if I zoom in, you will observe that the noise texture is visible on the fence here. Now to make a realistic wood texture, we'll change the value of the scale from the noise texture. And yes, before that, we'll be viewing the texture on this object because it's comparatively bigger in size, and so the texture will be properly visible. Now we'll go to the noise texture, increase the scale value like this, and let's increase it to something like maybe 50, and let's also increase the detailing. And you might have seen that the wood material has this stretching effect on its surface, and to achieve this kind of result in Blender, we'll go to the scaling in the mapping vector node, and let's try to change these values in different axes. And if I increase the scale in the x-axis and zoom in, you will notice that we are getting some kind of stretching effect, but it's not perfect right now. To fix this, we'll take this UV socket and connect it to the vector, tab into the edit mode, press A to select all, then in the UV option here, select Smart UV Project, click OK, and now if I go to the object mode again and try to change the values of scale from here, you will notice that by scaling it in the y-axis, it gives us a better texture. To view it properly, I'll go to the front view by pressing 1 on the numpad, and let's zoom in like this. So here you can see that with the scaling in the x-axis set to 1, if I increase the scaling in the y-axis, we get this stretching effect on the texture. So we'll finalize the texture, and now it looks like this. And now to give some color to it, we'll add the color ramp. So press Shift plus A, go to converter and select the color ramp. Let's place it here, and I'll select the first pointer and change its color from here. Let's increase the brightness slightly, and I'll change it to brown color. You can check the final result of the color from here. And for the second pointer, I need the color to be very slightly different from the first color. So with this cursor over this brown color, if I press Ctrl plus C and select the second pointer, and now with the cursor over the white color, if I press Ctrl plus V, the brown color will get added here as well. But for this color, we'll increase the brightness from this slider like this to give it a slight orange look. And to make the texture look better, you can try to change the position of these pointers like this, and in this way, you can make your texture look more realistic than before. Let's also add this principal BSDF after the color ramp, and now to give it a 3D effect, we'll add the bump node. So press Shift plus A, go to vector and select the bump node, place it over here, then take this factor socket of the noise texture and connect it to the height, then take this normal socket and connect it to the normal of the principal BSDF. And here the bump node is applied to the texture. You can make this texture look better by changing the scale value in the y-axis from here. So if I reduce it, you will notice that at a value of somewhere near 0.2 or 0.1, you will get a realistic looking wood texture. And yes, one more thing, it's not compulsory to enter the same values that I am adding here. You can try to get different results by changing the scale values here, or maybe the colors in the color ramp. You can also control the strength of the bump from here. So I think that we should keep it to somewhere near 0.5, and it looks better now. Since we are making the wood texture, let's increase the roughness in the principal BSDF to a very high value like 0.9 or 1, and now it looks perfect. And yes, this brings us to the end of this chapter. In this chapter, we learned about creating this fence in our scene with the help of all these geometry nodes. Then we even created a simple wood texture for this fence. In the next chapter, we'll be making the base of the landscape where the fence that we created will be placed. In the previous chapter, we created this fence with the help of geometry nodes, and in this chapter we'll be covering all these topics in complete detail. Now in the chapter number 32, we created this fence and also gave it a basic wood texture. And now let's work on creating a hilly landscape. For this, let's first add a plane by pressing Shift plus A, and in the mesh, select the plane. Tab into the edit mode, and to scale it up, press S, and if I press 10, then it will get scaled up 10 times. Now since we'll be creating a complex landscape with this plane, let's subdivide it. So right click and select subdivide. Then if I click on this menu, from here I can control the number of cuts. So let's change it to 10 or maybe 40. So we have to keep this number high so that we can easily make a complex landscape. Let's come out of the edit mode, and to work on the geometry nodes, with this plane selected, click on the new button. And now moving to the first topic of today's chapter, which is the set position node. We'll add it here by pressing Shift plus A, go to the geometry, and in the right category, select set position. Let's place it here. Now as the name suggests, this set position node allows you to set the position of the vertices of your mesh or instance, and to use this, I'll select it and drop it in between the group input and the group output. Now to understand it better, I will change this window from shader editor to the spreadsheet, and with the vertices selected, here you can see that we have 1800 vertices, and you also have the position of each of these vertices. For example, the vertex with the index value of 0 has the position of -10 in the x-axis, -10 in the y-axis, and 0 in the z-axis. And you can see here that all of these vertices are having the z component as 0, and the reason for this is that the position of this entire plane is at the position value of 0 in the z-axis. Now you can use this set position node to change the position of any of these vertices to any other new position. But in order to tell this set position node that the position of exactly which vertex it should be changing, we have to use the position node. To add it here, press Shift plus A, go to geometry, and in read, select the position. Let's place it here. Now if you remember, we studied about the index node in one of our previous chapters. The index node used to act like an input value for the index values here. Similarly, this position node will act as an input for the different position values here. To understand these positions better, let's go to the top view by pressing 7 on the numpad, and let's zoom out. Now here at the index number 0, the position of the vertex is -10 in the x-axis, -10 in the y-axis, and 0 in the z-axis. And to view this vertex in the 3D viewport, you have to understand a simple concept. In the x-axis, the left hand side is negative and the right hand side is positive. In the y-axis, the downward direction is negative and the upwards is positive. And yes, do remember that we are viewing this plane from the top view. Now if I look at the position of the vertex at index value 0, the x component is set to -10, meaning that the vertex is located at -10 meters away from the x-axis. And since we scaled up this plane 10 times, it means that it is somewhere located on this edge of the plane. Then the y-axis, the value is set to -10, meaning that it's in the negative direction, and so it's 10 meters downwards. As a result, we can say that the vertex at the index value 0 is placed at exact this point. And if I tab into the edit mode and zoom in, then this is the exact vertex I'm talking about. It's on the left hand side, meaning that the x component is negative and it is the farthest away from the y-axis. Then being in downward direction, it has a negative y component, and again being the point which is farthest away from the x-axis, the value of y component is -10. And as I already told you, the z components of all these points is fixed to 0 meters. Let's come out of the edit mode. Now to convert this plane into a hilly landscape, we'll be using the noise texture node along with this position node. And to add the noise texture, press Shift plus A, go to texture, and select the noise texture. Let's place it here. Now the reason for adding this noise texture is that in the geometry nodes, the noise texture allows you to push some of the vertices upwards, and so it can help us to create a hilly landscape. But to use it here, we first have to add the vector math node. So press Shift plus A, go to utilities, and in vector, select vector math and place it here. Now I'll take this position socket and connect it to vector, then take this vector socket and connect it to the position. Now the reason for adding this vector math node is that to make the hilly landscape, we need to change the position of these vectors, meaning that we needed to add some mathematical value to the position of different vectors with the help of the noise texture. So in the first socket we connected the position, and in the second socket we'll be connecting the noise texture. But before that, let's understand one more thing. In order to make this plane a hilly landscape, we have to change the position of vertices only in the z-axis. But if I take the factor socket of the noise texture and connect it to the second vector socket, then now it will begin to control the vector in all the three axes. And to affect only the z-axis, we will be using the combine xyz node. We learned about this node in one of the previous chapters while understanding the geometry nodes. Now to add the combine xyz node, press Shift plus A, go to utilities, and in vector, select the combine xyz. Let's place it here and connect this vector socket to over here. Now to connect this noise texture to the rest of the node system, we'll connect it to the combine xyz through the z-axis. So take this factor socket and connect it to the Z socket, and we notice some changes here. But before understanding that, let's first revise each and everything that we have done in this geometry nodes editor. The first thing that we added was this set position node because our purpose was to create a hilly landscape, and to do that we basically had to change the position of some random vertices by moving them upwards. And to achieve this target, we used the position node and the noise texture, and we needed to add them together in order to change the position of the vertices. For this we used the vector math node with the add operation enabled. Then we added this combine xyz node because we needed the change in position to take place only in the z axis. And the noise texture in the geometry nodes editor won't be actually adding a texture like it used to do in the shader editor. Instead, it will create this distortion effect on different vertices of the plane. It basically takes the default position of the vertex, and since we have connected it to this vector math node, it will add distortion to it in the z axis. And if you want, you can use the scale value in the noise texture in order to change the distortion effect on this plane. Right now the scale value is set to 0.3, and that's why it appears like this. To view it properly, I'll change the mode from the rendered view to the solid view, and this is how it looks right now. If you look closely at the plane, you will observe that in order to make this into a hilly landscape, we need to increase the distortion effect. And always remember that whenever you want to increase an effect significantly in geometry nodes, you can use the multiply math node. To add it here, press shift plus A, go to utilities, and in math, select the math node. Since we want to use this vector math node in order to manipulate the distortion effect, so we'll place it after the noise texture. Let's change the operation from add to multiply, and now with the help of this value, I can increase the distortion effect on the plane. But one more thing to notice here is that increasing this value also moves our plane upwards. So we basically want that as we increase this multiply value, the position of the plane should go downwards instead of moving up. And for this, we'll be adding a vector math node with the subtract operation. For this, press shift plus A, go to utilities, and in vector, select vector math. We'll place it just before the set position node, and I'll change the operation to subtract. And now if I take the value of z component in the vector socket and increase it, the plane will begin to go downwards. But since we wanted that the position of this plane in the z axis should be controlled as per the multiply value, so we have to connect the multiply value socket to the vector. And because it will be controlling only the z axis, as a result, we'll be adding a combine xyz node. For this, I'll select this combine xyz node, press shift plus D, and place it here. Take this vector socket and connect it to the second vector socket of the subtract. Then if I take this value socket and try to connect it to the z axis socket of the combine xyz, you will notice that they do not get connected, and that's because we have to use a value node to connect them. To add it, press shift plus A, go to input, and in constant, select value. We'll place it here, take the value socket and connect it to the multiply value. Then again take this value socket and connect it to the z axis in the combine xyz. Now this value node is working as a connection between the multiply value and the movement in the z axis. And if I try to increase this value, you will notice that the distortion effect is increasing because of this multiply node, and it's not moving upwards because of the subtract node. But here we see that we have another problem. If I increase the multiply value, then this time the plane will begin to move downwards. And to fix this, we have to use another math node with the divide operation. So press shift plus A, go to utilities, and in math, select the math node. We'll place it after the value socket and change the operation from add to divide. Now I'll change the value socket in the math node, and if I increase it, you will notice that the plane will begin to move upwards. Now we have to keep this value to that number where it just touches the x and the y axis. For this, we'll go to the front view by pressing 1 on the numpad, and let's zoom in, and since it is moved upwards, so we'll reduce the divide value, and at a value of somewhere near 2 or 2.5, the plane is perfectly touching the x axis. And to confirm, I'll go to this value socket and change the value to 0, and now it's perfectly placed here. So if I change the value to a higher number like 10, then basically two things are happening. One is that it will multiply the distortion effect by a factor of 10, and the second thing is that this value of 10 will reach this math node with the divide operation. 10 will get divided by 2, the output will be 5. This value of 5 will reach the combine xyz node, and as a result, the plane will move downwards in the z axis by 5 meters because of the subtract vector math node. Now to get a proper distortion effect, we'll use the scale value in the noise texture. Right now it is set to 0.3, but if I reduce it, you will notice that it looks better than before. And if you want to change the scale value slowly, then simply hold down the shift button, and now with the left click, if I drag, then I can slowly see the change in different scale values. And at a value of somewhere near 0.09 or 0.1, we get a distortion effect like this. And to increase their height, you can go to the multiply value here and increase it. So simply by changing the scale value and the multiply value, you can turn a simple plane to look like a hilly landscape. But right now I think that the height is a bit too much, so I'll reduce the multiply value to a lower number like 8 or 10. And now if we zoom in, we have this slight distortion effect applied to the vertices of this plane. And yes, if you want to make its surface smooth, you can add the set shade smooth node in the geometry nodes editor. So press shift plus A, go to mesh, and in the right category, select Set Shade Smooth. Place it just before the group output, and now we have the shade smooth applied to this plane. And also here we have a simple hilly base which we created by distorting the vertices. And if you want, you can even increase the size of this plane by simply going to the edit mode, press A to select all the vertices, and now you can press S to scale it up. So I've scaled it up 2 times, and this is how it looks right now. As I told you before, you can change the distortion effect and the height with the help of the scale value of the noise texture and this multiply value. But according to me, right now the basic structure of the base of landscape looks perfect. So we'll finalize this, and now moving ahead, we'll also be creating some grass and rocks to place on this plane in the upcoming chapters. But before that, we need to understand about another node which will help us to distribute the grass and the rocks all over the plane, and this is the distribute points on faces node. To add it, press Shift plus A, go to point and select distribute points on faces. We'll place it just after the set geometry node, and we see some changes here. As the name suggests, the distribute points on faces node basically distributes these points on different faces of the mesh object. Now the first option that you have here is the density, and it basically controls the number of these points per square meter of each face. Higher the density, more will be the number of points, and if I reduce the density, we'll have lesser points on the faces. Then the next option that you have here is the seed, and this one basically shuffles these points at different locations, and each time it will create a new output. And also from here, you can control the distribution method. By default, the random is selected, and so it distributes the points randomly on the faces. But if I change it to the poison disk, you will notice that we have a new option which is the minimum distance, and this parameter basically controls the minimum distance between any 2 points. So if I increase it, you will notice that the number of these points will reduce as the minimum distance required between them increases. And this is the special thing in the poison disk distribution method. For now, I'll change it back to random distribution method. And now suppose you want to place a specific mesh object in place of these points. For this, we'll be using the instance on points node. So press Shift plus A, go to instances and select the instance on points. Place it after the distribute points on faces, and everything will disappear because we have to tell this instance on points about which particular mesh we want to be placed as the instance on those points. For now, we'll be adding a cube as the instance. So press Shift plus A, go to mesh, and in primitives, select cube. We'll place it here and connect this mesh socket to the instance here. It appears like this because the size of the cube is too big, so we'll reduce it by left clicking and dragging like this. And before releasing, if I move my cursor, the size of the cubes will change. I think that we should reduce it to something like 0.1 meters. And now you can see that instead of the points, we have these cubes placed as the instances here. Let's also reduce the density to get a better view, and this is how it looks. And now suppose you want to see both the plane and these cubes in the scene, and for this we'll be using the join geometry node. So press Shift plus A, go to geometry and select the join geometry. We'll place it just before the output, and to view the plane here, simply take this geometry socket of the set position which is carrying the information about the plane and connect it to the join geometry. And now here we have both the plane and these cubes as the instances placed on it. And yes, in the upcoming chapters, we'll be creating some grass and rocks, and we'll place them as the instance objects at the position where the cubes are placed right now. And yes, one more thing, it might be possible that even after applying the set shade smooth, the plane still appears to be flat, and that's because we have placed the join geometry node after the set shade smooth. But if I remove it from here by holding the Alt button and left clicking, and if I place it before the set shade smooth, and again if I take the geometry socket of the set position and connect it to the join geometry, then in this case the shade smooth will be applied to our plane. And if you want, you can also change the color of this base by simply going to the material properties, and in the base color you can set any particular color as the base color. But for now I'll remove it. And yes, this brings us to the end of this chapter. In this chapter we learnt about all these topics in complete detail and also created this simple hilly base of the landscape. In the previous 2 chapters, we understood about creating this fence along with the wood texture and also a simple base for the landscape, and we created all this with the help of geometry nodes. And in this chapter, we'll be exploring about creating the grass for the landscape, and with this we'll also be covering all these topics in complete detail. So previously, we made this fence and this base for the landscape, and now let's begin with the creation of grass. Now to create the grass, first add a cube in the scene by pressing Shift plus A, and in the mesh, select the cube. Let's move it in the Y direction by pressing G and Y and place it over here. And we'll be creating the grass with the help of geometry nodes in Blender. For this, go to the geometry nodes editor and click on this new button. The first node that I'm gonna add is the mesh line node. To add it here, press Shift plus A, go to mesh, and in primitives, select the mesh line. Let's place it over here, and now this mesh line node is connected to the group output. Now, as the name of this node suggests, it basically creates a mesh in the form of a line. And since it is a mesh, therefore it has vertices and edges connecting with each other. And if you want to view those vertices, we need to add another node, which is the mesh to points node. So press Shift plus A, go to mesh, and in operations, select mesh to points. We'll place it after the mesh line, and here you can see that these points are the vertices of this mesh line. Now here you have some options in the mesh line curve, and let's explore them in detail. This offset option basically allows you to change the distance between each point on a particular axis. For example, if I increase the x value, you will notice that the distance between the points will increase in the x-axis. Similarly, if I increase the value in the y-axis, the distance between the points will increase in the y-axis. Similarly, with the z-axis also, if I increase it, the distance between 2 points or the offset will increase. Then the next thing that you have here is the start location. And by using this option, I can basically change the position of the first point or the first vertex of this mesh line. So if I change it in x-axis, you can see here that its position will change in the x-axis, similarly in the y-axis, and also in the z-axis. So this one is basically used to change the position of the vertex, and the offset is basically used to control the distance between 2 points or 2 vertices. And the next option that you have here is the count, and it basically determines the number of these points or the vertices in the mesh line. So if I increase it, the number of these points will increase, and also the length of the mesh line will increase. Now you also have this option of selecting the mode, which is set to offset by default, but if I change it to endpoints, it will allow us to control the things in the mesh line differently than before. With the endpoints mode selected, you can control the length of this mesh line, or basically the position of the starting point and the ending point from these values here. For example, the start location will determine the value of the first vertex, which is placed at the bottom, and the end location will determine the position of the last vertex, which is placed at the top. So if I increase the value of end location in the z-axis, you will see that the position of the last vector will move upwards, and as a result, the length of this mesh line will also change. Previously, in the offset mode, you were able to control the length of this mesh line with the help of this count option. But in this case, no matter what the value of count is, the length of the mesh line will remain the same, and only the number of these points or vertices will change. And now specifically in this endpoints mode, here you have the option of selecting the count mode. If I change it to resolution, then here you have the resolution value, which is basically the minimum distance between any 2 points in the mesh line. So if I reduce the resolution like this, then the distance between the 2 points will decrease, and as a result, in the same length of the mesh line, we'll be having a higher number of vertices or these points. And since we'll be using this mesh line for making the grass, I'll be changing the mode from endpoints to offset. Let's also change the value of offset in the z-axis to 1 meters, and let's round off the count value from 19 to 20. Now if you remember, we added this mesh to points in order to see these vertices, but now it's no longer required, so I will press X to delete it, and let's take this mesh socket and connect it to the geometry. And this is how a mesh line is looking right now. Since we'll be making a grass out of it, we need to apply some rotation to it, and for this we'll be using the vector rotate node. And to add it here, press Shift plus A, go to utilities, and in vector, select the vector rotate. Let's place it over here, and since we are changing the rotation of this mesh line, we also have to use the set position node. So press Shift plus A, go to geometry, and in the right category, select the set position. We'll place it just before the group output, and now here we have a mesh line node which created this mesh line, a vector rotate node which will be used to control the rotation of this line, and a set position node which is being used because we are changing the rotation of this line. Now to connect this vector rotate node to the rest of the node system, take this vector socket and connect it to the position, and we notice that the mesh line disappears. That's because we have to use these values to control the rotation and the visibility of the mesh line. Now since we'll be changing the rotation of different vertices, so we have to tell this vector rotate node about the position of those different vertices. For this we'll be adding the position node about which we learned in the previous chapter. So press Shift plus A, go to geometry, and in read, select the position node. Let's place it here and connect it to the vector socket, and now this mesh line is again visible. Now here you have this angle option in the vector rotate node, and if I try to change it, you will see that nothing happens, and this is because we need to give some input to it about the index value of different vertices to change the angle. To do this, press Shift plus A, go to geometry, and in read, select the index. Let's place it here and connect it to the angle. And now suppose you want that each of the vertex should rotate around a particular axis. For this, you can change the type of rotation to any particular axis. So if I select the x-axis, here we have all the vertices or the points of this mesh line rotated in the x-axis, and if you want to control this rotation, we have to use the math node. So press Shift plus A, go to utilities, and in math, select the math node. We'll place it between the index socket and the angle. And now if I change the function to multiply, then I can use this value to control the rotation of the different points of the mesh line in the x-axis. And if you feel that while changing the value by left clicking and dragging like this, it's changing very fast, so you can simply hold the shift button and then you can see the changes slowly. Now let's again understand what all we did here in order to revise each and everything. First we added the mesh line node because we wanted to create the grass with the help of this mesh line. Then to change the rotation, we use the set position node, and to control the rotation, we use the vector rotate node. Then we use this position node to act as an input about the position value of different different vertices, and to change the angle of rotation, we use this index node and connected it to the match node with a multiply operation so that we can control the rotation of this line. And it was rotating like this because we have set the type as the x-axis. Now moving ahead, let me tell you about some other useful nodes which are used to change the object type from mesh to curve or from curve to mesh. For this, the first node is the mesh to curve node. To add it here, press Shift plus A, go to mesh, and in operations, select the mesh to curve, and let's place it here. Now you may not notice any changes here, but it actually changes the object type of any object from mesh to curve. And to confirm this, you can go to this spreadsheet, and now in the mesh you can see that you have 0 vertices, 0 edges, 0 faces, and 0 face corners. But here in the curve section, you have this option of spline, and the number here is set to 1. And from this you can confirm that the object type for this mesh line is changed from mesh to curve. And there's another node whose function is just the opposite of this mesh to curve node, and it is known as the curve to mesh node. To add it here, press Shift plus A, go to curve, and in operations, select the curve to mesh. Let's place it here, and now the object type for this mesh line will change from curve back to mesh. And to confirm this, you can go to the spreadsheet, and here in the mesh category, you have 20 vertices and 19 edges. Previously, both of these values are 0, and the number of spline in the curve was set to 1, which is now again 0. So by using this node, you can simply convert the object type of any object from curve to mesh. And now moving ahead, in order to give some thickness to this mesh line, we'll be using another node, which is the curve line node. To add it here, press Shift plus A, go to curve, and in primitives, select the curve line. Let's place it here, and now this curve line is very similar to the mesh line that we added here. To view it in our scene, hold down Ctrl and Shift, and if I left click on the curve line node, then now we can see this curve line added in my scene. Now the difference between the curve line node and the mesh line is simply that the object type of the curve line is a curve and that of mesh line is a mesh. In order to view the vertices or the points of this curve line, we'll be adding the curve to points node. So press Shift plus A, go to curve, and in operations, select the curve to points. Let's place it over here, and now you can see that these are the points on this curve line. Now just like the mesh line, you can control the position of the first vertex with the help of the starting positions, and for the last vertex, you have the end position which you can control from here. So you can simply change the position of the starting point and the ending point in any of the 3 axes from the parameters here. Now we'll be using this curve line node to give the mesh line that we created some width or a dimension by connecting it to the profile curve here. To view the results, I will delete these two by pressing X, and let's zoom out, and we see some changes in the mesh line that we created. To increase the width in the x-axis, we'll change the position of the start parameter in the x-axis, and now you will notice that the width of this mesh line in the x-axis will increase. And another thing to notice here is that one side of this mesh line is slightly pushed upwards in the z-axis, and that is because the position of the ending vertex in the curve line is set to 1 meters in the z-axis. To level it perfectly, I'll change its value to 0 meters, and now it looks fine. And now let's revise the curve line node. As I already told you, it's very similar to the mesh line except for the fact that its object type is curve instead of mesh, and we connected it to the profile curve because we needed to give some thickness to this mesh line in order to create the grass. Now in order to make it look like a real glass blade, we need to change its shape. It should be bigger in size at the bottom, and then it should scale down as it moves upwards. For this we'll be using the set curve radius node. To add it here, press Shift plus A, go to curve, and in the right category, select the set curve radius. Now we have to understand one basic thing. This set curve radius node can be applied only to a curve, and so the input that it will receive should also be a curve. And in this node system, we added this mesh to curve node which converted the object type of this mesh line into a curve, meaning that the output that it will give will also be a curve. So we'll be placing it after the mesh to curve node, and here it gets connected. Now you can use this radius value to control the curve radius, but in order to achieve the result where the area is bigger at the bottom and smaller at the top, we have to use another node to control the radius, and it is the spline parameter node. To add it here, press Shift plus A, go to curve, and in the read category, select the spline parameter. We'll place it over here, and we have to connect it to this radius value because the spline parameter node is being used to control the radius, or basically the size, at the different points. And for this, if I take this factor socket and connect it to the radius, you will notice that at the starting point, it now has the lowest size, and then the size keeps on increasing and reaches the maximum at the ending point. And this is how the factor socket works in the spline parameter. And now let me explain you about this factor socket of the spline parameter in complete detail. Actually, the output that this factor socket gives is in the form of 0 to 1, meaning that it will pass the value of 0 for the beginning, and then it increases from 0 till it reaches 1. So you can say that at the lowermost point, which is the starting vertex, the radius or the size is 0, and at the topmost point, or basically the end, the radius or the size is equal to a value of 1. Now if you remember, I told you that we needed the starting point to be bigger in size and the ending point to be smaller, but here we have the opposite result, meaning that we need to remap the range value of this factor socket, which is currently set as 0 to 1, and we'll change it to 1 to 0. By doing this, the area at the starting, or basically the lower part, will be greater, and then it will reduce, and at the top top, or basically at the end, the area will be the minimum. And to achieve this result, we have to use the map range node. Now to add the map range node, press Shift plus A, go to utilities, and in the math category, select the map range. We'll place it after the spline parameter, and now this map range is connected to the spline parameter and the set curve radius. Now to invert the range from 0 to 1 into 1 to 0, simply go to this 2 minimum value and change it to 1 and this 2 maximum value to 0. And here we get the result. But let me also explain to you exactly how it worked. See, we added this spline parameter in order to make this look like a blade of grass. And when we connected this factor socket to the radius, it gave the radius a value of 0 to 1 from bottom to top. But we needed it to be opposite. As a result, we added this map range node, changed the minimum value to 1 and the maximum to 0, meaning that the range of this factor socket was now changed into 1 to 0. And as a result, the radius at the lowermost point is the maximum, and at the uppermost point, which is the end point, it is minimum. Now another thing to notice here is that at the top you can see that the radius is exactly 0, making it look very sharp and pointing. And if you don't want this, you can simply increase the 2 max value to a slightly higher number like 0.05 or maybe 0.03, and now it looks perfect. And yes, you can also control the size at the bottom either from the 2 minimum value or from the curve line node by changing the starting position in the x-axis. So you can control this size at the bottom with the help of this parameter. Now moving ahead, we'll be creating a bunch of this grass placed over a circular base, and for this I'll be adding a new node, which is the mesh circle node. To add and understand it, press Shift plus A, go to mesh, and in primitives select the mesh circle. Let's place it over here. Now to view the mesh circle in my scene, I'll take this mesh socket and connect it over here. Let's go to the top view by pressing 7 on the numpad, and here we have the mesh circle added in our scene. This mesh circle is exactly the same as the circle which you can add by pressing Shift plus A in the 3D viewport, and in the mesh, here you have the object of circle. So both of them are the same circles, it's just that you have added it from the geometry nodes editor. Now in the mesh circle node, you have this option of fill type, and by default it is set to none, meaning that this circle won't be filled with any faces. But if I change it to n gone, then now here we have one face and our circle is now filled. But in the fill type, you have the third option, which is the triangles, and if I select it, you won't notice any difference. That's because the main difference can only be seen in the edit mode. But if I tab into the edit mode, you won't actually be in the edit mode of the circle, and that's because originally the object that was added here was a cube, and you can even see this in the scene collection. We did all the changes in the geometry nodes editor to convert the simple cube into various other objects like grass, and then we added this mesh circle node to view the circle. But since originally it was a cube object, as a result in the edit mode it still appears as a cube. But to understand the working of the fill type with the triangles mode, we'll add another mesh circle by using the add menu. For this, first I'll take my cursor over here by holding shift and right clicking. Now if I press shift plus A, go to mesh and select the circle, here we have the circle added. Now if I go to the add circle properties and change the fill type from nothing to n gone, and if I tab into the edit mode, you can see that we have these vertices around the circle and a face in between. But let's come out of the edit mode, and to check the next fill type, I'll first delete this, add another circle by pressing shift plus A, and in the mesh I'll select the circle. From the fill type, I'll change it to triangle, and if I tab into the edit mode, now you can see that all these vertices are getting connected to the center and forming these triangle faces. And this is the use of the triangle fill type. In fact, the same concept is applied when I was working on this mesh circle and changed the fill type to triangles. Then you have this option of vertices, and by using this you can control the number of vertices of your circle object, and similarly this radius option will determine the size of your circle. Now we'll be using this mesh circle to place grass on its different faces in order to create a bunch of grass. For this, first I'll delete the second circle by pressing X, and let's also take this 3D cursor back to the world center by pressing shift plus C. And now if you want to look closely at the circle, one way is to zoom in like this, but an easier way is to select it and press the dot or the period button in your numpad, and now we get a close view of the circle. Now to place the grass at different faces on this circle, we'll be using the instance on points. So press shift plus A, go to instances and select instance on points. Let's place it over here after the mesh circle, and to place the grass over here, we have to connect the grass to the instance socket. For this, I'll take this mesh socket of the curve to mesh and take it to the instance socket, and now here we have the grass placed at different faces of the circle. And now one thing to notice here is that all of them are rotated in the same direction, and to give them different rotations, we'll be adding a random value node and connect it to the rotation. So press shift plus A, go to utilities and select the random value. Let's place it over here and connect this value socket to the rotation. Now it appears like this because the data type in the random value is set to float. However, we know that for rotation, we need to input a vector value. For this, I'll change the data type from float to vector, and now with the help of these parameters, I can control the rotation of of this grass in different axes. For this, I'll take this value socket and connect it to the rotation, and this is how our grass is looking right now. Now what this random value node is doing is that it is giving some random rotation values to all the blades of grass in all the three axes, meaning the x-axis, the y-axis and the z-axis. But suppose you want the rotation to be only in the z-axis, and for this we'll be using the combine xyz node. To add it here, press shift plus A, go to utilities, and in vector, select the combine xyz. Let's place it over here and connect it to the maximum socket in the random value. Now with this combine xyz node, I can easily control the rotation of this grass in any one of the three axes. But since we want to rotate it only in the z-axis, so I'll go to the z-axis and try to change the value here. And if I increase it, each blade of the grass will get a different rotation in the z-axis. Now similar to controlling the rotation, you can also control the scaling of this grass. For this, I'll again add the random value node. So I'll select this, press shift plus D and place it over here. Now take this value socket and connect it to the scale. And now with these parameters, I can control the scaling of different blades of grass in my scene. So I can change these parameters like the minimum in the x-axis, the minimum in the y-axis, and similarly the z-axis. With these values, I can directly control their scaling in different axes. For example, if I select the minimum value in all the three axes and change it to something like 0.4, then the grass looks like this. To view it properly, you can deselect the grass, and now you can view it from different angles and confirm if the scaling and the rotation are proper in the geometry nodes editor or not. Now if you want to control the size of this bunch of grass or the number of these grass blades, you can go to the mesh circle option here, and if I increase the radius, the size will increase like this. Similarly, the number of vertices will control the number of these glass blades, and here you can also see that we are not having any grass on the face of the circle. We are only having the blades of grass at the position of the vertices of the circle, and to get these blades on different points at the faces, we'll be using another node which is the distribute points on faces. To add it here, press shift plus A, go to point and select the distribute points on faces. Let's place it over here, and now we have the blades of grass placed over different points on the entire face of the circle. Now you can control the density of this grass from the density option here. So if I reduce it, the number of grass per square area will reduce, and now it looks like this. So we'll finalize the density to this value, and let's also reduce the size of the bunch of grass or the circle with the radius option here. And you can also use this seed value to generate a different output with the same settings each and every time. Now moving ahead, let's also give it some basic material. For this, we'll add the set material node. So press shift plus A, go to material and select the set material. Let's place it over here, and now we'll be connecting it after the instance on points node. For this, first I'll bring this group output node up in the geometry nodes editor over here. Then I'll take the set material node and we'll drop it in between the instance on points and the output. To create and view the material, let's go to the render view, and we have to keep the render engine to EV for now. Now to create the material, we'll change this spreadsheet into the shader editor. So click on this icon and select the shader editor. Click on the new button, and let's rename this material to grass. To assign this grass material to this bunch of grass, go to the set material node and click on this material option and select the grass. Now we'll be giving this grass a simple green color by going to the base color, and let's change it to light green color like this. And if you want, you can add a simple color ramp and make a combination of light green, light yellow color, or some dark green color. But right now I think that it looks perfect, so we'll finalize this simple base color. Now moving ahead, we'll be creating different bunch of grass with different settings. Like in one of them, we'll reduce the density or maybe the size of this grass or the rotation or the bending. And for this, we'll be using another node which is the collection info node. But before that, we'll be using the group input node to directly get all those settings in the modify properties editor. Let me explain you practically by doing it. I'll select this group input node, press N to open the toolbar, and we won't need this geometry socket, so I'll delete it by selecting this geometry socket and clicking this minus icon. Now if you want to create a new socket of your own, you simply have to select that particular socket. For example, if I want the density socket to be here, so I'll select it and connect it to the socket of the group input. And now here we have the density connected, and because of this, I can directly control the density from the modify properties here. Similarly, you can also connect the new socket to other parameters like the radius, and here you have the radius in the modify properties. And with this, I can control the size of the patch of the grass. So I'll rename it from this toolbar by double clicking on the radius socket, and let's change it to grass patch size. Now to create a socket to control the rotation, I'll take a new socket and connect it to this combine xyz node in the z-axis. This combine xyz node was connected to the random value which was connected to the rotation. And to rename it, I'll go to the toolbar, double click on the z, and we'll change it to rotate z. Press enter to confirm, and now we have three parameters in the modify properties. First one is the density, with which you can control the number of these grass blades in a particular area. Then with the grass patch size, you can control the radius, or basically the size of the patch of grass. Then you can use this rotate typeset parameter to rotate the blades of grass in the z-axis like this. And the benefit of using this group input node is that you can now control these values directly from here instead of going to the geometry nodes editor each time and understanding each and every node to create any change in the structure. Now we can also control the height of this grass by connecting this new socket to the random value node here, which is connected to the scaling. To increase its height, we basically have to increase the maximum value in the z-axis, because if I increase it, the height of the grass will increase. But if I take this socket, I have to connect it to the maximum socket, which is controlling all these three axes. And to control only the z-axis, we'll be using the combine xyz node. So I'll select this combine xyz node, press shift plus D to create a duplicate and place it over here. Let's change the value of all the three axes to 1, because we'll be connecting it to the maximum socket, which is having a value of 1 in all the three axes. Now I'll take this vector socket and connect it over here, and now I can directly connect this new socket to this z-axis, which will allow us to control the scaling, or basically the height of this grass in the z-axis. To rename it, go to the toolbar, double click on its name, and we'll change it to height. Now from the modify properties, you can directly control the height of the grass from here. Then moving ahead, we also added this multiply node here, which was controlling the bending of the grass. So if you want, you can even connect this one to the group input node, and to do this, let's bring the group input node over here, take out the new socket and connect it to the value. Go to the toolbar and double click to change its name. We'll rename it to bending. And now we have 5 different parameters to control in the modify properties. Now the benefit of doing all this is that we can now create different duplicates of this grass patch and control its appearance directly from here. For this, with this grass selected, press shift plus D, let's move it in the Y direction and place it over here. With this grass patch, I'll reduce its height from here. So let's reduce it to something like 0.7 or 0.6. Let's also reduce its bending to minus 0.3, and let's increase its density from here. Now all the changes that I'm doing here are completely random. It only depends on you that exactly which type of grass you need for your scene. So you can change these settings yourself in order to make the best looking grass. But let's also create another duplicate by pressing shift plus D, move it in Y direction and place it over here. And this time I'll increase its height to something like 0.9 or maybe 1 meters. Let's also increase the bending, and this time I'll be reducing the size of the patch of grass. Let's slightly increase the density also, and now it looks perfect. And now we have 3 different patches of grass with slight variations in each one of them. Now before placing them on our landscape, we first have to create a collection of these 3 grass. For this, I'll select all of them, and to create a new collection with only these 3 patches of grass, the shortcut is to press Ctrl plus G. You can change the name of the collection from here. So I'll rename it to grass. It will basically create a collection where it will store the 3 types of grass that we created. Now coming back to the landscape, if you remember, we distributed these points, or basically these cubes, on the faces of this landscape with the help of these 2 nodes, that is the distribute points on faces and the instance on points. But we'll be placing the grass that we created in place of these cubes. For this, I'll delete this cube node by selecting it and pressing X. And now to connect the collection of grass that we created to this instance socket, we'll be using the collection info node. To add it here, press shift plus A, go to input, and in scene, select the collection info. Let's place it over here. Now to select the collection of grass, click on this collection and select the grass. Now I'll take this instance socket and connect it to the instance. Now let's zoom out, and you can see here that the size of this grass is too high. To fix this, I'll first go to the density and reduce it to something like 0.1. Then I'll go to the scale values and change it in all the 3 axes to a lower number like 0.1 meters. And now here we have the different patches of grass placed at different points in the landscape. Now if I zoom out, you can see here that the position of this grass is not perfect. Some of the patches of grass are lying outside this plane, and to fix this, you simply need to turn on the separate children and the reset children in the collection info node. This will place the grass patches or any other object that you choose only on the plane or this landscape. Now if I go to the camera view by pressing 0 on the numpad, this is how our scene is looking right now. Also you can notice some imperfections. For example, this fence is going below the plane, but we'll be fixing it in the next chapter. But for now, if you want to render it, then to change the camera view, press N, and in the view section, enable the lock camera to view. Now you can change the view of your camera by holding the middle mouse button and dragging your cursor like this. Now to hide that area which is outside the camera view, we'll be changing some settings. So for this, select the camera in the scene collection, and in the object data properties, go to this passive part out option in the viewport display and increase its value from 0.5 to 1. And now we'll be seeing only that area which is inside the camera view. Let's also change the density and the size of this grass. So let's increase the density of grass from the density option over here. But I think that the density at 0.1 looks fine, so we won't be changing it. And for the size, we'll go to these scale values and let's reduce them down to something like 0.05. And now I can increase the density so that our scene is filled with grass. Now if you want, you can also change the color of the base of this landscape. For this, you can go to the material properties, click on the new button and change the base color from here. So if I reduce the brightness and change it to brown color, then our scene would look like this. this. But for now, I'll be removing this material from the base of the landscape because we'll be working on it later on. So click on this minus icon to remove it. Now we can make this scene look better by properly placing this fence and also by adding some rocks, and in this way we can finalize our scene. But we'll be doing all this in the next chapter. So this brings us to the end of this chapter. In this particular chapter, you learned about creating and adding grass on different points of faces on a plane object, and we understood all this with the help of geometry nodes in Blender. In the previous 3 chapters of this course, we created the base of landscape, this simple fence with the wood texture, and even distributed this grass all over the base. And in this chapter, we'll be creating some rocks that we'll place on the base of the landscape, and we'll also be finalizing this scene. And with this, we'll be understanding all these topics in complete detail. So this is how our scene looks right now. We have this simple looking fence and this grass spread over the base of the landscape. Now to create the rocks, we'll first add a cube in our scene and then do the changes in the geometry nodes editor. So first let's go to the solid view, and to add the cube, press Shift plus A, go to mesh and select the cube. Let's move it in the Y direction by pressing G and Y, and let's place it over here. Now we have added this cube in our scene, and to convert this cube into a rock, we'll go to the geometry nodes editor, click on this new button, and now we'll be using the subdivision surface node. So to add the subdivision surface node, press Shift plus A, go to mesh, and in operations, select the subdivision surface. Let's place it over here, and now this subdivision surface is applied on the cube. If you remember, we studied about the subdivision surface modifier in this chapter of the course where we covered all the modifiers in detail, and this subdivision surface node works in exactly the same way as the subdivision surface modifier. Now the reason for adding this subdivision surface node is that we want to turn this cube into a rock, and to create a similar shape, this subdivision surface node will help us. Basically this node subdivides the surface of your mesh and also smooths it out. Now to control the amount of subdivision and the smoothing of your mesh, you have the level option here. So if I increase it, the amount of subdivision will increase, and similarly the smoothing will also increase. So you can see here that if I change the level to a value of 0, we get the original cube. If I increase it to 1, the subdivision will slightly increase and it will look like this. But if I increase the level to 2, the subdivision increases even further and the smoothness also increases. And this is how the level parameter in the subdivision surface node works. Then the next option that you have is the edge crease, and if I increase it, it will basically crease the edges of your mesh object like this. So this option is used to control the creasing effect of the edges, and similarly the third option is the vertex crease, which controls the creasing effect of the vertices of the mesh. And so these are the 3 main options available in the subdivision surface node. Now to give this cube a rock-like shape, we'll be using the extrude mesh node. So press Shift plus A, go to mesh, and in operations, select the extrude mesh, and let's place it over here, and the extrusion is applied to all the faces of the cube. To view the cube properly, for now I'll change the level of subdivision surface back to 0, and here we can see that all the faces of the cube are now extruded. To extrude only some specific faces, we'll be using the compare node and the index node. For this we'll go to the geometry nodes editor, press Shift plus A, go to utilities, and in math, select the compare node. Let's place it over here. Let's also add an index node, and then we'll understand the purpose of adding them. So press Shift plus A, go to geometry, and in read, select the index node. Let's place it over here. Now the purpose of adding this compare node is that we'll be changing its mode to equal, and then we'll connect it to the index node and the result to the extrude mesh, and with that setup we'll be telling the extrude mesh node about the face to be extruded. For this, take the index socket and connect it over here, then take the result socket and connect it to the selection. And now you can see here that only one of the faces is extruded, and to be more specific, the face at the index value, which is equal to the value of B, which is 0, is extruded here. See, the compare node has the mode selected to equal, meaning that it will set the value of A and B equal. As a result, the input will be the face at the index value, because we have added this index node, equal to the value of B, which is 0, and then the result or the output will be the face at the index value of 0. Then it will get connected to the extrude mesh, and as a result that particular face will get extruded. Also, if you want multiple faces to be extruded, then you can change the mode to less than or equal, and if I increase the value of B from 0 to 1, then 2 faces are extruded here. Let's also do one more thing. Right now the data type is selected to float, but as I already told you, the index values are always integers like 0, 1, 2, 3. So I'll change the data type to integer. Let's connect the index node again and change the value of B from 0 to 1. Now since we have set the mode to less than or equal, it will basically apply the extrusion to all the faces whose index value is less than or equal to 1, or simply the faces with the index value of 0 and 1. As a result, 2 faces are extruded here. Now in the extrude mesh node, you can see that you have some option of individual, and it is turned on by default. This option basically controls whether the faces of your object will be extruded individually or not, and if I turn it off, then the faces will no more be individually extruded, and this is how the shape of the extruded cube is looking right now. And now if I go to the subdivision surface again and increase the level back to a value of 2, this is how our rock is looking right now. It looks very simple because we have not applied any distortion or any texture to it. For this we'll be using the Musgrave texture node, and as I previously told you in one of the chapters that in the latest version of Blender, the Musgrave texture is replaced by the noise texture, so we'll be adding the noise texture. So press Shift plus A, go to texture and select the noise texture. Let's place it over here, and to convert this into the Musgrave texture, you simply have to turn off this normalize option. Now since we'll be creating the distortion effect on the vertices of this cube, so we'll also be adding the set position node. To add it here, press Shift plus A, go to geometry, and in the right category, select the set position. Place it after the subdivision surface node, and to distort the vertices, we'll basically be adding this texture effect to the position of different vertices. For this I'll be adding the position node by pressing Shift plus A, and in geometry, go to the read category and select the position. Let's place it over here, and to add both of them, we'll be using the vector math node. So press Shift plus A, go to utilities, and in vector, select the vector math. Let's place it over here, take this position socket and connect it to the vector, and take this factor socket and connect it to the second vector. Now this will add the noise texture and the changes that we do in it to the position of different vertices. And to connect this with the set position node, I'll take this vector socket and connect it to the offset. And now here we have a sharp pointing texture applied to this rock. To control this, simply go to the noise texture and change the scale value. If I change it to 0, you will notice that basically no distortion effect will be applied to this cube. And if I increase it slowly, you will begin to notice slight distortion effect applied to the different vertices of the mesh object. And at a scale value of somewhere close to 1, you will begin to notice a slight rock-like texture. And if you want to give it a more smooth look, you can go to the roughness value and change it to 0. And now this is how the basic structure of a rock is looking right now. Now to give it some material, we'll go to the shader editor and click on the new button. Let's also turn on the render preview mode, and now we'll be creating a basic shader for this rock object. For this we'll be adding the Warner texture in the shader editor. So press Shift plus A, go to texture and select the Warner texture. Let's place it here, and to add the texture coordinate and the mapping node, simply press Ctrl plus T. But as I have told you in the previous chapters, in order to use this shortcut, you must have the Node Wrangler add-on turned on. Now I'll take this object socket and connect it to the vector, and to view the texture over here, hold down Ctrl Shift and left click on the Warner texture. And this is how the basic Warner texture looks on our object. Now this Warner texture will create these spots on the surface of the rock, and to make it look better, we'll be distorting these spots with the use of a noise texture. So go to the shader editor, press Shift plus A, and in texture, select the noise texture. We'll place it just before the Warner texture, and now we get a texture like this, where the spots which were due to the Warner texture are now distorted due to the noise texture. Now if you want, you can try to change the values like the detailing in the noise texture or the roughness from here, but right now the basic shader of the rock is ready. But if you wish, you can also create a realistic looking rock shader by following the steps that I'm gonna do right now. Making a realistic texture for this rock is completely optional for you, but if you want to understand the advanced level of shaders, then you can do that by understanding the creation of this rock texture. So to make it look realistic, I'll go to the shader editor, let's zoom out, place this principal BSDF away, and right now we have connected only this noise texture to the Warner texture to create this distortion effect on the spots of the texture. But now taking a step forward, I'll be combining two Warner textures together to create a much better shader. For this, I'll select the Warner texture, press Shift plus D to create a duplicate, and let's place it over here. Similarly, I'll select the noise texture also, press Shift plus D and drop it here. Just like the above noise texture, this one will also help to create a distortion effect on the spots created by the Warner texture. To combine both the textures, simply take the vector socket of the mapping node and connect it to the vector of the noise texture, then take this color socket and connect it to the vector of the Warner texture, and to get a combined output of both the textures, we'll be using the mix node. To add it here, press Shift plus A, go to converter and select the mix node. Let's place it over here and change the type of data from float to color. Now we'll connect the output of both the textures to the color A and B in the mix shader. For this, I will take this distance socket of the first one and connect it to the color A, then take this one and connect it to the color B. To view the result, hold down Ctrl Shift and left click on the mix shader. And here you can see that we get the same result as before. And that's because all the settings in the second Warner texture and the noise texture are the same as the first ones. To create some variations, go to the second Warner texture and change the feature output from here. If I change it to the second option, this is how the texture will look. Similarly, we'll be checking out all the other options to see which one looks the best. Let's select the third one, and this is how it looks. Then I'll go for the fourth option, which is the distance to edge, and this is the result. I think that right now it has a texture which looks slightly similar to a rock, but if you want, you can change the value of scaling in the noise texture to make it look different. So if I reduce the scaling, the texture will also slightly change, and similarly you can also try to change other values like the roughness in the noise texture or the detailing, but for now it looks perfect. And to give it some grey color, color, we'll be adding a color ramp. For this, let's first connect this principal BSTF to the material output. So I left click on it and place it over here. Now to give it some color, we'll be adding the color ramp. So press Shift plus A, go to converter and select the color ramp. Let's place it over here, and to get a proper color, we'll be changing the position of these pointers and their colors in the color ramp. So first I'll select the black pointer and try to move it, and this is how the texture is looking right now. Similarly, if I select the second pointer and try to move it, you can see how the color in the texture changes. And if I take this white pointer here, where previously the black one was placed, you can see that the basic color is now white and the color of the texture is the black color. And now I'll select the white pointer again and let's change its color to grey color with the help of this brightness slider. Let's also reduce the amount of black color by moving this second pointer, and here it looks perfect. So now we have a simple rock texture applied to this rock object. Now just like any other shader, to give this one a realistic 3D look, we'll be adding the bump node. So press Shift plus A, go to vector and select the bump node. Let's place it over here. Now take this normal socket and connect it to the normal of the principal BSTF, and to get the result of the textures as the input, I'll take this result socket in the mix shader and connect it to the height. And here you can see that the bump effect is applied, but its strength is too high, so I will reduce it from a value of 1 to something like 0.5, and this is how our rock is looking right now. I think that the material of the rock looks perfect, so I'll rename it from here. Let's type rock and press enter, and now this rock material is saved. Now moving ahead, we'll be creating some duplicates of this rock and do some variations in it. To do this, we'll be going to the geometry nodes editor and use a new node, which is the duplicate elements node. To add it here, press Shift plus A, go to geometry and in operations, select duplicate elements, place it after the set position, and we see some changes here. You can notice that the rock has disappeared and there are some points distributed all over the faces. That's because in the domain option here, point is selected. But to view the rock, I will have to change this from point to face, and here we have our cube again. Now to create the duplicates of this rock, you simply have to change the amount in the duplicate elements node. So if I increase it, you see that nothing happens, and that's because the duplicates of this rock have been created, but all of them are placed at the same position as the original rock. In order to move them at different locations, we have to use a set position node. For this, I'll go to the geometry nodes editor, take this set position node, and to create a duplicate of it, press Shift plus D and place it after the duplicate elements node. Now to change the position of the rocks, I'll take this duplicate index socket, which basically carries the index value of different duplicates of the rocks that are created. So if I connect it to the offset in the set position, then now we can partially see the duplicates of the rocks in our scene. And to move them in different positions, we have to use the math node. So press Shift plus A, go to utilities, and in the math, select the math node. Let's place it over here and change the operation from add to multiply. Now if I take the duplicate index and connect it to the value 1, and if I take the value socket of the multiply node and connect it to the offset, then now with the help of this second value, I can control the position of different rocks. So if I increase it, the position will change like this. But another problem here is that these rocks are moving diagonally, and that's because the multiply socket is connected to the offset, which is controlling the offset in all the three axes, the x-axis, the y-axis and the z-axis. But to move it only in the y-axis, we have to use the combine xyz node. So press Shift plus A, go to utilities, and in vector, select the combine xyz. We'll place it over here. Now to control the y-axis, I'll take this value socket and connect it to the y socket in the combine xyz, then take this vector socket and connect it to the offset. And now with the help of this multiply value, I can control the position of these rocks in the y-axis. So let's keep it to something like -15 or maybe -12, so that all of them are visible here. And now let's revise what we did. We added this duplicate elements node to create multiple copies of this rock. Then to change their position, I first added this set position node, and to control the offset, or basically the change in position, we used the multiply node. But then we faced an issue that the rocks were moving diagonally, and to fix this, we added this combine xyz node to control the movement only in the y-axis. And also if you want to increase the number of these duplicates, you can go to the duplicate elements node and change the amount from here. So if I increase it to 4, then now we have 4 copies of the rocks in our scene. Now moving ahead, you can see here that all these rocks are having the same rotation, and that's because these 4 rocks are not different objects, but they are simply the duplicates of the main rock. To change the rotation of each one individually, I first need to convert them into different instances. To do this, we have the geometry to instance node. To add it here, press Shift plus A, go to geometry, and here you have the geometry to instance. Let's place it over here. Now to convert each this into a separate instance, I'll take this geometry to instance and place it before the duplicate elements. And now we have only one rock in our scene. And the reason for this is that in the duplicate elements node, you can see that the domain is selected to face. And in this list, you also have the option of instance. Since we have converted the rocks into different instances, as a result, we have to change the domain from face to instance. And now here we have the 4 rocks back in the scene. And now to rotate each one of these rocks individually, we'll be using the rotate instance node. To add it here, press Shift plus A, go to instance instances and select the rotate instances. We'll place it just before the output, and with the rotation values here in the rotate instances, you can control the rotation of these different rocks. For example, if I go to the rotation in the x-axis and change it, then these rocks will begin to rotate in the x-axis like this. Similarly, if I go to the rotation in the y-axis and change it, they will begin to rotate in the y-axis like this. And similar is the case with the z-axis. But to give each one a random rotation, we have to use the random value node. To add it here, press Shift plus A, go to Utilities and select the random value. Let's place it over here, and by default, the data type in the random value node is selected to float. But here in this list, you can see that we have different options. Since we want to control the rotation, so I'll be selecting the vector and then take this value socket and connect it to the rotation. And now a random value is connected to the rotation of the rotate instances, and you can see that each of these rocks are now having a different rotation in the x, y and z axis. To control this rotation, go to the random value node and change the maximum values. If you want that these rocks should not rotate in the x and y axis differently, then you can change the values in the x and y axis to 0, and then they won't get any random value of rotation in the x and y axis and will rotate only in the z axis. To control the rotation in the z axis, go to the maximum value in the z, and if I increase it, the rotation of all the rocks will change. So let's keep it to a value of somewhere near 10, and this is how the rotation looks right now. All the 4 rocks are having different rotations in the z axis. Now, just like this rotate instances node, you also have a scale instances node using which you can change the scaling of different rocks. To add it here, press Shift plus A, go to instances, and here you have the scale instances. Let's place it over here, and this scale instances is very similar to the rotate instances, and the only difference is that this one is used to control the scaling of the rocks. To scale them randomly, we'll be adding a random value node. So I'll select this one, press Shift plus D to create a duplicate and place it over here. Now take this value socket and connect it to the scale, and the rocks will disappear because the maximum scaling in the x and y axis is set to 0. So I'll select both of them and change it to 1. Let's also change the scaling in the z axis back to 1. Now to view the changes properly, I'll go back to the solid mode, and here you can see that all the 4 rocks are now having different scale values, and also this one is very small as compared to the others, and that's because the minimum scaling value is set to 0, which means that the scale instances node will provide random scaling values to all the 4 rocks, which will range from a value of 0 to 1 in all the 3 axes. But to give it a better scaling, I will select the minimum values and increase it slightly, like if I change it to 0.4, and also the maximum values, if I change it to something like 0.6, then now all these rocks will have a random scale value which can be anything between 0.4 and 0.6. Now in order to get a proper scaling of these rocks, I will be placing them in the landscape that we created here. For this, we'll go to the top view by pressing 7 on the numpad, and here we have these rocks, and this is the plane. To move these rocks to the plane, press G and Y, and let's place them over here. Left click to finalize, and now here are the 4 rocks placed on the base of landscape. Now to view them properly, we'll go to the camera view by pressing 0 on the numpad, and here we have one of the rocks placed. Now to view all of them properly from the camera view, we have to do some changes. For this, I'll go to the top view, and we'll be bringing all of these rocks closer to each other so that they're properly visible from the camera view. To do this, we need to reduce the distance by going to the geometry nodes editor, and we'll be changing the multiply value here. So if I change it, you can see that the distance between these rocks will begin to change, and they are now closer to each other. Let's also rotate them by pressing R and rotating them like this. Press G to move them, and let's move it to somewhere near the middle of the base. And this is how the rocks are placed in our scene right now. If I change the angle and view below the plane, you can see here that some of the rocks are not properly placed. To fix this, press G and Z and move them upwards, but now the other ones have moved slightly more upwards. To fix this, we'll rotate them. So press R and X and rotate it like this, then press G and Z to move them downwards. And now if I go to the camera view by pressing 0 on the numpad, you can see that at least 3 of the rocks are visible in the scene. To get a proper view, I will zoom out in the camera view, and this is how our scene is looking right now. And here I feel that the size of these rocks is a bit too high, so I will go to the minimum values and reduce it to something like 0.25, and also the maximum values to something like 0.35 or 0.4. Let's move them downwards again by pressing G and Z, and let's place them here. Now the rocks are properly placed in our scene, and so we'll be moving ahead to fixing the fence in the scene. If I come out of the camera view by pressing 0 on the numpad, then you can see on the base of the landscape that the fence that we created is not properly visible. First of all, its size is very small, and also some part of the fence, like this one, is going below the base of the landscape. And to fix this, simply select the fence, tab into the edit mode, press A to select all, and we'll be deleting all of them and then create some new fence. So press X and select delete segments. To create new fence, go to the top view by pressing 7 on the numpad, and let's zoom out. Now to create the fence, we have to use the draw tool, which is here in in the toolbar. So we have to select it, and to draw the curve, simply left click, and if I drag my cursor and then release it, you can see here that it has formed this fence in our scene. But now also you can observe that it's not completely perfect. The fence at this part is clearly visible, but the one on the left hand side is hidden below the plane. As a result, it's not visible. And to fix this problem, I'll again go to the top view by pressing 7 on the numpad. Let's zoom out and press X to delete all. Select the delete segments. Now let's understand a very basic thing. The result that we want to achieve is that we'll draw the fence and it should appear on the surface of the plane. But instead of that, whenever we are drawing on the plane, it does not take the surface into consideration. For this, press N, and here in the tool category, you have this option of depth. It is by default selected to cursor, and that's why we were facing this problem. But if I change it to surface, and now whenever I draw the fence, it will basically lie on the surface. To check this, left click and drag your cursor like this, and a fence is drawn here. And if I change the angle to view it, let's also zoom in, and here you can see that this fence is now taking the surface into consideration, and it is also bending according to the surface of the plane. And this is the use of the surface depth option here. However, if you look closely at some parts, you will notice that it's still not perfect. Here on the left hand side, the entire fence is visible, but at this part you can see that it's again falling below the plane, and that's because we have not applied much subdivision to this plane. And to fix this issue, go to the tool properties here, and here you have an option of tolerance. And to fix the problem of aligning the fence to the surface, you basically have to reduce the tolerance to a very low value. So I will reduce it to something like 1 or 2. Let's go to the top view again, press X to delete all, and select delete segments. And now if I again draw the curve, or basically the fence, by left clicking and dragging like this, and if I change the angle, let's also zoom in to get a better view. And here you can see that this time the entire part of the fence is lying above the surface of the base. Now even though it's properly aligned with the surface of the landscape, at some areas you will notice that the fence is not properly positioned. Like here you can see that the fence appears like this, and that's because along with considering the plane, it's also considering the grass, and that's why when I tried to make a fence over it, the fence got placed like this. And to fix this issue, we again have to delete the entire fence by pressing X and selecting delete segments. And before drawing the fence again, I will remove this grass temporarily from the scene. To do this, come out of the edit mode, select this plane, and here in the geometry nodes editor, if I break the connection between the collection info node and the instance to remove the grass temporarily, then now we have no grass in the scene, and so we can easily place our fence. And now to create the fence, go to the top view again by pressing 7 on the numpad, select the Bezier curve from the scene collection, tab into the edit mode, and now we can draw the fence. So simply left click and drag your cursor like this, and now let's view the fence by zooming in, and this is how our fence looks right now. Let's also go to the camera view by pressing 0 on the numpad. Let's also turn off the draw tool, and here the camera to view option is enabled, so if I will zoom in or zoom out, the camera view will also change accordingly. And you can see here that we now have these rocks in the scene and also this fence that we created, and it might be possible that you want to increase the height of this fence so that it is properly visible from the camera view in your scene. And to do this, simply go to the geometry nodes editor, then in the scale value here, we'll increase all the three to something like 0.25, and now here we have the fence scaled up in the scene. And if you want to increase the distance between the two fence parts, for this you can go to the resample curve, and if I increase the length, you will notice that the distance between the two parts of the fence will increase. Let's keep it to somewhere near 0.25 or 0.3, and here it looks perfect. And now to view the grass here, come out of the edit mode, select the plane, and connect the collection info node to the instance on points. And so here we have the grass that we created back in our scene. To view them properly, let's fix the camera view, so I will adjust it properly to get a better view of the scene. And here it looks perfect, so I will finalize this, and this is how the scene looks right now. Let's also turn off the lock camera to view, so that if I adjust the view, the camera view does not change. For this you can either click on the lock button or you can press N, and in the view option, here you have the lock camera to view. Now moving ahead, you can see that the rocks that we have placed here are not shaded smooth, and to make them smooth, I will select them, and here in the geometry nodes editor, just before the output, we'll be adding the set shade smooth. So press Shift plus A, go to mesh, and in the right category, select the set shade smooth. Let's place it over here, and now we have made the rock smooth. Now let's come out of the camera view by pressing 0 on the numpad, and here you can see that some part of the fence is getting out of the plane. And to fix this, simply select the fence, tab into the edit mode, and we'll be selecting all these segments that are placed outside the plane. For this, simply left click and drag your cursor like this, and here some of them are left out, and to select them together with the others, simply hold down the shift button, and then I can select the remaining ones. Let's also select this one. Now to delete them, press X and and select delete segments. And here the fence is now fixed. Let's also go to the other part of the plane, and here also you can see that some part of the fence is lying outside the plane. To fix this, let's zoom in and we'll select these segments and delete them. So left click and drag your cursor like this, press X and select delete segments. And now we have deleted that part of the fence. And with this, our scene is also almost ready. To finalize it, let's first come out of the edit mode and go to the camera view by pressing 0 on the numpad. Let's also turn on the render view to see how the scene looks. And here you can see that we have each and everything properly placed in the scene, but still there are a few things which we need to do in order to finalize this scene. For example, the bigger part of the fence that we use for the texture has to be hidden while rendering, so I will select it and in the scene collection, click on this camera icon. Now this cross on the camera will appear, meaning that this object won't be shown in the final render. And if you don't want to see it even in the viewport, then you can click on this I button. Now each and everything looks perfect except for the ground or the base of the landscape. In order to give it some material, I will select it, and if you remember, we created a simple sand shader in this chapter of the course. So we'll be using that shader to give some material to this ground. For this, I'll change this shader editor in the asset browser by clicking on this icon and selecting the asset browser. We learned about the creation of different shaders or materials and also about saving them in your own library in these chapters of the course. Now to view only those materials that we ourselves created, click on this drop down menu and select user library. And here you can see that this is a sand shader that we created. So I will select it and drop it on the plane. And now we have the sand shader applied to the base of the landscape. However, one thing to notice is that the shader that we have applied is actually a sand shader and not a soil shader. And as we all know that since we have added a lot of grass in the scene, the base should have soil instead of sand. To fix this, we'll go to the shader editor and change its color. So click on this icon and open the shader editor. And here you can see that in the mix node, we combine these two colors to form the color of the sand. Let's also do one more thing. I'll duplicate this material so that whatever changes we make can be saved as a separate shader. For this, go to the duplicate button, and if you want to scroll like this, simply hold down the middle mouse button and drag your cursor like this. And here we have the duplicate material button. So I will click on it and let's change the name of this material to soil. Now to make it look like real soil, I'll go to the color A and we'll change it to brown color. For this, let's reduce the brightness with the help of this brightness slider and change it to brown color. Now the reason why it appears purple is that in the color B we have applied the purple color. So let's click on it and let's change it to red color or maybe a mix of orange and red. And this is how the soil looks right now. You can combine different colors together if you want to change the color of your soil. And also, if I zoom in, you can see here that it actually looks like real soil. The material is properly applied with a perfect texture, and with this our scene is almost perfectly ready. If you want to make it look different, you can increase the grass in your scene. For this, select the plane, go to the geometry nodes editor, and here you have the density option in the distribute points on faces. So if I slightly increase it, the density of the grass will increase like this. And here I think that it looks perfect, so we'll finally render it. In order to render this image, click on the render button and select render image. And here the image is finally rendered. It will take an average time of somewhere near 5 to 10 seconds to render based on your PC specifications. And you can check that time from here. For me, it took somewhere near 9 or 10 seconds and generated this output. And one thing to note here is that we are using the Eevee render engine, and that's why it's so fast. But if I close this and change the render engine from Eevee to cycles and then go to the render option and select render image, then now it will take much more time to render. But for now, we'll keep it to Eevee only. So I will close it and change the render engine back to Eevee. And yes, if you want to improve the quality of your render, you can change the sampling in the render. By default, it is set to 64, which is usually perfect for rendering in Eevee. But if you want, you can increase this value to get better results, but with more rendering time. For now, I will keep it to 64 and go to the render option and click on render image. So we have rendered the image, and if you want to save it, click on the image button, and here you have the option of saving it. And yes, this brings us to the end of this chapter. From the next chapter, we'll begin with understanding some new geometry nodes, and by using them, we'll be creating this house in Blender. In this chapter, we'll be understanding all these topics in complete detail and we'll be using them to create this simple looking house in Blender. So the first topic of today's chapter is understanding the raycast node. For this, I'll first open the geometry nodes editor from here, and to understand the raycast node, I'll first delete this cube by pressing X, and we'll be adding a Suzanne or the monkey model. So press Shift plus A, go to mesh and select the monkey model. Now to work on the geometry nodes with this monkey selected, go to the geometry nodes editor and click on this new button. And also I'll be adding a plane in my scene by pressing Shift Shift plus A, going to Mesh and selecting the plane. Let's move it upwards by pressing G and Z and place it over here. So now we have a Suzanne model and a plane placed over it. Now to use the Raycast node, go to the Geometry Nodes editor and click on this new button. And before using the Raycast node, we'll first subdivide this plane to see the changes in a better way. For this, go to the Geometry Nodes editor and we'll be adding the Subdivision Mesh node. So press Shift plus A, go to Mesh and in Operations, select the Subdivide Mesh. Let's place it over here. Now we have applied the subdivision to the mesh. Now suppose you want that instead of the vertices of the plane, you should be seeing some instance object such as a cube. For this, we'll be adding the instance on points. So press Shift plus A, go to Instances and select Instance on Points. Let's place it here. And to place the cube at the position of the vertices of the plane, we'll add the cube node. So press Shift plus A, go to Mesh and in Primitives, select the cube. Let's place it over here. And to connect it to the instance, take this mesh socket and connect it to the instance socket. Let's reduce their size to see them properly. So go to the scale option here, select all three and let's change it to something like 0.5 or 0.4. And here you can see that now we have these 9 cubes placed as instances on the vertices of the plane. And suppose you want to increase the number of these cubes, for this you can go to the subdivide mesh and increase the levels from here. Let's further reduce their size so that we can increase the number of these cubes even more. So go to the scaling again and let's change it to 0.1 this time or maybe 0.2 and increase the level from here. Now the levels in the subdivision is set to 4 and it looks as if we again need to reduce their size so that they're properly placed. So go to the scaling option again, select all the three and let's reduce it to 0.1 or maybe 0.08 and this looks perfect. So we simply added a plane and to place these cubes on the vertices of the plane, we added this instance on points and connected the cube to the instance. Then to control the number of these cubes, we used the subdivide mesh. But the main reason for doing all this was to understand the Raycast node. So we'll add it here by pressing Shift plus A, going to Geometry and in Sample, select the Raycast node. Let's place it over here and this is how the Raycast node looks. Now as the name suggests, it basically casts rays from one object to another. So suppose I want that the rays should be casted from the cubes of the plane onto the Suzanne model. So in this case, the target geometry that you can see here will be the Suzanne model. As a result, I'll go to the scene collection, left click on the Suzanne model and drag it over here. Now here is the object info node with the Suzanne model selected and we'll connect it to the transform geometry. So take this geometry socket and connect it over here. And now here you can see that we have some output options and the first one is named is hit. And to view how it works, we have to take this socket and connect it to the selection socket of the instance on points. And here we see some changes. Now as I already told you, the Raycast mode will basically cast the rays out of the different cubes towards the monkey object. And with this is hit option selected, it will only display those cubes whose rays will actually reach the target object, which is the Suzanne. To understand it properly, go to the top view by pressing 7 on the numpad, and if I zoom in and turn on the relative option here in the object info node, then now you can see that only those cubes are visible which are aligning with the top structure of the Suzanne or the monkey model. To understand it in an even better way, go to the front view by pressing 1 on the numpad. Let's zoom out, and here in the toolbar you can see that I have this annotate option. So I'll select this, and if I hold the left mouse button, then you can see that I have an option of annotate line. So I will select this, and yes, whatever steps I'm doing right now, you don't need to repeat them in your file, as I'm doing this only for explaining it to you. And here you can see that if I zoom in and let's adjust the view properly, then here you can see that if I draw this line, then it will fall on this monkey object. Similarly, this is also true for all the other cubes that are visible right now. And if I change the view to the side view by pressing 3 on the numpad, then here also you can see that if I draw a straight ray out of the cube, then it will fall on the surface of this monkey. But if I break the connection in between the raycast and the instance on points by holding the control button, right clicking and dragging like this, then some more cubes are visible. But if I draw a ray out of it, then you can see here that this ray is not touching the Suzanne or the monkey model. Similarly, if I go for this one and make a ray out of it, then this one is also not touching the Suzanne or the monkey model. And this was the reason why when I was using this raycast node, these particular cubes were not visible. If I connect it again using the is it option, then you can see that they will disappear. So in simple words, you can say that by using the raycast node, you will be able to see only those cube objects whose rays will reach the target object, which is the Suzanne. Now for deleting these annotations, again I'll go to the toolbar, hold down the left mouse button on the draw tool and select the annotate eraser, then left click and drag to remove it. And now let's go back to the select mode. So we just learned about the is hit socket, and the next one that is available here is the hit position socket. And you can use this to place these cubes on the surface of the Suzanne model at those points where the rays hit the Suzanne model. To understand it better, we'll be adding a set position node after the subdivide mesh node. So press Shift plus A, go to geometry, and in the right category, select the set position node, and let's place it after the subdivide mesh node. So if I take the hit position socket and connect it to the position socket of the set position, then here you can see that these cubes will get placed on the surface of the Suzanne or the monkey model. And now we can use the same method method to make the rooftop of a house. For this, we'll be adding a cube in the scene, so press Shift plus A, go to Mesh and select the cube and place it over here. Press G and X to move it in the X direction. Now Blender gives you an option to assign the geometry nodes of any object to some other object. For example, the geometry node system of these cubes placed over the Suzanne model is saved here with the name of geometry nodes.001. And if I select this cube, click on this new button, and then if I click on this icon, then here you will find the list of all the geometry node systems that are present in the scene. And if I choose the geometry nodes.001, then this particular node system will get applied to the cube. But the reason why we can't see anything here is that in the geometry nodes editor, the target geometry of the raycast is connected to the object info node, which is carrying the information about the Suzanne model. To connect the cube here, I will first delete this object info node by selecting it and pressing X, and then I'll take this group input, which is carrying the information about the cube that we added, and connect it to the target geometry. Now you can see these small cubes placed here because of the recast node and the instance on points, but suppose you want to see the actual cube. For this, I'll break the connection in between the group input and the raycast, and then I'll take this geometry socket of the group input and connect it to the group output. And now here we have the cube back in the scene. And now to give it a simple structure of a house, I'll tab into the edit mode, press 3 for the face select mode, and then I'll select the top face. To make the basic rooftop, I will extrude this face by pressing E, and let's move it in the Z direction like this. Press S to scale it down. Let's move it slightly downwards by pressing G and Z, and here it looks perfect. Now let's come out of the edit mode, and to see the effect of the raycast node, I'll take this geometry socket and connect it to the target geometry of the raycast node, then take this instances and connect it to the output. And now here we have the cubes placed as instances on the rooftop and the base of the house, and you can control the number of these cubes from the level in the subdivide mesh. Here I've set the value of level to 1, and it appears like this right now. But in order to make the rooftop, we need to make some roof tiles like this, and since its shape looks semicircular, so I'll be adding a circle in my scene and will delete it by half. To do this, let's go to the top view by pressing 7 on the numpad, press Shift plus A, go to Mesh and select the circle, press G and X to move it here, tab into the edit mode and press 1 for the vertex select mode. And now we'll delete the bottom half of it. So select these vertices by left clicking and dragging like this, and press X to delete. Select delete vertices, and now to scale it down, we first need to place our 3D cursor over its pivot point, and for this, first come out of the edit mode, hold down Shift plus S, and the snap menu will appear and select snap cursor to select it. And now here we have the 3D cursor placed over this point. Let's again enter the edit mode by pressing the tab key, and now to scale the circle around the 3D cursor, we have to change the pivot point from this icon to the 3D cursor. So I'll select this, press A to select all the points, and to scale it down, press S and Y and scale it down like this. Left click to finalize, and now to make the complete tile, we'll be extruding them in the Z axis. So press E and Z and move it upwards. Left click to finalize. To view it properly, let's rotate the object properly. So press A to select all the vertices, press R, and we'll rotate it in the X axis, so press X, and if I move my cursor, then you can see here that instead of rotating about its center, or basically the median point, it is now rotating about the 3D cursor. This is because in the pivot point option here, we have selected the 3D cursor, and to rotate it in X axis by 90 degrees, press R and X and type 90, press enter to confirm, and this is how it looks. In order to give it some thickness, let's come out of the edit mode, go to the modify properties, click on add modifier, and in the generate, select the solidify modifier. So you can control the thickness from here, and if I increase it, you can see that the thickness will increase outwards, and if I reduce it, the object will get thickness inwards. And here at a value of somewhere near minus 0.168 meters, it looks fine. And now we'll be replacing the cubes that were present at the rooftop with this roof tile that we created. For this, select the cube in the scene collection, and here in the geometry nodes editor, I'll delete this cube node by selecting it and pressing X. Then to add the roof tile here, select the circle in the scene collection, left click and drag it here, and now we can connect it using the geometry socket. So I'll take it and connect it to the instances, and now here we have the roof tiles in place of the cubes here. Now the rotation is not correct, so we'll be fixing it later on, but in order to see both the roof tiles and the house together, we'll be adding the join geometry node. So press Shift plus A, go to geometry and select the join geometry. Let's place it over here and connect the group input to the geometry socket. So here we have the house with these roof tiles placed as the instances. Now if you remember, we added a plane above the Suzanne model to cast the rays on it in order to place the instances. Similarly, for this house also we'll be adding a grid or a plane in order to place the roof tiles. To do this, go to the geometry nodes editor, press Shift plus A, go to mesh, and in primitives, select the grid. Let's place it here, and to view it, hold on Ctrl Shift and left click on the grid. And now here we have the grid added in the scene. And now to scale it up, we'll use the size options here in the X and Y axis. So I'll select both of them, and let's increase it to something like 3 or 4, and to move it upwards so that it's above the house, we'll be using the transform geometry node. So press Shift plus A, go to geometry geometry, and in operations, select the transform geometry. Let's place it over here, and you can use the translation in the Z axis to move it upwards. Let's keep it to a value of somewhere near 3, and this is how it looks. Now to give it some more vertices, you can use the vertices option here, and to see those vertices, click on this drop down arrow, and in the geometry section, turn on the wireframe. Now here you can see that we have 4 faces, and if I go to the vertices option here and increase the vertices in the X and Y axis to something like 10, then now the number of faces and the vertices will increase like this. Now since we have basically subdivided our plane by using the vertices option here, we no more need the subdivide mesh node. So I will select it, and to remove it from here, hold down Alt, left click and drag it away. And now to see the house with the roof tiles placed according to the rays coming out of this plane, we have to connect the geometry socket in the transform geometry node to the geometry socket of the set position node. And in order to see the result, I'll select this viewer node, press X to delete it, and now here we have this house with these roof tiles. Now before proceeding further, let me explain to you what all we did here. This will help you to revise the function of all the nodes that we have placed here. See, the group input node is carrying the information about this cube which we used to create the house in the scene. Then we connected it to the raycast as the target geometry so that the rays of the plane will fall on it, and then we can place these roof tiles as the instance on it. Then we took this hit position socket and connected it to the set position, and we took the is hit socket and connected it to the selection in the instance on points. The use of adding the instance on points was to place the roof tiles as the instances on the rooftop of the house. As a result, we connected this instance socket to the object info node with the circle selected which we used to create these roof tiles. Then moving ahead, we used the join geometry node in order to see both the roof tiles and the house in the scene. Then we added a plane by using the grid node, because in order to use the raycast node, we needed an object whose rays will fall on the house, and accordingly these roof tiles will be placed. Then we connected it to the transform geometry in order to move it upwards, and this was then connected to the geometry socket in the set position in order to connect it to the rest of the node system. Now moving ahead, you can control the number of these tiles from the vertices option here. For example, if I select them and increase it to a higher number like 12, then the number of these roof tiles will increase, and to fix its rotation, I'll go to the instance on points node, and here you have the rotation option. To make it perfectly aligned, we'll be connecting it to the align Euler to vector node, about which we learned in one of the previous chapters of the course. To add it here, press Shift plus A, go to utilities, and in rotation, select align Euler to vector. Let's place it over here and connect the rotation socket to the rotation in the instance on points. Now to control the rotation, we'll be connecting the normal node to the vector socket here. So press Shift plus A, go to geometry, and in read, select normal. Let's place it over here and connect it to the vector. Now let's understand about exactly which axis to align along the vector. So here you can see that the roof tile that we created is lying along the Y axis, and here on the rooftop of the house, in order to keep them straight along the Z axis, we have to align them in the Z axis. For this, go to the align Euler to vector, select the Y axis here, and in the pivot option, select the Z axis. Now what this basically will do, it will align the Y axis of the object along the Z axis. To understand it better, let's first increase the size of these roof tiles by going to the scale option in the transform geometry node, and let's increase it in all the 3 axes to something like 0.12, and to control their rotation, we'll be adding the transform geometry node. So press Shift plus A, go to geometry, and in operations, select the transform geometry. Let's place it after the object info node, and from the rotation options here, you can control the rotation of these roof tiles. So if I rotate it in X axis, you can see that they rotate like this. In order to make them look straight, I'll reduce the rotation in the X axis to a value of somewhere near minus 60 degrees, and the roof tiles look like this right now. And to make it look better, we'll be increasing their number from the vertices option in the grid node. So I'll take the vertices in the X and Y axis and increase it to a higher number like 30 or maybe 35, and this is how it looks. Now moving ahead, we'll be adding some windows to the house, and for this, go to the geometry nodes editor and add the cube node. So press Shift plus A, go to mesh, and in primitives, select the cube. Let's place it over here, and to view it in our scene, simply hold down Ctrl plus Shift and left click on the cube node. In order to increase the number of vertices in the cube, we'll be using the subdivide mesh node. So press Shift plus A, go to mesh, and in operations, select the subdivide mesh. Let's place it over here, and you can control the number of subdivisions with the help of this level option. But for now, we'll keep it to 1. Now to extrude the faces of this cube, we'll be adding the extrude mesh node. So press Shift plus A, go to mesh, and in operations, select the extrude mesh. Let's place it over here, and this will extrude all the faces of the cube like this. And to control the extrusion, go to the offset value here, and let's reduce it. And now suppose you want to scale scale down these extruded faces individually and to create an inset effect. And to do this we have to use the scale elements node. To add it in the geometry nodes editor, press Shift plus A, go to mesh, and in the operations select this scale elements node. Let's place it over here. But right now if I go to the scale value and try to increase or decrease it, you can see that the scale of entire object is changing. But now suppose you want to scale only the extruded faces, then for this, here in the extrude mesh node, you have the top socket here. And if I connect it to the selection in the scale elements, then now I can control the scaling of only these extruded faces. Now in order to make it look like a window, first let's reduce the extrusion back to 0, and here you can see that we have these faces on the cube, and the size of these faces can be controlled from the scale option in the scale elements. So you can increase it or reduce it as per your own choice. Now since we are making the windows, as a result we need to extrude these faces that are formed here inwards, and to do this we'll need another extrude mesh node after the scale elements. So I will select this one, press Shift plus D to create a duplicate and place it over here. But if I try to increase the extrusion from here, you will notice that all the faces will get extruded. But in order to get only the top extruded faces, I'll again take this top socket and connect it to the selection. And now if I change the extrude value, you will notice that these top faces will get extruded like this. Now in order to make the window, I need to extrude these faces inwards. For this, I'll take this extrusion value in this extrude mesh node to a negative number like minus 0.1, and now it looks like this. So whenever you have to extrude the faces inwards, you have to insert a negative value here, and to extrude the faces outwards, you should have a positive value. Now here you can see that these windows are visible on all the 6 faces of the cube. But suppose I need these windows to appear only on this face and the face on the back of it, that is this one. And for this, I need to connect something which carries this information about these 2 faces in the selection socket of the extrude mesh node here. And to do this, I'll be adding 2 nodes. One of them is the normal node, which we even added here and connected it to the align Euler to vector, and the other one will be the compare node. So we'll add it and understand them in detail. So press Shift plus A, go to geometry, and in read category, select the normal. Let's place it over here. And to add the compare node, press Shift plus A, go to utilities, and in math, here you have the compare node. We'll place it over here. And now let's understand the normal node. So the normal basically means perpendicular of a face. For example, for all the faces on the top of the cube, the normal will be in the direction perpendicular to them, or basically meaning the z-axis. To explain it in a better way, I'll go to the annotate tool and turn on the annotate line. Now see, if I draw the perpendicular to these faces, it means that they will form an angle of 90 degrees with the face, and this is how they will look like. And as you can clearly see, the perpendicular to these faces is in the z-axis. Similarly, for these faces, the normal or the perpendicular will be along the x-axis, and for these faces, the perpendicular or the normal will be along the y-axis like this. And this is the definition of normal. It simply means perpendicular to a face. Now I'll remove these annotations by pressing Ctrl plus Z. Let's go back to the select mode from here, and now this normal node basically acts as an input which is carrying the information about the normals of different faces. And here you have the compare node, and we discussed about it in one of the previous chapters of the course, where I told you that it takes 2 values in the value A and value B and compares them according to the operation selected here. If I select the equal operation and connect the normal to the value A, then it basically means that it will check for each value of normal, and whenever the normal will be equal to the value of B, which is 0, that will be returned as the output from the result socket. And here you can also see the input type to be selected. For example, float, integer, vector. But since we have a normal node here, we need the input type to be vector instead of float. And this is because the normal depends on the directions, that is the x, y and z axis. And you must also have learned this in your school, that vector quantities basically have a magnitude and a direction. And therefore we selected the input type in the compare node to be vector. Now I'll take this normal socket and connect it to the value of A, and here you have the value of B, which you can compare with the normal. And now suppose you want that the window should be visible only on this face. For this you have to check the normal of these faces, and as I already told you, the normal will basically be the perpendicular line from these faces. And you can clearly see here that the perpendicular of these faces will lie in the y-axis like this. But another thing to check is that if this y-axis is positive or negative, and you can confirm it from here, where you can see that in this direction it is pointing the positive y direction, and if I take my cursor over here, then here you have the negative y-axis, meaning that this side is positive and the opposite side, that is this one, is the negative y-axis. Similarly, you also have other axes like the x-axis and the z-axis. So in case of x-axis, this one is positive and this one is negative. Now I'll remove all this by pressing Ctrl plus Z 6 to 7 times and click on the select mode again. To see the extrusion effect to be applied only on these faces, I'll go to the value B, and here you can see that this one controls the x-axis, the second one will control the y-axis, and the last one will control the z-axis. So I'll go to the y-axis option and change it to 1, and the reason for entering 1 is that it's in the positive direction. If it had been in the negative direction, I would have entered -1 in the y-axis. And now I'll take this result socket and connect it to the selection in the extrude mesh node. And now you can see that these windows or the extruded faces are appearing only on this side of the cube, and this is because of the normal node and the compare node. Now moving ahead, suppose you want that these windows should also appear on these faces at the back. So for this, you can see that the normal is in the negative y-axis this time. So I'll go to the geometry nodes editor and we'll be creating a duplicate of these nodes by selecting both of them, pressing Shift plus D, and let's place it over here. And this time I'll change the value of B in the y-axis to -1. But if I try to connect it using the result socket to the extrude mesh through this selection socket, then although the windows will appear on this face, but they would disappear from this face of the cube. And that's because the selection socket can only accept one input at a time. And to assign multiple inputs to the selection socket, we have to use another node, which is the Boolean math node. To add it here, press Shift plus A, go to utilities, and in math, here you have the Boolean math node. So I'll select this and place it over here. Now in this Boolean math node, you have two input sockets named as Booleans and an output socket which is again named as Boolean. And by using this node, I can connect the result sockets of both the compare nodes in the Boolean inputs, and if I take the output and connect it to the selection, then this will create a connection between them. But another thing to notice here is the AND operation selected here, and this thing will basically mean that it will check if the result from this compare node and the result from this compare node are equal or not, and only if both of them are equal, then in that case it will give the output. But as we already know that both of these compare nodes are having different values, the first one is having +1 in the y-axis and the second one is having -1 in the y-axis, and as a result, when it compares both of them with this AND operation, the condition won't be satisfied and no output will be given, and that's the reason why you can't see the extrusion effect on any of the faces. And to fix this, we'll change the operation from here, and if I select the OR operation, then this thing will basically mean that first it will check if the normal in the positive y-axis is true, and then it will check the second one whether the normal in the negative y-axis is true or not. And since both of them exist, it will return the output that both of the conditions are true, and therefore we'll be able to see the extrusion effect applied to the faces on both the sides. And this is the use of the Boolean math node. Now moving ahead, in order to make this window smaller in the y-axis, we'll go to the cube node which is placed here and reduce the size in the y-axis. So let's reduce it slowly, and at a value of somewhere near 0.2 or 0.25, the structure of our window looks perfect. So in this way we understood about the Boolean math node and its working in the AND as well as the OR operation. See, previously when we selected the AND operation, the reason why we didn't get any output is that with the AND operation, it will give an output which will satisfy both the conditions. However, in this case, the first condition was that the normal should be in the positive y direction, and the second condition was that the normal should be in the negative y direction. As a result, both the conditions couldn't be fulfilled simultaneously because both of them are completely different, and therefore we didn't get any output. But with the OR operation selected, it will check both the conditions, that is whether the normal is in the positive y axis in the first case and in the negative y axis in the second case, and will return the output based on which one is true. And in this case, since both of them were true, as a result we got these extruded faces or the windows on both of these faces. Now moving ahead, we'll be placing this window on different faces of the house that we created, and here in the 3D viewport you can also see that the house that we created is not visible, and that's because we are using the viewer node here which is connected to this window. To view the house in my scene, first I'll delete this viewer node by pressing X, and here we have the house in our scene. Let's also connect this extrude mesh node which is carrying the information about the window that we created and connect it to the joint geometry. Now to view the windows on different points or different faces of the house, we'll be using the instance on points node. So press Shift plus A, go to instances and select the instance on points. We'll place it after the extrude mesh node, and since the window object is to be used as an instance to be placed at multiple points, we'll break this connection and connect the mesh socket to the instance socket. But the reason why we can't see anything here is that we have not added any input in the point socket, and here we need to add the input which is carrying the information about this house. For this we'll be using this group input node, and if I take the geometry socket and connect it to the points, then now here we have these windows placed at different points of the house. Now moving ahead, before fixing this house, let's learn about another node which is the mesh boolean node. This node is exactly similar to the boolean modifier about which we studied in this chapter of the course. To understand it again, we'll first add the mesh boolean node here. So press Shift plus A, go to mesh, and in operations select the mesh boolean. Let's place it over here, and now here you can see that you have option to add mesh 1 and mesh 2, and here it's also visible that mesh mesh 1 can take only one input, but the socket of this mesh 2 is oval in shape, meaning that it can take multiple inputs. Then from here, you can control the operation such as the difference, union and intersect, which is exactly the same as in the Boolean modifier. With the difference option selected, we'll be adding two mesh objects in the geometry nodes editor and connect it here. So the mesh 1 will be a cube. To add it, press Shift plus A, go to mesh and in primitives, select the cube. Let's place it over here. Let's also connect it to the mesh 1. And now for the second mesh, we'll be adding a sphere. So press Shift plus A, go to mesh and in primitives, select the UV sphere. Let's place it over here and connect it to the mesh 2. To view the output here, hold down Ctrl and Shift and left click on the mesh boolean node. Now the reason why you can't see anything here is that by default, the size of the cube is set to 1 meters, which is small. And if I change the size in all the three axes to something like 1.25 meters or maybe 1.5 meters, then now here you can see that this strange looking structure of cube will appear. To understand it properly, let me explain it to you with the help of the Boolean modifier. For this, let's first bring the 3D cursor on the selected object by pressing Shift plus S and select this cursor to selected. Then we'll add a cube and a UV sphere just like we added in the geometry nodes editor. So in the 3D viewport, press Shift plus A, go to mesh and select the cube, press G and X to move it here. Now the reason why that structure disappeared is that whenever I do any changes in the 3D viewport, the viewer node will get turned off here and only that output will be seen, which is connected to the group output node here. To fix this, we'll be connecting the mesh boolean node to the group output. So let's connect it here. And now in the 3D viewport, let's also add a UV sphere. So press Shift plus A, go to mesh and select the UV sphere, press G and X to move it in X direction and place it over here. Let's enter the edit mode, and to scale up the UV sphere, let's first change the pivot point back to the median point. Then press S and scale it up like this. Let's get back to the object mode, and now to apply the Boolean modifier on this cube, first I selected it, then go to the modify properties and click on add modifier. Then in the generate category, select the Boolean modifier. Now here you can see that you have three options: intersect, union and difference, which is similar to the mesh boolean node that we saw in the geometry nodes editor. Here also you can see that we have three operations: intersect, union and difference. If I again select this cube and in the object, if I click on the eyedropper and select this UV sphere, then it will basically subtract or remove the part of the UV sphere intersecting with the cube. And to see the changes here, first I need to apply this modifier. So I'll apply it from here, and then if I select the UV sphere and move it somewhere else, then here you can see that this area, or basically the volume of the UV sphere, will get removed from the cube. And the exactly same operation was performed by the mesh boolean node on the cube that we added here. Similarly, you also have some other operations like intersect and union, and if I select the intersect, then only the UV sphere is visible here, and that's because the cube is disconnected here. So if I connect it to the mesh socket again, then a structure like this appears. The reason why it looks like this is that with the insert operation, it will only show that part of the mesh which is common between the cube and the UV sphere. Then if I change the operation to union, then this one will basically join the two mesh objects, that is the cube and the UV sphere, and form a structure like this. And this is how the mesh boolean node works in Blender. Even though I explained you each and every operation in detail, but if you are still having any doubts in it, then you can understand about the Boolean modifier, which is exactly the same as the mesh boolean node in this chapter of this course. And now moving ahead, we'll be using this mesh boolean node in order to place the windows properly on our house. But first, let's remove all these nodes which we used for understanding the mesh boolean node. So I've selected all these and press X, and to view the house in our scene, I'll take back this geometry socket and connect it to the group output. Now if I press Shift plus A and in the mesh operations, select the mesh boolean node and place it over here just before the join geometry node, then here I can connect two mesh types with the difference operation. So what I'm gonna do is that I'll be selecting this house that we created as the first mesh object and the windows as the second. For this, let's first break the connection here by holding Control button, right clicking and dragging like this. Then for the mesh 1, I'll take this group input socket and connect it to the mesh 1. Then I'll take this instances on points, which is carrying the information about the windows, and connect it to the mesh number 2. And now let's understand what exactly is happening here. By using this mesh boolean node, we are basically subtracting the geometry of the windows from the geometry of this house. Now even though this is not the final result that we need, but still it helped us because now we have a clear idea about where we need to place the windows on these faces. We'll be adding a window over this face, similarly at the back face, and also at the side faces. So once again, this mesh boolean node simply subtracted the geometry of mesh 2, which is the windows, from the geometry of the mesh 1, which is the house. Now in order to place the windows on these faces, we need to add another node, which is the mesh 2 points node. To add it here, press Shift plus A, go to mesh, and in operations, select the mesh 2 points, and we'll be placing it just before the point socket of the instance on points. Now what it basically does is that it converts the mesh that comes as the input, which in this case is the house, because we have connected the mesh point node to the group input here. And as I already told you, this group input node is carrying the information about the house. But yes, before explaining the mesh points node to you, let me first place all these nodes properly here to avoid any kind of confusion. So I'll select the instance on points node here, and place it here. Similarly this one, let's place it here. Let's place this one and similarly select this one and place it here, and this one also. Then let's go downwards and bring this normal node upwards and let's place it over here. Now if I zoom in, you can see here that this group input node, which is carrying the information about this house, is connected to the mesh 2 points node. And if I change the mode from vertices to faces, then we see some changes here, but to understand them deeply, I will directly connect the mesh 2 points node to the group output. Now here you see some points added, which are basically placed at the different faces of the house that we created. And this is because in the mode option here, we have selected the faces. But if I change it to vertices, then it will basically place these points on the position of different vertices of the mesh object, or basically the house. But since we want that the windows should be placed at only the faces of the house, as a result, we'll change the mode to the faces. And if I connect the join geometry node back to the group output, then here you can see that our window is placed on all these faces of the mesh object. Now even though these two windows are perfectly placed, the windows at the sides are not perfect, and we can fix this with the help of rotation in the instance on points. For this, I'll connect the rotation socket to the align Euler to vector node. So press Shift plus A, go to utilities, and in rotation, select the align Euler to vector. Let's place it over here and connect it to the rotation socket of the instance on points. Now as I already told you, we need to input the normal information of all these faces in the vector option here. However, all these faces are having different normal information, and for this you have the capture attribute node in the geometry nodes editor. To use it, press Shift plus A, go to attribute and select the capture attribute node, and I'll place it here. Now what this capture attribute node does is that it basically captures the information about the normal of these faces, and that information can be used to rotate these windows properly. So we'll be connecting it in between the group input node and the mesh 2 points node. So let's place it over here. Now here you can see that you have the data type option, which is selected to float by default. But since we wanted to capture the normal information, which is a vector, so we'll be changing it from float to vector. And also one more thing is that the information that we want to get is about the normal on the faces. But here in the domain, point is selected, which will give you the information about the normals of the points. But here I'll change it to faces, and to tell it that we want the normal to be captured, we need to connect this value socket to the normal. So one way is to press Shift plus A, and in geometry, go to read and add the normal from here. And the other way is to select this normal node, press Shift plus D to create a duplicate, place it over here and connect it to the value socket of the capture attribute node. And now this capture attribute node will capture the information about the normal of different faces of the house object. And now to give this information about the normals to the align Euler to vector node, we'll take this attribute socket and connect it to the vector socket of the align Euler to vector. And now we can align the different axes with the X, Y and Z option here along any other axis which you can select from the pivot option. By default it is selected to auto, and this is how it will align the Y axis of the object, or basically the windows, like this. And since we want them to be straight like this in the Z axis, you should either align the Y axis and set the pivot to auto, or you can set it to the Z axis. Now although this house now has a perfect basic structure, there are still some imperfections in it. For example, the windows that you can see here are also added to the rooftop, which you can't see right now because of these roof tiles, and similarly it's also added here at the base of the house. And to fix this, we basically need to tell the mesh 2 points node here about at exactly which normal value of the faces we want these windows to appear. And if you remember, we did a very similar thing here in this case when we connected the normal socket to the equal, or basically the compare node, and we used it to compare the normal value to the vector B that we added here. Similarly in this case, we want that the window should be placed only on those faces whose normals are in the positive or the negative x direction, or in the positive and the negative y axis. Or in simple words, I can also say that we need these windows at all the faces whose normals are not in the positive or the negative z axis. And to do this, press Shift plus A, go to utilities, and in math, select the compare node. Let's place it over here, change the data input to vector, and to add the normal node, I'll select this one, press Shift plus D and place it over here. Let's connect it to the vector A. Let's also change the operation to equal and set the value in the z axis in the vector B to -1. Then to create another compare node with a vector value of +1 in the z axis, I'll select both of them, press Shift plus D, and let's place it over here and change this value to +1. Now both of them are carrying the information about the faces whose normals are in the negative or the positive z axis. But since we need the faces which are not in the positive or the negative z axis, we'll change the operation from equal to not equal. Similarly with this one, let's select not equal. Now another thing to understand here is that the normals of the faces where we have added these roof tiles are not perfectly in the z axis, and that's because they're not straight like the other faces. You can see that they are slanting like this, and as a result, if I take the annotate tool and change it to annotate line, and if I go to the side view by pressing 3 on the numpad, then the normal of these faces will be something like this. You can clearly see that this is perpendicular to the face, however it is not lying perfectly in any of the three axes. As a result, when I'll connect these compare nodes to the mesh 2 points, it will basically mean that these faces will also be included. And to solve this problem, let's first undo the annotations, go to the select mode again, and we need to see only the points of this mesh object. For this, hold on Ctrl Shift and left click on this mesh 2 points node, and this will basically allow you to see all the points of the mesh, or basically the house that we created. Now if I take the compare node and connect it to the selection of the mesh 2 points, then the uppermost point here gets deleted, and that's because it was carrying the information that it must be showing all those points whose normal is not equal to 1 in the z-axis. Similarly, if I connect this one to the selection socket, then the lowermost point will get deleted because this one is carrying the information that all the points must be shown whose normal is not in the negative z-axis. And also here you can see that these 4 points are actually the points lying on the faces of the rooftops. And to remove these, we'll take the second compare node again and connect it to the selection, and here you have the option of epsilon in the compare node. And if I slightly increase it by holding the shift button and dragging it like this, then at one particular point you will notice that those 4 vertices will get disappeared. And now we can connect both the compare nodes together with the use of the Boolean math node. So press shift plus A, go to utilities, and in math select the Boolean math. Let's place it over here and connect the first one to the Boolean, similarly the second one to the Boolean, and take this output node and connect it to the selection. And now here we have only these 4 points, which are actually those points that we needed to add the windows on the house. And yes, the reason for choosing the AND operation here is that we need both of these conditions to be true. The first one is telling that the point whose normal is in the negative z-axis should not be included, and the second one which is telling that the point in the positive z-axis and also those 4 points that we adjusted with the help of epsilon are not to be included here. So both the conditions need to be satisfied, and therefore we selected the AND operation. Now to view the windows on the house, I will delete this viewer node by selecting it and pressing X, and now here we have our house with the windows on all the 4 faces, but not on the bottom face and also not on any of the faces where you have these roof tiles. Now moving ahead to the next topic of this chapter, which is the bounding box node, and we'll be using this node to make our windows look better. Right now you can see that the windows are looking very simple, and so we'll be using the bounding box node to make this structure perfect. But before that, let's understand this node with the help of the Suzanne model that we added here. So I'll select this, and in the geometry nodes editor, here we have the default geometry node system applied. To add the bounding box node, press shift plus A, go to geometry, and in operations select the bounding box. Let's place it in between the group input and the group output, and here we see a cube or a box placed around the monkey object. Now to see what actually happened here, let's go to the wireframe mode by clicking on this icon. Now to view both the objects together, that is the bounding box and the Suzanne model, we'll be using the join geometry node. So press shift plus A, go to geometry, and here you have the join geometry node. Let's place it over here. Then I'll take the socket of the group input and connect it to the join geometry. And now here we have the Suzanne object with the bounding box. So this bounding box node will basically create a box around your object, and that too with the minimum volume such that it completely surrounds the object. So if I go to the front view by pressing 1 on the numpad, then here you can see that our Suzanne model is perfectly placed in this box like this. Similarly, if I go to the side view by pressing 3 on the numpad, then from this dimension also you can see that the box is exactly covering the Suzanne model. Similarly, if I go to the top view by pressing 7 on the numpad, let's hide this object by selecting it and clicking on this I button. Then from the top view also you can see that this box is exactly covering the Suzanne model. And this is the use of the bounding box node. It will create a box like structure covering your object completely, and that too with the minimum possible volume. Now just similar to the Suzanne model, we'll be using the bounding box node on the windows of this house in order to make the frame of these windows. For this, I'll delete the Suzanne model with this bounding box by pressing X. Let's also delete this cube and the UV sphere, which we used to understand about the Boolean modifier. So I'll delete both of them, and now if I select the house, then this geometry node system will appear. And so now let's add the bounding box node. So press shift plus A, go to geometry, and in operations select the bounding box. Let's place it over here. Now we have to place it after that node which is carrying the information about the windows, and that specific node is the instance on points node. If you remember, we added this mesh boolean node in order to subtract the first mesh which was the house and the second mesh which was the window, and at the mesh number 2 we have connected this instance on points node, and so we can say that this node is carrying the information about the windows that we created. So I'll take this bounding box node and connect it over here, and it creates these spaces in place of the windows that we added. And to get those windows back, simply take this instances socket and connect it to the join geometry, and this is the result. If I zoom in, you can now see that we have these frames added because of this bounding box node, and this makes the windows look much better than before. And now it's the time to give some materials to the house and the windows. For this, go to the render view, then go to the material properties and click on the new new button. Now the first material here will be basically that material that will appear on the house. So let's change its name from material to house, and let's change the base color to slightly yellow. Now moving ahead, let's create another material for the window glasses. So click on the new button, change its name from here, and we'll rename it to glass. Let's keep the base color to white right now. Then we'll create another material which will be used for the window frame. So I'll change its name from material to frame. Let's also change the base color, and this time I'll keep it to blue color. Now to apply the window frame material, we'll be adding a set material node. So press Shift plus A, go to material and select the set material, and we'll be placing it in between the extrude mesh and the instance on points node. And if I change the material to frame, and now the entire frame along with these window glasses are assigned the frame material. To give some different material to the window glasses, or basically the top extruded faces, let's create a duplicate of it by pressing Shift plus D and place it along with the first set material node and change the material to glass. And now we see that this glass material is being applied to the window frame as well as the glasses, and that's because we have placed the set material node with the glass material after the one where we assigned the frame material. And whenever you have such a situation where two similar nodes are giving different information about the same object, then in that case it will only consider that node which is placed after or basically on the right hand side of the previous one. But in order to assign this glass material only to these windows, or basically these top extruded faces, we have to take the top socket of the extrude mesh node and connect it to the selection in this set material node. And now you can see that this glass material is applied on the top extruded faces and this frame material is applied to the rest of the window. Now if you remember, while making the glass material, we simply added a white color to the base and did no other changes. But to make it look like a real glass, I'll click on the surface option here and change it to glass PSTF. Let's also reduce the roughness from here, so I'll reduce it to 0. But if you remember, in one of the previous chapters of the course, we created a simple glass material. But the reason why we can't use it here is that in the render properties, we have set the render engine to EV. But that glass material was only for the cycles render engine. And in order to make a glass material in EV, we also have to go to the screen space reflections here and turn it on. And also you have to turn on the refraction. And now to get some proper lighting in our scene, I'll select the light from the scene collection, go to the object data properties, and we'll change the light from point to sun. Let's reduce the strength to something like 5 or 6. Then press R to rotate and X to rotate it in the X axis. And if I move my cursor like this, then now we can see the house that we created properly. Now another thing that you can notice here is that even though we have assigned the glass material to these window glasses, you can't actually see through it. To fix this problem, I'll select the house, go to the material properties, and with the glass material selected, go to the settings option here and change the blend mode from opaque to alpha blend. To see the changes here, we need to view only the windows. And for this, hold on Ctrl Shift and left click on the instance on points node. And now here you can see that the glass material is perfectly applied on these window glasses and you can clearly see through them. Now press X to delete this viewer node. Now before giving some material to the roof tiles here, let's first turn off the wireframe mode that we turned on previously in this chapter. So click on this drop down menu, and from here I'll turn off the wireframe display. Now to give some material to these roof tiles, first I'll select the bigger roof tile that we created, and in the material properties click on the plus icon and let's create a new material. We'll rename it to roof tiles. Let's also change the base color to something like orange, and to view the changes here, with this roof tile selected, tab into the edit mode, press A to select all the vertices and click on this assign button. Let's come out of the edit mode, and now you can see that the color of these roof tiles has changed. But another thing that you can notice here is that the yellow color of the house is also appearing on this lower part of the roof. And to fix this issue, we'll add a set material node by pressing Shift plus A, go to material and select set material, and we'll be placing it in between the node connection of the group input node and the joint geometry. So let's place it over here. Let's zoom in and we'll change the material to house. Then I'll create a duplicate of it by pressing Shift plus D and placing it over here, and change this material to the roof tiles. But as I told you earlier, the one that is present on the right hand side will only be seen as the result. But in order to apply this house material only to the side faces, then for this we have to tell the set material node that we want to apply it only on those specific faces whose normal lies on the positive and negative x axis or on the positive and negative y axis. And if you remember, we created a system of nodes with the normal and the compare nodes which were serving the same purpose. So if I take the boolean socket here, which is connecting both of them, and connect it to the selection, then now you will see that the house material is getting applied only on the side faces and not to the rooftop. Now in order to see the glass material properly, do ensure that you have this ray trace refraction option turned on. And now we have a simple yellow color applied to this house, this blue color applied to the window frame, and the faces in between the window have been assigned the glass material. But the reason why you can't see anything inside the house is that the face behind this window is also having the yellow material that we assigned to the house. And to fix this issue, we'll be creating a transparent material and we'll place it after the bounding box node. So go to the material property properties, click on the new button. Let's create a new material, and to make it transparent, change the surface to transparent BSDF. Also, because we are in the Eevee render engine, so change the blend mode from opaque to alpha blend. Then to assign the material, select a set material node, press Shift plus D and place it after the bounding box node. Change the material to the material.001 where we created the transparent material. So I'll select this. Now to see the result, I'll go to the mesh boolean node, hold on Ctrl Shift and left click on it, and now here you can see that these faces are now having the transparent material. But if I delete this viewer node, you won't be seeing the same thing here. And the reason for this is the set material node that we added here. Since in the selection socket it is carrying the information that it has to apply this house material, or basically the yellow material, to all these 4 faces. As a result, it's also applying this yellow house material to the face behind the window. And to fix this problem, instead of connecting it in between the group input and the join geometry, we'll connect both of these nodes in between the group input and the mesh boolean node. I'll select the first one, press Shift plus D and place it over here. Then I'll delete it from here. Similarly, I'll select the second one, and yes, instead of creating a duplicate, you can also remove it by holding the Alt button and left clicking on it. Now I'll place it over here, and again I'll take the boolean socket of the add node and connect it to the selection in the set material node of the house material. And now you can see here that you can easily see through the windows of this house because the face at the back of them is having a transparent material. Now moving ahead, let's finalize this house and fix some minor issues in this house model. So I'll go to the solid view again. Now the first thing to notice here is that the tiles are not properly placed. For example, you can bring them down to make it look better. And to do this, we have to select the tile in our scene, tab into the edit mode, press A to select all the vertices, and if I press G and Y to move it in the Y direction, then you will notice that these roof tiles will also begin to move like this. Let's fix this position, and now our roof tiles are looking like this. And let's come out of the edit mode. And now another thing that we can fix here is the tiles appearing on the top here. And to solve this problem, I'll go to the geometry nodes editor, and if you remember, we created these tiles with the help of this raycast node. Now we'll be using the math boolean node in order to tell the instance on points node here that it does not need to add any tiles on this face which has a normal pointing towards the positive z axis. And to do this, press Shift plus A, go to utilities, and in math, select the boolean math. Let's place it over here. Then press Shift plus A again, go to utilities, and in math, select the compare node. Let's place it here. Change the input type to vector since we'll be adding a normal node. And to add that normal node, press Shift plus A, go to geometry, and in the read category, select the normal. Let's place it over here. Now we'll connect this normal to the vector A, then I'll change the operation to not equal, and we'll set the vector value in B to 1 in the Z axis. Now I'll take this result socket and connect it to the first boolean input, and for the second boolean input, I'll take this isHead socket and connect it here. And now to see the output, we'll be connecting this boolean output socket to the instance on points here. So I'll take this socket and connect it to the selection. And now here you can see that the tiles at the top of the face have disappeared, and now our house looks perfect. But let me show you another thing. If I tab into the edit mode, and if I press 3 for the face select mode and select this face, then I can extrude it like this, and it will automatically add these windows at all these side faces. Similarly, if I select this face and press E to extrude it, then in this case also it will add a window here and also some roof tiles. The reason why the number of roof tiles is less is that here in the grid option the size is very low, but if we increase it from 4 meters to something like 100 meters, let's also increase the vertices from 35 to a very high number like 400, or maybe let's increase them to 500, then this is how it looks. To see it properly, let's come out of the edit mode and turn on the render view. And now this is how this house is looking right now. And to fix these issues like the placing of the tiles, you simply have to change the values in the size option and the vertices option. For example, if I take the size values and reduce it to something like 80, then it looks like this. Let's also change the number of vertices in the X and Y axis, and if I increase it to something like 550, then it looks like this. And if you want to change the scale of these tiles, then you can go to the transform geometry node and change the scaling from here. But right now, I think that the house model looks perfect, so let's finalize it. And we'll also be adding a plane below it by pressing Shift plus A, go to mesh and select the plane, tab into the edit mode, press S to scale it, and to move it downwards, press G and Z, and let's place it over here. Let's also scale up this plane slightly more by pressing S, and I think that we should scale it up 10 or 20 times, so I will press 20 and press enter. Then go to the camera view by pressing 0 on the numpad. Let's also come out of the edit mode of this plane, and to change the camera view, you can either click on the lock button here, or you can press N, and in the view section, turn on the lock camera to view. Now let's change the view of the camera to that particular position where the house is completely visible, and that too from a perfect angle. So here I think that it looks perfect. So let's finalize this, and to hide this bigger tile, I'll select this and click on this eye button, and if you don't want it to appear in the rendered version also, then turn off the camera icon from here. Similarly, we also hided this plane in our scene, so I'll click on the camera button here also to hide it in the render view. Now to give some material to the base or the plane, we'll be assigning the sand material to it, which we created in this chapter of the course. To add it here, first we need to open the asset browser, so click on this icon, go to the asset browser, then change this to the user library, and now here we have the sand material that we created. So I'll select this and drop it on the plane. And yes, one more thing that I noticed just now is that this window of the house is colliding with the roof, and to fix this issue, I'll select the house, tab into the edit mode, and with the upper face selected, press G and Z to move it upwards. Let's move it up like this, and here it looks perfect. Let's come out of the edit mode. Let's also adjust the camera view, so I'll zoom out and adjust the camera like this. Now you can also try to change the color of this house, or maybe try to add some different materials with different types of roughness, metallic nature and other things, and also you can add some more lights in the scene in order to make it look better. And I also did some basic changes in the material and the lighting, and this is how the final rendered version looks. And also this brings us to the end of this chapter. In this chapter, we learned about lots of geometry nodes and their usage, and if you're learning them for the very first time, there is a really very high probability that you can't understand all of them by simply watching the video once. So a better approach will be to either rewatch the whole video again and then make the model, or else rewatch that particular part where you think that your concept is not clear. In this chapter, we'll be covering all these topics in complete detail, and we'll be using these geometry nodes to create this donut. So to begin with, we'll be adding a curve in our scene. So first let's delete this cube by pressing X, and to add the curve, press Shift plus A, go to curve and select the Bezier curve. Now since we'll be making the donut with the help of geometry nodes, so let's also go to the geometry nodes workspace. For this, click on the workspace named as geometry nodes here, and to add a new geometry node, click on this new button. Now the first node that we are going to discover is the set spline cyclic node. To add it here, press Shift plus A, go to curve, and in the right category, here we have the set spline cyclic. So I'll select it and let's place it over here. Let's also go to the top view by pressing 7 on the numpad. And now what this set spline cyclic node does is that it will make the curve cyclic by connecting the two ends of the curve together, meaning that this node will connect this end point of the curve to the first point here, and this can be done by turning on the cyclic option here. So if I turn it on, then now our curve is looking cyclic because it has joined the two endpoints together. Now the benefit of this node is that if I tab into the edit mode and select the draw tool from here, and to draw the curve, I simply have to left click and drag my cursor like this, and you can see here that it will automatically make the curve cyclic. So if I turn it off, then you can see here how the original curves look, and by using the cyclic option, the curves will get completed, and as a result they look cyclic. And now we'll be using this node to create the cyclic structure of a donut. For this, tab into the edit mode, press A to select all these points, and we'll delete them and create a new cyclic curve. So press X and select delete segments. Now let's draw the curve to be used as the donut. Let's come out of the edit mode, and you can see here that we have a simple basic structure in the form of a curve ready for the donut. Now in order to make it look like a real donut, we have to convert this curve into a mesh, and for this we'll be using the curve to mesh node. To add it here, press Shift plus A, go to curve, and in operations select the curve to mesh. Let's place it over here. Now since here we have a cyclic curve, so we'll be connecting this profile curve socket to a curve circle. To do this, press Shift plus A, go to curve, and in primitives select the curve circle. Let's place it over here and connect it to the profile curve. And now here you can see that we have a structure which slightly looks like a donut. In order to make it perfect, I'll go to the curve circle node and reduce the radius from here. Now if you think that it looks oval, then you can tab into the edit mode, and we'll scale it up in the Y axis. So press S and Y, and let's slightly scale it up like this. Let's come out of the edit mode. Let's also slightly increase the radius from here, and this is how it looks. Now moving ahead, let's also add the frosting at the top, and for this we'll be using the extrude mesh node. So press Shift plus A, go to mesh, and in operations select the extrude mesh. Let's place it over here. Now it's extruding all the faces individually, and to fix this, I'll first turn off the individual option, and to extrude only the face at the top, we'll be using the compare node. To add it here, press Shift plus A, go to utilities, and in math select the compare node. Let's place it over here, and we'll be using this to tell the extrude mesh node that we want the extrusion to be applied only on the top faces. And for this we'll be using the normal node, and that's because we know that the normal for the top, or basically the perpendicular to it, will be in the positive Z axis. And to do this, first I'll change the input type from float to vector. Let's also change the operation to equal. Now in the vector A, I'll be connecting the normal node, so press Shift plus A, go to geometry, and in read select the normal. Let's place it over here and connect it to the vector A. And now we'll be using the values in the vector B in order to make it equal to the normal node. The first value will control control the x-axis, second will control the y-axis, and the third will control the z-axis. And since the normal of these top faces lies in the positive z direction, so we'll be changing the value of b in the z-axis as +1. Now if I connect the result socket to the selection, then you see that nothing happens, and that's because you have to control the area where the extrusion is to be applied with the help of this epsilon option here. To increase it slightly, hold down the shift button, left click, and if I drag my cursor like this, you will notice that the extrusion is being applied to certain part of the top. And to increase this area, I'll go to the epsilon option again, and if I slightly increase it, then the area to be extruded will increase like this. And to reduce the extrusion, go to the offset option here and reduce it like this. Let's further increase the epsilon value from here so that it actually looks like the frosting of a donut. So let's increase it like this, and let's keep the value to that point where the structure actually looks like a donut. So this epsilon value will basically control the area to be extruded, and the offset value will control the extrusion of that area. Also, to make it look better, I'll reduce the resolution from here from 32 to something like 16. And now this is how our donut is looking right now. And here I think that the extrusion at the top face is a little high, so I'll reduce it from here, and at a value of somewhere near 0.1, the extrusion looks fine. Now in order to add some sprinkles to it, we'll be using the distribute points on faces node. To add it here, press shift plus A, go to point and select the distribute points on faces. Let's place it over here, and now this will distribute these points over the different faces of the donut that we created. In order to view both the donut and these points, we'll be adding a join geometry node here. So press shift plus A, go to geometry and select the join geometry. Let's place it over here, and to view the donut, take the mesh socket of the extrude mesh and connect it to the geometry in the join geometry. And this is how it looks. Now if you want to make your donut look better and more smooth, then for this you can use the subdivision surface node. To add it here, press shift plus A, go to mesh, and in operations, select the subdivision surface. We'll place it in between the extrude mesh and the join geometry node. And now the subdivision is applied to this donut. Now here you can see that these points are distributed all over the donut, but we wanted them to appear only on this extruded part. And for this, we'll be using the same result socket that we connected to the extrude mesh in order to extrude this part, and we'll connect it to the selection socket of the distribute points on faces. And now the points will be distributed only on the extruded part. Now one more thing to notice here is that the things that are distributed on this extruded face are simply these points but not sprinkles. And to replace these points with the sprinkles, we need to add the instance on points node after the distribute points on faces node. So press shift plus A, go to instances and select the instance on points. Let's place it over here. And yes, if you want to know about these two nodes and their functioning in complete detail, then you can check the previous chapters of the course where we discussed about both of these geometry nodes in complete detail. But for now, I'll be using this instance on points node in order to place the sprinkles on this extruded part. But before that, we also need to model the sprinkles. For this, in the 3D viewport, press shift plus A, go to mesh and add a cylinder. Let's move it in the X direction by pressing G and X, and let's place it over here. Tab into the edit mode, and now to make it look like a sprinkle, first I'll scale it up in the Z direction. So press S and Z and scale it up like this. Now we'll be applying the subdivision surface modifier to it. For this, go to the modify properties, click on add modifier, and in generate, select the subdivision surface. Let's increase the levels viewport to a value of 2. Now, in order to make this pointing part flat at the top and the bottom, enable the face mode by pressing 3, select the top face and press I to inset it. Let's bring it down, and now here the inset is applied. Similarly, I'll select the face at the bottom and press I to inset, and now this is how it looks. Now since we are making a sprinkle, so we need to reduce its thickness, or basically the scaling, in the X and Y axis. To do this, press A to select all, then S to scale, and to apply the scaling in the X and Y axis simultaneously, press shift plus Z. Let's scale it down like this and left click to finalize. Let's come out of the edit mode, and now our sprinkle is ready. And to distribute these sprinkles over the extruded face of the donut, we need to select the donut. We have to connect the sprinkle to the instance option here. For this, I'll go to the scene collection, left click on the cylinder object, or basically the sprinkle, and if I drag it into the geometry nodes editor and drop it here, the object info node is created with the cylinder selected here. Now I'll take this geometry socket and connect it to the instance, and here the sprinkles are placed at different faces on the top of the donut. However, we need to reduce their scaling from the scale option here. So let's select the scaling in the X, Y and Z axis, and let's reduce it to a very low value like 0.1, and this is how it looks. Now in order to rotate them, I'll first select the cylinder, or basically this main sprinkle object, and we'll be rotating it. So with the cylinder selected, tab into the edit mode, press R and X to rotate it in the X axis like this, and to rotate it by 90 degrees, press 90 and enter to confirm. Now just like this main sprinkle, these other sprinkles on the donut are also rotated in the X axis by 90 degrees. Now even though the basic rotation looks good in the X axis, but another thing to notice here is that all of these sprinkles are having the same rotation. But to make it look realistic, let's give each of them a random rotation. So let's come out of the edit mode, select the donut, and to give the sprinkles a random rotation, we'll be connecting this rotation socket to the random value node. So press shift plus A, go to utilities and select the random value. Let's place it over here and change the data type to vector. Now take this value socket and connect connect it to the rotation, and now you will notice that these sprinkles are now rotated randomly. And if you want to control this rotation, you can try to change the maximum value in the random node. For example, if I try to change the maximum value in the z-axis, then you can see that the randomness of the rotation in the z-axis will change like this. Similarly, I can do the same with the x-axis and also the y-axis. And yes, if you want to increase the number of these sprinkles, then you can go to the density option here, and if I increase it, the number of sprinkles will increase like this. Also, I think that I should increase their scaling in order to make them look thicker. So I'll go to the scale option here, select all the three, and let's increase it to a slightly higher number like 0.12, and now it is looking perfect. And yes, with this our structure of donut is ready now. But let me show you one more thing. If I select the donut, go to the top view by pressing 7 on the numpad, and also go to the edit mode, then with the draw tool selected, if I draw a curve like this, then it will automatically create a donut out of it. Similarly, I can create any number of donuts by simply making a curve like this. And see, that's the benefit of using the geometry nodes. Even though the geometry nodes look complex to understand in the starting, but if you master them completely, then they're really very helpful and can save a lot of time if you want to create different objects. Also, since we have used the set spline cyclic node here, which makes any curve cyclic, so I don't need to draw the entire circle and close it. I can simply draw a curve like this, and it will automatically join the two endpoints together. And now I'll be keeping these two donuts in my scene and will delete the other ones. For this, click on the select tool, left click and drag like this, and to select the other one, hold on the shift button, left click and drag like this. Now all the points on the two donuts are selected, and to delete them, press X and select delete segments. Let's come out of the edit mode, and now the next topic for today's chapter is understanding the realize instances node. So what it basically does is that it helps to convert the duplicate objects into separate geometries. For example, the sprinkles that are placed on this donut are simply the instances that are placed on different points. And to confirm this, you can go to the spreadsheet, and in the instances option here, you can see that we have 490 instances, and these are basically these sprinkles that are distributed over the top of the donut. However, to convert them into different geometries, we have to use the realization instances node, and using this node is also important in order to assign different colors to these sprinkles. So to add it, press shift plus A, go to instances, and here you have the realize instances node. So I'll select this, place it over here, and now it's connected, but you won't see any difference here. However, if I go to the spreadsheet, then now in the instances you can see that there are 0 instances, and that's because all these sprinkles which were the instances are now converted into separate geometries. Now in order to give different colors to the sprinkles here, we have to use a new node, which is the store named attribute node. To add it here, press shift plus A, go to attribute, and select the store named attribute. Let's place it here for now. Now this node is basically used to capture some attribute and store it with a name, which you can then use somewhere else in the program. If you remember, in one of the previous chapters, we studied about the capture attribute node, and it's exactly similar to the store named attribute node, except for the fact that this node is having the name option here. To understand it better, let's first place it after the instance on points, and since we'll be using it to give different colors to the sprinkles, so we'll change the data type from float to color. And since we have connected it to the instance on points, we'll also change the domain from point to instance. Now if you want your sprinkles to have random colors assigned to them, then for this we have to connect the random value node to the value socket here. To do this, press shift plus A, go to utilities, and select the random value. Let's place it here. Let's also change the data type to vector and connect it to the value socket here. Now you also have the name option here in order to save this attribute with a name. So if I left click on it, I can assign any name to it. So for now, I'll keep the name to color, and now it is saved with the name color. Now to give these sprinkles some material, I'll change this to the shader editor. So click on this icon and select the shader editor. To give it a new material, click on the new button. Now to give some colors to the sprinkles, let's add the color ramp. So press shift plus A, go to converter, select the color ramp. Let's place it over here and connect it to the base color in the principal BSDF. So we'll be using this color ramp node to assign different colors to the sprinkles here. Also, we'll change the interpolation from linear to constant so that we can add different colors here without blending them with each other. Now to view the colors of the material, let's go to the render preview mode. Now to apply the colors on the sprinkle, we need to add the attribute node here with the name that we assigned in this node. To do this, press shift plus A, go to input, and from here select the attribute. Let's place it over here. Now in the name option, we'll type color, and this is the same name which we assigned to the attribute in this node. And now to connect it with the color ramp, I'll take this color socket and connect it to the factor. And to view the changes here, we need to use the set material node in the geometry nodes editor. So press shift plus A, go to material, and select the set material node, and we'll place it after the realize instances. And from here, I'll select the material.001, and with this you can also see that the sprinkles are now assigned the material.001, and so they appear to be black colored. Now to get different colors here, we have to use the pointers in the color ramp. For example, if I move this white pointer, then now here we have some black sprinkles as well as some white sprinkles. You can even add some more colors to it by clicking on this plus icon. Let's change the color from here by increasing the brightness and let's assign it yellow color. Similarly, let's add one more color and change it from here, increase the brightness, and this time I'll change it to pink color. Also, I'll change the color of this first pointer because we won't need any black sprinkles on the donut, so I'll select it and change the color by increasing the brightness. And for this one, let's change the color to green, and to see all the colors properly, we have to adjust the pointers at different positions. The amount of sprinkles having a particular color will depend on the position of these pointers. For example, here you can see that most of the part is yellow colored, and as a result, most of the sprinkles in the donut are also yellow. So to get a uniform distribution of colors, we have to adjust these pointers properly, and if you want, you can even create more colors by clicking on this plus button and changing the color from here. Let's give it the red color, and now this is how the sprinkles are looking on our donut. Now to create the chocolate material to be placed on the top of the donut, let's go to the material properties, click on the plus button and go for new material. Let's change the name of this material to chocolate. Similarly, for the sprinkles material, let's also rename it to sprinkles, and now we have two materials in the material properties. One of them is the sprinkles and the other one is the chocolate material. Now let's go to the shader editor, and in the principal BSDF, we have to change the base color to make it look like the chocolate color. And for doing this perfectly, we'll use the hex code of chocolate. So I searched it up on Google and this result came up. So we'll change the hex code to the hex code of chocolate, which is 411900. And now in the base color, you can see we have the chocolate brown color. And now to set this chocolate material to our donut, we'll be using the set material node. For this, I'll select the set material node and create a duplicate of it. So press Shift plus D and place it after the subdivision surface node. It appears like this because we need to change the material from sprinkles to chocolate. And now this is how our donut is looking right now. We have these colorful sprinkles distributed over the top and this simple chocolate material applied on the donut object. Now although our donut is almost ready, we can do some more changes in it. For example, it might be possible that you want that only the top extruded layer where the sprinkles are placed should have the chocolate material and not the remaining part. And to do this, we'll create another material for the base of the donut. So go to the material properties, click on the plus icon and let's create a new material. We'll rename it to donut, and for now, I'll keep the base color to white and we'll work on applying this material only to the base of the donut. For this, we need to create a duplicate of the set material node and add the donut material to it. So press Shift plus D and place it over here. Change the material from chocolate to donut. But here you will observe that since this set material node with the donut is placed after the set material node with the chocolate material, as a result, the entire donut, including the top extruded face, is now having the white donut material. But in order to assign the chocolate material to the top extruded face of the donut, we need to tell this node to apply the material only on that specific part. And if you remember, we used this compare node with the normal selected, which carried the information about the extruded top face. So if I take the result socket and connect it to the selection here, you will observe that nothing happens. And that is because, as I already told you, that since we have placed this set material node with the donut after the chocolate material, so only this node with the donut will be considered. And to fix this problem, we basically need to place this set material node after this one. And to do this, let's first remove it from the node connection. So hold down the Alt key, and if I left click and drag my cursor like this, then the node will get removed. And now we'll place it after this set material node with the donut material. So let's select it and place it over here. Again, take the result socket and connect it to the selection socket. And now here you can see that the chocolate material is now applied only to the top of the donut. However, you can see here that the material is not perfectly placed. Like in this area, you have the chocolate material, but it's not present in the remaining area. And to fix this problem, we simply have to go to the epsilon value here and we have to slightly increase it. So we'll increase it slightly like this, and at a value of somewhere near 0.75 or 0.8, our donut looks perfect. So let's finalize this. And now we should also reduce the size of the sprinkles because they appear to be too large on the top of the donut. For this, I'll select the cylinder, tab into the edit mode, and let's scale it down in the Y axis by pressing S and Y and scale it down like this. And if you want to make the sprinkles thicker, then for this, press S and Shift plus Z to restrict the scaling only in the X and Y axis. And now you can change the scaling to increase or decrease the thickness of the sprinkles. For now, let's finalize this and come out of the edit mode. Now moving ahead, in order to give this chocolate a realistic look, we'll go to the shader editor, change the material from donut to chocolate, and we'll be using the noise texture with the bump node. To add the bump node, press Shift plus A, go to vector and select the bump node. Let's place it over here and connect the normal to the normal in the principal BSDF. And now to add the noise texture, press Shift plus A, go to texture and select the noise texture. Let's place it over here, and to connect it with the bump node, take the factor socket and connect it to the height. And now this chocolate material is having this noise texture, real melted chocolate. Now to connect the noise texture to the input and the mapping node, press Ctrl plus T, and in the input node, or basically this texture coordinate node, take this object socket and connect it to the vector. And now this is how the chocolate material looks now. You can change its appearance from the scale value here. So for now, I'll reduce reduce it to something like 1.5 or 2, and if you want to control the bump effect applied to it, then for this you can go to the bump node and change the strength from here. For now I'll keep it to 0.5, and this is how it looks. Now moving ahead, suppose you want the chocolate material to cover more area of the donut, or maybe this inner area of the donut, and to do this you have to go to the compare node here and try to change the values of the vector b in the x and y axis. For example, if I change both the values to a slightly higher number like 0.1, then now the area on which this chocolate material is applied will increase. And with this, our chocolate material is completely ready. And before moving towards the creation of the material for the rest of the donut, let's first improve the lighting in our scene. So for this, I'll select this lamp and change the type of light from point to sun. Let's reduce its strength to something like 5 or 10, and now we have a proper lighting in our scene. Now to make the donut material, I'll go to the shader editor, change the material from chocolate to donut, and to give it some color, we'll be adding the color ramp. So press Shift plus A, go to converter and select the color ramp. Let's place it over here and connect it to the base color. Now in order to create a color which resembles the donut, we have to use a combination of orange and yellow color. So I'll change the first color by increasing the brightness, and I'll change it to orange color, and for the second color, I'll select it and change it to a mix of orange and yellow color. If you want, you can even make the color look darker by reducing the brightness from here, and now it looks like this. Now to give it some simple texture, we'll be adding the bump node and the noise texture. To add the noise texture, press Shift plus A, go to texture and select the noise texture. Let's place it over here. Press Ctrl plus T to connect it with the mapping and the texture coordinate node. Connect the object to the vector socket, and to view the texture, take this factor socket and connect it to the factor in the color ramp. And now to give the texture a more 3D look, we'll add the bump node. So press Shift plus A, go to vector and select the bump node. Let's place it over here and connect the normal to the normal in the principal BSDF. Then to connect it to the texture, take this factor socket and connect it to the height. And now this is how the texture of the donut looks. Let's reduce the bump effect from the strength option here to something like 0.1, or maybe to a much lower number like 0.02 or 0.01, and this is how the base of the donut looks now. And also if you want, you can make it look shinier by reducing the roughness in the principal BSDF. So if I reduce it to a lower value like 0.2, the roughness of the donut will reduce, giving it a shiny or a smooth look. And with this, our donuts are completely ready. And the best part about creating donuts procedurally with these geometry nodes is that I can simply go to the edit mode, and with this draw tool enabled, if I draw a curve like this, then it will automatically convert it into a donut. So you can create any number of donuts with different sizes simply by drawing them in the edit mode. But for now, to finalize this scene, we'll be keeping only 2 donuts, and to delete the rest of them, let's first change the mode to solid mode so that we can see the points properly. Turn off the draw tool by clicking on the selection tool, and with this one selected, I'll also be deleting this donut in the scene. So hold down the shift button, left click and drag like this, press X to delete and select delete segments. Now I have to select the best 2 out of the remaining 3, so I'll go to the render view again. Let's change the view to see them properly, and I think that I should delete this one because its shape is not perfectly circular. So let's go to the top view again, switch to the solid mode, select these vertices and press X to delete segments. Now to finalize the scene, we'll be placing one donut in such a position that it looks inclined towards the first one. And to do this, we have to select the points of one of the donuts and let's rotate it in the Y axis. So press R and Y and rotate it like this, and to place it perfectly, let's go to the front view, press G to move it and place it over here. And now we have both the donuts perfectly placed in our scene. Let's come out of the edit mode. Let's also turn on the render view. Now let's create the base with the help of the plane. So press Shift plus A, go to mesh and select the plane, tab into the edit mode, press A to select all the vertices and S to scale it up. Let's scale it up to a very high number like 20. Let's also bring it downwards by pressing G and Z and move it down like this, and then come out of the edit mode. Now let's also fix the lighting. So for this, I'll select the first light, press Shift plus D and let's move it in the X axis, and to rotate it towards the donut, press R and Y and rotate it like this. Left click to finalize, and if you want, you can also change the type of light from sun to spotlight or area light, and they will also work in the similar way. For example, if I select the spotlight and increase the power to a higher number like 1000 watt, then we get a lighting like this. Let's also change the color of this light from the color option here. I'll change the color to slight pink, and similarly for the second light, I'll select it, and for this one also, you can change the type of light to spot or area or point, but for now I'll keep it to sunlight. And let's also change the color of this base to a darker color like grey color. So I'll go to the material properties, click on the new button and change the color by reducing the brightness from here. If you want, you can also change the color to dark blue or dark purple or red color or any other color of your choice. For now, I'll be keeping the purple color. Now let's go to the camera view by pressing 0 on the numpad, and to turn on the lock camera to view, either click on this lock button or press press N, and here in the view option, you can turn on the lock camera to view. So let's change the view to that position where both the donuts are perfectly placed in the scene. Let's also bring it down, and here I think that it looks perfect, so we'll finalize it. And to finally render it, go to the render option and select render image. And so this is the final rendered image of the donuts that we created with the help of geometry nodes. To save the image, you can click on the image option here, and here you have the option to save the file. And yes, this brings us to the end of this chapter. In this chapter, we'll be understanding all these topics in complete detail, and we'll be using them to create this amazing Meteor apocalypse scene in Blender. Now, the first topic for today's chapter is understanding the split edges node. But before that, let's open the geometry nodes workspace from here. Then go to the geometry nodes editor, and with this cube selected, click on the new button. So to add the split edges node, press Shift plus A, go to mesh, and in operations, select the split edges node. Let's place it over here. Now, as the name suggests, the split edges node basically splits the edges of your mesh and helps to separate each and every face. If you remember, while understanding the generate modifiers in this chapter, we studied about the edge split modifier, and the split edges node is exactly similar to that modifier. To revise it, let's add another cube in the scene. So press Shift plus A, go to mesh and select the cube. Let's move it in the Y direction and place it over here. Then go to the modifier properties, click on add modifier, and in the generate section, select the edge split modifier. Let's apply it from here. And now if I tab into the edit mode, then because of the edge split modifier, the edges of this cube would have been splitted, and as a result, the faces must also be separated. To check this, press 3 for the face select mode, and if I select the top face and press G to move it, you can see that it is now separated from the rest of the cube. Similarly, if I select any other face and press G to move it, then this one will also get separated. And just like this modifier, in the geometry nodes, you have the split edges node. To check the same thing on this node, we'll be adding a scale elements node. So press Shift plus A, go to mesh, and in operations, select the scale elements. Let's place it over here. And as discussed in one of the previous chapters, this node is basically used to scale different elements like the edge or the faces of your mesh object. So if I go to the scale option here and try to slightly reduce it, you will notice that the faces are no longer connected with each other, and this is because of the split edges node. Also, if I remove it from here by holding Alt, and if I left click on it, and then if I use the scale value, you can see that all the faces are connected with each other. So the split edges node will simply split the edges of your mesh object. Now moving ahead, we'll be creating a scene with some futuristic buildings. And for this, we'll delete this cube by pressing X, and now let's add a new cube in the scene. So press Shift plus A, go to mesh and select the cube, and to make them taller, tab into the edit mode, and let's scale them up in the Z axis. So press S and Z and scale it up like this. Let's also move it slightly upwards, so press G and Z and let's place it over here. Now to get some more vertices and edges, we'll be using the loop cut. So press Ctrl plus R, and to increase the number of loop cuts, you can scroll the mouse wheel, and I'll be keeping the number of loop cuts to 5. Left click to finalize, and then it will give you the option to fix their position, but to get the default position, simply right click. Now let's come out of the edit mode, and before doing any changes to it, let's create 2 more duplicates for some different buildings. So press Shift plus B and place it in the Y direction, and to create another duplicate, press Shift plus B again and place it over here. Let's select the first building again. Now to modify this building, let's tab into the edit mode, and I'll be selecting some of these edges. So I'll select this one, hold down the Shift button and select these also. Since we need to make the buildings look futuristic, so we'll apply the bevel effect to it by pressing Ctrl plus B and move your cursor like this, then left click to finalize. And this is how the basic structure of a first building looks. We'll be doing similar things with the other buildings also. So let's come out of the edit mode, select the other building, tab into the edit mode, and now I'll select the upper face and extrude it. So press 3 for the face select mode, select the top face, press E to extrude, bring it here, and let's scale it down like this. Now just like this one, you can also select random edges here by pressing 2, then hold down Shift, and let's select these edges, press Ctrl plus B to apply the bevel effect, then left click to finalize, and let's also do the same with some other edges as well. So I'll select some random edges here also, press Ctrl plus B and apply the bevel effect like this. Now our second building is also ready, so let's come out of the edit mode, and now for the third building, let's go to the edit mode, press 3 for the face select mode, select the top face, press Ctrl plus B to apply the bevel effect, and you can use the scroll wheel to increase or decrease the number of segments. Then left click to finalize, then I'll press 2 for the edge select mode, select some random edges, press Ctrl plus B to apply the bevel effect, then left click to finalize. And yes, all the changes that I have made here are completely random and you can make any random changes according to what you think will look the best for your buildings. And yes, if you want, you can even make similar changes for the back of the building. And to do this, I'll select some random edges here also, press Ctrl plus B to apply the bevel effect and left click to finalize. Then I'll do the same with other buildings also. So let's come out of the edit mode, select the second building, I'll select some random edges, press Ctrl plus B to apply the bevel effect. And similarly for the third building, let's select some random edges here, press Ctrl plus B and left click to finalize. The basic structure of all our three buildings is completely ready now. And now to give them some material, we have to open the shader editor. To do this, I'll change this geometry nodes editor into the shader editor by clicking on this icon and selecting the shader editor from here. To give it a new material, click on the new button, and here we have the default basic material assigned to the building. Now to view the material, switch to the render view from here, and to get a proper lighting in the scene, I'll select this lamp, go to the object data properties and change the type of light from point to sun. Let's reduce the strength to a lower number like 5 or 10. You can rotate the light by pressing R and moving your cursor like this. And now we have a perfect lighting in our scene. Now to give some material to the buildings, let's go to the shader editor again and we'll be using the Warner texture. So press Shift plus A, go to texture, and here you have the Warner texture. Let's place it over here, and to connect it to the texture coordinate and the vector mapping node, press Ctrl plus T. Then as always, I'll take this object socket and connect it to the vector, and to view the texture here, hold down Ctrl and Shift and left click on the Warner texture. Now to make this pattern look like windows, we have to change the distance metric option to the third one and then reduce the randomness to 0. And now we have this window-like pattern that we created using the Warner texture. If you remember, we used this Warner texture to create a similar pattern on the buildings in this chapter of the course as well. And now to make the window pattern look better, we'll be adding the color ramp. So press Shift plus A, go to converter and select the color ramp. Let's place it over here and change the interpolation mode from linear to constant. Then if I move the second pointer, which is the white colored, in this direction, then you will begin to notice this pattern of black windows appearing on the building. And now to have separate colors for the windows and the rest of the building, we have to use the mix shader node. So press Shift plus A, go to shader and select the mix shader. Let's place it over here, and instead of connecting the color ramp to the first shader, we'll connect it to the factor socket. And now for the first shader, I'll take this principal BSDF and connect it to the first shader socket, and for the second one, we'll create a duplicate of it by pressing Shift plus D, place it over here and connect it to the second shader socket. And now if I select the base color from here and change it to suppose blue color, then now you can see that we have the blue color added here. And now since this principal BSDF node is controlling the material of the windows of the building, so I'll increase the metallic nature from here to a value of +1. Let's also make the color slightly darker by reducing the brightness from here. And now this is how the material of these windows is looking right now. And now for the borders around the windows, you can set the color from the second principal BSDF. So we'll make it darker by bringing the brightness slider down, and in this way we'll change the color to dark gray color. And now let's change the name of this material from here and let's rename it to buildings and press enter to confirm. Now if I view the top face of the building, then you can see that this pattern of windows is also applied here. And to get some other material for the top face, or basically the rooftop, simply go to the material properties and click on the plus button. Let's create a new material, and for this one, let's change the base color to the red color and reduce the brightness from here. To assign this material to the rooftop, simply tab into the edit mode, press 3 for the face select the top face, then select this material.001 and click on the assign button. And now we have this red colored material applied to the top of the building. And now for this beveled part, we'll be creating another material. But before that, let's change the name of the material.001 to rooftop and press enter to confirm. To create a new material, click on the plus icon here and create the new material. And for this one, we'll set the base color to dark orange color. Let's also reduce the brightness from here, then tab into the edit mode, and we'll be selecting all the faces in this beveled part. So left click and drag like this, and for the remaining part, hold on the shift button, left click and drag like this. Then here also, hold on shift button and select these faces also, and similarly with the last part here. To assign this material to these faces, click on the assign button, and now we have this dark orange color applied to this bevel part. Also, I think that I should make it darker, so I'll reduce the brightness further, and now it looks like a mix of dark orange and brown color. And now to apply the building's material to the remaining two buildings, I'll first select both of them, and with the shift key holded, if I select this building, then I can use the link material tools to assign the same material to these two buildings. For this, press Ctrl plus L and select link materials. And now I'll select the second building, tab into the edit mode, and for the rooftop, I'll select this face, click on the rooftop material and click on assign button. Similarly, I'll select this bevel part by left clicking and dragging like this, select the material.001 and click on assign button. Let's also do the same with the remaining bevel part. So I'll select this one by left clicking and dragging like this, click on the assign button. Let's also go to the back of the building, select these faces, click on the material.001 and assign material. Similarly, let's select these faces also and click on assign button. And with this we have the materials properly applied to these two buildings. And now similarly for the third one, we'll select it, tab into the edit mode, select the top face, and let's assign the rooftop material from here. And now for the bevel part, let's select all the faces by left clicking and dragging like this, buildings, select the material.001 and click on assign button. Let's do the same with other faces also. Select these faces by left clicking, dragging like this and click on assign button. Let's go to the back of the building, select these faces, click on assign button, and in the end select all these faces and assign the material. And so now we have our basic material applied to all these buildings. And now to create a scene with several duplicates of these buildings, I will add a cube in the scene and place these buildings as instances on all its edges. And to do this, first I'll select all the three buildings by holding the shift button and select all the three, press G and Y and place them over here. Then press shift plus A, go to mesh and add the cube, and to place these buildings as instances on the different edges of the cube, we have to go to the geometry nodes editor. For this, let's change the window from shader editor to the geometry nodes editor. Click on the new button, and now here we have the default geometry node system applied to it. And to place the buildings, we'll be using the instance on points node. So press shift plus A, go to instances and select the instance on points. Let's place it over here, and to use the buildings as the instance object here, we have to create their collection. So I'll select all three of them, and to create the collection, press Ctrl plus G, then click on the create new collection, and let's change the name of the collection to buildings. And to add these buildings in the geometry nodes editor, we'll be using the collection info node. So press shift plus A, go to input, and in scene, select the collection info node. Let's place it over here and connect it to the instance socket. Then I'll choose the collection, which is the buildings collection here, and turn on the separate children and the reset children, and also turn on the pick instance option so that all the three buildings are not placed over each other. And now to scale them down, I will use the scale option here. Let's select all the three and reduce it to something like 0.5. However, since I have used the instance on points node, as a result, these buildings are being placed at the vertices of the cube, and to place them on the edges, we have to use the mesh to points node. So press shift plus A, go to mesh, and in operations, select the mesh to point. Let's place it over here and change the mode from vertices to edges. And now here we have the buildings placed around the edges of the cube. Let's reduce the size from here, and this time I'll reduce it to something like 0.4, and now this is how it looks. And yes, to ensure that no two buildings are intersecting with each other, for example, here I can see that these two buildings are intersecting with each other, and to solve this problem, we simply have to go to the scale value and try to reduce it even further. So this time, let's reduce it to something like 0.3, but still they are intersecting. So again, I'll scale it down to a value of 0.28, and now they are no longer intersecting. And now because of scaling them down in all the three axes, their scaling in the X and Y axis is also reduced. But to make them look better, we'll increase the scaling in the X and Y axis by selecting them, and let's increase it to something like 0.33 meters, and now it looks better. Now if you want, you can even make a skyscraper type of structure with the help of these buildings. And to do this, you simply have to select this, tab into the edit mode, and this cube will appear on which we have applied the geometry node system. And if I select the top face and extrude it by pressing E, then now you can see that these new buildings will appear here. Let's zoom out, and so you can create any number of buildings simply by extruding the faces and moving them by pressing G and Z, and now you can change their position in the Z axis. Let's place them over here. Let's extrude it one more time. So press E and bring the buildings upwards. Let's scale them down by pressing S, and this is how it looks. Similarly, to increase the number of these buildings, you can increase the number of edges by pressing Ctrl plus R and adding the loop cuts. And now if I left click with these 4 loop cuts, then now we have so many more buildings in the scene. But for now, I will undo it by pressing Ctrl plus Z, and this is how the scene is looking right now. And yes, you can scale it up and scale it down in any way that you think will look the best for your scene. To understand it even better, I'll turn on the solid view from here. Then if I turn on the X-ray mode by pressing Alt plus Z, then here you can see that this is the extruded cube, and just by extruding these faces or scaling them up and down, we are changing the position of the buildings. So if I bring this face down by pressing G and Z and place it over here, then if I create its duplicate by pressing Shift plus D, move it upwards in the Z axis and place it over here. And if I go to the render view, then this is how it looks. I can control the distance between the buildings by scaling the face up and down. But right now it looks perfect, so we'll finalize this. Now let's also come out of the edit mode, and to give each building some random rotation in the Z axis, we'll be using the random value node. So press Shift plus A, go to utilities and select the random value. Let's place it over here, change the data type to vector and connect it to the rotation. To get random rotations only in the Z axis, I'll change this value in the X and Y axis back to 0, and with this third value, I can control the random rotation of these buildings in the Z axis. And now if you remember, we understood about the split edges node, and we can use it here to make the buildings look broken. So for this, press Shift plus A, go to mesh, and in operations, select the split edges node. Let's place it over here, and to view the changes, we'll be adding the scale instances node. So press Shift plus A again, go to mesh, and in operations, select the scale elements. Let's place it over here, and now if I slightly reduce the scale value, then you can see here that the buildings are now appearing as broken, which is because of the split edge node here. But for now, let's delete the scale elements node and connect the split edge node to the group output. And with this, we have the structure of buildings completely ready in the scene. And now we'll move to the next topic of this chapter, the geometry proximity node. And this node basically allows us to make the changes in an object based on the position of some other object. And to understand it, I'll first add a plane in my scene. So press Shift plus A, go to Mesh and select the plane, press G and Y and place it over here. Then go to the Geometry Nodes editor and click on the new button. And yes, if you want to control the size of this plane from the Geometry Nodes editor, then for this you can simply add the grid node. So press Shift plus A, go to Mesh and in primitives select the grid node and place it over here. Now this group input node, which was carrying the information about the original plane, will get disconnected and a new plane will appear because of the grid node. Now let's increase its size from here. So I'll select the size in the X and Y axis and let's increase it to something like 4 meters. Let's also increase the number of vertices in the X and Y axis to a higher number, like maybe 30 or 35. And now to add the geometry proximity node, press Shift plus A, go to geometry and in sample select the geometry proximity. Let's place it over here and we'll be using this node to displace the vertices of this plane with the help of a target object. And since we'll be working on the position of vertices, so let's also add the set position node here. So press Shift plus A again and in geometry go to right category and select the set position node. Let's place it over here, and for the target object we'll be adding a cube here, and to place it exactly at the plane we'll bring the 3D cursor over it. So press Shift plus S and select the cursor to select it. Then to add the cube, press Shift plus A, go to Mesh and select the cube. Let's move it slightly upwards by pressing G and Z and place it over here. Now to use this cube as the target object, I'll select the plane and you can see in the scene collection that this cube has the name cube.004. So to bring this cube in the geometry nodes editor of the plane, I'll go to the scene collection, select cube.004 by left clicking on it, and if I drag it and drop it here, then this object info node will be added with the cube selected. So to use it as a target object, first I'll select the relative from here and connect it to the geometry socket in the geometry proximity. And to see the changes here, we have to connect the distance socket to the offset. And now you can see here that the plane has been deformed, and I can also control it by selecting the cube, and if I press G to move it, then the vertices of the plane will also get displaced because of it. And now suppose you want that it should only move in the Z axis as per the cube. So for this I'll select the plane, and now I'll be adding a vector math node. So press Shift plus A, go to utilities and in vector select the vector math. Let's place it over here and change the operation to multiply. And now if I select the cube and try to move it, you will observe that nothing happens. And that's because in the geometry nodes of the plane, this vector in the multiply node is having a value of 0 in all the 3 axes. But suppose I change this value in the Z axis to -1, and then if I select the cube and try to move it, then you can see that this is how the vertices of the plane are getting displaced now. And now to see this effect more properly, we'll be adding the map range node. So press Shift plus A, go to utilities and in the math select the map range. We'll place it after the geometry proximity node. And now if I increase the size of this plane with the grid option here, let's keep the size to something like 6 meters. And now if I select the cube and try to move it, then you can see here that these vertices of the plane are getting displaced upwards as per the movement of the cube. Now if I go to the plane again, and here in the geometry proximity node, you can see that the target geometry is set to faces, and this means that it will basically consider the faces of the cube in order to displace the vertices. For example, if I select the cube, tab into the edit mode, and if I select the bottommost face, and if I try to scale it down by pressing S, then you can see here that the displacement of the vertices of the plane will also get changed like this. And this is all because in the geometry proximity node, the faces option is selected here. Similarly, you can also change the target geometry to edges or maybe to points, and you will get the displacement accordingly. And now we'll be using this geometry proximity node with the building that we created here. We'll be creating a scene where a meteor is hitting the building, and then that part of the building will begin to break off. Now for this, I'll delete this cube and the plane by pressing X. Let's also take the 3D cursor back to the world origin by pressing Shift plus C. And now if I go to the side view by pressing 3 on the numpad, and here in the toolbar, I have this measurement tool. So if I select it and then left click and drag like this, you can see that this tool helps us to measure the distance between any 2 points. And so I can also use it to measure the height of this building. And you can see here that it's somewhere between 9 and 10 meters. But we'll be increasing its size to something like 50 or 100 meters. For this, first I'll undo and then I'll zoom out, and I'll use the measure tool to measure the distance of 50 to 100 meters. So I'll left click and drag like this, and let's keep it to something like 80 meters. And you can see that this point is somewhere located here. So I'll select the annotate tool and make a point here. Let's switch to the select mode again. And now to scale up the buildings, first I need to select them. So I'll select it from here, tab into the edit mode, press A to select all, and press S to scale it up. Let's also bring it upwards by pressing G and Z and place it over here. And now let's come out of the edit mode. So we have increased the height of the building. Let's also remove the annotations. So I'll go to the annotate tool, hold down the left mouse button, and I'll select the annotate eraser. Let's erase it from here and go to the select tool again. And to increase the scaling, I'll go to the scale option here, select all 3, and if I drag my cursor, then the scaling will begin to change. Let's keep it to something like 3.5, and now it looks like this. And now to create the breaking off effect on the buildings, we'll be using the geometry proximity node. But before that, since we'll be breaking the building, so we'll add the set position node after the split edges. Go to geometry and in right category, select the set position. Let's place it over here. And now to add the geometry proximity node, press Shift plus A, go to geometry, and in sample, select the geometry proximity. Let's place it over here, and for the target object, we'll be adding a cube in the scene. So press press Shift plus A, go to Mesh and select the cube, move it in the Y direction by pressing G and Y and place it over here. And to scale it up, tab into the edit mode and scale it up like this. Let's come out of the edit mode and let's also move it upwards by pressing G and Z and place it over here. Now to use it as a target object, I'll go to the scene collection and this cube is named as cube.005. So I'll drag it and drop it in the geometry nodes editor and we'll connect it to the geometry proximity node, and we'll also change it to relative from here. And now if I connect the distance socket to the offset here, then you will notice some changes in the scene. So now with the cube selected, if I try to move it, then it will basically change the offset of the buildings in the scene. But what we really wanted was that when the cube touches the building, it should break off at that point. And to achieve this result, I'll select the buildings again and we'll be using the map range node in order to restrict the range of movement or the offset. So press Shift plus A, go to utilities, and in math select the map range node. We'll place it after the geometry proximity node, and now if I select the cube and press G to move it and take it close to the building, you can see here that the position of the buildings is not changing. However, if I zoom in and then move the cube, then you will notice slight changes in the geometry of the building. To view them properly, I'll turn on the solid mode from here, and with the X-ray mode turned on, if I try to move the cube, then you will notice very slight changes in the geometry of some buildings, and this is because of the geometry proximity node added in the geometry nodes editor. And right now, this effect of displacing is working on the instance as a whole. Therefore, it shows a very small result on moving the cube. So to increase this result, I'll be using the Realize Instances node. So press Shift plus A, go to Instances and select the Realize Instances node. Let's place it over here. And also to increase its effect, we'll be adding the Math node with the multiply operation. So press Shift plus A, go to Utilities, and in Math, select the Math node. Let's place it over here. Let's change the operation from add to multiply. And if I increase the value, you will begin to notice some changes here. So if I select the cube, press G to move it, then you will begin to notice that wherever it touches the building, it will begin to displace the vertices or the edges of that particular building. And to see this effect in a better way, we'll scale up this cube. So tab into the edit mode, let's scale it up like this. Let's come out of the edit mode, and now if I try to move the cube towards the buildings, then you can see this effect in a much better way than before. At the point where it touches the building, it's creating a slight breaking of effect, which is due to the geometry proximity node. And yes, if you want, you can try to change the values in the map range node here in order to increase the effect. For this, I'll increase all these values by a slightly higher number. So let's increase the first one to something like 0.5. Let's increase the from max value to a higher number like 8 or 10. Let's also increase the to minimum value. And now if I select the cube again and try to move it, then you will begin to notice the displacement effect applied to the different vertices and the edges of the buildings in a much better way. However, since I already told you that we need to create a scene where a meteor will be hitting the building and it will break away at that point. And to achieve this effect, we have to capture the normal of the face of the building where it breaks off or shows the explosion. And for this, we'll be using the capture attribute node. So press Shift plus A, go to attribute and select the capture attribute node. Let's place it over here. And now this capture attribute node will basically capture the information of the normal, or basically the perpendicular of the faces of the building which will explode or the one that will break away. And since we'll be using it to capture the normal, so I'll change the data type from float to vector. Also, since we want to calculate the normal of the faces, we'll change the domain from point to face. And now I'll connecting the normal node to the value socket here. So press Shift plus A, go to geometry, and in read select the normal node. Let's place it over here and connect it to the value socket. Now for the output, we'll be connecting this attribute node to a vector math node placed over here. So press Shift plus A, go to utilities, and in vector select the vector math. Let's place it over here and change the operation to scale. Now I'll take this attribute socket and connect it to the vector, and this value socket to the value in the scale node. Now this will basically change the scale of your buildings according to the input of the normal that it receives from this node, and also as per the multiply effect from here. And now if I select the cube, press G to move it, then you can see here that it's creating this displacement and the buildings appear to explode or break away as it touches the cube. However, one thing that you can see here is that all the buildings are breaking away, and to fix this problem, we have to change the values in the map range node. First of all, change the to max value to 0, and now you can reuse the rest of the values and try to change them in order to increase the explosion effect. For example, if I select the to minimum value and try to increase it, then you can see here how the explosion effect is also increasing. Similarly, if I try to change the other values, then we'll also get some similar results. The only thing to take care of in the map range node is that the to max value should be 0, and then you can try to change these other values. And to make it look realistic, I'll reduce the from maximum value, which is basically controlling the breaking away effect of the buildings. So I'll reduce it slightly, but I'll be increasing the value of the to minimum from here, which is creating this explosion effect. So let's keep it to something like 1.2 or 1.3, and now it looks like this. Let's also add a light here to see the building properly. So for this, press Shift plus A, go to light and select the sunlight, press G and Z and move it upwards like this. Let's move it in the X direction over here and increase the strength to a higher number like 10 or maybe 30. Press R to rotate it. Let's also slightly reduce the strength to something like 15 or 20. And now we can see the buildings properly with the cube and also the explosion part. And now if I select the building again, then using this multiply option over here, you can increase the explosion effect like this. However, to make it look realistic, we'll be keeping it to something like 12 or 13. And now it looks like this. So try to change these values here in the map range node and in the multiply value socket. And in this way, you will be able to create the perfect explosion effect for the buildings here. And now moving ahead, in order to make this cube look like a meteor, I'll first scale it down by going to the edit mode and scale it down like this. Then in the geometry nodes editor, click on the new button, and to give it a spherical look, we'll be adding the subdivision surface node. So press Shift plus A, go to mesh, and in operations, select the subdivision surface. Let's place it over here, and to make it look more spherical, I'll change the level value from 1 to 2. Now this meteor will be having two parts. The first one will be this rock, and the second part will be the smoke coming out of it. And to create the smoke trail, we need to extrude some faces emerging out of the rock part. And for this, we'll be using the extrude mesh node. So press Shift plus A, go to mesh, and in operations, select the extrude mesh node. Let's place it over here, and now I'll be using the index value of different faces to create the smoke trail. And for this, I'll first add the index node. So press Shift plus A, go to geometry, and in read, select the index node. Let's place it over here, and to connect it to the extrude mesh node, we'll be using the compare node. So press Shift plus A, go to utilities, and in math, select the compare node. Let's place it over here. Since the index value is an integer, so I'll change the input type from float to integer. Now I'll take this index socket and connect it to the value A. Then I'll take the result socket and connect it to the selection here. And now what it basically does is that it will extrude only those faces whose index value is greater than or equal to the value of B. And since we already discussed it in one of the previous chapters that the index value starts from 0, as a result, because of the value of B set to 0, all the faces are being extruded here. However, to extrude only some particular faces, we have to increase this value. So I'll increase it like this, and now you can see here that only some of the faces are getting extruded. And to reduce the number of faces that are extruded, we'll again increase the value of B from here. And yes, we are doing all this in order to make the smoke trail. So let's increase the value of B from here, and I'll keep it to something like 90 or 91. Like at a value of 90, it will extrude all the faces whose index value is greater than the value of B, which is 90. And as a result, you can see here that all these faces are extruded here. But suppose I need only these three faces to be extruded, then for this, I'll increase the value of B further, and at a value of 92, you can see here that only these three faces are extruded. And now to increase the amount of extrusion, I'll go to the offset value here and increase it. Let's also turn off the individual from here, and now it looks like this. Let's keep the offset value to something like 15 or 20. Now let's rotate it also. So tab into the edit mode, press A to select everything, then R and Z, and rotate it in the Z direction like this. Now to convert this into smoke, we'll be adding the mesh to volume node. This will convert the mesh object into volume in order to make the smoke. So press Shift plus A, go to mesh, and in operations, select the mesh to volume, and let's place it over here. And you can see here that the meteor that we were creating is now converted into volume. Now you can also control the density of this volume from the density option here, but we'll be keeping it to a value of 1. And now to distribute some points all over the volume, we'll be using the distribute points in volume node. So press Shift plus A, go to point, and select the distribute points in volume. Let's place it over here, and now you can see that there are these points distributed all over the volume. Also, you can control the density from this density option over here, and the number of points will increase or decrease like this. Now, even though we can see the points here, but in order to make the meteor, we need to see it in the mesh form, and for this, we have to convert it into mesh. However, in case of points, you can't directly convert into mesh. You first have to convert the points into volume, and then you can convert the volume to mesh. So first, press Shift plus A, go to points, and select points to volume, place it over here. Now again press Shift plus A, go to volume, and in operations, select the volume to mesh. Let's drop it over here. Now you can see here that due to the points that we added by using the distribute points in volume node, the meteor appears like this. However, we need only the smoke trail part to have the points distributed, or in simple words, you have to make this rock part look solid like a sphere. And for this, we'll be using the join geometry node. So press Shift plus A, go to geometry, and select the join geometry node. Let's place it over here, and now the details of this rock part is carried by the subdivision surface node. So I'll take this mesh socket and connect it to the geometry socket here. And yes, we should also scale it up. So tab into the edit mode, press S to scale it up, and left click to finalize. Now if you want to increase this smoke trail part, then for this you can go to the extrude mesh node here and try to increase the offset value. So let's increase it to something like 25 or 30, and now it looks like this. Let's also increase the density of the points from the density option over here. So let's increase it to a value somewhere close to 1.5. And now we'll give some material to this meteor that we created, and we'll be starting with the rock part first. So let's create a new material in the material properties. And to apply this material to the rock part, we'll be adding the set material node here. So press Shift plus A, go to material and select the set material node, and we'll place it after the subdivision surface node. Now click here and select the material. And now moving to the creation of the material, let's convert this window to the shader editor. So click on this icon and select the shader editor from here. And now for the material, we'll be adding the Musgrave texture. So press Shift plus A, go to texture and select the noise texture. Let's place it over here, and to convert it into the Musgrave texture, simply turn off the normalize option here. To view the texture, hold on Ctrl Shift and left click on the noise texture. And now here we have the Musgrave texture, or basically this noise texture with the normalize option turned off, applied to the rock part. And now to give it some texture of fire, I'll first connect the principal BSTF in this node system. Then I'll go to the emission and connect this factor socket to the emission strength. Now I'll go to the color option here and let's change it to yellow color. However, as you can see here, the texture doesn't look realistic at all. And to fix this problem, I'll go to the noise texture here and try to increase these values. First of all, I'll increase the detailing to its maximum value of 15. Then I'll go to the roughness and let's increase it to something like 0.8 or 0.9. Now the texture is starting to look better. Then if I go to the scale option and increase it, the texture will begin to change like this. Let's keep it to a value of somewhere close to 10. And now if you want to increase the emission strength of the yellow color, then for this you can use the map range node. So press Shift plus A, go to converter and select the map range, and we'll drop it over here. Now with the help of this 2 max value, you can control the emission strength of the yellow color. If you want very high emission strength, then you can increase it to something like 20 or 30, but we'll be keeping it to a value of something around 5 or 10, and here it looks perfect. And now moving towards the material for the smoke part, we'll go to the material properties and create a new material. Let's also change its name to smoke, and in the shader editor, instead of the principal BSTF node, we'll be using the principal volume node. So press X to delete it, then press Shift plus A, go to shader and select the principal volume node. Let's place it over here and connect the volume socket to the volume of the material output. Now the reason why you can't see the smoke material here is that we have not added any set material node in the geometry nodes editor for this smoke material. To add it here, I'll create a duplicate of this set material node by pressing Shift plus D. Let's place it here for a while, and we'll be connecting it after the volume to mesh node. So let's drop it over here and change the material to the smoke material. It appears like this because currently we have turned on the EV render engine, but to see the smoke material properly, we have to change the render engine to cycles. So go to the render properties and change the render engine from EV to cycles. Now the smoke is visible here. We'll be reducing its density to a much lower number from the principal volume option here. So let's keep it to something like 0.1 or 0.2, and to give it some color, you can go to the emission color option here, and suppose I change the color to yellow or orange, then the emission color will change. However, since the value of emission strength is 0, as a result you can't see the color of emission here. So let's increase it to a slightly higher number like 0.1 or 0.2, and now the color of emission is slightly visible on the smoke that we created. Let's keep it to a mix of yellow and orange, and to make it look better, we can increase the black body intensity option here. So if I increase it to something like 20 or 25, then now it looks like this. Now although it looks good, but there are still some changes that we can do here in order to make it look better. For example, we can cover this entire rock part of the meteor with fire to make it look better. And for this, go to the geometry nodes editor, and we'll be adding the set position node. So press Shift plus A, go to geometry, and in right, select the set position node. We'll drop it in between the subdivision surface node and the extrude mesh node. And now to cover it up entirely with fire, we'll basically use this node by giving some random offset values to the position of different vertices. And to do this properly, we'll be adding a vector math node here. So press Shift plus A, go to utilities, and in vector, select the vector math. Let's place it over here, connect the vector socket to the offset, and for the first vector, we'll be using the position node, and for the second vector, we'll be using the random node. So press Shift plus A, go to geometry, and in read, select the position node. Let's place it over here and connect it to the vector socket. To make the offset random, we'll be using the random value node. So press Shift plus A, go to utilities, and select the random value node. Let's place it over here and change the input type to vector. Let's connect it to the second vector, and now this is how it looks. You can use the maximum values in the random value node to change the way how the meteor looks. So let's keep it to something like 7 or 8, and now this is how this meteor is looking right now. And if you want to make it look better in terms of the fire color, then you can go to the emission color and change it to more of orange color. Then I'll increase the emission strength to a higher number like 7 or 8. Let's also reduce the black body intensity to something like 1 or 2, and this will give an explosive look to the meteor in the scene. Let's keep the emission strength to something like 5, and now it looks like this. Also, if you want to expand the smoke trail that we created here, then for this you can go to the extrude mesh option here and try to increase the offset value from here. So if I increase it to something like 35 or 40, then the length of this smoke tail will increase. Let's also increase the density from the distribute points in volume node. So we'll keep it to something like 1.6 or 1.7, and now it looks like this. So it completely depends upon you about which color you need and the emission strength. If you'll reduce it, it looks like this, and if you increase it to a higher value, the amount of emission will increase and this will give it more of an explosion-like appearance. I'll be keeping it to somewhere near 4 and 5, and you can also try to control the density with this density option here. And with this, our scene is now looking perfect, so we'll finalize this. And you can try to move this meteor by pressing G, and when I move it away, you can see here that there's no displacement or any effect on the buildings, but if I bring it closer to them, then at some point they begin to break off and show the destruction effect like this. You can even try to create an animation out of it, like initially you can fix the position of this meteor here, and then it will move towards the buildings like this, and then the buildings will explode. So try to do different things with this. You can change the parameters of the smoke shader, then you can also change the number of faces that will extrude to form this smoke trail with the help of the greater than option here. Then you can also use the offset value here to increase or decrease the length of the smoke trail. So try to play around with these values, try to create a simple animation out of it. And yes, it might be possible that you couldn't memorize the function of each and every geometry node right now, but you don't need to worry, because in most of the cases you won't be needing all the geometry nodes together. It's always advisable to understand the reason of adding any node, and if you understand that properly, then you will get a proper knowledge of that particular geometry node, and this will help you to master the geometry nodes in Blender. And yes, this brings us to the end of this chapter. In this chapter, we'll be learning all these topics in complete detail, and we'll be creating this simple looking sci-fi corridor scene with the help of geometry nodes. Let's first open the geometry nodes workspace. So click here, and this is the geometry nodes workspace. If you want, you can increase the area of the 3D viewport by closing the spreadsheet. So we'll close it for now, and we'll reopen it only if it is required. So to close this, take your cursor over here, and this double-headed arrow will appear. Then if I right click and select join areas, and now I have to take this arrow to that window which we want to close. So with this arrow on the spreadsheet, I'll left click, and now we have only the 3D viewport in the scene. And now moving to the geometry nodes, the first node that we're going to understand today is the icosphere node. So click on the new button here, and to add the node, press Shift plus A, go to mesh, and in primitives, select the icosphere node. Let's drop it over here. And now what this icosphere node does is that it basically creates this icosphere mesh in your scene. The icosphere is basically a mesh type which you can also add by going to the 3D viewport. And if I press Shift plus A, then in the mesh category, you can see that we have an option of adding the icosphere. And similarly in geometry nodes, if you want an icosphere in your scene, then you can use this node. The special thing about icosphere is that it is completely based on these triangle faces. If I switch to the wireframe mode, then here you can see that all the faces of the icosphere are made up of triangles, and this is the unique thing in the icosphere. Then here in the icosphere node, you also have some more options like the radius, which basically controls the size of the icosphere. Then you have the number of subdivisions, which will increase the number of these triangle faces, and it makes it look like a spherical ball. So you can control these settings from this node. And now we'll move towards the next topic of today's chapter, which is the dual mesh node. To add it over here, press Shift plus A, go to mesh, and in operations, select the dual mesh node. Let's place it over here, and now we see some changes in the geometry of the icosphere. Now what this dual mesh node does is that it basically converts vertices into faces and faces into vertices. To understand it better, I'll turn on the annotate tool from here, and yes, whatever annotations I'm making here, you don't need to repeat them in your file, because I'm doing it here only to explain the concept to you. Now to ensure that whatever annotations I make appear on the surface of the object only, I'll press N to open the toolbar, and here in the tool option, I'll change the placement to surface. Now if I remove this node from here, then you can see that we have a point over here, then we have one point here, then the third point is located here, here's the fourth point, and similarly the fifth one is here. Also we have one point at the center. Now if I take this dual mesh node and connect it over here, and now if I change the angle, then you can see that at the position of each vertex we have a new face, and this is the use of the dual mesh node. You can check this with other vertices also. At each placement of the previous vertex, we have a new face created over here, and if I remove it again by holding Alt and left click, then from this angle also you can confirm that we had this vertex here, but after connecting the dual mesh node, we have this new face created over here. And this is the use of the dual mesh node. It simply converts the vertices of your object into faces and faces into vertices. And now I'll remove these annotations from here. So I'll select the annotate eraser tool, and let's erase all of this. And now let's also try this dual mesh node on a cube object. So I'll delete the icosphere from here and connect the geometry socket to the mesh socket in the dual mesh. And now you can see here that the dual mesh node is now applied to the default cube. If I remove it from here by holding Alt and left click, then this is how the original cube looked. And to convert the faces into the vertices and vertices into faces, I'll take this dual mesh node and connect it over here. And now to make it look like a real cube, we'll be subdividing the mesh. And to do this, we'll use the subdivide mesh node. So press Shift plus A, go to mesh, and in operations, select the subdivide mesh. Let's place it over here. Let's also increase the levels from here. And now this is how it looks. And another thing that you can notice here is that by using this dual mesh node, a bevel effect is applied to the edges of the cube. Because if I hold the Alt button and remove it from here, then this was our original cube with no bevel effect. And after connecting it, we have this bevel look on this cube cube object. And now if you remember, in the previous chapter we learned about the split edges node, which were used to split the edges of your object and basically separate out the faces. So if I add it here by pressing Shift plus A, and in the mesh go to operations and select the split edges, place it over here, and now to see the effect we'll be adding the scale elements node. It will help us to scale down the faces individually on this cube. So press Shift plus A, go to mesh, and in operations select the scale elements node. Let's place it over here, and now with the scale option over here I can control the size of the individual faces. So because of the split edges node, the faces are now separated, and to scale them down we use the scale elements node. And now moving ahead, the next topic of today's chapter is the triangulate node. Now to understand it, we'll be adding a plane in the scene. So in the 3D viewport, press Shift plus A, go to mesh and select the plane. Let's move it in the Y direction and place it over here. Now tab into the edit mode, and to increase the number of vertices, right click and subdivide. Let's increase the number of cuts from here, and let's keep it to something like 3 or 4. Now let's come out of the edit mode, and in the geometry nodes editor, click on the new button, and now we'll add the triangulate node. So press Shift plus A, go to mesh, and in operations select the triangulate node. Let's drop it over here, and to see the changes click on this drop down menu and turn on the wireframe in the geometry option. And now you can see here that the triangulate node will basically triangulate the faces of your object. If I hold down Alt and remove it from here, then previously we had these square faces in the plane object, and after using the triangulate node it converted the square faces into these triangles. And this is the use of the triangulate node. Now I'll delete it. Let's select the cube again, and now let's see what happens if I use the triangulate node with this cube object. So press Shift plus A, go to mesh, and in operations select the triangulate, and we'll drop it after the subdivide mesh node. And now you can see here that instead of triangle faces we are now having these hexagonal faces, and this is because we are using the dual mesh node. To explain it in a better way, I'll first remove the dual mesh node from here, and now here we have these triangle faces because of the triangulate node. And as I already told you before, this dual mesh node will basically convert the vertices into faces and faces into vertices. So if I select the annotate tool again, and let's also increase the thickness from here so that the annotations are properly visible. And now if I mark the faces which are present on this cube like this, let's mark some more faces also like this. And now if we take the dual mesh node and drop it over here, then you can see that the faces are now converted into vertices, and because of this we are having these hexagonal faces here. And now I'll erase all these annotations by selecting the annotate eraser tool from here and erase all these points. Let's go back to the select mode, and now we'll be moving towards the next topic of today's chapter, which is the separate geometry node. To add it here, press Shift plus A, go to geometry, and in operations select the separate geometry node. Let's place it over here, and you can use this node to see only a particular face, vertex or edge of your mesh object. To understand it better, I'll drop it over here, and with the selection socket here I can basically input which particular face, point or edge I need to see in my scene. So suppose I need to see only the bottom face which is present here, and one thing that we know about this face is that its normal, or basically the perpendicular, is in the negative z axis. And to put this information in the selection socket here, we'll be adding a normal node and a compare node. So press Shift plus A, go to geometry, and in read select the normal. Let's place it over here, and to add the compare node, press Shift plus A, go to utilities, and in math select the compare node. Let's place it over here, and since we are using the normal, so we'll change the input type to vector. Let's connect it to the vector A, and now to see only this face whose normal is in the negative z axis, I'll change the operation to equal, and in the value of vector B I'll change this third value, that is the z axis, to -1, and this is because the normal is in the negative z axis. And now I'll connect the result socket to the selection in the separate geometry node. The reason why we can't see anything here is that by default the domain here is selected to point, and to see the face I'll change the domain to face, and now you can see here that only the bottom face whose normal is in the negative z axis is visible in the 3D viewport. And now one thing to notice here is that you have two output options in the separate geometry node. The first one is the selection, and this will basically give the output based on what you have entered as the input through the selection socket. And the second one is the inverted, which will basically invert the selection, or in simple words, it will give the output of all the faces except the one that we selected. To practically understand it, if I take this inverted socket and connect it to the mesh socket, then now you can see here that all the faces are visible except the bottom face that we used as the input here. And this is the use of the inverted socket in the separate geometry node. But for now, I'll change it to selection again, and this is because we'll be using this face with this pattern of hexagonal faces as the base of the sci-fi corridor that we'll be making in this chapter. Now to make the rest of the corridor, we need the other faces also. Only this base will be having this pattern, and the other faces will not be having any such pattern and will just be the simple faces of a cube. And for this we'll be using the join geometry node in the geometry nodes editor. So press Shift plus A, go to geometry, and select the join geometry. Let's place it over here, and now if I take the inverted socket which is carrying the information about the rest of the faces and connect it to the join geometry node, then in this case we still have the bottom face with this hexagonal pattern, and we have normal faces for the rest of the object. effect. And this is because I have converted the inverted socket directly to the joint geometry, since we have not connected it to the triangulate node or the dual mesh node. As a result, the hexagonal pattern is not visible on the rest of the faces. However, you can see here that this face is not completely covering the base of the corridor. And to fix this, you simply have to turn on the keep boundaries option in the dual mesh node. And now moving ahead, you can also extend this corridor by going to the edit mode, press 3 for face select, and if I select this face, press E to extrude it, then now you can see here that this pattern is also extending. However, if I extrude the face too much, then you can see here that the pattern will begin to show this stretching effect. So to avoid this problem, you can either extrude it by a small uniform distance, like if I press G and Y to move this face like this, then you can fix the position at that point where the base looks perfect, or else if you have extruded it too much, then you can add some loop cuts. So if I press Ctrl plus R and use the scroll wheel to increase the number of loop cuts, then now you can see that we again have this hexagonal pattern all over the base. And let's extrude it a little bit more. So I'll zoom out, enable the face select mode, and I'll select this face and again extrude it like this. Let's add some loop cuts by pressing Ctrl plus R, and I'll be keeping 2 loop cuts, then left click to finalize and right click to cancel the movement. And now we again have this hexagonal pattern at the base. Let's also extrude one face in the X direction like this. So I'll select this face, press E to extrude it. Let's add some loop cuts by pressing Ctrl plus R, and I'll be adding 4 to 5 loop cuts. Left click to finalize and right click to cancel the movement. And now we have this simple corridor with this hexagonal pattern applied to all the faces on its base. Also, to get a view of the inside of the corridor, you simply have to zoom in like this and adjust your camera. Let's zoom in again and adjust the camera accordingly. And at one point, you will get that view from where you can see the inside of the corridor. You can also see this hexagonal pattern that we applied on the base. And now moving ahead, we have 2 issues in the scene. The first one is that this hexagonal pattern is completely flat, and the second issue is that there is nothing below the base. As a result, you can easily see through it. And so to make them look thicker, we'll be adding the extrude mesh node. So press Shift plus A, go to mesh, and in operations, select the extrude mesh node. We'll drop it after the scale elements node, and now you can see that the extrusion effect is applied to the hexagonal pattern on this bottom face. You can control the extrusion from the offset option here. So let's reduce it, and we'll be keeping it to a negative value of something like minus 0.02 or minus 0.01. And now this hexagonal pattern has some visible thickness in it. And now another thing is that we are having nothing below this hexagonal pattern of the base. As a result, we can see through it like this gray area of the 3D viewport. And to fix this problem, we'll be adding the original bottom face here, just like the rest of the faces. And if you remember, the information about the bottommost face was stored in the selection socket of the separate geometry node. So if I take it and connect it to the joint geometry node, then now we'll have a simple face added to the bottom along with this hexagonal pattern. And you can even see the difference between both the cases, like if I break the node connection between the selection socket and the joint geometry by holding Ctrl, right clicking and dragging like this, then in this case, you can easily see through the empty spaces in between these hexagonal faces. And if I connect it again, then you can no more see through the empty spaces in between these hexagonal faces. Now let's also come out of the edit mode. Now moving ahead, we'll be creating some pillars to place on the sides of the corridor. But before that, I'll fix this position inside the corridor. For this, I'll bring my camera view over here, and to do this, press Ctrl plus Alt and 0 in the numpad. And now here we have the camera view. In fact, even if I try to change my view like this, then I can return back to the previous view by pressing 0 on the numpad, because now my camera is placed over here. You can also adjust the camera view by selecting the camera in the scene collection, and if I press N, then in the item category, I can change the location and the rotation of this camera. So in order to get a proper view, I'll first go to the rotation, and we'll be rounding off these rotation values. So the rotation in the x-axis is very close to 90 degrees, so I'll type 90. Then for the y-axis, we'll change it to 0 degrees, and in the z-axis, let's keep it to 90 degrees. Now in the location, I'll change the z-axis to 0 meters, and now with the help of these values in the x and y-axis, I can change the camera view like this. In the y-axis, the position looks perfect. Let's also change it in the x-axis, and I'll keep it to something like 14.5 meters, which is approximately equal to the location in the y-axis. So you can try to adjust these values on your own depending upon the position and the view of your camera. And now to add the pillars here, let's first change the view, press Shift plus A, go to mesh and add the cylinder. Let's move it in the x direction like this. And now to place it on the sides of the corridor, we'll be using the instance on points node. So I'll select the corridor again, go to the geometry nodes editor, press Shift plus A, go to instances and select instance on points. Let's place it over here, and now we'll be placing the cylinder on the different points of the base. So I'll take the selection socket and connect it to the points, and then I'll be assigning the cylinder as the instance object. So I'll go to the scene collection, left click and drag the cylinder into the geometry nodes editor, and now we have the object info node with the cylinder object selected. Now I'll take the geometry socket and connect it to the instance, and to view the cylinders here, take this instance socket and connect it to the join geometry node. So here we have the cylinders placed at different points on the bottommost face. Let's adjust their size. So with the cylinder selected, I'll tab into the edit mode, press S and Z to scale it up in the Z axis. Then to reduce its thickness, press S and Shift plus Z and scale it down in the X and Y axis like this. Let's also scale it down in the Z axis slightly by pressing S and Z and scale it down like this. Let's also move it slightly upwards. So press G and Z and place it over here. here, and now it looks like this. Let's come out of the edit mode, and to view the corridor from inside, press 0 on the numpad for the camera view, and from this view, you can also clearly see that their thickness is too high. So I'll select the cylinder again, tab into the edit mode, and let's scale it down again in the X and Y axis. So press A to select all, then press S and Shift plus Z and scale it down like this. Come out of the edit mode, let's again go to the camera view, and now this is how these pillars are placed. And now to remove this wireframe display from here, I'll go to this drop down menu again and turn off the wireframe in the geometry option. Now to give some basic material to these pillars, I'll again select that cylinder, and I'll change this window of the geometry nodes editor into the shader editor. So click on this icon and select the shader editor. Click on new button, and to see the texture, let's turn on the render view. To get a proper lighting in our scene, click here and turn off the scene world. Now to give it some basic texture, we'll be adding the Warner texture. So press Shift plus A, go to texture and select the Warner texture. Let's place it over here, and to view the texture, press Ctrl plus Shift and left click on the Warner texture. Also to add the texture coordinate and the mapping node, press Ctrl plus T and take this object socket and connect it to the vector. And now here we have these simple spots visible as the texture on this cylinder. And to make it look better, we'll try to change the distance metric option in the Warner texture and adjust the scaling to view the changes in the texture. So right now the first one is selected, but if I select the second option, then the texture looks like this, and if I increase the scaling from the scale option here, then this is how the texture is looking right now. However, this texture is also not looking good, so I'll select the third option in the distance metric and change the scale like this, and I think that we should keep this texture for the pillars. Also, if you want, you can combine this Warner texture with the noise texture to get a better result. So if I press Shift plus A, go to texture and select the noise texture, let's place it before the Warner texture, and now the texture looks like this. Let's try to change the value of scaling from here to get some better results. And here I think that it looks perfect, so we'll finalize this. To give it some color, I'll first connect this principal BSDF here, and then I'll be adding the color ramp. So press Shift plus A, go to converter and select the color ramp. Let's place it over here, and now you can use these pointers to change the amount of black and white color in your texture, and you can also change these colors by increasing the brightness and setting different colors. So for the first color, I'll keep it to dark green. So let's reduce the brightness from here. Let's also change the position of this pointer like this. And for the second color, I'll select this pointer and change the color from here, and I'll be assigning the light blue color to it. And now this is how the pillars of a sci-fi corridor are looking right now. Now let's go to the camera view by pressing 0 on the numpad, and this is how our scene is looking right now. And now if you want to add some 3D bump effect, then for this go to the shader editor, press Shift plus A, go to vector and select the bump node. Let's place it over here and connect it to the normal. Now I'll take the distance socket of the Warner texture and connect it to the height socket in the bump node. And now this is how our texture on the pillars is looking right now. Let's reduce the strength of the bump effect from here, and we'll be keeping it to something like 0.4 or 0.5. And now we'll be working on the side walls. Right now they're looking very simple, but to give them a sci-fi look, we'll first extrude the face and then inset it with the help of geometry nodes. So to do this, first I'll change this shader editor into the geometry nodes editor and select the corridor. Then to extrude these faces, I'll be adding an extrude mesh node. So press Shift plus A, go to mesh, and in operations, select the extrude mesh node. Let's place it over here, and as I already told you before, the information about the side walls and the ceiling is here in the inverted socket. So I'll select this inverted socket and connect it to the mesh socket. Let's also turn on the wireframe display to see the changes that we make here. So click on this drop down menu and turn on the wireframe from here. Now to view the changes, I'll take this mesh socket and connect it to the join geometry node. And right now you can't see any changes in the scene, and that's because the offset value in the extrude mesh node is set to +1. As a result, the extrusion is being applied to the outside faces. So if I reduce the offset from here, you will begin to notice that the amount of extrusion is reducing, and if I take it into a negative value and go to the camera view, then in this case the extrusion is being applied inwards. But since we want to create an inset effect on the faces, so I'll change the offset value to 0, and now to insert these extruded faces, we basically need to scale them down. So for this, we'll be using the scale elements node. So press Shift plus A, go to mesh, and in operations, select the scale elements node. Let's place it over here, and to make sure that the scaling is done only on the extruded faces, I'll take this top socket and connect it to the selection socket here. And now if I slightly reduce the scaling, you will notice that the faces are now begin to showing this inset effect. So we basically added this extrude mesh node and set the offset value to 0 so that we can create this extruded face, and then we connected it to scale elements to create this inset effect. Also, one more thing to notice here is that in the geometry nodes editor, we have connected the inverted socket to the join geometry node twice. First we directly connected it to the geometry socket, and just now we connected it to the extrude mesh node and the scale elements, and again connected it to the join geometry node. So I'll remove the initial connection. So hold down the control button, right click and drag like this, and now we have only a single connection in between the inverted socket and the join geometry node. Now if you want to make it look more complex, then you can again apply the extrusion to these inset faces. For this, I'll create a duplicate of this extrude mesh node by pressing Shift plus D and place it over here. Let's again take this top socket and connect it to the selection, and now I can control the extrusion from the offset value here. Let's keep it to something like 0.2 or 0.1, and now this is how our scene looks. We have these extruded faces on the side walls of the corridor and also on the top or basically the ceiling of the corridor. Now moving ahead, let's assign some material to the walls of the corridor, and for this we'll be using the set material node. So press shift plus A, go to material and select the set material node. Let's place it over here. Now go to the material properties, let's create a new material, and I'll change the name of this material to walls. Right now we'll only keep the basic white color to it, and now I'll go to the set material node and select the walls material. Now moving ahead, we'll also be placing some lights at the ceiling at these extruded faces, and to achieve this we'll first be placing points with the help of mesh to points node at the center of each face, and then we'll replace the points with a light object. To do this, go to the geometry nodes editor and we'll be adding the mesh to points node. So press shift plus A, go to mesh, and in operations select the mesh to points. Let's place it over here, and now we'll be connecting it to the inverted socket which is carrying the information about the walls as well as the ceilings. So I'll take this socket and connect it to the mesh. However, since we only need to add the points on the ceiling, so for this we'll be using the compare node and the normal node. So press shift plus A, go to utilities, and in math select the compare node. Let's place it over here. Now let's also add the normal node. So press shift plus A, go to geometry, and in read select the normal node. Let's place it over here, and since we'll be using the normal node as the input, so I'll change the input type from float to vector. Now I'll connect this normal socket to the vector A, and now since we need the points to be added at the ceiling on the top, and we know that its perpendicular, or basically the normal, is in the positive z axis, so I'll change the value of vector B in the z axis to +1. Also, I'll change the operation to equal and connect the result socket to the selection. Also, since we want the points to be added at the faces of the ceiling, so I'll change the domain from vertices to faces, and now we'll be connecting it to the join geometry node. So I'll take this point socket and connect it to the geometry socket in the join geometry, and now here we have these small points added on the top, and to replace them with a light object, we'll be using the instance on points node. So press shift plus A, go to instances and select the instance on points. Let's place it over here, and now we'll be creating the ceiling lights to be placed as the instances. So I'll change the view and press shift plus A, go to mesh and select the cube. Now the cube is placed at the position of the 3D cursor at this point. However, since we have this corridor here, we are not able to see it properly, and so I'll be telling you a shortcut which you can use to focus only on a selected object, and the shortcut is to press this / key in the keyboard. So if I press it, then now everything else will disappear except for the selected object. So to convert it into a ceiling light, I'll tab into the edit mode, press S and Z and scale it down like this. Now press 3 for the face select mode and select this bottom face. Press E to extrude, right click to cancel the extrusion. Then to insert this extruded face, press I and insert it like this. Left click to finalize. Let's also extrude it inwards. So press E and extrude it inwards in the Z axis like this. Left click to finalize, and now this is how the basic structure of the ceiling light is looking. We'll be assigning an emission material to this extruded face so that it will emit the light, and we'll be having some different material for the rest of the cube. So first we'll be creating a simple material for our ceiling light. So go to the material properties, click on the new button, and let's change the base color to dark gray by reducing the brightness from here. If you want, you can even assign some other color like dark blue or green, but right now I'll be assigning the dark gray color, and let's also increase the metallic strength from here. And now for the emission material, I'll click on the plus button, then create a new material, and let's open the shader editor. So click on this icon and select the shader editor. Let's zoom out, and here we have the default material added here. Now I'll be deleting the principal BSTF by pressing X, and we'll be adding an emission shader. So press shift plus A, go to shader and select the emission. Let's place it over here and connect it to the surface socket. Let's change the color of emission from here. So we'll give it slightly blue color and change the strength to a very high number, like something around 10. And to assign this material to this face, click on the sign button here. And with this, the ceiling lights are completely ready. Now let's come out of the edit mode, and now to get back the corridor that we created in the scene, press the / button again. Now I'll select the corridor, go to the geometry nodes editor from here, and to place the light on the ceiling, we'll be connecting it to the instance on points node here. So take this cube.001 which we use for creating the light and drop it in the geometry nodes editor. Now I'll be connecting this object info node to the instance socket here, and now here we have the light placed at the ceiling of the corridor. Let's also scale it down from the scaling option here. So first I'll select the X and Y axis and reduce it like this. Let's also scale it down in the Z axis slightly. So we'll scale it down to something like 0.7 or 0.8, and now we'll be hiding this main light from the scene as well as the render view. So go to the scene collection, click on this I button, and it's no more visible in the 3D viewport, and I'll click on this camera button to hide it from the render view also. Go to the camera view by pressing 0 on the numpad. Now here we have the ceiling lights placed at the top, and to view the effect of lighting, I will open the drop down menu here and turn on the scene world. It looks like this because currently we have turned on the EV render engine. So in the render properties, I'll change the render engine to cycles, and now this is how the lighting effect is looking in the corridor right now. And now we'll be working on the texture of walls. So I'll select the corridor, go to the material properties, and with the wall selected, I'll go to the shader editor from here. Let's zoom out, and here we have the default basic material applied to the walls. Now to give it a sci-fi look, we'll be using the Warner texture. So press shift plus A, go to texture and select the Warner texture. Let's place it over here. Press Ctrl plus P to get the texture coordinate and the mapping node. Now I'll take this object socket and connect it to the vector, and to view the texture on the walls, this, hold down Ctrl, Shift and left click on the Warner texture. Now this is how the basic Warner texture is looking on the walls. But to get a different texture, I'll change the distance metric option to the third one, and to give it a sci-fi look, we'll be adding the color ramp to change the amount of black and white color. So press Shift plus A, go to converter and select the color ramp. Let's place it over here, change the interpolation to constant, and now I can use these pointers to create this pattern on the walls. Let's also scale it up from the scale option here. So I'll keep it to something like 8 or 9. Let's change the position of the white pointer again, and now it looks like this. To give it a 3D effect, we'll be adding the bump node. So I'll take this principal BSTF and drop it over here, press Shift plus A, go to vector and select the bump node. Let's place it over here and connect the normal socket in the bump node to the normal in the principal BSTF, and for the texture, I'll take the distance socket and connect it to the height in the bump node, and with this we have the bump effect applied to the texture. And now we'll work towards finalizing the scene. So I'll go to the render properties and change the render engine back to EV. To get a proper lighting, we'll be adding some lights throughout the corridor. So for this, go to the top view by pressing 7 on the numpad, and here we have this default light placed in the scene. So I'll select it, press G to move it, and we'll place it over here. Then we'll be creating lots of duplicates of this light. So press Shift plus D, move it in the Y direction and place it over here. Press Shift plus B again, place it over here, and we'll be repeating these steps until we have added these lights throughout the corridor. So the shortcut to do this is to select all the 3 lights by holding Shift, select the remaining 2 lights, and now if I press Shift plus D to create the duplicate, we'll have the duplicate of 3 lights. Let's place it in the Y direction like this. Now press Shift plus D again, place the lights over here. Now I'll select this light, press G and move it over here. Let's select these 2, press Shift plus D, move the lights like this, then press Shift plus D one more time, and we'll place them over here. Now let's change the view, and this is how these lights are placed in the scene. In order to get them inside the corridor, I'll select all these lights, press G and Z and move them down like this, then left click to finalize, press 0 to go to the camera view, and now we have this lighting setup in the scene. Let's change their brightness and color. So I'll select a random light from here, go to the object data properties, and right now the power is set to 1000 watt, but since we are having so many lights in the scene, so I'll reduce the power to something like 100 watt. Let's also change the color of light, and I'll change the color to red color. And because of this red color, we also have these amazing shadows on the walls of the corridor. Similarly, we'll do the same with all the other lights. We'll change the power to 100 watt and assign some random colors. So I'll select this light.011, reduce the power to 100 watt, change the color to green color. Similarly for the next light, select it, reduce the power to 100, and we'll change the color to the dark blue color this time. Now I'll select the next light, change the power to 100 watt, and let's change the color to yellow color. Now I'll select the next light, go to the power option and reduce it to 100 again. Let's change it to light blue color. Similarly the next light, select it from here, go to the power option and change it to 100 watts, and this time I'll change the color to red color again. Let's select the next light, reduce the power to 100 watts, and for this one we'll be keeping the yellow color. Now I'll select the light.005, change the power to 100 watts, and yes, one thing to notice here is that we are done with all the lights on this side of the corridor where we have the camera, and now we are editing the lights on this part of the corridor. You can see the light of different colors in all these parts. However, here we still have the white color, which means that we have to edit the colors and the powers of all these lights. So I'll change the color of this light also, and let's assign the green color. Now I'll select the light.004, change the power to 100 watts, and similarly I'll change the color to dark blue. Now I'll select the light.003, reduce the power again, go to the color option and change the color to red color. Next light, reduce the power to 100 watts, change the color to yellow, and yes, it's completely up to you which random colors you want to assign to each light. And now I'll go to the light.001, reduce the power to 100 watts, change the color to pink color, and finally I'll select the last light, reduce the power to 100 watts and change the color to red color. Let's go to the camera view by pressing 0 on the numpad, and this is how our sci-fi corridor is looking right now. Now if you want, you can even create a simple animation where you will be navigating through the sci-fi corridor, and for this we'll be using the walk navigation. And yes, because we no longer need the geometry nodes, so I'll open up the layout workspace again from here, and this is how our scene looks now. Let's turn on the render view, go to the camera view by pressing 0 on the numpad, and this is how it looks. Now for the walk navigation, click on the view option here, go to navigation, and here we have the walk navigation. So I'll select this, and now if I move my cursor, you will notice that our camera view is now changing just like you experience in the open world games such as GTA, and in fact you can use the WASD keys in your keyboard. So if I press W, then you can see that we are navigating forward in the corridor. Similarly, I can press S to go backwards, A to move towards the left, D to move right, and in this way we can create a simple animation by navigating through this sci-fi corridor. To get back to the same position where we were before, I'll simply click the right mouse button, and to create an animation, we first need to assign a shortcut to use the walk navigation. And yes, let's also turn on the solid mode from here so that we can easily navigate around the sci-fi corridor without any lags in between. So to assign the shortcut to the walk navigation, click on the view option, then go to navigation, and if I take my cursor to the walk navigation and right click, then it will give me some options, and on the second number I have the assign shortcut. So I'll select this, and now it's asking me to press a key which is to be used as a shortcut to enable the walk navigation. But one thing to keep in mind is that we should assign that key which is not used as a shortcut somewhere else. So I'll be assigning the shortcut Shift plus Q, and now the shortcut is saved. So if I go back to the 3D viewport and press Shift plus Q, then now the walk navigation is activated, and to create the animation, I'll go to the timeline editor, and we need that the animation should be created automatically as we move through the sci-fi corridor. And for this I'll be turning on this auto key option, which will automatically add the keyframes whenever I make some changes in the scene. Let's also change the ending frame to a higher number like 1000. Now I'll play the animation by pressing spacebar, and to start the walk navigation, press Shift plus Q, press W to go ahead, and we'll be creating an animation like this. Left click to finalize, and now we have the animation ready. Press spacebar to stop the animation in the timeline editor, and now if I go to the frame number 1 and play the animation, then you can see that after some frames it will begin to show this animation where we are navigating through the sci-fi corridor, and at a frame of somewhere near 350 the animation will stop. However, you can see that at somewhere near frame number 200, if I play the animation, then the navigation is not proper, and to fix this we'll again go to the frame number 1 and recreate the animation. But before that we need to delete the animation that we just created. So I'll select the camera, go to the timeline editor, press A to select all the keyframes, and X to delete keyframes. Now I'll press the spacebar, press Shift plus Q to enable the walk navigation, and we'll walk around the sci-fi corridor like this. Then left click to finalize and press spacebar to stop the animation. And you can see here that we have animation of somewhere near 400 frames, and to view the animation, I'll bring this pointer to somewhere near 130 frames and then press spacebar. And this is how the animation looks now. And you can even render this simple animation. So for this, I'll first change the start value to 130, and that's because the keyframes are starting from somewhere near 130. Now hold on middle mouse button and drag like this, and you can see that the last frame is somewhere near 385 or 390 frame. So I'll change the end value to 385. Let's also go to the render view to see how the animation looks. So press spacebar to view the animation, and this is how it looks. And yes, one more thing to notice here is that at somewhere around 260 frame, if I play the animation, then you can see here that the change from frame number 265 and frame number 266 is very quick. And to fix this problem, we'll be adding some gap in between. So for this, first I'll increase the end frame to 390. Now I'll select only these keyframes here, press G and move it like this. And now if I play the animation again, then you can see that we are getting a much smoother movement or a much better animation than before. So I'll take the pointer back to the frame number 130 and let's play the animation again. So with this, our scene is finally ready, and if you want to render this animation, then go to the output properties, and in the file format, we'll change it from PNG to this FFmpeg video type. And you can even change the location where you want to save this video from the output path option here. So you can click on this folder icon and select any particular folder, and when you're done with all this, you can even set the resolution from here. Right now it is set to 1920 in the X and 1080 in the Y, meaning that it will be in the landscape mode just like normal YouTube videos. But if you want it to be in the portrait mode, or basically that form in which you watch the YouTube shorts or Instagram reels, then for this you simply need to reverse these values. So I'll go to the resolution in the X and change it to 1080, and for the Y I'll change it to 1920, and the resolution is now changed. And then to render the animation, click on the render button and select render animation from here. And yes, this brings us to the end of this chapter. In this chapter, we'll be understanding all these topics in complete detail, and we'll be using them to create this simple scene with this billboard along with the text added to it. So to begin with, let's go to the geometry nodes editor. Let's expand the area of the 3D viewport like this. And now the first topic for today's chapter is understanding the string to curve node. So in the geometry nodes editor, click on the new button, and to add the string to curve node, press Shift plus A, go to utilities, and in text, here we have the string to curves node. So I'll select this and place it over here. Now here the string means some characters or basically some text, and this node allows us to see that text in the 3D viewport. And here you have the string option where I can type any random text which I want to be displayed in the 3D viewport. So suppose I type JB 3D Studio and press enter to confirm, then here we have the text added in the scene. Now in the string to curves node, you have several options to change the way how your text looks. If you remember, we understood about the 3D text in Blender in this chapter of the course, and all these settings that you are seeing here are very similar to the ones that we covered in that chapter. So the first option that you have here is the font option, and to select any particular font, then click on this folder icon, and this will display a list of all the fonts that are saved in your PC. So suppose I select any random font like this one and click on open font, then you can see here that the text font now changes. So you can set any particular font with this option here. Now the next important thing is the string option here. It basically takes the input, which is the text that you want to see in the 3D viewport. Then you have the size option, which will basically control the size of your text. And then you have character spacing. But before that, let's also go to the top view by pressing 7 on the numpad. Let's zoom in, and now this character spacing basically means the spacing in between your characters. So if I increase it, the spacing, or basically the distance between any two characters in the text, will increase like this. Let's change it back to 1, and then you have the word spacing, which basically means the spacing, or basically the distance between the words in your text. So you can use this to change the distance between the words. Now here you have the line spacing, but if I change it, you won't see any difference in the text, and that's because we are only having a single line in the text. So we'll see this option later on. And now here you have the text box width, and it basically means the width of the invisible text box that is around the text in our scene. By default, it is set to value of 0, meaning that the width of the text box is infinite right now. However, if I increase it to a slightly higher number like 0.6 or 0.7, then now you can see that the width of the text box is now changed, and as a result, the words of the text are now in different lines. To understand it better, I'll change it back to 0. I'll enable the annotate line tool from here, and right now, since the text box width is 0, as a result, the width of the text box in the x-axis is infinite right now. However, if I change it to 0.5 meters, then now this width has decreased, and as a result, the text appears in a box like this. And this is the use of the text box width node. And now since we have more than one line in the text, so we can also look at the line spacing option here. The line spacing means the spacing, or basically the distance between any two lines in the text. And for now, I'll change the width back to 0. Let's also remove all these annotations by selecting the annotate eraser, and I'll remove all this. Let's go to the select tool again. And so this is how you can add some text in your scene with the help of geometry nodes. Now if you want to fill your text, then for this you can use another node, which is the fill curve node. So press shift plus A, go to curve, and in operations, select the fill curve. Let's place it over here, and now you can see that we now have this fill effect applied to the text. And now moving ahead, we'll be making a billboard and place the text over it. So in the 3D viewport, press shift plus A, go to mesh, and select the cube. Let's tab into the edit mode, press S and Z, and scale it down in the Z direction like this. Let's also scale it up by pressing S and scale it up like this. Let's scale it down in the Z axis again, and now it looks like this. Now we'll apply the inset to the top face. So press 3 for face select mode, select the top face, press E to extrude, right click to cancel the movement, and now to inset this extruded face, press I and inset it like this. Left click to finalize. Let's also extrude it slightly inwards, so press E and let's extrude it in the Z axis like this. And now one more thing to notice here is that currently this billboard is square in shape. To make it rectangle, press A to select all the faces, press S and X and scale it up in the X axis like this. Let's come out of the edit mode, and with this, our billboard is now ready. Now to place the text over it, I'll select this text, and to view it properly, we'll go to the render view. Let's also give it some different material. So go to the material properties, and let's change the base color to the black color by decreasing the brightness from here. To assign this material to the text, go to the geometry nodes editor, press shift plus A, go to material and select the set material node. Let's place it over here and select this black material. Now to move it upwards by using the geometry nodes, we will be using another node, which is the translate instances node. So press shift plus A, go to instances and select the translate instances node. Let's place it over here, and now I can use these values to change the position of the text in the scene. Now to move it upwards, I'll go to the translation value in the Z axis, and we'll slightly increase it to that particular value where it just intersects with the billboard. To get a better view, press 7 on the numpad to go to the top view. Now let's also move it in the X axis. So I'll go to the translation in X axis and change it like this. Let's also move it upwards in the Y axis and place it over here. And with this we have the simple billboard with some text added over it with the help of geometry nodes. Now moving ahead to the next topic, which is the string node, and it's basically used as an input to connect to the string socket here. So to add it, press shift plus A, go to input, and in constant, select the string node. Let's place it over here, and just like you had the option to enter the text here, similarly in the string node, you can enter any text here, and then you can connect it to the string socket like this. Now you might be thinking that what exactly is the use of this string node when you can directly put the text in the string socket of the string to curves node, and the answer to this is that you can use multiple string nodes and connect it to the string socket to have more than one text in your scene. However, from the string option in the string to curves node, you can only add a single text. So to add multiple text, I'll select the string node, press shift plus D to create a duplicate and place it over here. Let's change the text, and I'll type random and press enter to confirm. Now to connect both of them together, we have to use another node, which is the join string node. So press shift plus A, go to utilities, and in text, here we have the join strings node. So I'll select this and place it over here. Now I'll be connecting these two string nodes to the string socket here. So I'll take this one and connect it here. Similarly this one and connect it here. Now for the output, I'll be taking this string socket and connect it to the string socket in the string to curves node. And now we have two different text in the scene. However, in the join strings node, you can see here that apart from the string socket, we also have a delimiter socket. And by using this, I can tell this node that exactly what we want to insert between the two texts. So if I go to the delimiter and enter this exclamation mark, then now you can see that the two texts are now separated with this exclamation mark. And now moving ahead, we'll be creating some text which we we'll place below this JB3D Studio text. So for this, I'll first delete this string node which is having the random text. Also I'll select the join strings node and delete it from here. Let's connect the string node to the string socket in the string to curves node. Now for the text to be placed below the main text, I'll select all these nodes and create a duplicate of them. So let's select them like this, press Shift plus D to create a duplicate, and let's place them over here. Now to view both the text in the scene, we'll be using the join geometry node. So press Shift plus A, go to geometry and select the join geometry. Let's place it over here, and now I'll connect the geometry socket of the first text to the join geometry node, and similarly I'll take this socket and connect it over here. Now for the output, let's connect the join geometry node to the group output. Now the reason why you can't see two different text in the scene is that right now the second node system is also having the same information as the first one. For example, the position in the translate instances node and the data in the string node, all this is completely same. So first of all, I'll go to the translate instances node and let's change the translation in the y-axis. And now you will begin to see that we have two different texts in the scene. To change this text, I'll go to the string node and you can type anything over here. So I'll type random and press enter to confirm. Now if you want multiple strings to be added in the second text, then for this, I'll select the string node, press Shift plus D to create a duplicate and place it over here. Let's change the string to something else. So suppose I type MasterCourse and press enter to confirm, and to connect both the text, I will be adding the join strings node. So press Shift plus A, go to utilities, and in text, select the join strings node. Let's place it over here. Now I'll take this string socket and connect it to the strings. Similarly, I'll take this string socket and connect it over here. For the output, I'll connect the join strings node to this string socket like this. Now let's also change the first string, and I'll type blender and press enter to confirm. To separate the two strings, I'll go to the delimiter option here, and suppose I want to add an underscore between them. So I'll type it and press enter, and now the two strings are separated by the underscore like this. Now you can even add more than two strings and connect it to the join strings node. So suppose I select this string, press Shift plus D to create a duplicate and place it over here. Let's change the string to something else like YouTube and press enter to confirm. Now I'll take the string socket and connect it over here, and in this way I added three different strings separated by the underscore. Now one more thing to notice here is that if I go to the word spacing option here and try to change it, you won't notice any difference in the text, and that's because the entire string is being treated like a single word, and that's because we have not added any space in between any two words. So suppose if I go to the second string and in between master and course I press spacebar and enter and go to the word spacing again and try to change it, then you will notice that it is now treating this blender underscore master as one word and this course underscore YouTube as the second word. So the number of words basically depends on the space added while typing the text. Now if you want, you can even place the second word below the first one. For this, I'll go to the text box width, and if I slightly increase it, you can see here that we are now having this second word which is course underscore YouTube placed below the first one which is blender underscore master. If you want to scale it down, you can go to the size option here and reduce it like this, and if you want to change its position, then you can go to the translation option and I'll move it in the x-axis like this. And so this is how you can place different text or basically different words in your scene with the help of geometry nodes. Now we'll also be creating some more string nodes, so I'll select this one, press Shift plus D to create a duplicate and place it over here. Let's change this to animation and press enter to confirm. Let's connect it over here, and this is how it looks. However, suppose you want that it should change the line after each and every word, so for this you can go to the delimiter option here, and after the underscore I'll press the space bar, and if I press enter, then now we'll be having each of these words placed in a different line. This is because each one of these is now being treated as a separate word since we have added a space in the delimiter. And for now, I'll go to the second string and I'll remove the space in between the master and course. Now press enter to confirm, and in this way we are having four different words separated by this delimiter which is having the underscore that you can see, and because of the space that we added, all of them are placed in different lines. You can even increase the text box width in order to change the position of these words like this, but for now I'll be keeping it to 0.5 meters, and this is how it looks. Now moving ahead, let us discover the slice strings node. To add it here, press Shift plus A, go to utilities, and in text here we have the slice string node. So I'll select this and we'll place it after the upper text or basically the main text, and with this you will notice that some part of the text has now disappeared, and this is because the slice string node is basically used to slice or trim some part of your text. I'll go to the top view, and now you can see here that currently in this main text we are having 10 characters. The first character is J, second is B, then the third one is the space, then this is the fourth one, then fifth, then we again have a space, so it will be the sixth character, then similarly 7th, 8th, 9th and 10th, meaning that right now the text is having 10 characters, and so we can say that the length of this string is 10. Also in the slice string node you have this length parameter which is set to 10, and if I increase it to 11, then now the length of characters will increase. This letter I will appear, which is basically the 11th character of the string. So to get all the 12 characters, I'll change the length to a value of 12, and now we have the entire text. Then in the slice string node you also have this position parameter, which basically means that whatever value we add in the position, it will display the string starting from the index value of that number. For example, right now the position value is set to 0, and as a result the text that appears here will start from that character which has an index value equal to 0. And always remember that the indexing of the characters in string starts from 0 and goes on like 1 to 3 3, 4. So you can see here that the first character, which is J, is having the index value of 0. Then the second character of B will have the index value equal to 1, and similarly the indexing will go on like this. And for the last, which is the 12th character, the index value will be equal to 11. So for a string of 12 characters, the indexing will be from 0 to 11. Or in general terms, we can say that for a string having n number of characters, the indexing will be from 0 to n minus 1. Now if I go to the position socket and change the value to 1, then now the string will be displayed starting from the character having the index value equal to 1. In fact, by changing the position values here, we can even create a simple animation of the text in the scene. And to do this, I'll change the position back to 0, then I'll go to the timeline editor and we'll make an animation where initially at the frame number 1, there will be no text visible because we'll change the position value to 12, then at somewhere near frame number 40, we'll take the position value back to 0, and then we'll be having the simple animation of the text. So let's do it practically to understand. So at the frame number 1, I'll go to the value of position and change it to 12, and to insert a keyframe with the cursor hovering over the position parameter, press I and a keyframe is inserted here. Then I'll go to the frame number 40, change the value of position to 0, press I to insert a keyframe, and here we have the second keyframe inserted. Now I'll go to the frame number 1 and press the space bar to play the animation, and this is how the animation looks. Now we can even make a loop animation out of it where it first appears in the scene and then disappears again. So for this, I'll go to the timeline editor, select the second keyframe, and I'll be creating a duplicate of it by pressing Shift plus D and place it at the frame number 50. And the reason why I did this was that by creating a duplicate of this keyframe, the text won't suddenly disappear, as we'll be able to see the complete text for a fraction of a second. So now at the frame number 50, we have this keyframe with the position value of 0, and to make the text go disappear, I'll take the pointer to the frame number 90, change the value of position back to 12, and to insert the keyframe, press I. Let's also change the end frame from 250 to 90, and now I'll play the animation. So the text will first appear and then disappear like this. Now moving ahead, we'll be discovering the special characters node. To add it here, press Shift plus A, go to utilities, and in text, here we have the special characters node. So I'll select it and place it over here. Now this node is basically used to add characters which you can't otherwise add from your keyboard. Here we have two options. The first one is the line break and the second one is the tab. If I take the line break socket and connect it to the delimiter in the join strings node, then what it basically does is that it will change the value of delimiter from underscore space to a new line for each of the string. To explain it in a better way, I'll remove the connection from here, and in the delimiter, I'll enter the exclamation mark. Now since I have entered this exclamation mark in the delimiter, as a result, each of the strings is getting separated by this exclamation mark in between. However, if I connect the line break to the delimiter, then in this case, the delimiter is getting an input of line break, and as a result, there will be a new line after each string. Similarly, in the special characters node, you also have an option of tab. So if I take it and connect it to the delimiter, then the spacing in between the different strings will be as if you press the tab key in between them. So this is the use of the special characters node. For now, I'll take the line break socket and connect it to the delimiter. Now moving ahead, the next node that we're going to explore is the value to string node. To add it here, press Shift plus A, go to utilities, and in text, here we have the value to string node. Let's place it over here, and now this node is basically used to convert some value, which is basically a number, and give the output as a string. To explain it in a better way, I'll select all these nodes from the string to curves node to the set material. Let's create a duplicate of them by pressing Shift plus D. Let's place them over here, and now I'll be connecting the string socket of the value to string node to the string socket here. Now to view the output, I'll take this geometry socket in the set material node and connect it to the join geometry node. Let's move the text in the x-axis with the help of this translate instances node, and here you can see that we have this number 0 written as a string on the billboard. Now in the value to string node, you can change the value to any number like 10 or 12, and then you have the option of decimals, and if I increase it, this will basically add the specified number of decimal places in the number like this. Now suppose I want to use this node in order to create a simple animation where this number will be showing the number of subscribers from 0 to a particular number. Then for this, I'll change the value back to 0, and let's also reduce the number of decimals to 0 because obviously the number of subscribers can't be in decimals. So to create the animation, I'll take the pointer back to the frame number 1, and to insert a keyframe with the value set to 0, I'll take my cursor over it, press I to insert the keyframe. Now I'll take the pointer to the frame number 90, and I'll change the value to the final number of subscribers. So I'll keep the value to 700 because this is the number of subscribers that I remember the last time I checked the subscriber count. And to insert a keyframe at this value, press I, and now if I go to the frame number 1 and press the space bar to play the animation, then this is how it looks. The number increases from a value of 0 to 700. Now let's also add a text subscribers below it with the help of the string node. So I'll select this, press Shift plus D to create a duplicate, and let's place it over here. I'll change the text from animation to subscribers, and since we are using two different strings, so we have to use the join string node. So I'll select this one, press Shift plus D to create a duplicate, and let's place it over here. Now I'll take this string socket and the value to string node and connect it over here. Similarly, I'll take this string socket also and connect it here. For the output, we'll connect the join string node to the string to curves node. Now here you can see that we have the text added showing 700 and subscribers separated by the exclamation mark. To remove this exclamation mark and to get both of the strings in different lines, we'll be using the special character characters node. So press Shift plus A, go to utilities, and in text, here we have the special characters node. So I'll select it and place it over here. Let's connect the line break to the delimiter in the join string. To align them properly, I'll change the alignment from left to center. Let's also reduce their size from here, and to bring them down in the y-axis, I'll go to the translate instances node and reduce the translation in the y-axis. And now this is how it looks. The reason why we can't see the upper text is that we created an animation where the text is not visible initially, then at somewhere near frame number 40 and 50, the upper text is visible, and then it again disappears as it reaches the last frame. So I'll take the pointer to the frame number 45 to view all the text in the scene. Now let's finalize the scene by giving some material to the text. So in the material properties, I'll go to the emission. Let's increase the strength to a higher number like 8 or 10. Let's also change the color of emission, and I'll change it to orange color. Now the reason why you can't see the emission effect properly is that in the render properties, we have turned on the EV render engine, and therefore we need to change a setting here in order to view the emission properly, and that particular setting is the bloom setting here. So if I turn it on, then now you can see the emission in a much better way than before. And right now all the text is having the same material, which is this orange emission material, and to change this material, I'll go to the material properties. Let's create a new material from here. So I'll go to the emission, change the strength to something like 10, and for the color, I'll be selecting the blue color. Now let's assign this material to this text part of Blender MasterCourse YouTube animation, and you can see here that this node connection is connected to this set material node. So I'll go to the material here and change it to material.001, and with this we have a different material applied to this text. And now let's also give some basic material to this billboard. So I'll select this, go to the material properties, and click on the new button. I'll change the base color to black by reducing the brightness from here, and if you want, you can even change the color of this particular face where the text is placed to something like dark blue. So for this, I'll tab into the edit mode, and let's select this face, go to the material properties, and let's create a new material. I'll go to the base color, let's keep it to blue color, and reduce the brightness from here. To assign this material to this face, click on the assign button, and now this is how the billboard looks now. It kind of looks like a tablet which has this glowing text over it, and so in this way you can create the text with the help of geometry nodes. And yes, to ensure that in the render properties you have turned on the bloom settings from here. If I turn it off, you can see how it looks very dull and uninteresting, but if I turn it on, then now it looks amazing. Now let me also show you one more thing, which is the screen space reflections here. If I turn it on, you will notice that the reflection of light from the text are now falling on the billboard. Previously when it was turned off, then there were no such reflections visible on the billboard, and by turning this setting on, you will get the perfect reflections in the EV render engine. Let's also check out the final animation one more time. So I'll take the pointer to the frame number 1 and play the animation by pressing the space bar, and this is how it looks. I'll do one more change here, which is to select the slice string node connected to the main upper text. Let's also select the text in the scene, and in the timeline editor, I will remove this animation in the second part where the text disappears. So for this, I'll select the last pointer, press X to delete it. So now let's replay the animation from the frame number 1, and this is the final animation. And yes, this brings us to the end of this chapter. Today we learned about using the text in Blender with the help of geometry nodes. We learned about different tools for placing the text, animating it, added this emission material to it, and even learned about some important settings in the render properties.